Welcome to the Excel, VBA and SQL 3-in-1 crash course. The course is totally free and most importantly, it is suitable for absolute beginners. Even if you have never used Excel before and you don't know what VBA and SQL are, I encourage you to watch this video because you can learn a lot from it. And it will give you very valuable skills for the job market. You are currently watching the introduction section of the course. After this section, the three most important sections of the course follow. There is a separate section for Excel, VBA, and of course SQL. Later in the course, I'll give you a lot of information about Excel, VBA, and SQL, but I think I should talk briefly about these three main topics of the crash course now. You should know what Excel, VBA, and SQL are, and more importantly, why you should learn them. Excel, or Microsoft Excel, is a software for storing, organizing, and analyzing data. We can also use Excel to manipulate or act upon our data. For example, we can perform various calculations and save the results. What you see here is an example for performing calculations by using formulas and functions. Don't worry if you don't understand anything about what you see. Step by step, we'll gain the knowledge, and when you reach the end of this crash course, you will be confident about what calculations we are performing here. Excel is a very versatile software. For example, it has features for visualizing data. What you see here is a chart. This chart will also be part of this crash course, so by the end of this video, you will be able to recreate this chart or create a brand new chart that is similar to this one. VBA is a programming language that we can use for automating Excel tasks. We can implement very complex processes in Excel. After a while, it becomes tedious to do the same things over and over again. However, with VBA, we are able to write code that does the job for us. Because VBA is a programming language, in this crash course, you learn the very basics of programming as well. No need to worry if you've never written a single line of code. By the end of the video, you realize that anyone can learn programming. What you see here is an example of some code that we will write together. It might not mean anything to you now, but by the end of the video, you'll fully understand what is going on here. SQL, like VBA, is a programming language, but it has a very specific purpose: to interact with a database. Databases are used for storing data. Many times, an insane amount of data. But of course, we need a way to retrieve data from a database or to add new data to it or to update the existing data. For these purposes and more, we can use SQL. During this video, we are going to create our own database and use SQL to interact with it. What you see here is the database that we'll create and some SQL code that we'll use to retrieve data from it. By the end of the video, it will be clear to you what is happening here. The most important question you probably have now is, why learn these things? Simply put, we learn about Excel, VBA and SQL to become experts in working with data. There is always a place, and usually a very comfortable place, on the job market for those professionals who know their way around data. You might have heard the expression that data is king. I fully agree with it, and I believe that the world needs a lot more professionals who know how to work with data. The aim of this crash course is to help you take the first steps in becoming a data expert. In other words, someone who can work with data professionally and has valuable skills that are in demand on the job market. I believe this is the point where I should introduce myself. My name is Mark and I'm a self-taught software developer. I've worked for some of the biggest names on the job market, for example, IBM, Morgan Stanley, BlackRock, and Siemens. I have many years of professional experience in working with Excel, VBA, SQL, and other programming languages and various technologies. What I know about working with data and programming, I've learned myself. And if I could do it, you can do it. I hope I'll do a great job at being your instructor, and this is where I should end the introduction section of the video. So let's move on to the Excel section of the course and let's start learning. The first step is of course installing Excel. If Excel is already installed on your computer, then you can skip this part of the video. However, if you don't have Excel yet, then I will show you how you can purchase Excel and how you can install it. Navigate to office.com in your browser. Excel is part of the Office suite. The Office suite is a collection of software that we use primarily for work, like Word, Excel, and PowerPoint. Ultimately, you'll have to register an account here if you want to purchase and install Office, but for now you don't need to do that. Let's click on Get Office. We are redirected to a site where we see the currently available Microsoft Office options. Because Excel is part of Microsoft Office, we will of course install Microsoft Office and not just Excel. We see these two tabs on the top of the page, for Home and for Business. I will not click on the For Business tab, but if I clicked on it, I would see some other options for purchasing Microsoft Office. But let's stick to the Home versions. The current version of Office is Microsoft 365. As I mentioned, it's a collection of software like Word, Excel, PowerPoint, OneNote, Outlook, and you also get some cloud storage. On the right side, we see two options here. You can purchase Microsoft 365 Personal for $70 a year or $7 a month. You get 1 terabyte of cloud storage, but only you can use it. However, there is another option, there is a family plan that is recommended for 2 to 6 people, and it costs $100 a year or $10 a month. So if you have a few family members or friends who want to use Microsoft Office as well, then it's worth going for the family version. For the yearly or monthly subscription fee, up to 6 people will have access to Office, and each person gets 1 terabyte of cloud storage. Moreover, you can try the family plan for free for a month. So you can use Office for a month, and if you don't like it, then you don't have to start paying. Let's scroll down a bit. Let's stop at this section, Compare Microsoft 365 with Office. We should understand this as compare the current version of Office, so Microsoft 365, with earlier versions of Office or with an earlier version of Office. Microsoft 365 is the current version of Office, so this is the version that gets updated regularly. But if you don't like subscriptions, then you can purchase an earlier version of the Office suite, the Office Home and Student 2019 version. It is a one-time purchase of $150. As you can see in the table below, Word, Excel, PowerPoint, and OneNote are included in the Office Home and Student 2019 version. What I'll show you in the crash course is compatible with the 2019 version. However, I would suggest buying Microsoft 365, either the personal plan or the family plan, because the 2019 version doesn't get updated anymore. By the way, these two plans, so the family plan and the personal plan, are the same as the two plans here, so we've already discussed these two plans. So it is really up to you which plan you're going with. I have an active subscription, of course, so we'll move forward and I will show you how to install Office on your computer. I'll scroll up and I'll click on Sign In. If you don't have a Microsoft account already, click on Create One. I will sign in with my email address. Once I've typed my email address here, I will click on Next. And of course I have to provide my password here. Once I'm ready, I will click on Sign In. On the top right corner, I will click on the Account Manager. Once you see this pop up, click on My Microsoft Account. Of course, your Microsoft account will have a different name. I am part of a Microsoft 365 family plan, so I have the opportunity to install Office apps on my PC or Mac. I'm actually using a PC, but it doesn't matter. What matters is that you click on the Install button here. Eventually, this small window should appear. I will install the default version of Office, the English version, and I suggest you do the same, because if you use Excel in another language, eventually it will be hard for you to follow the crash course. I will click on the other options, but if you see this window, you can actually just click on Install, provided that you're installing the English version of Office. But like I said, I will click on other options, and I'll make sure that the 64-bit version of Office is installed on my computer. I'm using a 64-bit operating system, and if you have a modern computer, then most probably you also have a 64-bit operation system. But if you're not sure about this, you can always choose the default version. I will not download an offline installer, I will simply click on Install, and this should also work for you. Once I pressed Install, a file has been downloaded onto my computer, officesetup.exe. It's not the first time I'm downloading this file, so this is why you see this number 3 in parentheses before the .exe part. So most probably you will see office setup.exe instead of office setup3.exe. But this doesn't matter, simply click on the downloaded file. And now the installer has started. The installation process takes a while, so I will just fast forward this part in the video. If the installation has run successfully, then you should see this message, "You're all set, Office is installed now." I will close this window, and we will finally start Excel. I'm using a Windows 10 operating system, so I will come to the search bar, and although I have Excel as a recommendation, I will start typing Excel here. And this is what you should also see, so Excel should have been found by your computer. Let's click on Open. Click on the blank workbook option. And now you should have a new Excel workbook called Book 1. If this is the first time you're using Excel, this Excel workbook might look a bit scary to you. But there's really nothing to be scared of. Let's discuss what we are seeing here. We'll start with this green area at the top. I will call this the top area. On the top left corner, you see the Quick Access toolbar. The Quick Access toolbar offers some useful commands. Your Quick Access toolbar might look a bit differently. You might have an autosave option. This option is not active for me, but it might be active for you, so let me reactivate it for myself. I will click on this downward pointing arrow. A menu pops up. The title is Customize Quick Access Toolbar. You see that for me, 3 options are checked: the save, the undo, and the redo. The floppy icon here represents the save command. Of course, this is the command that lets us save our work. The arrow pointing to the left is the undo command, and the arrow pointing to the right is the redo command. We will discuss these a bit later, but I will not deactivate them. Let's go to the top, to the automatically save command. Once I hover my mouse over it, we see a tip or a small message that appears, Add to Quick Access Toolbar. If I click on this, then the autosave feature appears on the Quick Access Toolbar. Notice that this feature is currently off for me, so it's not active. But this feature can be very useful if you want to save your work automatically. I'm not using this, however, so I will click again on this downward pointing arrow, so I will have the Customize Quick Access Toolbar menu pop up again. You see that now there is a check mark next to the automatically save command, and when I hover my mouse over it, then this little message or tip on the right says Remove from Quick Access Toolbar. Because I don't need this, I will remove it, so I will simply click. And now you see that the autosave command is not in the Quick Access Toolbar. Make sure that the save, the undo, and the redo commands are checked for you, and then we can move on. In the top area, we also see the name of the workbook that we have. And because we opened our first blank workbook, then the name Book 1 was automatically assigned to this workbook. The name of the workbook that we are working with is also shown in the top area. Because we opened our first blank workbook, the name Book 1 was automatically assigned to this workbook by Excel. A bit later, we will use the save command to save this workbook for the first time, and we will give a new, more meaningful name for this workbook. There is a search bar in the top area. We will actually not use this in the crash course. Nevertheless, this is a useful feature. You can search for things or information in the Excel help, for example. On the right-hand side, you should see the name this subscription belongs to. I'm not working on my own computer, it is a colleague's computer, so this is why you don't see my name here. However, in your case, probably you see your own name here. The next option we have in the top area is the Subscription Benefit Center, but this is something that we don't need to discuss. Next to it, you see the ribbon display options. We will get back to this a bit later. On the top right corner, you see 3 familiar buttons probably. We can minimize the Excel window. We can also resize the window or maximize it. And of course, if I clicked on the X, then this workbook would be closed, but I don't want to close this workbook just now. Below the top area, you see the ribbon. The ribbon consists of different tabs. On the different tabs, different Excel commands are grouped together. Of course, we use commands to achieve something in Excel. I've already mentioned the save, undo, and redo commands, for example. So these are the commands in the quick access toolbar. On the Home tab of the ribbon, we see, for example, the clipboard command group, where we can find the copy command, for example. This might be already familiar to you. Of course, you can use the copy command to copy data, and the shortcut for it is Ctrl+C. If you hover your mouse over a command, then a small pop-up should appear that gives you some information about what that command does. You see that there are quite a few tabs on the ribbon, so there are a lot of available commands. Don't worry about these commands. As we progress through the course, we'll use quite a few of them, of course, but I'll always explain how to use the commands. Probably you don't see the developer tab here, and this is not a problem for now. We will need it for the VBA section of the course, but for a long time we will not use any of the commands that are here. Let me actually deactivate this developer tab. Click on the File tab of the ribbon. Once you click on the File tab, you should see something similar to this. We are currently at the Home screen. If you click on this arrow above the Home, you get back to your workbook, but if you click on the File tab again, then you are back to this Home screen. In the Home screen, I see some files that I've recently worked with, but if this is the very first time that you're working with Excel, you will not see any files here. We could create another workbook or open an existing workbook or save this workbook here. However, now I want to deactivate the developer tab of my ribbon, so I will go to the bottom and I will click on Options. Once I clicked on Options, the Excel Options dialog appeared. Of course, there are a lot of options here that you can change, but you shouldn't worry about this at this point. I will click on Customize Ribbon, and then I see two lists here. This is a list of commands, but now I'm interested in the other list. This is the list that shows which tabs are active on my ribbon now. For now, I will uncheck the Developer tab, and I will click on OK. You see that now I don't have the Developer tab available anymore. Let's click on the File tab again, and let's click on the options at the bottom again. You see that one of the Excel options is Language. This is where we can change the language of our Office. My Windows is in English, and Office matches the language of my Microsoft Windows, which is perfect for me. However, if your Office is not set to English, you should set it to English, at least for the time period while you are taking this crash course. Eventually, it will be very hard for you to follow this crash course if your Office is not in English. If English is not an available option for you in this box, you can always click on the Install Additional Display Languages from Office.com link. Because I don't want to change anything, I will click on Cancel. A bit earlier, I've mentioned that I will come back to the ribbon display options. So let's click on it. We have three options to choose from, and the option that is selected now is the Show Tabs and Commands option. So we are showing the ribbon tabs and commands all the time. This means that whatever I do, I will always see the ribbon here, so I will always see these tabs, and I will always see these commands under each tab. This is actually perfect for us, so I don't want to change this. I just want to show you that you can change this later. You can go for the Show Tabs option. And now you don't see the commands, but the tabs are still here. And if you click on the tab, then the commands appear. However, if I click outside my ribbon, then the commands disappear, but I still see the tabs, the ribbon tabs. The last option we have here is the Auto Hide Ribbon option. I will click on it. Now we don't even see the ribbon tabs. However, I can move my mouse to the top, and now you see that the color changed to green at the very top. I can click on these 3 points or dots, and now the top area and the ribbon are back. But if I click outside of them, then they are hidden again. I will click on the ribbon display options again, and I will click on the Show Tabs and Commands, so this was my default. Right under the ribbon, you see the name box and the formula bar, and there is also the Insert Function command. We will get back to these later, because now we'll discuss probably the most important part of a workbook, the worksheet. Every Excel workbook has at least one worksheet. In this workbook I have only one sheet, and you can see the name of this worksheet at the bottom. It's called Sheet 1. Excel, of course, automatically assigned this name to my worksheet. Once we created a new blank workbook, Excel assigned the name Book 1 automatically to the whole workbook, but it also assigned the name Sheet 1 automatically to our one and only worksheet. The worksheet is the area where we do the actual work. This is where we will put our data, and this is where we will manipulate our data. A worksheet is made up of rows and columns. Rows are designated by numbers or indexes. You can see these indexes on the left side, so this is row 1, this is row 2, then row 3, and so on and so on. Columns are designated by letters. We see column A, column B, C, D, and so on and so on. When we are working with Excel, we are usually not working with whole columns like column A here, or whole rows like row 1 here. We work with cells. We can refer to a cell by a column letter and a row index. Click into the cell that is right below the letter A. You should see a green border around your cell. This means that currently this cell is selected, and of course this cell is cell A1. Because cell A1 is selected, you see that the column index 1 has a bit different background than the other column indexes, and the background of the letter A is also a bit different than the rest of the letters. If you look at the name box, so the book above the letter A, you see the text A1, which means that currently cell A1 is selected. So the cell that is in the A column at row index 1. The horizontal and vertical gray lines that you see in your worksheet are the grid lines. The grid lines separate the cells from each other. They are of course a very useful visual aid for us. Let's select cell B2. Now you should see this green border around cell B2, and the text B2 should be in your name box. You should also see that the background of the letter B is different than the other letters, or the background of the other letters. And the background of row index 2 is also different than the background of the other row indexes. There is also a horizontal green line below the letter B, and a short vertical green line next to row index 2. These also indicate that cell B2 is currently selected. Previously I hovered my mouse over the letter A. You see that my mouse cursor has changed to a black downward pointing arrow. If I press my left mouse button, then I select the whole column A. You see the text A1 in the name box. However, you see this green border here, and you see that if I keep scrolling down, this border is still there, so all these cells are selected. I will select cell A256, but I could select any cell in column A actually, and I will press Ctrl-Shift-Down arrow on my keyboard. I wanted to quickly get to the bottom of my worksheet. Each worksheet in Excel has more than 1 million rows. I've just selected cell 1,048,576. So now we know that altogether there are 1,048,576 rows in an Excel worksheet. I will press Ctrl Home, so I will jump back to cell A1. Once cell A1 is selected, I will press Ctrl Shift right arrow. I have selected the whole first row now, but I could also hover over row index 1 and press my left mouse button, and I achieve the same. On the bottom right corner of the workbook, there is a horizontal scroll bar. Let's scroll to the right a bit. We can use this scroll bar to scroll to the right side or the left side of our worksheet. And of course, when we are scrolling to the left or the right, the column letters are changing. I see now column AF on the left side and column BH on the right side of the worksheet. I will click into cell AT1 and I will press again Ctrl-Shift right arrow. I've done this to reach quickly the end of my worksheet or the right side of my worksheet, so the rightmost column. The last column we have in a worksheet is designated by the following three letters XFD. We have fewer columns in a worksheet than rows. In an Excel worksheet we have 16,384 columns. But remember that we have more than 1 million rows. I will press Ctrl Home again. So now I can say that I'm at the beginning of my worksheet, so cell A1 is selected. Although we haven't even put any data into this worksheet, I think at this point you can appreciate how much data Excel can store. More than 1 million rows multiplied by more than 16,000 columns is a lot of cells. Of course, most of the time only a fraction of these 1 million columns and 16,000 rows are used. But still, Excel is capable of working with data of an enormous size. And of course, this is just one worksheet. Let's hover over the New Sheet button. This is this plus sign at the bottom. Let's click on it and add a new sheet. A new worksheet has been created for us, and it has been assigned the name Sheet 2 automatically. You see that the name Sheet 2 is in green, and we have this horizontal green line under the name Sheet 2, so we know that Sheet 2 is currently selected. If I click on Sheet 1, then Sheet 1 gets selected, but actually nothing else changes on the interface, because both sheets are blank or empty. So we store no data on these sheets. Hover over Sheet 2, press your right mouse button, and click on Delete. We have of course deleted Sheet 2, it was very easy. You can always add as many new sheets as you want, and of course you can delete them. Let's rename Sheet 1 to Test. We can hover over Sheet 1, press the right mouse button, and click on Rename. And now you see that the name of the sheet has been automatically selected. We are in edit mode, so now I can rename my sheet. I will press backspace to delete the name, and I will add a new name to this sheet, Test, and I will press Enter when I'm finished. You can also hover over the sheet and press the left mouse button quickly twice. And now you are in edit mode again, so you can rename the sheet again. I will rename this to Test 1. Of course, once we get into edit mode, we don't have to change anything. I will press with my left mouse button twice again on the name of the sheet. But this time I will press Escape. So now I've quit edit mode and I didn't change the name of this Test 1 sheet. You can always add more worksheets to your workbook, however, they have to have different names. So far in the course we haven't done much work, but we actually renamed our worksheet. This is the point where we can discuss saving our workbook. This is the first time we are saving this workbook. We have two options. We can go to the File tab and click on Save. Once I clicked on the Save button, the Save As button was selected actually, but this is not a problem. I can click on Browse, and I can select where I want to save this file, and I can change the name of this file or workbook as well. But for now, I will click on Cancel, and I will go back to my workbook, and I will click on the Save command on the top left corner. The Save This File dialog appears. I can rename the file, and I can also change the file type or extension of this file. Since Excel 2007, the default file type for an Excel workbook is XLSX, and this is perfect for us. I can also choose a location where I can save my file. If the location where I want to save my file is not in the list, then I can click on More Locations. And once I clicked on More Locations, we are back to the Save As screen. So let's get back to the workbook again, and let's click on the Save command again. And this time let's click on More Options. And now we are back to the Save As screen again. So don't be surprised if this screen pops up while you're saving a file. Basically, if we don't accept the default options here, or more like the limited options that we have here for saving the file or workbook, then we'll eventually end up at the Save As screen. If, however, I just wanted to quickly change the name of this workbook, and if I was fine with saving into the Documents folder, then I could just click on Save and the file would be saved. But I want to save this file onto my desktop, so I will click on More Options. I'm back at the Save As screen again, and I will click on Browse. I will select my desktop, and I will rename my workbook to Testbook. I deleted the extension as well, the .xlsx, from the file name field. But it's not a problem because I have a Save As type field as well, where I can see that the workbook will be saved as an XLSX workbook. If I click onto this field, I get more file type options. For example, I could save my workbook as a macro-enabled workbook, so the extension would be XLSM, and this is what I would choose if I wrote VBA code into this workbook. But of course there is no VBA code in this workbook, so the default XLSX extension is perfect for me. Now that I've selected my desktop, gave a new name to a file, and selected the extension, I will finally click on Save. Once I clicked on Save, I got back to the workbook, but notice that now I don't see book 1 here, but testbook.xlsx, so the name under which I saved this workbook, and Excel also tells me that this workbook has been saved. I will click on the X in the top right corner to close this workbook. Of course, I've successfully closed the workbook, but I'm on my desktop now and I see that the testbook.xlsx file is here, so I will double click on it. And now my workbook named testbook is open again. We also see that the name test1 has been preserved for the worksheet. So now we know that this very small change that we made has been successfully saved. Select cell A1 and start typing the words test data. As soon as I started typing, I got into edit mode and the characters appeared in the selected cell. I know that I'm in edit mode because there is the pipe character inside the cell. Let me finish typing test data. Once I'm finished, I will press enter. Once I pressed enter, some important things happened. Cell A2 was automatically selected, so the cell right below cell A1, in which I typed test data, was automatically selected. Cell A1 is not selected anymore, however, we can see the text test data inside it. In the bottom right corner of the workbook, we have an option of zooming in or out of the workbook or worksheet. By default, the zoom is 100%, however, I will increase this zoom so that you can see better what is happening on my worksheet. Cell A2 is still selected. We can see this by the green borders around it, and also in the name box we see A2. But let's now reselect cell A1. We see the text test data inside it, and if you look at the formula bar, you see that it has the same text there. Once you select the cell, the formula bar shows the contents of that cell. For now, this is not really interesting because we only have some text in cell A1, but once we start learning about formulas and functions, the formula bar will be much more important for us. I still have cell A1 selected, and if I double click on it, I'm back to edit mode. I can press escape to quit edit mode, and I actually didn't change anything. But I can double click again into the cell, and I will delete the word data and the space from it. I will press enter, and now again the cell below the selected cell has been automatically selected by Excel, so cell A2 was selected after I finished editing cell A1. By the way, there is nothing in the formula bar because there is nothing in the selected cell. We still haven't done much work, but let's save the workbook again. This workbook has already been saved, so this time if I simply click on the save command here in the top left corner, then the workbook will be saved. Once I clicked on it, you see that this saved text or information appeared. So now I know that I have saved my progress. I didn't have to choose a location for the file because the file is already saved on my desktop. Let me close this workbook again and let me reopen it by double-clicking on it. Cell A1 still contains the word test, so I have successfully saved my workbook. So far we've discussed the very basics and we haven't done actual work. This will change in a minute, however, it's very important that at this point you know the very basics of a worksheet, so you know about cells, rows and columns, and you also know how you can save your work and how you can open an Excel workbook, a new one or an already saved one. I will close the test book and I will open the Excel section start.xlsx workbook. We'll work with this workbook for the rest of the Excel section of the crash course. You can find a link in the description of the video where you can download this workbook. Once you have downloaded and opened this workbook, you might get a notification like this. Protected view. Be careful, files from the internet can contain viruses. Unless you need to edit, it's safer to stay in protected view. And then there is a button for enabling editing of the file. For security purposes, the default behavior of Excel is that it opens workbooks in protected view that, for example, you have downloaded from the internet. Protected view means that you have the right to view the workbook, so you can select any of the sheets and you can see what data the sheets contain. But you cannot edit the workbook. If you trust the source of the workbook, of course you can enable editing. Of course, this workbook doesn't contain anything harmful, so you can safely click on Enable Editing. There are quite a few worksheets in this workbook, as you can see. You can check them out. I have, of course, prepared some data for you, so when we learn about new topics in the crash course, we don't have to type everything from scratch. The data is already provided for us and we can focus on the new topic. Our first topic will be data organization, so make sure to select the first worksheet called Data Organization. This worksheet is empty. So now actually we will type everything from scratch. But of course there is a reason for this. Select cell A1 and type Mark into it. This is my name. Once you finish typing, of course, press Enter. Make sure that cell A2 is selected and type West Sales Company into cell A2. Let's type EMEA in uppercase into cell A3. What we are doing here is, of course, adding some data to our worksheet. Let's imagine that we are adding some data to our worksheet about salespeople, and we have a salesperson whose name is Mark, who works for the West Sales Company in the EMEA region. EMEA stands for Europe, Middle East and Africa. Select cell A4 and type the name Jane in it and press Enter. Let's put the text East Sales Company into cell A5. And let's put the word APAC in uppercase into cell A6. APAC stands for Asia Pacific. So now we have another salesperson called Jane who works for the East Sales Company in the APAC region. Of course, these two company names are totally imaginary. So they are not real companies and they are not real salespeople. I mentioned before that if you select a cell, you can see the contents of the cell in the formula bar. Of course, you can see the contents of the cell in the cell itself as well. So now we see Mark in cell A1, but also Mark in the formula bar. Let's select cell A2. In the formula bar, we see the text West Sales Company, and in cell A2, we also see the text West Sales Company. However, something strange is going on. We see that cell A2 is selected because of the green border, and in the name box we also see A2. But the text West Sales Company is overflowing to cell B2. And in cell B2 we see the word company and the end of the letter S. However, when we select cell B2, we see that there is nothing in the formula bar. Because actually there is nothing in cell B2, the whole text West Sales Company is in cell A2. If I select a cell that is neither A2 or B2, for example D2, we see that the grid line between cell A2 and B2 disappeared. We see the grid line between cells A1 and B1 and also cells A3 and B3, but there is no grid line here. By default, all the columns of a worksheet have the same width. If the contents of a cell is shorter than the width, then we don't see anything strange, so we see the text Mark here, and it's obvious that this text is in cell A1, and it's also obvious that the text Jane or the name Jane is in cell A4. But once the text doesn't fit the column width, it will overflow to the neighboring cells. But the contents of the neighboring cells will not be touched. You see that cell B2 is still empty and cell B5 is also empty. However, the text company overflew into it. I think this is a great feature of Excel. But if it's the first time you see this, you might get a bit confused. So this is why I wanted to explain what is happening here. We could actually change the width of column A, so the text West Sales Company would fully fit into it. But this is not something that I want to do now. I want to talk about something different. We are organizing our data in a one-dimensional way. We are using several rows, so our data is in 6 rows, but we are using only one column, column A. Don't worry about selecting your data. You saw that I selected these 6 cells and then I selected column A. We will discuss later how to select the data. For now, the important thing is to understand why it is a very bad practice to store your data in a one-dimensional way like this. We have little data here. We have some information of only 2 salespeople. So still it is quite simple to see what data belongs to Mark and what data belongs to Jane. If we had, however, information about 1,000 salespeople, then we would be using 3,000 rows, and it would be much more challenging to scroll with our mouse and with our eyes and to see which pieces of data belong to which salesperson. But that is not the biggest problem we have. The biggest problem we have right now is that what if we want to extend our data? What if we want to add some extra information about the salespeople? Where should we put that information? We could theoretically put some other data into the neighboring column. Let me select cell B1 and put the text some extra information about Mark. And of course I'll press enter. Now basically I have 4 cells that contain information about Mark. And I think it's already getting chaotic. Why don't I put this text into cell B2 or cell B3? And why is it next to the name? So now we are storing data in an unstructured way. It's better to stick to one column now, so at least we will know that every piece of information that is between Mark and Jane belong to Mark, and any data that we have for Jane is below the cell where we have the name Jane. Hover your mouse over row index 3. Once your cursor changes to a rightward pointing arrow, press your left mouse button. Now we have selected the whole row, so the whole row 3. Press your right mouse button and click on Insert in this menu that popped up. We have inserted a new row into our worksheet, however, the overall number of rows didn't change. But now we have a totally blank row between West Sales Company and EMEA. EMEA used to be in cell A3, now it is in cell A4. So after we inserted a new row, everything was pushed down by one row. Let's select cell B1, go to the Home tab on the ribbon and click on the Cut command. Once you click on the Cut command, cell B1 will have a scrolling border or dynamic border. The contents of cell B1 are on the clipboard now. Select cell A3. Notice that cell A3 has been selected, so there is the green border around it, but cell B1 still has this scrolling border because it's still on the clipboard. And when the contents of a cell are on the clipboard, it means that we can paste them somewhere else. Make sure that cell A3 is still selected. Go to the Home tab of the ribbon and click on Paste. So now we moved this text from cell B1 to cell A3, and now it is more straightforward that the contents of these cells pertain to Mark. By the way, you can use keyboard shortcuts for the Cut and the Paste commands. The shortcut for the Cut command is Ctrl+X, and the shortcut for the Paste command is Ctrl+V. You might have already used these keyboard shortcuts when you were working with different software. Select cell A1, then press and hold your left mouse button while you are in cell A1. Start dragging your mouse down to extend your selection. Once you see the border around cells A1 to A4, release your left mouse button. I have selected multiple cells many times now, so I just wanted to quickly explain to you how you can do that. Let's do another one. Hover over cell A5 and press and hold your left mouse button and drag your selection until cell A7 and now release your left mouse button. So this is how you can select multiple cells. Of course, it's very useful, but later we will talk about this. So at this point, we have some extra information about Mark, but probably we want to have some extra information about Jane as well. Hover over row index 7, and when the cursor changes to this rightward pointing arrow, press the left mouse button to select the whole row, press the right mouse button to get this pop-up menu, and click on Insert to insert a new row. Select cell A3 and either press Ctrl+C or go to the Home tab and press the Copy command. Now select cell A7 and either press the Paste command here on the Home tab or press Ctrl+V. We've copied the contents of cell A3 into cell A7. But in cell A7 we don't want the text to be some extra information about Mark, but we want it to be some extra information about Jane. Notice that the contents of cell A3 are still on the clipboard, so they could still be pasted somewhere else as well. But once we double click onto cell A7 and get into edit mode, the clipboard is cleared, so we can no longer paste this text. I can press Escape to quit edit mode, and actually I can just go to the formula bar, click into it, and change the name Mark to Jane. So now we have 4 cells pertaining to Mark and 4 cells pertaining to Jane. But what if we had 1,000 cells, people? Do we want to insert 1,000 new rows? Of course not. It would be very error-prone and it would take a lot of time. And this is the biggest problem with organizing your data one-dimensionally, so only in one column. Once you have a lot of data and once you have to extend that data, sooner or later you will make a mistake and your data will be corrupt or invalid. And this is something that you have to avoid at all costs. No matter how skillful you are in working with data, if the data is not good and not well structured, then the results will not be good either. Let's select cell D1 and convert the one-dimensional data we have into two-dimensional data. In other words, let's organize this data in a table. Put the text name into cell D1, company into cell E1, extra info into F1, and region into G1. You might have noticed that I didn't use my mouse to select the cells. Instead, I use the arrows on my keyboard. You can navigate in a worksheet using the arrows as well. I will select cells A1 to A4 and press Ctrl+C to copy these cells. You see that now I have the scrolling border around these cells, so they are on the clipboard. I can paste them somewhere. I will select cell D2, press my right mouse button, and from the pop-up menu that appears, I will go to Paste Options and I will select the Transpose option and I will click on it. With the Transpose command, I not only pasted the values starting from cell D2, but I also changed the direction of the values or the copied cells. I copied some vertical cells, but I changed direction to horizontal, so I didn't have to copy the cells one by one. This is a neat trick that Excel can offer you. Let's select cells A5 to A8 and let's press Ctrl+C again. Now these cells are on the clipboard, so there is a scrolling border and there is no scrolling border around cells A1 to A4. Select cell D3 and again press your right mouse button and select the Transpose Paste option. Now we basically have a table, so two-dimensional data, which is much better than the one-dimensional data that we have in column A. Notice that in our small table here, there is no overflowing of contents. The contents only overflow when the neighboring cell is empty. Because G2 is not empty, the contents of cell F2 don't overflow. But in the formula bar, you can see the full contents of cell F2. However, in cell F2 itself, you see only the text some extra. Notice that the contents of cell A2 overflow into cell B2 because cell B2 is empty. I want to see the full contents of the cells in column E's and F, so I will adjust the width of these two columns. Hover your mouse over the border between column E and F. Once your cursor changes to this symbol, so leftward pointing arrow and the rightward pointing arrow, press and hold the left mouse button and start dragging it to the right. Let's make column E 100 pixels wide. It's still not good, so while this symbol is on, press and hold your left mouse button and let's make it 200 pixels wide. You see the pixels in this pop-up tip. Although now we can see the contents of cell E2 and E3, the column is too wide. I will deselect column F because it bothers me that there is this huge green border here. And I will again hover over the border of column E and F. And when this rightward and the leftward pointing arrow symbol appears, I will simply double-click. This way the width of column E was adjusted automatically. We can say that Excel auto-fitted column E. It made sure that we see all the information that is in column E, but column E is not wider than necessary at the same time. Let's do the same with column F, so hover your mouse over the border between columns F and G, and when the symbol appears, double-click. Now column F has been auto-fitted as well. It bothers me that the data in cell A3 overflows until this table, so I've selected cell A3 and I'll press delete. So the contents of cell A3 have been deleted. This is how we delete data from a cell. Now our data is two-dimensional. We are using multiple columns and multiple rows. Now we have a nice overview of our data, and even if we had 1,000 or thousands of salespeople, we would still have the nice overview. And if we needed to add some more information, we could always insert a new column into the table, but it would still be well structured. Let's hover over column E, select the whole column, press your right mouse button and click on Insert. I have inserted a new column between D and F, and I could select cell E1 and let's say I will put the text job into it, and I will put the text salesperson into cell E2 and cell E3. I have quickly copied and pasted the text salesperson, and I will quickly auto-fit the column. If you want this scrolling border to disappear, you can either double-click in any of the cells, or while the scrolling border is there, you can simply press Escape, so the clipboard will be cleared again. But this was not that important. What is important is that we extended this table, so we added a new column to it, but the integrity of the table is still intact. It doesn't matter how many salespeople we have, we can very simply and easily insert new columns to the table or delete existing columns, but our data would still be valid and well structured. Let's actually remove column E, hover over column E, press your left mouse button, press the right mouse button to get the pop-up menu, and while the whole column is selected, click on Delete. And now the column has been removed, and column F became column E, and column G became column F, and so on and so on. So now we have this small table here, and in the first row of the table, we have what is usually called a header. We use headers to group related information. Because of the header in cell D1, we know that the data that we see in column D will represent names. So we sort of grouped the names of the salespeople. Based on the rest of the headers, we know that in column E, we will see company names. In column F, we will see some extra information about the salespeople. And in column G, we will see regions. This is probably not the first table that you see in your life. You could rightfully think that I'm talking too much about data organization, so one-dimensional data, two-dimensional data, organizing the data into tables, and so on and so on. This might be something that is obvious to you. But still, I wanted to talk about this issue because it's very important that you understand why we are organizing our data in tables. And when we work with data, we better explain why we do things in a certain way. Now we know why it is very bad to organize data in a one-dimensional way and why it is very advantageous to organize data in tables or in a two-dimensional way. If you like to think about issues like this, then you're probably a true data person. I'd also like to point out that while we were discussing basic data organization, we also discussed copying and pasting and cutting and pasting, and we also discussed how we can select multiple cells. Because this is a crash course, there are certain time limitations that I have to be aware of. For example, I won't be able to give a detailed explanation of all the pasting options in Excel, but still you could learn about it while at the same time you learned about a basic data organization. Before we move on, I will save my work. And I want to point out something very important. In the description you can find a link to another file as well, and that other file's name is Excel section end.xlsx. While we are progressing through the course, I'm constantly saving my work, and all the work that I've done during the course is saved into the Excel section end.xlsx file. So if something is not clear to you, or something is not working for you, it's always a good idea to check the other file, the end file, and compare it with your file, the file that you're working on. Let's move on now, however, so select the addition worksheet. We have a small table on the addition worksheet. In column A, we see the names of the salespeople. In column B, we see what company they are working for. In column C, we see how many items they sold. And in column D, we see what sales region they represent. What are important for us now are these three numbers. We will add up these three numbers. Before we do that, however, notice that these three numbers are right aligned in the cell by default. They are different than the other cells of the table. In the other cells we have text, so we don't have number values, and these text values are left aligned by default. We can perform different operations on texts than on numbers. For example, we cannot add up text, however, we can add up numbers, so that we can get the total value of some numbers. When we work with data, we have to consider that there are different types of data. When you put some data into Excel, Excel is quite good at guessing what type of data you're using. Later, we'll talk more about data types. For now, what is important is that if Excel thinks that you are putting in a number, the number is right aligned in the cell by default. However, if Excel thinks that you are putting in text, then the text is left aligned in the cell by default. But let's get back on track. We want to add up these three numbers. In other words, we want to perform a calculation on some of our data. In order to perform a calculation in Excel, or to manipulate data, we have to use formulas. Simply put, a formula is a way of doing something with our data. For example, adding up some of our data. Select cell C5 and double-click in it. Type an equal sign. Every formula in Excel starts with an equal sign. If you type an equal sign at the very beginning of a cell, Excel will consider it a cell containing a formula. So Excel will try to perform the calculation or operation designated by your formula. Type 500 plus 600. Then press enter. Select cell C5 again. In cell C5 itself, we see what our formula returned. We added up 500 and 600 and the result is correct. It is 1100. Take a look at the formula bar. Although in cell C5 we see the result returned by the formula, in the formula bar we see the underlying formula. Make sure, of course, that cell C5 is selected for you, because of course the formula bar always shows the underlying formula behind the selected cell. So in the formula bar we still see the formula that we used to arrive at this result. We typed 500, a plus sign, and 600. Excel understands that 500 is a number and also understands that 600 is another number. Between these two numbers, we typed the plus symbol, which is a special symbol. Inside the formula, the plus symbol is the symbol for addition. We could also say that the plus symbol in Excel is the addition arithmetic operator. Let's change this formula. We can double-click into cell C5 and change the formula there, but I will press Escape because I will change this formula in the formula bar. So let's click inside the formula bar, type another plus sign and 550. Then press Enter. Now in cell C5, we see the result of adding up these three numbers. However, we are not very efficient because we are using hard-coded values. A hard-coded value means that you actually type the value inside the formula. So we typed 500, 600 and 550. The alternative would be to refer to cells. Let's delete everything from our formula except for the opening equal sign. I'm editing the formula in the formula bar and you see this pipe character, which means that I'm in now edit mode. I will click on cell C2 and now a few interesting things happened. In the formula bar, a reference to cell C2 has been automatically added. By the way, if you look at cell C5, you see the same thing. The changes I make in the formula bar are reflected in the cell itself as well. Cell C2 now has a bluish scrolling border. I'm not sure how well you can see it, but in the formula bar, the reference to cell C2 is also in blue. Excel is very helpful in giving us these visual aids. Let's type a plus sign and select cell C3. Now in the formula bar, we have a reference to cell C3 as well. The text cell C3 is in red, and you see that cell C3 now has a red scrolling border. Let's type another plus sign. And this time, let's actually type C4. C4 is actually now in purple, and you see that cell C4 now has this purple border. Let's press Enter. The result is still fine, however, our formula is now much better because we are not hard-coding any values. Instead, we are making references to cells. What happens now is that Excel takes the values from the cells that we referred to in our formula and adds up these values because of course we are using the addition arithmetic operators in our formula. Select cell C2 and change the value 500 to 700. Have you actually noticed that our formula has been updated automatically as soon as we change the value? By default, if you change the value of a cell and that cell is referred to in a formula, then Excel automatically updates or recalculates that formula. In our formula in cell C5, we refer to cell C2, so if the value of cell C2 changes, then the formula is recalculated. Also remember that when we were typing the formula, I referred to cells in two different ways. In the case of cells C2 and C3, I simply selected cell C2 and C3 while typing the formula. While in the case of cell C4, I just simply typed C4. But Excel was intelligent enough to understand that I was making a reference to cell C4. And actually, I typed the reference to cell C4 with a lowercase c, however, Excel has adjusted it. In this formula, we are explicitly referring to the cells. We are explicit about referring to cell C2, C3, and C4. There is actually a better way in Excel to perform additions. Let's talk about this, so select the SUM worksheet. On the SUM worksheet, we almost have the same data as on the addition worksheet. The only difference is that on the addition worksheet, I changed the value of cell C2 from 500 to 700, and on the SUM worksheet, it is still 500. We've already discussed what a formula is, but we haven't discussed functions. We can think of functions as predefined formulas. A function usually takes some input and performs some kind of calculation or operation based on the input. In regards to Excel, formulas and functions are sometimes used interchangeably. So you will hear people not really differentiating between the two. And although they are not exactly the same thing, it happens to me as well that I use these terms interchangeably. On the addition worksheet, we have a formula without a function. Of course, I have selected cell C5, and we see that in this formula we are simply referring to three cells and we are using the arithmetic operators for addition to arrive at the result. So this is an example of a formula without a function. However, when we work in Excel, most of our formulas will contain at least one function. The first function we learn about is the SUM function. We can use the SUM function to add up numbers. Select cell C5. Go to the Insert Function command next to the Formulas tab. Press your left mouse button, and now the Insert Function dialog has appeared. I will move it out of the way so I want to see what is happening in cell C5. This is one way of inserting a function or using a function in Excel. In this dialog we see a list of functions here, so we could choose a function from the list. However, we want to search for the SUM function now. Simply type SUM into the search for a function box and then click on Go. In this list now I see the SUM function and it has been selected for me. Below this list you see the description of the currently selected function. So we see SUM, then number 1, number 2, and below this we see a short description of the function adds all the numbers in a range of cells. We'll talk about what a range of cells is, but for now what is important is that based on this description we know that the SUM function adds up numbers. Let's click on OK. Now the function arguments dialog has appeared. Functions usually require some input. The different pieces of input that a function might require are called arguments. The SUM function has an argument called number 1 and also an argument called number 2. Number 1 is in bold, which means that it is a compulsory argument. We have to provide something for the number 1 argument, otherwise the SUM function will not work. The number 2 argument is not in bold, so it means it is an optional argument. Once I've selected the SUM function, Excel has populated automatically a range of cells as the number 1 argument. Once you select a function, Excel usually tries to guess what you want to do with that function. And in this case, Excel guesses correctly, however, we will talk about what this range of cells is a bit later. Below these argument boxes, you see the description of the function again, adds all the numbers in a range of cells. Below that, you see the description of the number 1 argument. Number 1, number 2, and so on are 1 to 255 numbers to sum or add up. This means that the SUM function has 255 arguments. They are called number 1, number 2, number 3, number 4, and so on up until number 255. This means that we could refer to 255 individual cells and add up their values. Or we could hardcode 255 values and add them up. But of course we don't want to hardcode so many values, and actually we don't want to refer to so many cells. Currently the argument called number 1 is selected, but let me select number 2. As soon as I selected the argument number 2, number 3 appeared, and if I select number 3, then number 4 will appear. If I kept doing this, then I would eventually see number 255, but I don't want to see that argument, because we will not use that. Notice that only the argument number 1 is compulsory, this is why it is in bold, all the other arguments are optional. Eventually, we will only use the number 1 argument to add up these 3 numbers. But for now, let's be explicit about what cells we want to add up. From the number 1 argument box, I will delete the colon and C4. On the right side, you see that Excel took the value of cell C2 and processed it. And of course this is correct because the value of C2 is 500. In the middle of the function arguments dialog, you also see the processed value of the number 1 argument. And in the bottom left corner, actually you see the result of the whole formula. So far we are adding up only one cell, so these 3 numbers are the same. By the way, the name number 1, number 2, number 3, and so on are the names of the arguments in regard to the SUM function. Other functions might use similar or the same names as for their arguments, but most functions will use different argument names. Take a look at the formula bar and also in cell C5. When we use the insert function command, then Excel automatically types the opening equal sign, so Excel already starts our formula. But once I selected the SUM function and I provided the number 1 argument as a reference to cell C2, the name of the function has been automatically typed, so SUM has been typed automatically, and inside parentheses a reference to cell C2 has been added. The arguments of a function, so the input that we provide to a function, are inside parentheses. For now, we only use one argument, the argument called number1, so we only see a reference to cell C2 inside the parentheses here. Let's click on OK. In cell C5, we see the result of this formula. But in the formula bar, of course, while cell C5 is selected, we see the underlying formula. Equals sum, and inside parentheses a reference to cell C2. Let's click on the insert function command again while cell C5 is selected. And now we are back to the function arguments dialog. Let's add cell C3 as argument number 2. And then click on OK. Now the formula returned the result of 1100. And in the formula bar you see that now there are 2 arguments. So we provided 2 arguments for the sum function. Cell C2, which is the number 500, and cell C3, which of course has the value of 600. Notice that the arguments, the function arguments, are separated by a comma. If we want to use a function, we don't have to use the insert function command, we can simply edit the function in the formula bar as well. After cell C3, I will type a comma and C4. Notice that when I started editing this formula, a pop-up appeared. Our formula now only contains the sum function. So when I edit the formula, basically I'm editing the sum function. We see the arguments here, number 1, number 2, number 3, and so on and so on. Because there are no brackets around argument number 1, it means that this is a compulsory argument. But there are brackets around argument number 2, number 3, and so on. So this means that these arguments are optional. It is indicated by the brackets that the arguments are optional. However, notice that argument number 3 is in bold. And it is in bold because currently I'm editing argument number 3. So I have typed C4, which is argument number 3, and still I'm in edit mode, and the pipe character is at the end of C4, so is at the end of argument number 3. If I click after C3, then the pipe character moves, and you see that now the argument named number 2 is in bold, so currently I'm editing the argument called number 2. And if I click after C2, or in between C2 actually, then Excel tells me that currently I am editing the argument called number 1. Because now I'm using explicit cell references, so I'm explicit about summing cell C2, cell C3, and cell C4. We see the same visual aids provided by Excel that were provided when we were adding up the numbers without a function, without the sum function. Let's press enter. So now we have arrived at the correct result. We have successfully summed these 3 values. Although now we are using the sum function, we are still quite inefficient with our formula. We have provided 3 explicit cell references and we are using 3 arguments of the sum function. However, we could use only 1 argument if we used a range of cells. Make sure that cell C5 is selected and click on the insert function command. Notice that on the right side, each reference is evaluated, so each value is processed. In the middle, we actually see the sum of these 3 values, and of course the sum of these 3 values now correspond to the overall result of the formula here. I will delete the argument number 3 and the argument number 2 as well. And I will edit the argument number 1. Let me actually just delete everything from here as well. And while I'm still editing argument number 1, I will select cells C2, C3, and C4. Now there is a scrolling border around my selection, but what is important is the number 1 argument here. This time, this argument refers to a range of cells, C2, C4. A range of cells, of course, means multiple adjacent cells. Adjacent means that they are next to each other, so there is no gap in the range. C2 is the beginning of the range. Then I use a colon, which indicates that actually I will add a range of cells here or provide a range of cells here. And after the colon, I typed cell C4, which means that this is the end of the range. Actually, I didn't type anything, of course, because we just selected these 3 cells, but we could actually type this and the result would be the same. You should understand the colon as every cell between the beginning of the range and the end of the range. So every cell that is between cells C2 and C4, and of course the only cell that we have in between them now is cell C3. On the right side, you see that Excel has successfully processed this range of cells. You see curly braces and semicolons, which means that Excel processes this range of cells as an array, but that is not really important now. What is important is that Excel has successfully processed the range of cells. It processed the value 500, this is the value in cell C2, the value 600, which is in cell C3, and the value 550, which is in cell C4. Let's click on OK. The result is correct. However, if I go to the formula bar and click inside the parentheses, you see that because we provided the range of cells, we are using only the argument called number 1. And actually, Excel is quite helpful because it puts a blue border around the range of cells that we refer to in the sum function. I will press Escape so I will not be in edit mode. Go to the Formulas tab, and in the Formula Auditing command group, select Evaluate Formula. The Evaluate Formula dialog has appeared. The Evaluate Formula command can be very useful because Excel shows us the steps it takes to calculate our formula. We've discussed that whenever we type an equal sign in the beginning of a cell, it means that we are typing a formula. Our current formula is made up of the sum function. I will click on Evaluate, and actually the result of the sum function has been returned. So basically Excel calculates this in one step, or at least the Evaluate Formula command shows this as one step, shows this calculation as a one-step calculation. So this doesn't really give us extra information. However, when you work with more complex formulas, the Evaluate Formula command can be very useful because you can see each calculation step. By the way, don't worry about these dollar signs here while referring to cell C5. We'll discuss later what they mean. I will close the Evaluate Formula dialog. So now we know how to use the sum function, and we also know what a range of cells is. We are making good progress, but so far we have only added up numbers. Let's take a look at the other arithmetic operations, so select the Arithmetic Operations worksheet. On this worksheet, we see a very small table. There are a bunch of numbers in column A and a bunch of numbers in column B. The header for column A says number 1 and the header for column B says number 2. Of course, this is not that important. I formatted the headers a bit so now they have a yellow background and the texts number 1 and number 2 are in bold. But don't worry about this now. We'll discuss basic formatting soon enough and I will show you how you can do this. Select cell C2 and add up cell A2 and cell B2. You can use the sum function or you can just use the plus sign as an arithmetic operator. I will just use an arithmetic operator, so I will simply type A2 plus B2 and I will press enter. This is nothing new for us. We are referring explicitly to cells A2 and B2 and I'm using the arithmetic operator, the plus sign, to add these two numbers. Let me actually delete the 2 from cell B2. I just want to show you that when you are typing a formula and you type a letter, Excel gives you suggestions for functions. If the letter here was not B, for example, but S, then Excel would suggest functions that start with an S. If I type a U as well, you see that Excel now suggests using the sum function. And I could select the sum function, but now it would not make sense. However, let me delete everything up until the equal sign. And now I will type SUM. So now I see the suggestions. And now the sum function has a blue background. And if I press tab now, then I select the sum function from the list. Excel capitalized the function name, the sum. And it also added a left parenthesis. So now I can start providing arguments to the sum function. For example, A2, comma, B2. I have to type, however, a right parenthesis or a closing parenthesis when I'm done. And now I can press enter. I just wanted to show you another way of using functions in Excel. So you don't have to always use the insert function command. You can just simply start typing your formula and Excel will help you find the function you're looking for. Of course, typing your formulas or functions by hand requires some experience, so I would suggest using the insert function command instead. Because I want to show you arithmetic operations, I will not use the sum function here, so let me just remove the sum function and have this very simple formula for adding the two numbers. We know how addition works, so now let's see how subtraction works. Let's subtract 300 from 500. In other words, let's subtract cell B3 from cell A3. If I tell you that the subtraction operator is the minus sign, then I think you will be able to type this formula on your own into cell C3. But of course I will type it as well, so equals A3 minus B3 and press enter. So now we have subtracted 300 from 500 and the result is good. In cell C4, let's multiply cell A4 by cell B4. In Excel, the multiplication arithmetic operator is the star sign or asterisk. So if I type equals A4 star B4 and press enter, then I have arrived at the correct result and I have performed a multiplication. Select cell C5 and of course let's divide cell A5 by B5. The arithmetic operator for division is the forward slash, so I will type equals A5 slash or forward slash B5 and I press enter and we have performed our first division. Now you know which symbol or sign stands for which arithmetic operator in Excel, and you also know now how to use the arithmetic operators, so there is nothing else to discuss. Let's move on to the dynamic cell references worksheet. We have a table here. In column A we see the names of the salespeople, in column B the company they are working for, and in columns C, D and E we see how many items they sold in the years 2019, 2020 and 2021 respectively. You might have already guessed that in column F we will do some calculations, and actually we also have column G, which shows us what sales region the salespeople represent. So far we've used dynamic cell references when we referred to cells or when we referred to ranges. We'll only use dynamic cell references for quite some time, so we should discuss what it actually means to use dynamic cell references. What makes a cell reference dynamic? Select cell F2 and sum the range of cells C2 to E2. Of course, I'll do the same. Equals sum. I could press tab now that the sum function has been searched for and is actually selected, but I will just type an opening parenthesis. You see that a pop-up has actually appeared, so Excel guessed correctly that I wanted to use the sum function. And I will simply type C2 colon E2. Of course, I have to type a closing parenthesis, and now I can press enter. So far so good, nothing new has happened. When you see a cell referred to by simply the column letter and the row index, it means that it is a dynamic cell reference. If a cell reference is dynamic, it means that it adjusts itself in case the formula is copied. Make sure that cell F2 is selected and press Ctrl+C or go to the Home tab and click on the Copy command. We have a dynamic or scrolling border around cell F2, so it is on the clipboard. Select cell F3 and either press Ctrl+V or select the Paste command from the Home tab. I will press Escape so we will not have this scrolling border anymore. Now it is easier to see what is going on. Notice that we copied the formula from cell F2, but this has not been copied exactly as it is in cell F2. In cell F2, the argument that we provide to the sum function is the range C2 to E2. However, after copying and pasting this formula into cell F3, the range has been adjusted. So now the range is not C2 to E2, but C3 to E3. And this is actually correct. This is actually what we wanted. Because in cell F3, of course, we want to sum these three numbers. And in cell F2, we want to sum these three numbers. Because we are using dynamic cell references here, and they are sort of the default cell references, once we copy a formula, the column letters and the row indexes are adjusted. The original formula in cell F2 was in row 2 and column F as well, but now what is important that it is in row 2. Then we copied down this formula by +1 row, so we copied it into row 3. And because row index 3 is bigger by 1 than row index 2, the row indexes of the cell references have been adjusted automatically. So +1 was added to them. Instead of C2, we have C3, and instead of E2, we have E3. Let's copy cell F2 again, but this time let's paste it to cell F4. I'll press Escape again so that I will clear the clipboard and we will not see this dynamic border anymore. Notice that this time I pasted the formula 2 rows down, or +2 rows, and the row indexes of our range have been correctly adjusted. So now in cell F4 we are summing the range C4 to E4. This is what dynamic cell references are. It simply means that the column letters and the row indexes are adjusted automatically when you copy and paste your formula. But you don't have to use copy-paste actually. Let's delete the contents of cell F3 and F4. So I selected both cells and then I will press delete. Select cell F2 again. Now it has this green border and you see that in the bottom right we have this green square. Hover over it. When your cursor changes to this black cross or black plus sign, whatever, press and hold your left mouse button and start dragging the formula down. I'm still pressing and holding my left mouse button, but you see that now, if I released it, I would copy the formula to cell F3. But I'll keep dragging it down, and now the border appears around cell F4 again, so now I will release my left mouse button. If you look at the formulas in cells F3 and F4, we see that they have been copied, and the cell references have been adjusted automatically. Let's delete the contents of cell F3 and F4 again. Select cell F2 again and hover over to the bottom right again to this green square. And when we see this black cross or plus sign symbol, then simply double click. Excel automatically copied the formula down. So this time we didn't have to drag anything, we just had to double click. Excel copied the formula down until cell F4, because actually Excel realizes that in the range of cell C5 to E5 there are no numbers, so it makes no sense to copy the formula to cell F5. As you can see, the cell references or the range references have been adjusted automatically and they have been adjusted correctly. I've mentioned that when we are working with dynamic cell references like now, Excel adjusts not only the rows but also the columns when we copy formulas. We will confirm this in a minute. Before that, I just want to repeat that when you see a cell or a range reference like this, so a cell is referred to simply by the column letter and the row index, then it is a dynamic cell reference and it is the default cell reference. If you saw a dollar symbol in front of the column letter or the row index or both, then it would not be a dynamic cell reference anymore. But we will discuss what the dollar symbol is for later. Now select cell C5. We will of course add up the range of C2 to C4 in cell C5. Let's use the sum function, but this time go to the Home tab, go to the Editing command group to the right, make sure that cell C5 is selected and click on the Auto Sum command. Once you do this, you should see that Excel has written the whole formula for you, and Excel tries to guess the range of cells that you want to sum. Excel is correct, so I can just press Enter. The result seems to be good and the formula is okay. So you see that the AutoSum command can be quite convenient. Honestly, I don't use it that much. But if you have to use the sum function a lot, then the AutoSum command can make your life a bit easier. If you hover over the AutoSum, actually not the AutoSum, but this downward pointing arrow next to it, and click on it, then you see that the sum is not the only function that we can use with this auto command, but we have only discussed the sum function for now, so we will not check these other functions now. I just wanted to show this to you, so that you know that there is a command in Excel that you can use with functions, and this command will try to do all the work for you, so it will type the whole formula and it will also try to guess what range of cells you want to work on. But this is not our main focus now. Now we are still discussing dynamic cell references, so make sure that cell C5 is selected. We will not copy paste now, we will just drag this formula to the right. So let's drag it to cells D5 and E5, and let's release the left mouse button. If we take a look at cell D5, we see that the range has been adjusted. But this time, compared to cell C5, the row indexes did not change because we copied or dragged the formula over in the same row. So row index 2 and 4 were not adjusted. But we copied the formula to a different column, so the column letter or the column index was adjusted. Instead of column C2 and C4, what we see in cell D5 is D2 to D4. And in cell E5, we see E2 to E4. In cell C5, so in our original formula, we summed cells that are in the same column, so in column C. So when we copied this formula to the neighboring column, let's say to the +1 column, then the column letter was also adjusted, so we could understand this as C plus 1 equals D. And of course, in cell E5, what we see is column E, so E2 to E4. If in cell C5 we referred to A2 to A4, then in cell D5 we would see B2 to B4, because A plus 1 equals B. But I don't want to confuse you with this. What you should know at this point that by default, so when we are using dynamic cell references, the rows and the columns are adjusted when we copy or drag our formulas over. And of course this is a great thing because it saves us a lot of time. But of course you have to be very careful about this. If your references are not good in the formula that you type, and you copy that formula over, then all your formulas will return erroneous results or bad results. But on the other hand, of course, you just have to make sure to type the formula once without any errors, and then it doesn't matter how many times you copy it, the results will always be good. Now you have some knowledge about how to perform calculations or operations on your data. But you don't know how to format your data or make it visually more appealing. So let's select the basic format in Sheet and let's talk about format in a bit. Select cell A1 and press Ctrl-Shift-Right arrow. Now we have selected the range of A1 to D1, so basically the header of our table here. We have already worked with this table, so I think that at this point it's quite obvious what this table represents. While your header is selected, go to the Home tab of the ribbon and check the Font command group. These are of course commands that let us manipulate the letters or the characters that are in the cell. Let's make the header bold, so while your header is selected, hover over to this letter B, which represents the bold command, and click on it, or you can press Ctrl B. Now the header is in bold, and you see that this B command is selected, so now it has this darker gray background. If you don't like it what you see, you can select the bold command again, so basically you are deactivating it now. But let's activate it again. But this time let's deactivate it by using the undo command, which is in the top left corner if you remember. I hover over this leftward pointing arrow, which is the undo command, and the shortcut for it is Ctrl-Z. You see that now a pop-up appears, undo bold, which means that it will undo the last applied bold command. Let's click on it. And now you see that the bold command has been deactivated. We could also make the header italic. We can click on this I here. And we could also add an underline to it. And if you click on this downward pointing arrow next to the underline command, then you can actually choose double underline. Go to the font field, and actually here if you click on the rightward pointing arrow, you can change the fonts. You see that of course there are a lot of possibilities. I don't want to change the font actually, however we could change the font size. You see that we could make the font size ridiculously big or quite small. I think however that the default 11 for Calibri is good. We also have these two commands to quickly increase or decrease the font size. I will actually deactivate the double underline and also the italic, and I will reactivate the bold font. I could choose a different font color. If I click on this button, the font color button, then the font color has been changed to red. You see that there is this red underline here. But you could click on the downward pointing arrow and choose another color, for example green. And now the header is in green, and you see that under the letter A now, there is this green line. So it means that if I, for example, select cell A2 and press on the font color command, then the font will be in green and not in red as previously. However, I will undo this and I will reselect my header. I will just simply select it with my mouse now. I actually don't want to have a green header, so I want the header to be in black, so I can simply select this black color here, or the automatic option, doesn't matter, the result is the same. However, I want to add a background or a fill to these cells, so to my header, so I will simply click on the fill color command. And now my header has a nice yellow fill, so it is sort of separated from the rest of the table. If you click on this arrow, you can choose a different color for fill, but yellow is fine for me. My whole header is still selected. Now I will press Ctrl-Shift down arrow. So now my whole table is selected. I think I've mentioned earlier that what we see here are not borders, but grid lines. By default on a worksheet, the cells are separated by grid lines. And of course these grid lines are these vertical and horizontal gray lines. We could, however, add borders to the cells, and the borders are actually thicker than the grid lines. So they separate the cells better from each other. Hover over this downward pointing arrow, click on it, and choose the All Borders option. I will deselect my table or this range of cells, so I will just click into cell A6, let's say. And now I'm actually finished with formatting my table, so I've applied some basic formatting to my table. The header is in bold and it has a yellow fill, and all the cells have borders. When I get some raw data, so data that is not formatted at all, usually I apply this quick basic formatting to it, because I can do this very quickly, and it also makes it easier for me to grasp the data or to get a good overview of the data. These are not the only options, however. Go to the font command group and go to the bottom right of this command group. There is this rightward and downward pointing arrow here. If you click on it, you will get the font settings, where you actually have more options for setting the font, giving a border to the cells, giving a fill to the cells, align the cells. And actually you also have the option to format a cell based on its data type, but we will actually talk about this in more detail a bit later. When it comes to formatting your data, the options are almost infinite, but because this is a crash course, we cannot really dig deep into the topic of formatting. We will actually talk about formatting a bit more later in the course, but for now it's enough if you know how to do basic formatting like this, and you know how to reach the font settings. And actually if you click on this one, alignment settings, then you go back to the same format cells dialog, but this time the alignment tab is active, not the font tab. So if you want to do some basic formatting, then go to the Home tab and check what Excel has to offer in the Font command group and the Alignment command group. And now you also know how you can get to the Format Cells dialog so that you can have even more options. I think we are making great progress. At this point, you know some of the basic formatting options that Excel offers, and you also know how to write formulas and how to use functions. But of course, we have only discussed the sum function, so we should discuss some more functions, of course, now. But before that, we'll check what happens if you make a mistake in your formula, for example, a typo. So let's move on and select the Errors worksheet. Let's make some mistakes now so that we'll see some of the error messages that Excel returns. Let's use the sum function to sum these two numbers. However, let's make a typo in the function name. Select cell B1, double-click into it, and type SU, equal sign SU, opening parentheses, A1, colon, A2. Close the parentheses and press enter. Instead of the correct result in cell B1, so instead of 1100, we see hashtag name and a question mark. We also see a green triangle in the top left corner. If you see something like this in a cell, it means that that cell contains a formula that has an error in it. This time Excel actually has returned the name error to us. Let's select cell B1. In the formula bar we see what we have typed exactly, and of course there is no formula that is called SU or SU, so this is the problem. The formula name that we provided does not match any of the formulas that Excel could recognize. Once I selected this cell, to the left of the cell this exclamation mark symbol appeared, and if I hover over it, I have some options to check if I click on this downward pointing arrow. The first thing it shows me that it is an invalid name error, so there is no function with the name of SU. But if you don't know what the invalid name error means, then you can actually check it in the Excel help, so let's click on help on this error. And now here you see some information about the name error. The top reason why the name error appears in the formula is because there is a typo in the formula name. Indeed, we have a typo in our formula, we have a typo in the name of the sum function now. So I will just close this help. Let's go back to these options we have. If I click on Show Calculation Steps, then the Evaluate Formula dialog appears. So basically we activated the Evaluate Formula command. I could click on Evaluate. Now we see that Excel could not make sense of the name SU, so it already returned this name error before doing anything with the range, so before processing the range. If I click on Evaluate again, we see that Excel will not even try to process the range, but it will just return the name error. It's not very helpful now to evaluate the formula, but if you're working with more complex formulas and you get an error, it could be actually helpful to evaluate the formula, but I will close this down now. Let's check out the remaining options that we have here. We could actually just ignore the error, but it is another good idea now because it is a real error, so we don't get a good result. In the future, it might happen that Excel understands something as an error, which is not, so which is deliberate on your part. And in that case, you can go ahead and ignore the error. But now it would not be a good idea because we actually want to show that there is something wrong with this formula, so there is an error in this formula. We don't want to ignore it. We could edit the formula in the formula bar, and there are also the error checking options. Let's click on this. We get to the Excel options dialog. Earlier in the course, we saw this dialog when we selected the File tab on the ribbon and then we selected Options. In the menu, the Formulas section is selected now, and you see that we have some error checking options. And we have an option here, Indicate Errors using this color, and the color is green by default. And I've mentioned that we have this green triangle in the top left corner of the cell, so cell B1 that contains an error. You could change the color of this triangle here. But actually I would advise against that, because the default error indication color is rarely changed. If you change the default color for indicating an error in a formula, then your future colleagues might get confused because everyone expects this green triangle or green corner when a formula contains an error. And if this corner had a different color, then it could be confusing. It would actually also confuse me. But I wanted to show you that there is an option for this as well. But I will click on cancel now. And I will make another mistake. I will select cell B2. And this time I will not use the sum function to add up numbers, but I will use the basic arithmetic operator, and I will add the values of these three cells. So in cell B2, I will start typing equal sign. A1 plus A2 plus A3. And I will press enter. And now I have received a value error. So in the cell, I see hashtag value and an exclamation mark this time. I see the underlying formula in the formula bar. There is also the green triangle, and there is also this exclamation mark. So check what options we have now. And of course the options are the same, but now we have an error in value error. Let's click on help on this error. How to correct a value error. Value or value error is Excel's way of saying there is something wrong with the way your formula is typed, or there is something wrong with the cells you are referencing. The error is very general. Now I can tell you that the problem is with the cell that I'm referencing, or one of the cells that I'm referencing. When we add up numbers without using the sum function, so when we use the plus sign, the arithmetic operator, then we better make sure that the cells that we are referencing in this formula all contain numbers or number values. Because cell A3 is not a number, Excel cannot make sense of this formula. I will close the help actually, and I will delete A3 from my formula. If I press enter now, you see that the correct result has been returned. However, if I add a reference to cell A3 back, then we receive a value error again. I think I've already shown you that it's better to use the sum function. However, there is one more reason why it is better to use the sum function. And the reason is that you will not get the value error even if the reference cells are not all numbers. Select cell B3 and type sum, opening parentheses, A1 to A3, A1 colon A3. Type a closing parenthesis and press enter. Now this time, because we used the sum function, we get the correct or correctish result. 500 and 600 have been added up, but the text mark has been completely disregarded by the sum function. Now you see what a cell looks like if it contains an erroneous formula. And we also discussed what options we have for investigating or correcting these errors. So it's time to move on. And I think it's time to check out some functions, because the only function that we've discussed so far is still the sum function. By the way, don't forget that if you don't get the same result that I get, or you have some problems along the way, then you can always download the Excel section and.xlsx file. In the description you will find the link to the file. Of course, that is the file in which I save all the work that I'm doing during the crash course, at least during the Excel section of the crash course. So be sure to download it and check it out if you have problems along the way. But now we will move forward, so let's select the average sheet. In the table here in column A, we see the names of the salespeople. In column B, the company they are working for. In column C, the items that they sold. And in column D, the region where they work or where they represent the company. By the way, it doesn't matter what items they sell, because we are just learning about Excel formulas and functions. So for us, the calculations are important. So from our point of view, it doesn't matter if they sell books or laptops. What matters is that we have some meaningful numbers for performing some calculations. Notice that I have selected the range of cells C2 to C16. In the bottom right, actually, you see that once I selected the range of cells, Excel already does some calculations on the range automatically. It calculates an average. This is what we'll discuss now. It calculates a count, but we will discuss this later. And it also calculates a sum. We, of course, are very familiar with the sum now. So now you should know that this number 37,570 means that the total number of sold items is 37,570. If you want to get the sum of a range of cells quickly, you can simply select the range of cells and look into the bottom right corner. You don't even have to type a formula for this. So Excel is quite helpful, but most of the times, of course, we need to type formulas because we need to do some actual work. I just wanted to show you that there is a quick and easy way to get the sum of some numbers, for example. But now we will discuss the average formula. Of course, the average formula calculates an average, so it calculates the average of the numbers that we provide for the formula. Like the sum function, the average function requires input, so numbers. Select cell C17 and let's click on the Insert Function command. In this box in the top or field in the top, let's search for the average function and click on Go. Hopefully you found the average function. The average function returns the average arithmetic mean of its arguments, which can be numbers or names, arrays, and so on and so on. What is important for us is that it returns the average of some numbers. Make sure that the average formula is selected for you and click on OK. Because I want to insert the average function into cell C17, Excel correctly guesses the range whose average I want to be calculated. Indeed, I want to get the average of the numbers that are in the range of cell C2 and cell C16. In terms of arguments, the average function is very similar to the sum function. The arguments are named the same way, so number 1, number 2, and so on up until number 255. Only the number 1 argument is compulsory, the rest of the arguments are optional. And as in the case of the sum function, we can use ranges, so most of the time we will only use the number 1 argument. On the right side you see that Excel has processed this range as well. We don't see all the numbers, but we can assume that Excel successfully processed this range. Don't forget that the arguments of a function are just the input that we have to provide to a function so that it can perform a calculation. This time we want to get the average of sold items, so the average of these numbers. We want to know how many items a salesperson sells on average. We can already see the formula result here at the bottom, but of course let's click on OK. So now the result is also written in cell C17. Later in the course we'll talk about how to increase or decrease the decimal places here. For now these 4 decimals are good for us. In cell C17 we see the result of the formula, and of course in the formula bar we see the underlying formula. In this formula, of course, we are using only the average function. If I click inside the parentheses, we see that we provided only the number 1 argument, but it is a range of cells from C2 to C16, and Excel also shows this range to us, this provided range to us with a blue border. I will press Escape, so I will quit edit mode. I will save my progress now, so I will just click on this copy icon or the save command. And now you see that my workbook has been saved. I don't think there is more to discuss about the average function. It is really similar to the sum function. It just performs a different calculation. If you don't know what this calculation is good for, then I will explain it a bit. We altogether have 15 salespeople in this table, and they sold a different number of items. You see that Peter Floyd sold only 500 items, while Paul Rode sold 7,000 items. The average items sold by salesperson is 2,504.6667. So now we know that Peter Floyd is way below the average, and Paul Rode is way above the average. If we check the sum of all these numbers, or all of the sold items, then we see 37,570. But the salespeople sold different number of items. But now we know that the average salesperson sells 2,504.6667 items. Kelly Masters, for example, is right at the average. If all of the salespeople here sold 2,504.6667 items, then we would get the same number for sum, 37,570. I hope my explanation was useful. Basically, once you get the average, then you can see who is around average, so who has average performance, so to say. And you can also see the people who are way below the average, so whose performance is not that good. And you can also see that there are salespeople who are performing way above the average actually. But let's now move on to discussing the min function, so select the min worksheet. The data we have on the min worksheet is the same as the data we have on the average worksheet. We can use the min function to quickly find the smallest number of a range of numbers or range of cells. Select cell C17, click on the Insert Function command, search for min, click on Go. The description says the min function returns the smallest number in a set of values. Make sure that the min function is selected and click on OK. And you see that the min function is also very similar to the sum function in terms of function arguments. It has 255 arguments and all of them are named as number 1, number 2, number 3, and so on up until number 255. Now Excel correctly guessed again what range of cells I want to provide as an argument to the min function. Of course, I want to get the smallest number that is in the range of cells from cell C2 to cell C16. Only the number 1 argument of the min function is compulsory, the rest of the arguments are optional. We see here in the function arguments dialog that only the number 1 argument is in bold. So I just simply have to click on OK, and the smallest number that is contained in the range of cells here has been returned to cell C17. Of course, in the formula bar we see the underlying formula, so we are using the min function. And if I click inside the parentheses, we see that we provided only the number 1 argument, or the argument called number 1. And Excel also shows us with a blue border or blue selection the range of cells that we provided as an argument to the min function. I will press escape, so I will quit edit mode. And actually I think we can just move on to the max function, so select the max sheet. The data in our table is the same as on the min sheet. And of course the max function is the opposite of the min function, so it returns the largest value or largest number that is contained in a range of cells. Let's select cell C17 again. Let's click on Insert Function, but this time let's search for the max function. The max function returns the largest value in a set of values, so it's basically the opposite of the min function. Make sure that the max function is selected here and click on OK. And when the function arguments dialog appears, we see that the arguments are named the same way as in the case of the min function. And once again, Excel correctly guesses the range of cells that we want to provide as an argument to this function. And also note that only the argument named number 1 is a compulsory argument. This is why it is in bold here. Let's click on OK. And now 7000 has been returned, so this is the largest number that we have in this range of cells. And of course, if we select cell C17 again and look at the formula bar, we see the underlying formula. So we are using the max function, and inside the parentheses, we are providing the range of cells C2 to C16. If I click inside the parentheses, we see that only the number 1 argument has been provided. So this range of cells is the number 1 argument. And actually I mentioned it earlier, but in this pop-up, you see the brackets around the number 2 argument, which means that this is an optional argument. There are no brackets around the number 1 argument, so it means that it is a compulsory argument. I will press escape to quit edit mode, and I think we can move on. Notice, however, that the max sheet is the last sheet we see. However, there are these 3 dots next to the max sheet. Let's click on the 3 dots. Now you see that new sheets appeared actually, and the count sheet has been selected, so the sheet next to the max sheet that was previously selected. If you're working in a file like this, where you have a lot of worksheets, Excel cannot show you all the worksheets all the time. But it's not a problem, because in the bottom left corner you have these 2 arrows with which you can navigate through your worksheets. If you hover your mouse over either this leftward pointing arrow or rightward pointing arrow, and you press your right mouse button, the so-called Activate dialog appears. And here you see a list of the worksheets that you have in this file. I could click on Sum, for example, and then click on OK, and Excel navigates me to the Sum worksheet. If I do this again, so if I hover over my mouse to the rightward pointing arrow, press the right mouse button, and select the count sheet and click on OK, then I'm back to the count sheet. So these two arrows are very handy for navigating through the worksheets. However, you can also use the three dots in the bottom left corner or the three dots right in front of the Add New Sheet button. Let me click on these three dots. Now I'm selecting worksheets that are to the right, so to say. But if I go to the three dots that are in the bottom left corner and I click on them, then I'm going back, so I'm going to the worksheets that are on the left. I have to get back to the count sheet, so I will click on these three dots on the right side, so to say, and actually I'm back to the count sheet, so I don't have to navigate anymore. Now that we've discussed how we can navigate through the worksheets, let's select cell C17 and learn about the count function. By the way, the table is still the same, so this is the table that we have seen on the max sheet, for example. Make sure that cell C17 is selected, click on Insert Function, and let's search for count here. The count function counts the number of cells in a range that contain numbers. Let's click on OK when the count function is selected. I will move the function arguments dialog to my right. Excel guessed correctly again the range of cells I want to pass to the count function as an argument. So I want to count the cells that contain numbers in the range from C2 to C16. We can use the count function, for example, for checking if there are gaps in our data. This range of cells includes 15 cells altogether, and all of them contain numbers, so the formula will return 15. But if there was a gap, or one of the cells didn't contain a number, then the result would be less than 15. The arguments of the count function are very similar to the arguments that we saw for the max function, for example. However, the arguments are named differently. The arguments of the count function are named as value 1, value 2, value 3, and so on, up until value 255. In case of the max function, the argument names were number 1, number 2, number 3, up until number 255. But it doesn't really matter what the argument names are. What is important is that we know what we should pass as an argument. So the value 1 argument can contain or refer to a variety of different types of data, but only numbers are counted. Basically means that we can refer to any cell or any range of cells as the value 1 argument. More precisely, we can pass any cell or any cell range to the value 1 argument. But only those cells will be counted that contain a number. Let's click on OK. Select cell C16, and instead of this 670, let's put mark into this cell. And let's press enter, of course. The count function has been immediately updated because it refers to a cell whose value was changed. Because mark is not understood as a number by Excel but as text, the count function returns 14 instead of 15. I have selected the range of cells from C2 to C16, and in the bottom right you see that the average went up a bit after I deleted the last number, or more like changed it to text. And the sum decreased a bit because, of course, I removed the number. What is very, very interesting is that the count is 15 here, while it is 14 here. I will hover over this count on the bottom right corner, and you see the pop-up number of selected cells that contain data. So this count here shows you actually how many cells are currently selected. But the count function that we use here shows us how many of the past cells contain numbers. And this is of course very important. If you select a range of cells, and you can of course also rely on this count of cells that Excel gives to you, but ultimately you have to use the count function if you want to make sure that a range of cells contains only valid numbers. Of course, here it's obvious that cell C16 doesn't contain a valid number, but if you have a lot more data, it is better to use the count function to get to know for sure how many cells contain valid numbers. And if we quickly compare the result returned by the count function and the count of the cells, then we see that there is some discrepancy in the data there is a number missing. And of course this number missing is from cell C16. I think it was 670. So let's delete mark and let's type 670. The last thing I want to talk about regarding the count function, that make sure that cell C17 is selected. In the formula bar now we see our formula. We are using the count function, and if I click inside the parentheses, we see that we are only using the argument named value1. We are passing a range of cells as this value1 argument, and Excel shows us the range that we passed to the count function. I will press escape, so I will quit edit mode. And I think I've told you everything about the count function that I wanted, so let's move on to the data types and formatting worksheet. I think I've mentioned earlier that when we work with data, we work with different types of data. If we want to perform calculations, then of course we need some kind of number or numbers as input. We simply cannot calculate anything if we have texts instead of numbers. I will put my example data into column B. In column A, I have already put a short description next to the future examples of data types and their formatting. Select any blank cell. For example, select cell C4. If you are not on the Home tab of the ribbon, make sure to go to the Home tab and let's check the Number command group. Hover over this field, the Number format field. The description says that we can choose a format for our cells, such as percentage, currency, date, or time. This is not an exhaustive list, however, so let's click on this downward point arrow. In Excel, we can format our cells based on what type of data we put into them, but we can also choose how we want to present that data, so we can change the formatting of a cell. And now I don't mean changing the fill or the background of the cell, but for example, how we show a number. As a simple number, so to say, or as currency, for example. But more on that a bit later. What is important that by default, all the cells have a general format, and it says the general format is a no specific format or non-specific format. As I mentioned earlier, Excel is quite good at differentiating between text and number. A lot of the times you don't even have to change this general format. Excel can work with text or numbers even if the format of the cell is general or non-specific. But actually it is a good practice to be specific about the data that you have in a cell. I will select cell B1. I will double click into it, so I'm in edit mode, and I will start typing a number. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. It is easy to see that this number has 9 digits. 1 is the first digit and 9 is the 9th digit. Let me press enter. Excel actually automatically auto-fitted the column, and this is quite cool, I think, so now we see the whole number. I click on cell B1 and you see that the format of the cell is still general. Now Excel understands that this is a number, but it didn't change the format of the cell. This is actually not a problem. We could perform calculations using this cell or referring to this cell in Excel. Now, however, I will add a 10th digit. I will add a 10th digit to the formula bar. I will add a 0. Now I will press enter. Column B was auto-fitted again, so we see the number in whole again. Still there is no problem, so we see that we have 10 digits. The first digit is a 1 and the 10th digit is the 0. If we select cell B1 again, we see that the format is still general. Now let me add an 11th digit to this number. I will add another 1 here, so this will be the 11th digit. Everything seems to be fine. The format is still general, but we see the number in a whole, so we see that the first digit is a 1 and the 11th digit is a 1. And this is exactly the number that I typed into the cell. Let me copy this number to cell B2. I can see the same number in cell B2 now, of course, and cell B2 also has a general format. Now let me add a 12th digit to the number in cell B2. So I will add a 2, this will be the 12th digit. I will press enter. And something strange happened here. Let's select cell B2. In the formula bar, we see the actual number that I put here. So the first digit is the 1 and the 12th digit is a 2. However, because I didn't change the format of the cell, so the format is still general, After the 11th digit, Excel changes to scientific notation. The number you see in cell B2, so this 1.23457E plus 11, is basically the same as the number that you see in the formula bar, but it is written in a different way. E plus 11 at the end of the number means that this is a huge number. In this case, it means that the first number or first digit is 1, and there are 11 more digits coming after this one, after this first one. Don't forget that we can still see the actual number in the formula bar, only the cell itself changed to scientific notation. Although it looks like a decimal, so 1.2345 and so on, this is not a decimal number. This means that after the 1, 11 more digits come. You might have also noticed that Excel rounded a bit already. Although in the formula bar we see that the actual number is 1, 2, 3, 4, 5, 6, 7, we see that in the cell this 6 was rounded to 7. So actually it was rounded up, sorry, not rounded down. But no matter what you see in cell B2, Excel will calculate with the number that you see in the formula bar. Let's select cell B3 and let's change the formatting of cell B3 to the number format. I will copy the number from cell B1 to cell B3. So now we have an 11-digit long number in cell B3. And actually, when I copied and pasted this number, I also copied the format of the cell. So let me delete this. So let me delete the contents of cell B3. Let me change the format into number again. I will go back to cell B1, press Ctrl+C to copy the number. Then I will select cell B3. But instead of simply pasting it, I will press my right mouse button and I will select the Paste Values option. I will click on it. Now you see a lot of hashtags here, and this only means that Excel cannot show us the whole number. That is Excel's way of telling us that there is a value here that Excel cannot show because the column is not wide enough for it. So this time actually Excel did not auto-fit the column for us, but let's auto-fit the column. I have hovered my mouse over the border of columns B and C. When you see this symbol, so this leftward pointing and rightward pointing arrow, then double click. So the column will be auto-fitted. I will press Escape to clear the clipboard. And now actually we see that the format of the cell was not changed after pasting the number. If you copy the contents of a cell and paste it to another cell, but you use the Paste Values option, then you only copy the values of the cell and you don't copy any of the formatting of the original cell. This is why cell B3 is still in the number format, but cell B1 is in the general format. Excel added 0.00 to our number. We don't need this actually, so we will just decrease the decimals. Hover over the decrease decimal command here and click on it twice. So now we basically see the same thing in cell B1 as in cell B3. We see the same thing in the formula bar as well. So now in cell B3 we have a number that is 11 digits long. But this time we are explicit about the cell having a number format. So not a general format, but a number format. We indicated it to Excel that this cell contains a number. Let me add some more digits to this number in cell B3. I will go up to 15 digits. So the 2 is the 12th digit, the 3 is the 13th digit, the 4 is the 14th digit, and the 5 is the 15th digit. I will press Enter, and this time Excel was kind enough to auto-fit the column. So now we see that because we are using the number format, Excel doesn't have a problem showing a 15-digit long number in the cell. So after 11 digit, we didn't change to the scientific notation as we did in cell B2. One advantage of using the number format if you are working with big numbers like this one is that up to 15 digits, Excel will not have a problem showing your number. But if you stick to the general format, then from the 12th digit, scientific notation will kick in. Select cell B4, it has a general format. Now select cell B3 and copy the contents. Select cell B2 and press Ctrl+V to paste the number or the contents. Now the format of cell B4 has been changed to number format because we copied the number and also its format, so we didn't choose the paste values option, but we just pasted the number with the default option by pressing Ctrl V. I'll press Escape to clear the clipboard. So now we have the same numbers in cells B3 and B4. Let me add a 16th digit to the number in cell B4. So I will add a 6, and this 6 will be the last digit of our number, the 16th digit. I will press Enter. Something strange happened. Indeed, a digit was added to the number, so now this number is a 16-digit long number. But the 16th digit is not a 6, it is a 0. It was rounded down. I can add a 17th digit. I will add a 7. I will press Enter. And you see that now I have 17 digits in cell B4. However, the last digit, the 7, was also rounded down to 0. When you're working with Excel, you have to consider that Excel can give you precision only up to 15 digits. You can work with huge numbers in Excel, but you get precision only up to the 15th digit. After that, Excel rounds down everything to 0. If you want to calculate with really big numbers, then most probably you will use the scientific notation. Actually, we can also use the scientific notation to represent very, very small numbers, but in the crash course we will stick to very big numbers. Even if you don't plan on using the scientific notation, you might receive files that use it. For example, you see in cell B2, we have a 12-digit number, and in the cell it is represented in scientific notation. So you have to be prepared to make sense of the numbers even if you see them in scientific notation. Select cell B5 and type 1 capital E plus 50 and press Enter. The format of cell B5 was changed automatically by Excel to scientific, so to scientific notation, because Excel realized that I used scientific notation here. In the formula bar you see what we typed exactly, 1E plus 50. In cell B5 you see that Excel actually added 2 decimals. We could decrease these decimals if we wanted, or we could increase the decimals as well. But let's not do anything now, so let's keep the 2 decimals. And of course decimal here is a bit misleading because I told you that when you see E plus 50, it means that after the first digit, so after this 1 in this case, 50 more digits come. So this is not a decimal number. This is a huge number. This number is a 1 followed by 50 zeros. And what you see after the decimal point is the first number that follows the number 1. And then the second 0 you see is the second number that follows the number 1. In cell B2 we see that there is a number that starts with the digit 1 and is followed by 11 more digits. However, it is followed by a 2, then by a 3, then by a 4, and so on and so on. But in cell B5 we see that the number is followed by zeros. So the first digit, the first number, this one, is followed by 50 zeros. Let me actually copy this, so I will press Ctrl C, select cell B6, and I will paste the number into it, and I will press Escape to clear the clipboard. So now we have the same numbers in cells cells B5 and B6. We can actually perform calculations using cells with the format of scientific notation. Let's select cell B7 and simply sum cell B5 and cell B6. Let's select cell B7, and for a moment we will disregard the error here. So Excel thinks that there is a problem in this cell, but we will disregard it for now. We see the formula behind the cell, but we see that the calculation was a success, because now we have a number that starts with a 2 and is followed by 50 zeros. So now we see the correct result of summing these 2 numbers. Basically we see that 1 plus 1 equals 2, and the number of zeros following the first digit didn't change. Now let's talk about this error. Actually it is not an error, So let's click on this downward pointing arrow. Excel tells us that formula omits adjacent cells. So basically I use the sum function here, but I'm not summing all the cells that are above the cell in which I have written the sum function. And generally, when you write a sum function, you want to include all the cells that are above this cell. I mean above the cell in which you write the sum function. But here there is no problem at all. I intentionally summed only these two cells, or the values of these two cells. So this is the case when I can go to this exclamation mark, the downward pointing arrow, and I can tell Excel to ignore this error because it is actually not an error. You see that the exclamation mark disappeared and also the green triangle or corner from the bottom left of the cell. I will select cell B8 and I will change the formatting of it to text. And I will put here something like some text, for example, and I press enter. I will select cell B8 again. Now we see that it is still formatted as text, and the text that it contains is left aligned, while all the numbers above it are right aligned. Previously, we didn't use the text format, but it doesn't really matter. If you have text in a cell, it doesn't matter if the format is general or text. However, let me select cell B9, and let me change this to text as well. And I will put a formula here. So let's say that I will sum cells B5 and B6 again. I will close the parentheses and press enter. And something very interesting happened here. Because I changed the format of the cell to text, Excel does not perform any calculations in the cell. Although this is a completely valid formula that I have here, Excel will not evaluate it because I told Excel that this cell contains text. So Excel shows what I put in this text as it is. So far we've talked about text, numbers, the scientific notations, and of course also the non-specific general format. Let's talk about the date format. I will select cell B10 and I will put there today's date 2021-08-01. So this is the 1st of August 2021. I'll press enter. The format of the date changed for me. Maybe it won't change for you, but it did change for me. However, Excel understands this as a proper date. The format of the cell has been changed to date, as you can see. But later in the course, actually, I will show you how you can confirm that Excel truly understands some value as a date and not as text, for example. If you want to change the formatting of the date here, so if you don't want it to have month, day, and forward slashes, you can go to the number command group on the Home tab, and here is the number format command. Let's click on it. So let's click on this rightward and downward point arrow. And here we are on the number tab. This is the format cells dialog. We have already seen this, but we didn't check the number tab. My locale is English, so the United States locale. I usually use this locale for my operating system and also for Office. So for me, dates are presented in the US or American way. But of course, this can be changed. We have this list here, so the type list, so to say, and we can change the format of the date using this list. Above the list, you see that there is a sample, so it basically shows you what the date would look like if you changed the type of it. Let's select the third one. This is actually how I typed my date exactly, so after the year there is a dash, then the month there is a dash, and then there is a day. I will click on OK. Now the date is represented as exactly I have typed it, like this. But actually if you check the formula bar, still the date is represented in the US format. However, this is not a problem. I don't want to make any more changes to my locale or to my settings. It doesn't matter that the date is represented differently in the formula bar and in the cell itself. The main thing is that these are the same dates, so Excel understands that this is a date. And now you know how you can change the representation of the date in the cell if you don't like the default. I will change it back to the American way actually, but it really doesn't matter to me. I will copy this date to cell B11. You know what, actually I will undo this. Still cell B11 is selected, but I will press my right mouse button and I will paste this date as a value. And now something interesting has happened. What we see here is not the date, but a number. 44,409. The format of the cell is general, but it doesn't matter now. What matters is that when you work with Excel, it might happen that you expect to see dates in a column. However, you see numbers like this, something above 40,000, let's say. Excel understands each date as a number. Number 44,409 represents the 1st of August 2021. Let's increase this number by 1 and let's change the format to date. Short date from the list here. Now we have a proper date and this is the 2nd of August 2021. So I increased today's date by 1, which resulted in tomorrow's date. So if you increase the number by 1 in Excel and then you change it to date, then it means that you added 1 day to the date. I will change this back to number, however, and I will decrease the decimals. It is very important that the first date that Excel can understand is 1900, 1st of January. I will put a 1 into cell B11 and I will change the format to short date. And now you see that it is the 1st of January 1900. Now actually I see that if I add 44,408 days to this date, so the 1st of January 1900, then I arrive at today's date. So 44,408 days passed since 1900, 1st of January, if I'm not mistaken. But actually I will copy this date from cell B10 to cell B11 and I will change the formatting to cell B11 to number and I will decrease the decimals because the description in column A says that number behind the date above, so I don't want to confuse you. Now you see that the number 44,409 in Excel represents the date 2021, 1st of August. Let's select cell B12. Let's put 1200 here, so 1200. Let's reselect it and let's go to this number format list. First of all, let's check what we have discussed so far. So what data types or data formatting types we have discussed so far. We've discussed the general format. So this is the default format of a cell. We've also discussed the number format, the short date format, and the text format. Oh, and actually also the scientific format for the scientific notation. The last format I will discuss with you is the currency format. Actually, currency and accounting are very similar. I will select the currency format here. I will decrease the decimals. And now I see $1,200 here, so US dollars here, there is the US dollar symbol, and there is also a thousand separator, a comma acting as a thousand separator. And you can see that the format of the cell is currency. If you want to change the currency symbol, then simply go to the number format command. On the number tab, select currency and change the symbol here. There are a lot of symbols here, so I think you will find what you're looking for. Let's actually change the currency to euro. I'm not sure it matters which one here I choose, but I will go with this one. And I will click on OK. So now instead of $1,200, I have 1,200 euros. Of course, if you look at the formula bar, you see that the number here is still 1,200 or 1,200. The currency format, of course, doesn't change the underlying number or underlying value. It only makes the cell look better. It is not a big number, but of course it's much better that the thousands are separated from the hundreds. And of course, many times it's very useful to know what currency a number represents. I think I've told you all the essentials about data types and their formatting. So let's move on to our next sheet, the filters and sorting worksheet. We have a table here representing sales transactions. In column A, we see the names of the salespeople. In column B, we see what company they represent. In column C, we see how many items they sold. In column D, we see how much profit they generated. In column E, we see the date when the sales transaction took place. And in column F, we see the region where the salespeople work. EMEA stands for Europe, Middle East and Africa, and APAC is short for Asia Pacific. There are quite a few things that we are going to discuss while working on the filters and sorting worksheet. You see that I've changed the background of some of the cells in column C. I gave a green fill or background to the cells with the most sold items, and I gave a red fill or background to the cells with the least sold items. This way we can immediately see our best performers, in this case Paul Rode and Tobias Ferguson, and we can also immediately see our worst performers. I've changed the background of the cells manually, but later we'll see how to do this automatically. Let's, however, select cell C10 and let's add a green fill or background to this cell. You just have to select the Home tab on the ribbon, click on the Fill Color command, and choose light green. Let's say that I've made a mistake and I don't actually want to give a light green fill to this cell. Using the undo command, I can simply undo my last action. I can either press Ctrl Z, the shortcut for the undo command, or I can navigate to the top left corner of the worksheet and click on this sort of backward pointing arrow, which is of course the undo command. Now the cell doesn't have a light green background. Let's say that I realize that it wasn't a mistake and actually I want this cell to be light green. One solution is of course using the Fill Color command again, but I can also use the Redo command. On my Quick Access toolbar, the Redo command is right next to the Undo command. This rightward pointing arrow or forward pointing arrow symbolizes the Redo command. In this little pop-up you see that the shortcut for the Redo command is Ctrl Y. Using the Redo command you can redo or you can reapply what you undid with the Undo command. So I will simply click on this symbol, and now cell C10 again has a light green fill or background. But actually I don't want to give this light green background to the cell, so I will simply press Ctrl Z, which is the shortcut for the Undo command. Now that we've discussed the undo and the redo commands, we can talk about finding and replacing data. This table represents only 16 sales transactions. If I'm interested in the sales transaction belonging to Jane Pearson, then my job is quite easy. I can see that Jane Pearson is in row 8. But if we worked with a bigger table, so for example with a table that has information on thousands or tens of thousands of sales transactions, then it would be quite problematic to find Jane Pearson only by scrolling through the data. Of course, there are better ways in Excel to search for data. Select cell A1, select the Home tab of the ribbon and navigate to the right of the Home tab of the ribbon, and click on the Find and Select command. Then click on Find. The Find and Replace dialog has appeared. I will close this down and I will press Ctrl F. And now the dialog has reappeared. You can use the shortcut Ctrl F to make the Find and Replace dialog appear. We see two tabs here, the Find tab and the Replace tab. Let's first discuss the Find tab. We have a field here, Find What, and of course into this field we just have to type what we are searching for. I will type Pearson into this field, and when I'm done I will click on Find Next. Have you noticed that cell A8 has been automatically selected? This is the cell with the content Jane Pearson, so actually Excel found Pearson for me, or the cell containing Pearson. I will click on Find Next again, and nothing really happens. Cell A8 is still selected. It doesn't matter how many times I click on Find Next. Cell A8 will always be selected because this is the only cell that contains the name Pearson. I will now try search for Pearson 2, so a text that is not contained in the table. I will click on Find Next. And the warning dialog pops up. We couldn't find what you were looking for. Click Options for more ways to search. So I will click on OK. I could click on Options here to refine my search. However, I know that Pearson 2 is not in the table. So it doesn't matter what I do here, it will never be found. So I will click on Options again. And this time I will search for Brooks. I will click on Find Next, and I don't know if you've noticed, but cell A8 has been selected. The cell containing the name Grace Brooks. But Grace Brooks appears in this table twice. You see that in cell A7 we also have a Grace Brooks. I will click on Find Next again, and this time cell A7 has been automatically selected. If I click on Find Next again, then cell A6 is automatically selected. It doesn't matter how many times I click on Find Next. Excel will simply jump between these two cells because these are the only two cells containing the text Brooks. Instead of clicking on Find Next, I will click on Find All. Now a list has appeared and I will resize this dialog, so I will make it bigger. In this list we see the cells in which Excel found the name Brooks. We basically have a small table here that shows us the workbook in which the name Brooks was found, the worksheet on which it was found, the cell in which it was found, and it also shows the underlying values of the cells in which the text Brooks was found. In cell A6, of course, we have a Grace Brooks, and in cell A7 we also have a Grace Brooks. You see that in front of the column letters and the row indexes there are dollar symbols. These indicate absolute cell references, but we will talk about absolute cell references later. So don't worry about the dollar signs here. So we can use the find command to search for some data. And of course it's much better than just scrolling through the data and trying to find what we are looking for without using any commands. And shortly we'll discuss a better way of finding data in Excel. But first I want to briefly talk about the replace command, so click on the replace tab of the find and replace dialog. Actually I don't need this list or table here, so I will just close it. And I will just reopen the find and replace dialog by pressing Ctrl F. I will click on replace again on the replace tab again. In the find what field you have to define what you want to replace. Because of course we use the replace command to replace or change data. Let's say we want to replace Brooks with Beans. Because let's say that the name of the salesperson was changed, so she is not Grace Brooks anymore, but Grace Beans. Make sure that cell A6 is selected for you, so a cell that contains the name Grace Brooks, let it be A6. In the replace with field, I will add the text Beans with a capital B because it's of course a surname. And I will click on replace. Although Excel automatically selected cell A7, let's look at cell A6. In cell A6, the name that we see is Grace Beans, so Brooks was replaced with Beans successfully. Notice that by default, capitalization doesn't matter when we are finding or replacing data. So it doesn't matter that in the find what field I have Brooks with a lowercase b, even though in the cell in cell A6 it was an uppercase B, Excel successfully replaced the surname Brooks with the surname Beans in cell A6. But I want to undo this, so I will use the undo command here on the top left corner. So now in cell A6 I have a Grace Brooks, like in cell A7. I will, however, replace Brooks with Beans again, but this time I will use the replace all command. Excel shows me an information dialog that all done, we made 2 replacements. I will click on OK. And now you see that both Grace Brookses have become Grace Beans. The replace all command can be very useful if there is a systemic error in your data. So if you know, for example, that you have to replace all the Brooks with the Beans in your data, then the replace all command is very useful. But if you want to replace data in a specific cell, then make sure that you select the cell in which you want to replace the data or part of the data and use the replace command instead of the replace all command. The find and replace dialog was the second thing I wanted to discuss while working on this worksheet. Now that we've discussed it, I will close this dialog and we'll start discussing filtering. We can use filters for narrowing down our data or to search for something in our data. Select any of the cells in your table header. You can select cell A1, I will select cell B1, but you could select cell C1 as well, of course. So I will select cell B1. Select the Data tab of the ribbon, navigate to the right side and select the Filter command. Click on it. Notice that all in our header cells a downward pointing arrow appeared in the bottom right corners. This basically means that filters have been added to all of our columns. I will click on the filter in cell B1. We have some options for sorting our data, but we will discuss this later. We have some grayed out options here. Of course, we cannot use them now, so let's talk about the search field and this box that is below the search field. In this box we see all the values that we have in column B except for the header. In this column we only have the values East Sales Company and West Sales Company, and of course the header is company, but the header is excluded. There is a check mark next to the East Sales Company and the West Sales Company, and there is also a check mark next to the option Select All. I will uncheck the East Sales Company. So there is only a check mark next to the West Sales Company now, and there is no check mark next to the Select All option. It was actually changed to sort of a black square. So the check mark was changed into a black square. Let's click on OK. The filter icon that we have in cell B1 has been changed a bit. Now we have a downward pointing arrow and basically this filter icon or filter command icon. It means that we have an active filter here, so we are narrowing down our data. And of course what it means now is that we want to look only at the rows that have the value West Sales Company in column B. Look at the row indexes on the left side. The rows that we see now of our table are in blue, so we see a blue 2, a blue 3, a blue 4, then a blue 7. And actually between rows 4 and 7 we see these two horizontal lines, let's say, which is an indication of rows that were filtered out or data that was filtered out. In rows 5 and 6 we have data pertaining to the East Sales Company, but we are now only filtering for the West Sales Company, so these rows are hidden. The same is true for row 17, that is the last row we have, and all the rows between rows 9 and 14. Let's click on the filter symbol in cell B1 again. This time let's check the East Sales Company, but let's uncheck the West Sales Company, and now let's click on OK. So this time we are narrowing down our search for the East Sales Company. So this time we only see rows that pertain to the East Sales Company. If I click on the filter in cell B1 again, I can actually click on the Select All option, and now there is a check mark next to all the values, so if I click on OK, then I see the whole table again. And notice on the left side that the row indexes are not in blue, so nothing is hidden, nothing is filtered out. Because I'm not filtering out anything, now the filter symbol in cell B1 is the same as the other filter symbols, so I don't have any active filters in any of the columns now. Let's click on the filter in cell B1 again, and this time in the search bar let's search for West. What is interesting now is that I can only see the West Sales Company checked, so there is no East Sales Company, because the value East Sales Company doesn't contain the word or the text West. If I click on OK now, then again I only see the rows pertaining to the West Sales Company. And we see that a filter is active on column B, so we see the filter symbol here. Let's click on the filter again, and now let's click on Clear Filter from Company. I deactivated my filter, so now I see all the rows again. You can actually also find the clear command here next to the filter command. But now it's grayed out because I don't have any active filters, of course. Select cell A1 and let's check the filter. Here we have a bit more data, so in column A we have the names of the salespeople, but we've already discussed how to use the search bar, and you also know how to uncheck or check the names to filter for them. So this time let's check the text filters options. Here we can sort of fine-tune our filtering. Now we will only check one option here. Let's check the ends with option. The custom auto-filter dialog appeared. And let's say that I want to filter for the names that end with beans. In the first row, the ends with option is selected. In the neighboring field, then I typed beans because this is the name that I want to filter for. Basically what I'm doing here is that I will filter for cells whose value ends with beans. I will click on OK. And now, of course, I have filtered for the two Grace beans that we have in the data. Actually, I wanted to change beans back to Brooks, so let me do it just very quickly manually. Okay, now it's better. Let's clear the filter, so let's use the clear command on the data tab of the ribbon, so that we see our whole table again. In both column A and B, we have text values. However, in column C, we have numbers. Let's click on the filter in cell C1. We have the search bar again, and we also see the values that are in column C, but this time these are numbers, not text. However, here we don't have a text filters option, but a number filters option. And the options for filtering are a bit different here. Let's click on the greater than option. The custom auto filter dialog appeared again. And we see that the rows will be shown where the sold items are greater than, let's say, 3000. So in the first field, the is greater than option is selected automatically. And in the neighboring cell, I typed 3000, so we will filter for the rows where the sold items are greater than 3000. Let me click on OK. And indeed, all these numbers are greater than 3000. Let's clear the filter. Select cell D2 and go to the Home tab. You see that the format of cell D2 is accounting. Accounting is very similar to the currency format. In column D, I'm using a currency, but this time not the dollar, but I've selected the Swiss franc. The official international abbreviation of the Swiss franc is CHF. This is why you see CHF on the left side of the cells. From the point of view of filtering, it doesn't really matter if we have a number format, an accounting format, or a currency format. So let's select cell D1 and let's check the filter in cell D1. If I go to the number filters, I can again select greater than. I will type 3000 again and I will click on OK. Now we have a filter for the rows where the profit exceeds 3000 Swiss francs. Now let me clear the filter. I can actually clear it using the filter symbol here, so I will clear the filter from the profit column. But let's also check the sales date filter. You don't have to select cell E1 actually if you want to use the filter in cell E1, but actually I prefer to select the cell where I'm actually filtering. For me it's a bit confusing when cell B1 is selected, for example. However, I'm filtering for data in cell E1, but this is only my problem, so you don't have to do this. But I will select cell E1 and I will check the filtering options for the dates, for the sales dates. Here we have date filters, and yet again we have different options than when we were filtering for simple numbers. We could filter from data from the last year, for example, or from the current year. But let me select the before option now. And now I can actually filter for rows where the sales date is before a certain date. And I even have this date picker on the right side. I will actually pick the 16th of March 2021. And I will click on OK. Now we are filtering for rows where the sales transactions took place before the 16th of March 2021. In cell E3, so notice that now the third row is the first row sort of that we can select. So in cell E3, we have the date 15th of March 2021, which is indeed before the 16th of March. But of course, all the other sales transactions took place before the 16th of March. Let's clear the filter. And let's go back to the filter. Notice that in the box below the search bar, the data is very well structured. When we are filtering for dates, we have these levels, sort of. First comes the year, then the month, and if I click on this plus sign next to January, then I can actually see the individual days in January, from which we have data, of course. If I click on the minus sign, then I will not see the days, but of course I can do the same with February as well, for example. Let's uncheck the select all option. So now no dates are selected, and let me select the 10th of February and let's click on OK. This time I see only the sales transaction that took place on the 10th of February 2021. But let's clear the filter from here. There's more to discuss about filtering, but I think now you know all the essentials about filtering for data. So we can move on to sorting data. Select cell A1 and let's click on the filter in cell A1. We have some options for sorting here. We will check the sort A to Z option and the sort Z to A option. Of course, sort A to Z means that we will sort alphabetically based on this column. So based on the names of the salespeople. Let's click on sort A to Z. Actually, nothing has changed because this table has automatically been sorted alphabetically based on the names of the salespeople. Notice, however, that now the filter symbol changed because we are actually sorting the data, or we use the sort command. Let's click on the filter again, but this time let's sort from Z to A, so in a reversed alphabetical order. And now actually our table has changed. Our table is still valid, so when we change the sorting in column A, then of course the data in the other columns also changed. Previously, row 2 was row 17, but now all the data that used to be in row 17 is in row 2. Select cell A1 and go to the Data tab, and actually we can use the sort commands here as well. So let's sort A to Z now. Now our table looks as it used to look, because now again the data has been sorted alphabetically based on the names of the salespeople. Let's sort now based on the sold items. I will select cell C1 and then I will click on the filter. And I will sort from smallest to largest. So now in the first 3 rows we see the worst performers, or let's say the worst sales transactions. And in the last 2 rows we see our best transactions, or with the most sold items at least. Notice that the sorting from column A has been cleared or deactivated. Because of course now we are sorting based on a different column or based on different criteria. Of course, we could also sort based on profit, so I will click on the filter in cell D1 and I will select the largest to smallest option. And now we see who made the most profit, or which sales transactions made the most profit. And we also see what sales transactions made the least amount of profit. And actually it's quite interesting that although Grace Brooks from the eSales company only sold 800 items, she made more profit than Jane Pearson, who sold 1,000 items. This is why it's a good idea to get different views of our data. For example, to sort based on the sold items and also sort based on the profit as well. Based on the sold items alone, Jane Pearson outperformed Grace Brooks. But if we take a look at the profit generated, then we see that from a point of view of profit, Grace actually outperformed Jane, or at least the sales transaction pertaining to Grace Brooks outperformed the sales transaction pertaining to Jane Pearson. Let's sort now based on the sales dates, so I will select cell E1 and I will click on the filter here. I will select sorting by newest to oldest. So now in the first few rows I see the most recent transactions. These sales transactions were done in April 2021. And in the last rows I see the oldest sales transactions. These 4, for example, were done in January 2021. We have now discussed the essentials of sorting your data as well. Let's actually sort alphabetically based on the names again, so we will get back the original sorting, so to say. And let's actually deactivate all the filters. On the Data tab, if you look at the filter command, you see that it is basically pushed, so this button is pushed, which means that filtering is active for this table. But if I click on it, then all the filters have disappeared. Select any of your header cells, for example cell A1, and press Ctrl-Shift-L. This is a very useful shortcut which activates and deactivates your filters, so if you press Ctrl-Shift-L again, then the filters are deactivated again. But I will press it again because I want to leave this worksheet for you with active filters. Let's move on to the next worksheet now, to the Named Ranges worksheet. On this worksheet, we see the same table that we saw on the previous worksheet. Select cell I1, write a formula using the sum function for adding up all the sold items that we have in the table. I will of course also do it, so pause the video if you want to do it yourself first. Otherwise, I will just start. So equals sum, opening parentheses, and I will simply select the range of cells C2 to C17. I will close the parentheses and press enter. I will select cell I1 again, so this has been nothing new so far. We are using the sum function, and as the first argument of the sum function we pass the range of cells C2 to C17. Excel lets you give meaningful names to ranges. If, for example, you know that you have to use this range of cells C2 to C17 very often in your formulas, then it's worth giving it a meaningful name, and then you can refer to the range of cells in the formulas by the name that you define for it. Go to the Formulas tab on your ribbon and click on the Name Manager command inside the Defined Names command group. The Name Manager dialog pops up. Click on New. In the name field, let's type sold_items. This will be the name of our range. So we will name the range C2 to C17 as sold items. Workbook has been selected as the default scope. We could select a different scope, but workbook is fine. This means that in the whole workbook, if we use the name sold items inside the formula, we will refer then to the range of cells C2 to C17 on the named ranges worksheet. We could add a comment here, but we don't need to add a comment here about this named range. But we have this refers to option, and actually now we are naming the range of cell I1 as sold items because cell I1 is selected for me. Notice that we have the name of the worksheet, named ranges, then an exclamation mark, and then an absolute reference to cell I1. Don't worry about absolute references and the dollar signs, we will discuss them later. What is important now is that you select cells C2 to C17. You can click on this arrow here, and now you can select cells C2 to C17 once you see this new name refers to dialog. So let's do that. Now we can click on this downward pointing arrow, and now you see that we are referring to the range of cells C2 to C17 on the named ranges worksheet. So now we will give the sold items name to this range of cells. And we will be able to refer to this range of cells under the name sold items in all of our formulas in the whole workbook. So I will click on OK. We are back to the Name Manager dialog. So now we have a named range, sold items. I will resize this dialog a bit, and I will make the columns wider. And here we see that the name sold items refers to cells C2 to C17 on the named ranges worksheet. And this is scoped to the whole workbook, which means that this name sold items will always refer to this range of cells in every formula that we write in this workbook. I will click on Close. I will select cell I2, and now I will use the sum function with my named range, so I will simply type equals sum opening parentheses and sold items. When I'm typing the text, Excel gives me suggestions for functions. I have already mentioned this. But once we defined the named range sold items, then Excel can suggest it as well while I'm typing the formula. I can actually press simply Tab now, so I don't have to type out sold items. Notice that the text sold items is in blue, and the range of C2 to C17 is also in blue. So it means that Excel has successfully referred to the named range sold items. I will type a closing parenthesis and I will press enter. And you see that the calculation is the same, so the calculation is still correct. But if you look at the formula bar, you see that now the argument passed to the sum function is the name of this range, so the sold items range, and it's not the actual range, so we are not referring to range explicitly like in cell I1. Usually, actually, I'm quite explicit about the ranges I'm referring to inside functions or formulas. So actually, I prefer using C2 to C17 than a named range like sold items here. However, if you have a range that you have to use in lots of formulas, then it makes sense to name that range and refer to it by its name in your formulas. But of course, it's up to you how often you'll use named ranges. My job is simply to show you how to work with them. We could go back to the name manager and we could add a new named range or edit the selected named range or delete the selected named range. However, I don't want to do any of that. I want to leave this named range for you in the workbook. So I will just simply close this dialog. And now we can move on to the next worksheet, the VLOOKUP worksheet. On the VLOOKUP worksheet, we have two small tables. In the first table, we see the names of the salespeople, and we also see how many items each salesperson sold. In the other table we have, in column D, we have 4 salespeople, so the names of 4 salespeople. And in column E, we have a header sold items, but the neighboring cells are all empty. So we don't know how many items these salespeople sold. You might have guessed that our task here is to find out how many items each salesperson here sold. Of course, now we are not working with a lot of data, so I can see, for example, that Daniel Kin sold 2,300 items. I could also use the find command, so let me just copy the name Daniel Kin. I'll press Ctrl F. I'll paste Daniel Kin here into the find what field, and I will click on find next. So now Excel found Daniel Kin for me, and I see how many items he sold. I will close this and I will press escape so the clipboard will be empty. We also know how to work with filters, so I will press Ctrl-Shift-L while cell A1 is selected. And if I check my filter, I can actually uncheck the select all, so now no one is selected. And I can, for example, search for Daniel Kin. And I can also search for Grace Brooks. Let's say if I click on OK, I see that Daniel Kin sold 2,300 items. And actually we have Grace Brooks appearing twice in the table. So we see that one Grace Brooks sold 800 items and the other one 1,800 items. I will clear the filter, however. So now we know some ways of searching for data. If you search for 1 or 2 salespeople, then filtering could be a good option. But imagine that you're searching for 1,000 salespeople in a table that has 50,000 rows, for example. Filtering is not that effective anymore. You don't want to filter for 1,000 people. What we have to do is to write a formula that can search for the data we are looking for very quickly and efficiently. The function we'll use to achieve this is called VLOOKUP, just like the worksheet here. The V in VLOOKUP stands for vertical, so VLOOKUP is for vertical lookups. A bit later we'll talk about why VLOOKUP performs a vertical lookup. If I had to guess which function is used the most in Excel, I would probably go with SUM or VLOOKUP. VLOOKUP is used profusely. A lot of times we have to search for data. You can imagine, for example, that you are the boss of these salespeople and you have to find out how many items they sold. Select cell E2 and let's write our formula. Actually, let's use the insert function command. Let's search for VLOOKUP. Then click on Go. We have found VLOOKUP and we see the description of it as well. Looks for a value in the leftmost column of a table and then returns a value in the same row from a column you specify. Let's click on OK. We see that VLOOKUP has 4 arguments and 3 of them are in bold, so they are compulsory. Let's check first the lookup value argument. Lookup value is the value to be found in the first column of the table and can be a value, a reference, or a text string. Understand the word string as a series of characters. In short, we have to pass as the lookup value argument the value or the name of the salesperson that we are searching for. Now, instead of typing Daniel Kin here, I will simply refer to cell D2, so I will just select cell D2 here. You see here on the right side that Excel has successfully processed the contents of cell D2, so now we are searching for Daniel Kin. You see that the name Daniel Kin is enclosed in quotation marks. That's because it is text, so we are not searching for a number, but for a text, and we can see it based on the quotation marks. Let's click into the table array field. Table array is a table of text, numbers, or logical values in which data is retrieved. Table array can be a reference to a range or a range name. In short, table array is basically the table in which you are searching for the name Daniel Kin. We will pass a range of cells to the table array argument from A1 to B17. Let's check the call index num argument. Call index num is the column number in the table array from which the matching value should be returned. The first column of values in the table is column 1. Our table where we are searching is in columns A and B. In this context, column A is the column with the index of 1 and column B will have the index 2. If our table was in columns B and C, then column B would be the column with index 1 from the point of view of VLOOKUP. And column C would be the column with the index number 2. But I don't want to confuse you, so I put the table into columns A and B, the leftmost column that we have. Column A will have the column index 1, and VLOOKUP will consider the neighboring column, column B, as having the index 2. It is very important that VLOOKUP looks for a value in the leftmost column of a table. We specified that we are looking for Daniel Kin, and we also specified the range in which we are looking for Daniel Kin. And what happens now is that VLOOKUP will search for Daniel Kin in the leftmost column, so in column A, the column with the index 1, from the point of view of VLOOKUP. We want to get to know how many items Daniel Kin sold, which is in column B. And column B now, of course, has the index of 2, so I will put 2 here. Let's check the range lookup argument as well. Range lookup is a logical value. It means that it can be a true or a false value. If it is a false value, then we will force VLOOKUP to find an exact match. If you force VLOOKUP to find an exact match, then VLOOKUP will only return a result if it finds what you are looking for exactly. For example, now we are looking for Daniel Kin, and indeed there is a Daniel Kin in cell A4. But if in cell A4 we didn't have a Daniel Kin, but a Daniel Kings, for example, so Kings in plural, then VLOOKUP would not return the number of sold items. Most of the times when you use VLOOKUP, you want to force it to find an exact match. So for the range lookup argument, you either have to type false here, and on the right side you see that Excel knows what you mean, because in capitals it indicated the special false value. But instead of false, you can simply type a 0. You can see that the point of view from Excel, 0 is the same as the special false value, and 1 is actually the special true value. I prefer to use 0 here actually, because then I don't have to type the word false. We can already see that VLOOKUP found the number of sold items for Daniel Kin, but of course let's click on OK. The correct result has been returned to cell E2, but if we select cell E2 and look at the formula bar, we will see how the VLOOKUP function is written. I will click after D2, so we see that the lookup value argument is D2, so Daniel Kin. I will click inside this range of A1 to B17, and now we see that the range A1 to B17 here is the table array argument. So this is the table in which we are searching for Daniel Kin. I will click right after the 2, so we see, or sorry, it was right before the 2, but now we see that the 2 is the call index num argument. So it means that we want to return the match from the second column, so from column B in this case. You see that the range lookup argument is in brackets, which means that it is an optional argument, but we provided the value 0 to it, which means that we are forcing VLOOKUP to do an exact match. In other words, VLOOKUP will only return the number of sold items for Daniel Kin if VLOOKUP finds Daniel Kin in the first column or in column A, and exactly Daniel Kin, not any other name. I will press escape, and while I'm still on cell E2, I will click on the evaluate formula command. Here we will see how Excel processes the VLOOKUP function step by step. First, the lookup value argument will be processed. You see that the lookup value is cell D2, so Daniel Kin, and it is underlined here, so if I click on evaluate, this reference will be processed. So now we see that VLOOKUP will search for Daniel Kin in the range of cells from A1 to B17. If VLOOKUP finds Daniel Kin in the first column, so in the leftmost column of the range, then VLOOKUP will return the corresponding value from the second column of the range, which is of course column B here. And the 0 in the end forces VLOOKUP to find an exact match, so to search for or find Daniel Kin exactly, the text Daniel Kin exactly, and not any other form of Daniel Kin. I will click on evaluate again, and this was actually the last step, so basically Excel solved this in 2 steps, at least according to the evaluate formula command. So we see that 2,300, the sold items of Daniel Kin, has been returned. Okay, I will close this. I will now copy down this formula. I will hover over the bottom right corner of cell E2 where we have the formula, and when this black plus sign appears, I will simply double click. It seems that Grace Brooks was found successfully, and also Tobias Ferguson was found successfully. But in cell E4, next to Peter Jackson, we see an error, a so-called NA error. Basically here the NA error means that VLOOKUP was not able to find Peter Jackson in column A. By the way, I told you that in VLOOKUP the V stands for vertical, and we know that when we pass a range of cells or a table to VLOOKUP, then it will search for a value in the leftmost column. So VLOOKUP will search vertically. And of course in this context, lookup is just a synonym for search. So VLOOKUP is basically searching vertically for the value that we specify or for the value that we are searching for. Select cell E3. I know that we have two Grace Brooks in the table, but VLOOKUP successfully found the first Grace Brooks and returned 800. So actually everything looks fine, but not everything is fine. Look at the formula bar and try to guess what my problem is. Also look at cell E2, so select cell E2 and look at the formula bar, and then look at the formula bar when you select cell E3. If you want to think about the problem, then pause the video, because I will tell you now, of course. The problem is that we are using dynamic cell references in cell E2, so when the formula is copied down, then this range of cells, so from A1 to B17, has been adjusted to A2 to B18. D2 was also adjusted to D3, but it is good, because in cell E3 we don't want to search for Daniel Kin, who is in D2 in cell D2, but we want to search for Grace Brooks, who is in cell D3. So in case of the first argument, it is good that we are using a dynamic cell reference. We want the row index to be adjusted to change who we are searching for. Notice that the last two arguments are hard-coded values, so this column index number is the number 2, and with the 0 we are forcing VLOOKUP to find an exact match. Because they are hard-coded values, so we are not referring to any cell, they are not adjusted in any way. You see that the arguments 2 and 0 don't change even after we copied the formula down. But now the problem is that while in cell E2 we passed the correct table range or range of cells to the VLOOKUP formula from A1 to B17, this range was adjusted after we copied the formula down, and in the rest of the cells the table range is not good. Although the results seem correct. Grace Brooks is in rows 6 and 7, so in cells A6 and A7, and our table range here is A2 to B18, so A6 and A7 are included here. That's why VLOOKUP still finds the correct result. Peter Jackson is indeed not in this table, so actually here it doesn't matter that the range was adjusted. Of course it matters, but even if here we had the correct range, then Peter Jackson would still not be in it. Tobias Ferguson is in cell A17, and VLOOKUP searches in the range of cell A4 to B20, so cell A17 is part of that range. But let's search for Abby Wood, so I will just put Abby Wood here. So now she is in cell D6, and let's just quickly drag down this formula. And now we get an NA error, so Abby Wood was not found by the VLOOKUP function, because yet again the range was adjusted, so now VLOOKUP is searching in the range from A5 to B21, while Abby Wood is in cell A2, so she is outside the current range. There are 3 solutions for this problem, and we will discuss 2 of them now. Of course, the problem is that the table range here is always adjusted when we copy down the formula. So let's discuss the first solution for this, so that the range would not be adjusted even if I copied down the formula. The first solution is defining a name for this table. So basically defining a new named range. Select the table, so cell A1 to B17. Go to the Name Manager on the Formulas tab. You see we have the sold items named range already. But of course we want to have a new named range, so click on New. Let's call this range Small Table. And before you click on OK, confirm that the name Small Table will refer to cells A1 to B17 on the VLOOKUP worksheet. So on the worksheet that we are currently working on. Because of the $signs here, this will be an absolute reference, and this is what we need, but we will talk about absolute references later. The main thing is to give a name to the range and make sure that the range is A1 to B17. Then click on OK. So now you should see two ranges here, two named ranges, the small table and the sold items. Click on Close. Let's go back to cell E2. Click right after B17. Delete it. So now we are deleting the table array argument. And start typing small. And I didn't even have to type small. Excel already suggests the small table named range for me. So I will press the down arrow to select it. And once it is selected, so once it is in blue, I will press tab. Actually, you can select it with your cursor as well, but make sure that it is selected and press tab. You see that the text small table is in red and the range is also red here. So our table has a red border. So we see that we are using the correct range here. So Excel is referring to the correct range here, but this time we gave the range a name. After you're finished, you can press enter. And let's copy down the formula again. This time, the sold items of Abby Wood were found. Select cell E6 and look at the formula. The lookup value was adjusted, so now we are looking for Abby Wood. We are looking for the salesperson referred to by cell D6, and it's good that the lookup value was adjusted. So here in cell E2, we were looking for Daniel Kin, who is in cell D2, but after we drag down the formula, in cell E6, we are looking for cell D6. So the lookup value is still adjusted, but the table array argument is not adjusted anymore because we are referring to it by a name, and there is an absolute reference behind this name, but we will talk later about absolute references. So now we see that only Peter Jackson was not found, and it is good because we don't have a Peter Jackson here in column A. We will discuss this NA error as well, but first let me show you the second solution. So using a named range was the first solution for preventing the adjustment of the range or the range of the table here. I will click right after the small table text and I will delete it. And I will select the whole columns A and B. So now the range is A to B, so column A to column B. I will press enter. The formula still returns the correct result, and I will copy down the formula now. And actually everything should look fine because the range of A to B, so from column A to column B, has not been adjusted. If I drag the formula from cell E2 to F2 and I select cell F2, then we see that actually the range of A to B changed to B to C, but it doesn't matter to us now. Let me just delete it because we are simply copying down the formula, so the column indexes are not adjusted. We talked about this when we were discussing the dynamic cell references. So you see that in every cell here, the range is still A to B. Usually it is not a problem to refer to whole columns, but actually I prefer to be specific about my range. So I liked it better when I referred to cells A1 to B17. However, when you see VLOOKUP formulas, in my experience, you will see very often that people are referring to columns instead of specific ranges with row indexes. I still want to talk about two things. One is this NA error here, and the other is why the Grace Brooks with 800 sold items was returned and not the Grace Brooks with 1,800 items. Let's discuss this first. Let's try to visualize what happens step by step. In the formula in cell E3, we are looking for Grace Brooks. We are referring to cell D3, of course, and the salesperson in cell D3 is, of course, Grace Brooks. We tell VLOOKUP that we want it to look for Grace Brooks in columns A and B. It is very important about VLOOKUP that VLOOKUP always searches in the leftmost column of the range that you provide here. Of course, the leftmost column between columns A and B is column A. So VLOOKUP starts searching, and it goes from top to bottom. It checks if cell A1 is equal to Grace Brooks. No, so it goes down a row. Abby Wood is not Grace Brooks, so it goes down, and because Catherine Jones is not equals to Grace Brooks either, it goes down again and again. And finally, it will reach cell A6. In cell A6, of course, we have Grace Brooks, and she is the same Grace Brooks that we have here in cell D3, sorry. At least this is the same text. So we have the text Grace Brooks in cell A6 and also in cell D3. Don't forget that in our formula, we provided the range lookup argument and we provided a 0 to it, so we are forcing VLOOKUP to only find a match if it is an exact match. So if the text Grace Brooks is exactly found in a cell, and only the text Grace Brooks. Because in cell A6, the text Grace Brooks is found exactly, then VLOOKUP happily returns 800 to us. And it doesn't care that there is another Grace Brooks in column A, it found the first Grace Brooks and it returned the sold items of the first Grace Brooks. Don't forget that we are returning 800 because in VLOOKUP, as the third argument, the call index num argument, we specify that the corresponding value from the second column should be returned, and of course the second column here is column B, and the corresponding value for cell A6 is in cell B6, which is 800. It's very important regarding VLOOKUP that if you have duplicates in your data, VLOOKUP will return the first match. Let me rename the Grace Brooks we have in cell A6 to Grace Brooksy, for example. I will press enter. Have you noticed that the formula has been updated in cell E3? Because I changed the value in column A, then the underlying formulas have been updated. And now, because Grace Brooksy is not an exact match of Grace Brooks, VLOOKUP continued the search, and now it stopped at cell A7, which has the text or name Grace Brooks exactly as it is in cell D3. The last thing I wanted to talk about regarding VLOOKUP is this NA error here, so let's select cell E4. Let's hover over this exclamation mark symbol. A value is not available to the formula or function. In this context, of course, it means that Peter Jackson was not found in column A, so an NA error was returned. Let's click on this downward pointing arrow next to the exclamation mark. We see that the error is called value not available error, and we could get help on this error. And here we see that the NA error generally indicates that the formula can't find what it's been asked to look for. So this is exactly what I said. Peter Jackson was not found among the salespeople in column A. So VLOOKUP returned an NA error instead of a correct result or instead of a number of sold items. I will close the help here. I don't think that is a problem that we see an NA error here, but we actually could beautify this error. So we could tell Excel to indicate a more specific error message, but we will discuss it a bit later. Now that you know all the essentials to know about VLOOKUP, it's time to move on to the next worksheet, to the Inserted Tables worksheet. On this worksheet we have the same data or the same two tables we had when we started working on the VLOOKUP worksheet. When we see a range of cells like this one in columns A and B, we immediately think that we are seeing a table. But from the point of view of Excel, it is not a table, but merely a range of cells. We know that we can define a name for a range of cells. And let's do that again. So select cells A1 to B17, and on the Formulas tab, click on the Name Manager and click on New. Let's call this range of cells Test Table. We see that the range goes from A1 to B17 on the Inserted Tables worksheet. So this is perfect for us. Let's click on OK. And I will close this dialog. Select cell E2 and write a formula with VLOOKUP using the Test Table named range. Pause the video to do that because I will actually do that as well, of course. This time actually I will use the insert function command. So let's search for VLOOKUP. The lookup value will be, of course, cell D2 or Daniel Kin. And the table array will be test table. If everything is fine, then on the right side here you should see that Excel has successfully processed the named range test_table. The column index number will be 2, of course, because we want to return the sold items from column B or column 2. And the range lookup should be 0, so it should be false, and we will force VLOOKUP to give us an exact match and an exact match only. By the way, I mentioned earlier that there are special values in Excel, the true and the false values. I will talk more about these values later. Let's click on OK, and let's copy down the formula quickly. Now we see that our formula works as intended, and we used the test table named range, so we were referring to this range. Let's add a new salesperson here. Select cell A18 and put the text Vernon Smith in it. And let's say that Vernon sold 2,000 items. We discussed how to give borders to the cells, but you know what? Let's select, for example, cells A15 and B15. Go to the Home tab, click on the Format Painter command, and now you see this scrolling border around cells A15 and B15. And you should also see that your cursor has been changed to a big white plus symbol and a paintbrush. Select cells A18 and B18 and release your left mouse button. And what happened here is that we copied the format of cells A15 and B15 to cells A18 and B18. So with the Format Painter command, you can simply copy the format of some cells onto other cells. So I didn't have to select cell A18, for example, and manually select a border for it or choose a border for it. So the Format Painter command can be quite useful. It can save you quite a bit of time, and your data will look the same, or your data will still look good. All the cells will have the same formatting. I will copy cell A18 and I will select cell D6. I will press Ctrl V to simply paste Vernon Smith into cell D6. I will deselect cell D6. If you use the default paste option and I press Ctrl V, which is basically the default paste option, then not only the contents of the copied cell, so cell A18, are pasted into cell D6, but also the formatting of cell A18. And because cell A18 has borders, now cell D6 has borders as well. But I don't want to have borders, so I will simply undo this. Notice that cell A18 is still on my clipboard. We see this scrolling border. When cell D6 is selected, press the right mouse button and choose the Paste Values option. And now cell D6 does not have any borders, so only the contents of cell A18 were pasted into cell D6. I will press Enter, so I will clear the clipboard. Let's drag the formula down from cell E5 to cell E6. We get an any error because Vernon Smith was not found by the VLOOKUP function. Don't forget that we are using the test table named range, and this named range refers to cells A1 to B17. We added Vernon Smith to the table, however, and he is in cell A18, so he is outside this range, the test table named range. I will select cell A1, then I will press Ctrl Shift and right arrow. And you know what, actually I don't want these cells to have fill, so I will just change the fill of these cells to no fill. While cell A1 and B1 are selected, press Ctrl Shift down arrow. So now the whole table is selected. Click on the Insert tab and click on the Table command. The Create Table dialog appears. In the first field we have to refer to our table, but we already selected cells A1 and B18, so the correct range is specified here. And there is also an option My Table Has Headers, and indeed our table has headers, the name and the sold items, so we can simply click on OK to insert a table here. From the point of view of Excel, this is a proper table. I usually refer to tables like these as inserted tables. Notice that a few things happened. The most obvious is that Excel gave a formatting automatically to this table. The headers have a light bluish background and the fonts are in white, And the rows are sort of banded rows, so it means that the color of the rows are changing. Notice that a new tab on the ribbon has appeared, Table Design, and this is for formatting our table. If I click outside this table, then the Table Design tab disappears, but if I click again inside the table, then the Table Design tab reappears. We will not spend much time formatting our table here. I just want to show you that there are some nice predefined styles here in the Table Styles command group, sort of. And here you can choose a different style for your table if you don't like the default one. But I will go with the default one actually now. You see that the filters have been activated for our table automatically, which is a nice feature. But I think what is the most important about inserted tables is that at the bottom right corner, you see this bluish or purplish symbol or corner symbol actually. This indicates the end of the range of our table. And actually, when we delete stuff from the table or when we add stuff to the table, this range is resized automatically. Let's go to the Formulas tab and let's click on the Name Manager. Now we have 4 defined names. Excel has automatically assigned the name Table1 to our inserted table. The range of this table is from A2 to B18, so basically the header is excluded. But it is not a problem. We have the named range, the test table, which goes from A1 to B17. Because Vernon Smith is in A18 and the VLOOKUP formula returns an error because we are using the test table named range here and Vernon is excluded from it. We could edit this range and add Vernon to it, but we can also simply use the table1 table in our formula instead of the test table named range. Now actually, let's give a more meaningful name to this table. Let me click on Edit. You see that actually I cannot change the range of it, so it's grayed out, because will Excel adjust this range automatically. I want this range to be named Inserted Table. I want to name this table as Inserted Table. This is not a range of cells anymore, but Excel realizes that it is a proper table. So let me click on OK. I will close this Name Manager dialog. Select cell E2 and instead of Test Table, we should have Inserted Table. Once Excel finds it, I can click on it, double click on it and then I can press Enter and I will copy down the formula. So now we found the sold items for Vernon Smith because he is in the range of the inserted table. Let's add another salesperson here, so let's select cell A19 and let's add Wendy Paulson here. I will press Enter and notice that something very interesting happened. So Wendy Paulson was added to cell A19, but she was added automatically to our inserted table as well. You see that we have this purplish corner symbol in the bottom right corner of cell B19. So now the end of our range is cell B19. Let's say that Wendy sold 2,500 items. I will copy her name here into cell D7 and paste it as a value. Let me scroll up a bit actually. And I will simply drag this formula down. So now Wendy Paulson's sold items were found and we are still using the inserted table name inside our VLOOKUP function. If I go to the Name Manager, I see that indeed the range of this inserted table has been automatically adjusted by Excel, so now it refers to A2 to B19. I will close the Name Manager dialog actually. So the biggest advantage of using inserted table is that their range is automatically adjusted. So if you add new data to them and you refer to them by name in the formulas, then you don't have to do any additional work. When you add new data to your inserted table, it will automatically adjust itself or resize itself or adjust its own range. I mentioned earlier that instead of this NA error, we can show a more meaningful error message to our users. Let's discuss this now. So let's go to the next worksheet, which is the IFERROR worksheet. On this worksheet, we are still working with the same data as on the previous worksheets. In column E, you see that we are using the VLOOKUP formula as we used it previously. However, let's use the IFERROR function now. Let's actually combine the IFERROR and the VLOOKUP functions. I will actually delete this formula from cell E2, and I will click on the insert function command. Let's search for IFERROR. Hopefully you've found it as well. So the IFERROR function returns a value if error, if expression is an error, and the value of the expression itself otherwise. This seems a bit cryptic, I think, but basically we can use the IFERROR function to return more meaningful error messages than the errors. So let's click on it. The IFERROR function has two arguments and both are compulsory. You see that both are in bold here. So the value argument and the value IFERROR argument. Into the value argument, we basically have to write our VLOOKUP function. So let's do it. So VLOOKUP. Notice that there is no equal sign here. So now the VLOOKUP function will be an argument of another function. It will be the argument of the IFERROR function. So we are not putting an equal sign here. If you look at the formula bar, you see that now our formula reads equals IFERROR. So when we pass a function to another function as an argument, we don't use the equal sign anymore. I have to type an opening parenthesis, of course, and then a reference to cell D2. Then comes the table array argument, so I have to refer to the table in which we are searching for Daniel Kin or cell D2. Of course, this will be columns A to B. I want to return the sold items of Daniel Kin, so column index 2 from columns A to B. And actually I want to find an exact match, so I will have to provide a 0 here as well, and I will close the parentheses. Notice that actually the sold items of Daniel Kin were found already. So on the right side you see that this expression, which is basically a function, evaluated to 2,300. So the sold items of Daniel Kin were returned or will be returned. I'll click into the value if error field. Now this is the message that we want to show to the user when VLOOKUP doesn't find a match. So when VLOOKUP throws an error. This message will appear whatever error the formula returns. But in the case of VLOOKUP, we know that an NA error is returned when VLOOKUP cannot find a match. The message should be cannot find a match. But we have to indicate it to Excel that this is a text. So our message is not a number, for example, but it is strictly a text. So we have to use double quotes around our message. So I will type a opening double quote, and then the message cannot find a match. And then I will type a closing double quote. And you see on the right side that once I typed the closing double quote, then Excel was able to process this as a text. And on the right side, after the equal sign, you see cannot find a match enclosed in double quotes. Let's click on OK. And let's actually copy down the formula. Now look at cell E4. Instead of the NA error, we see the text cannot find a match. I will auto-fit column E. So when we use the IFERROR formula, the value IFERROR argument has to be the message that we want to show to the user instead of an error. The first argument of the function of the IFERROR function is the value argument. And in this case, we are using the VLOOKUP function in the value argument. Basically what happens is that the VLOOKUP function is evaluated here, so the value argument is evaluated here, and it either throws an error or not. If it doesn't throw an error, then what is returned by the function, the VLOOKUP function here, will be returned to the cell as well, as you can see in cell E2, E3, and E5. But if the VLOOKUP function returns an error, then instead of the NA error, the cannot find a match text will be returned to the cell. And of course we know that Peter Jackson is not in this table, so it's good that the cannot find a match text is returned. Let's click on the evaluate formula command. First, cell D4 will be evaluated. So we are looking for Peter Jackson, and you see that now the VLOOKUP function will be evaluated. an NA error has been returned, and because an NA error has been returned, the IFERROR function will take the cannot find a match text and it will return it. So it will return the value IFERROR argument and not the value argument. So the text cannot find a match has been returned. I will close this and I will select cell E2 and I will evaluate the formula again. Cell D2 is processed first, so we are looking for Deniakin. Now the VLOOKUP function will be processed. Now this time VLOOKUP returned a number 2300, so it didn't return an error. So in this case the IFERROR function will take what the value argument returned, so 2300. So 2300 has been returned and not the beautified error message. What we are doing here is nesting functions. We are passing the VLOOKUP function as an argument to the IFERROR function. So we are nesting the VLOOKUP function into the IFERROR function. If I click inside VLOOKUP, you will see that the whole VLOOKUP here is the value argument of the IFERROR function. And the cannot find a match text is the value IFERROR argument of the IFERROR function. Notice that the VLOOKUP function also has parentheses, so the arguments of the VLOOKUP function are inside parentheses, and these parentheses are in red actually. But the IFERROR function also has its own parentheses. In Excel you can combine functions. In other words, you can nest functions into each other, and the result can be very complex formulas. But don't forget that whatever the complexity of the formula, you can always use the evaluate formula command to see how Excel processes a formula step by step. Actually, I don't mind if I see an NA error here instead of this beautified error message. By the way, when I say beautified error message, I mean an error message or a message that is more meaningful than a simple Excel error. So I don't mind seeing the NA error here, but I think using the IFERROR function with the VLOOKUP function is a very good opportunity to introduce the nesting of functions. Earlier I've mentioned that we have the true and false special values in Excel, but we haven't really discussed them. But this will change now because we will move on to the next worksheet, to the if worksheet, and we will talk about these logical values. I think the table here that we have is quite familiar to you already. In column A we have some salespeople. We have already seen most of these names, but maybe we haven't seen a George Green yet. But it shouldn't be a problem, so we have the names of the salespeople in column A, and in column B we see what company the salespeople work for or what company they represent. In column C we see how many items they sold, and in column D we see how much profit they generated for our company. Or more likely for the West Sales Company or the East Sales Company, it doesn't matter. In column E we see in what sales region these salespeople are active or in what sales region they are selling the items. What is important for us now is column F, and the header is bonus info. Let's say that we want to write a formula for determining if a salesperson is eligible for a bonus or not. Let's say that if a salesperson made a profit that exceeds 2,000 francs, so more than 2,000 francs, then we want to give that salesperson a bonus, so that salesperson is eligible for a bonus, otherwise the salesperson is not eligible for a bonus. For this we will have to use conditional logic. We have to test a condition. And this condition can evaluate to true or false. In this scenario, the condition is if the salesperson generated a profit that exceeds 2,000 francs. If the salesperson made a profit that is more than 2,000 francs, then we say that the condition is true. So the condition that we test for is true. Otherwise, the test evaluates to false, so it is not true. For the conditional logic, we will use the if function. Select cell F2 and click on the insert function command and search for the if function. The if function checks whether a condition is met and returns one value if true and another value if false. Let's click on OK. The if function has 3 arguments, but only the first one, the logical test argument, is compulsory. The logical test is any value or expression that can be evaluated to true or false. In other words, that it is anything that we can test. And what we will test now is if the salesperson generated a profit that exceeds 2,000 Swiss francs. We are in cell F2, so let's refer to cell D2 here. I will select cell D2. Now you see that it already evaluates to true, but it is not really meaningful now. I'll type a greater than sign and then 2000. And actually you see that this condition evaluates to false because 1300 is less than 2000. So it is not more than 2000, so it is false. I will click on OK, and actually Excel tells me that there is a problem with this formula. Now, there is not really a problem with this formula. I will close this one, and I will go back to the insert function command. But the thing is that Excel doesn't like it that I didn't specify a value if true argument or a value if false argument. So though only this logical test argument should be compulsory, I have to put something here as well to the value of true and to the value of false arguments. Otherwise, Excel will regard this formula as erroneous. So if the profit generated was more than 2,000 Swiss francs, then I want to have the text here eligible for bonus. But because I'm hard-coding text here, so I'm not referring a cell with text, I have to enclose my text in double quotes so that Excel understands that this is a text. It has to understand it as a text. So the value if true argument is the value that is returned if a logical test is true. So this means that if this logical test, so this logical test argument evaluates to true, then this is the text that will be returned. But we see that actually in this case, this argument evaluates to false because Abby Wood only made a profit of 1,300 Swiss francs. So actually the value if false argument will be returned. So it's the value that is returned if logical test is false. And you see here that the logical test argument here indeed evaluates to false. So let me type no bonus here, enclosed in double quotes. And if I click on OK now, then Excel will not complain anymore and I can copy down my formula. And it seems that the formula works well because only those salespeople are eligible for a bonus who made a profit that exceeds 2,000 Swiss francs. Select cell F2. If you look at the formula bar, you see how the if function is written. So this is the first argument, the logical test argument, which is supposed to be the only compulsory argument here. So here we are saying D2 greater than 2000. So this is what we are testing for, if the value in D2 exceeds 2000. If yes, then we say that this condition evaluates to true and the value if true argument or value is returned. But if this logical test, so if this condition evaluates to false, if it is not true, then the value if false argument is returned. Let's change our logical test and let's say that if D2 is greater than 1000, and I will copy down the formula again. So now actually I think the only change is that Abby Wood gets a bonus because everyone else has a profit that is less than 1000 Swiss francs. But let's get back to cell F2 again. And let's say D2 is greater than or equals 1000. So after the greater than sign, simply type an equal sign. And Excel will understand that this is a greater than or equal sign, so the Excel will not want to evaluate a new function, so don't worry about this. So now we are testing if the profit is at least 1000 Swiss francs. So I will press enter and copy down the formula. And now we see that, for example, Jessica Stone is eligible for a bonus and Kelly Masters as well, and also Sarah Parker. We can test for equality as well, so we can say that if the profit that was generated is exactly 1000 Swiss francs, so if D2 equals 1000, and then we will give a bonus, otherwise not. So if I copy down the formula, then only those salespeople are eligible for a bonus who made exactly a profit of 1000 Swiss francs. Not a very sensible approach, but actually what I'm doing here is showing you how you can test for conditions. So how you can test for equality or how you can use the greater than sign. Notice actually that we are using dynamic cell references. So the profit cell, so to say, is always adjusted. In cell F11, for example, we are testing if cell D11 is equal to 1000. While of course originally we were testing cell D2. Let's say that we will give a bonus to those salespeople who made a profit of less than 1000 Swiss francs or exactly a profit of 1000 Swiss francs. Of course, it's not really sensible or realistic. But now you see that only those salespeople don't get a bonus who made too much profit. We can of course use the less than sign in itself. So I can just delete this equal sign here. And now only those salespeople will get a bonus who made a profit of less than 1000 Swiss francs. Now when you see these signs, so the less than sign, the greater than sign, and so on, we can say that we are using conditional operators. Now the last conditional operator I want to show you is the not equals operator. It is a less than sign followed by the greater than sign. So now it means that only those salespeople will not be eligible for a bonus who made exactly a profit of 1000 Swiss francs. So if I copy down the formula, you see that everyone is eligible for a bonus except for Jessica, Kelly, and Sarah, because they have made 1000 Swiss francs of profit each. But everyone else gets a bonus, so the profit has to be less than 1000 or greater than 1000, but if it is exactly 1000 Swiss francs, then you are not eligible for a bonus. So here we say that the profit must not equal 1000 to be eligible for a bonus. Let me select cell F2 and let me change this back to a more meaningful condition. So if the profit was more than 2000 Swiss francs, then the salesperson will be eligible for a bonus. And I will drag down this formula. And now I think we have a sensible approach. Let's click on the Evaluate Formula command. Of course, I have selected cell F2, so you see cell D2 here. This will be processed first, so the value behind cell D2. The next step is that Excel checks if 1300 is greater than 2000, but of course this will evaluate to false. And you see that the if function evaluated to false, or this argument evaluated to false, and because of this the no bonus text is returned. But if I select cell F5 and evaluate the formula, then you see that this first argument will evaluate to true because 200 and 300 is greater than 2000. So now the first argument evaluated to true, and now the eligible for bonus text will be returned. So true and false are special values, not just in Excel actually, but in most, if not all, programming languages. When we are using Excel, and later when we will use VBA, you'll see that conditional logic is extremely important. We have to be able to write testable conditions, we have to test for these conditions, and based on the evaluation of these tests, we make decisions. For example, here we evaluate how much profit a salesperson made, and if it's high enough, this figure is high enough, then we will give the salesperson a bonus, otherwise there will be no bonus. The if function is of course not the only conditional function in Excel. Let's go to the COUNTIF worksheet now. On the COUNTIF worksheet we should have the same data that we had on the if worksheet, but the formulas in column F are already populated. And here actually I'm checking if the profit of the salesperson was greater than or equal to 2,300 Swiss francs. And only those salespeople are eligible for a bonus who made a profit of at least 2,300 Swiss francs. So altogether 3 salespeople will get a bonus based on this if formula. We'll use the COUNTIF formula to count or get the number of salespeople who are eligible for a bonus in one step. Select cell I1 and click on the Insert Function command. Search for COUNTIF. The COUNTIF function counts the number of cells within a range that meet the given condition. So let's click on OK. The COUNTIF function comes with two compulsory arguments, the range argument and the criteria argument. The range argument is the range of cells from which you want to count non-blank cells. So blank cells will not be counted, and of course it is good for us. Now the range, of course, here will be D2 to D17, so the profit figures. And now we have to specify the criteria argument. Criteria is the condition in the form of a number expression or text that defines which cells will be counted. I will provide the condition or the criteria argument as a text now. Inside double quotes, I will type greater than or equals 2300. I'm hard coding the value 2300 here, so I will wrap this condition inside double quotes, and Excel will be able to understand what I want to do. Excel will basically check if D2 is greater than or equals to 2300, and if yes, it will increase the count, and of course the count has to be 0 at the beginning. Then Excel will of course check if D3 is greater than or equal to 2300, and if yes, it will increase the count, and so on and so on. We already see that the result that will be returned will be 3, and of course this is good because only 3 salespeople made a profit of at least 2,300 Swiss francs. I will click on OK, and indeed the formula returned the correct result, and in the formula bar you can see how the formula is written. Let's click on the Evaluate Formula command. Unfortunately, Excel will do this in one step, so if I click on Evaluate, we will see that the number 3 has been returned. But behind the scenes, what happens is what I've just told you. Excel goes over each of these cells and checks if the number behind them is greater than or equals 2300. And if yes, then Excel increases the initial count of 0. And we know that Excel will increase the count at cell D5, at cell D13, and cell D17. So the final result will be 3. So with the COUNTIF function, we simply count cells that meet a certain condition. Now that we are familiar with the COUNTIF function, I don't think that the SUMIF function will be such a great challenge, so let's move on to the next worksheet, to the SUMIF worksheet. On the SUMIF worksheet, we are using the same data that we used on the COUNTIF and in the IF worksheets. This time we want to add up the profit that we made in the APAC region. And of course we want to do this in one step, so we will use the SUMIF function. Select cell I1 and click on the Insert Function command. Search for SUMIF. The SUMIF function adds the cells specified by a given condition or criteria. Let's click on OK. There are 3 arguments here, 2 of them are compulsory, and there is also a third optional one. The range argument is the range of cells you want evaluated. This time the range of cells will be cells E2 to E17. We want to see if the region is APAC or not. And of course the region data, or the information about the region, is in the range of cells E2 to E17, so this is why it is the range argument. Now comes the criteria. Of course, the criteria argument is the condition or criteria in the form of a number expression or text that defines which cells will be added. I will add the text APAC here. And don't forget that when we are using text, then we have to use double quotes. And now let's check the sum range argument. Sum range are the actual cells to sum. If omitted, the cells in range are used. So if we don't specify anything as the sum range, then Excel will try to sum these regions, so the APAC regions, and it doesn't make sense, so we don't have any numbers in this range of cells. So we have to provide the sum range to Excel so that it can actually sum the values where the region is APAC. Of course, this will be the range of D2 to D17, so the profit column. Let's click on OK. Now we see that a profit of 8,900 Swiss francs was made in the APAC region. And to get this, we only had to use the SUMIF function. If I click on Evaluate Formula, we will not get much smarter, because Excel evaluates this formula in one step. However, of course, behind the scenes, what happens is that the default return value, let's say, is 0, but Excel will check the regions here in the range of E2 to E17. And if the region in any of the cells is APAC, so is equal to APAC, then the corresponding cell from the range of cell D2 to D17 is added to the return value. So of course, when the function reaches cell E4, for example, then 800 is added to the return value, and when it reaches E5, then 2300 is added to the return value, and then when it reaches, for example, cell E9, then 1000 is added to the return value, and in the end it seems that altogether a profit of 8,900 Swiss francs was generated in the APAC region. As its name suggests, the SUMIF function is a combination of the sum function and the if function. We are summing values, but we are using conditional logic at the same time. In this case now, we sum only the profit figures if they were generated in the APAC region. Now that we have some experience with conditional functions and now that we understand conditional logic a bit more, I think it's time to check out conditional formatting, so let's go to the next worksheet, the conditional formatting worksheet. We are still using the same data as on the SUMIF worksheet. We have already talked about formatting. Now, conditional formatting is formatting based on conditions. Although it is a simple concept, from the visual perspective, it can enhance our data enormously. Earlier I showed you a table where I added different fields or backgrounds to cells based on the number of items that the salespeople sold. For example, I have added a light green field to the cells with the most sold items. I think I used similar data, so Tobias and Paul Road were the guys who sold the most items back then as well. And I added a red field to the people who sold the least amount of items. I did that manually using the fill color command, but I told you that I will show you how you can do that automatically, and this is the time when I will show you that. And of course, in order to make this automatic, you have to use conditional formatting. Select the range of cells C2 to C17. Make sure that you are on the Home tab of your ribbon and click on Conditional Formatting. A drop-down menu has appeared, and I will choose the Highlight Cells Rules option. And I will click on Greater Than. Actually, as soon as I clicked on this Greater Than option, you see that the Greater Than dialog appeared, but Excel already added some red fill to some of the cells. In the first field, we have to provide a value, so a number here, and based on this number, the cells will be formatted. The text says, format cells that are greater than. And actually I want to format cells that are greater than 6,000. As soon as I finish typing 6,000, you see that there are only 2 cells that have a value that is greater than 6,000. On the right hand side in the field, there are some options for formatting our cells. We can use a custom format, so we can create our own format, but actually I'm satisfied with the default format that Excel suggests. What I will go with is the green fill with dark green text version. As soon as I selected it, you see that now our best performers, so to say, have cells with a green fill and the fonts are also in green. So I will click on OK, and I will deselect this range actually. And now you can see the format well that the conditional formatting applied to these 2 cells. So we tested for a condition. We tested if a salesperson sold more than 6,000 items. If this condition evaluated to true, then the cell was formatted. But as you can see, if the condition evaluated to false, then nothing happened to the cell. I will select cell C2 and I will press Ctrl-Shift down arrow. So now again I have selected the range of cell C2 to C17 and I will add another conditional formatting rule. But this time I will go with less than, and I will say less than 1000. And this light red field with dark red text option is perfect for me, so now if I click on OK, then you see that our best performers have green cells and our worst performers have red cells. Of course now we are measuring performance based on sold items. The result would be a bit different if we did it using the profit column, but using the sold items column is perfect for our purposes. I have selected cell A1 and I will click on the conditional formatting command and on Manage Rules. Now the Conditional Formatting Rules Manager dialog appeared, and you see that we are shown the formatting rules for the current selection, so for cell A1, but of course there are no conditional formatting rules for cell A1, so there is nothing here in this list. However, I can check out this list, and I can say this worksheet. And after I've selected this worksheet, you see that actually two conditional rules are applied. They both apply to cells C2 to C17, but the first rule is that if the cell in the range of C2 to C17 contains a number that is less than 1000, then the format is this red field. And the second rule says that if the cell value exceeds 6000, then the format of the cell should be this green field. We could actually discuss conditional formatting for hours, I think. But the purpose of this crash course is that you get to know all the essential knowledge of Excel. And now I think you know everything that is essential about conditional formatting. You know where to find the command, you know how to apply the command or apply rules, and you also know where you can manage your rules. I will close this dialog, and I think we can proceed to the next worksheet, to the Absolute Cell References worksheet. Before finally discussing what absolute cell references are, I'd like to talk about a few minor things that I might have missed out on up until this point. I think I've mentioned earlier that in the bottom right corner of the worksheet we can zoom in and zoom out of the worksheet. So I can click on this minus sign and I can zoom out of my worksheet so my data will be less visible. By default, the zoom value here is 100%. Most of the time actually I don't change the default zoom, or usually I just make minor adjustments. For example, I zoom into 110 or 120%. But because now I'm producing educational content, I want to make sure that you see everything clearly, so I zoom in a bit more. Or actually a lot more. For example, I will zoom into 190% here. If you're using a big screen or a medium-sized screen, then approximately you should see what I see. However, if you're working with the Excel section start.xlsx file on a small screen, you might want to zoom out of the worksheets, so that you have a better or clearer overview of the data. Zooming in and out of a worksheet was the first minor issue that I wanted to discuss with you. Now I want to show you two shortcuts that I think I haven't shown you before. I will select, for example, cell D19, or you know what, actually I will scroll down and I will select cell D82. If I want to go back to the top of the worksheet, I can of course scroll back, but I can also use a shortcut, so I will scroll down to cell D82 and I will press Ctrl Home. By pressing Ctrl Home, Excel automatically selected cell A1 to me, so it jumped to the top of the worksheet, to the top left corner of the worksheet, so to say. I've already showed you that if you want to select a whole table or a continuous range of cells, then you can select the top left cell, for example cell A1 here, and you can press Ctrl-Shift right arrow and then Ctrl-Shift down arrow to select your whole table or whole range. I will select cell A1 now, and I'll press Ctrl-A. If you select any cell of a continuous range or a table and press Ctrl-A, then your whole range and table is selected and you only have to use one keyboard shortcut for that. Now let's move on and discuss absolute cell references. Let's discuss our data first. We have a table here with a list of salespeople, as usual. In column B, we see what companies they represent. In column C, we see their gross salary in Swiss francs. In case you don't know, gross salary is the salary including taxes. Typically, you cannot spend your whole gross salary because first you have to pay taxes from it. Column D has the header tax multiplicator. The idea here is that each salesperson has to pay 20% tax from the gross salary. So if we multiply their gross salaries with the tax multiplicators, then we will get to know their net salary. Net salary is of course the salary excluding taxes, So this is the actual amount that you receive and you can spend. You see that in column D the tax multiplicator is always 0.8, and the formula in column E is simply a multiplication of the gross salary by the tax multiplicator. Basically here we get 80% of the gross salary. So the idea here is that everyone pays 20% tax. In column E you see the header net salary dynamic references. In all of these very simple formulas we are of course using dynamic cell references. And you might have guessed that what we'll do is in column F we will use the same formulas, however with absolute references. We know that in case dynamic references, when we copy a formula, the cell references are adjusted automatically. In cell E2, we multiply cell C2 by cell D2, but after the formula was copied one row down, then the cell references were automatically adjusted by Excel, so in cell E3, we multiply cell C3 by D3. This has been just a recap, we have already discussed this. Because the tax multiplicator is always 0.8, it would make sense to have the value 0.8 in one cell and to refer to that one cell in all of these formulas. This is of course what we will do in column F. In cell B19 we have the value 0.8, so the value of the tax multiplicator. Let's write our formula into cell F2 and of course let's refer to cell B19 in our formula. So I will just simply multiply cell C2 by cell B19. I'll press enter. The result looks good. Now let's quickly copy this formula down by double-clicking in the bottom right corner. Of course in cell F2, cell B19 is a dynamic reference. So when the formula is copied down, then this dynamic reference is adjusted. And of course this is not good for us because, for example, in cell F7 we are multiplying cell C7 by cell B24, and of course there is nothing in cell B24. To solve this problem, let's select cell F2 and in the formula bar click after the reference to cell B19. Once you're in edit mode, press F4. Excel automatically added $signs in front of the column letter and the row index. We are still referring to cell B19, however now this has become an absolute reference. The $sign in front of the column letter means that the column is locked or the column reference is locked. And of course the $sign in front of the row index means that the row index is also locked. This means that if we copy down this formula, then the reference to cell B19 will never change. Because now this is an absolute cell reference. You don't have to use F4 if you want to make a cell reference absolute. You can manually type the $signs in front of the column letter and the row index. However, using F4 is just more convenient. Let's press enter and let's quickly copy down the formula from cell F2. Now our numbers look good. If you check the formulas in these cells, you see that the reference to cell B19 never changes. However, the cells in column C are adjusted. Because of course in the original formula, cell C2 is a dynamic reference, so when it's copied down, it is adjusted. Let's say that the government changes the tax policy, and now people only have to pay 15% tax. In this case, we have to multiply the gross salary by 0.85 to arrive at 85% of the gross salary. So basically 85% of the gross salary is the net salary and 15% goes to the government. Let's change the value in cell B19, so instead of 0.8 I will put 0.85 here. And of course all the underlying formulas in column F have been automatically recalculated. It is much easier to change one value here than to change all these values to calculate the net salary. Let me change this back to 0.8 however, so we are more consistent. Select cell F2 again, and in the formula bar Click right after the reference to cell B19. Press F4. You see that now the $sign in front of the column letter has disappeared, but we still have the $sign in front of the row index. This is a type of a mixed cell reference, so now we only lock the row index. So the row index will never change, it is locked. However, the column index can change, or the column letter can be adjusted. Press F4 again. This time it is vice versa, so the column is locked, however the row index will be adjusted. If you press F4 again, then you will get the dynamic cell reference back, and if you press F4 again, then we are at the absolute cell reference. Most of the time in Excel you will see either dynamic cell references or absolute cell references, but I wanted to show you that there are actually also mixed references, where either the column is locked or the row index is locked. Mixed references are beyond the scope of this crash course, but it's important that you know that they exist. Press Escape to quit edit mode. This is actually not the first time that we see absolute cell references. For example, if you go to the Formulas tab and you go to the Name Manager, you see that all of our named ranges here and the table that we inserted refer to absolute references. For example, we have this small table named range, and it refers to the range of cells from A1 to B17 on the VLOOKUP worksheet. And now you understand that because this is an absolute reference, whenever we use the small table named range in a formula, we always refer to these cells on the VLOOKUP worksheet. So it doesn't matter if we copy the formula, because this is an absolute reference, so the beginning of the range is an absolute reference and also the end of the range is an absolute reference. This range will never be adjusted in any of the formulas. I think we've reached the end of the discussion about absolute references, so let's move on to the next worksheet, to the pie chart worksheet. When discussing Excel, many people immediately think about charts. Charts are a tool for data visualization. So far we've discussed in the course how we can format our data so that it looks better, so that it's more visually appealing. But charts are of course something different. By using a chart, you can represent your data in a very intuitive way. We could talk for hours about charts actually, it's a huge topic in Excel. But in the crash course we will focus on one specific type of chart, the pie chart, as the worksheet's name suggests. Of course we have some data to work with, so there is a small table here representing the market share of American banks. These are actual market share figures, maybe from the year 2019, but I'm not sure. However, I'm not sure what aspect of market share is represented here. For example, you can calculate market share by the number of customers that the banks have, or by the amount of money or capital that the customers keep in these banks. But it doesn't matter to us what these market share figures actually represent. What matters is that we have 9 market share figures. We have 8 banks with a market share of at least 2%. And then we have a category called Other, which has the greatest market share, almost 56%. And this other category encompasses all the banks that have a market share of less than 2%. Make sure that you select the cell that is a part of your table. Then go to the Insert tab and take a look at the Charts command group. These are the commands for inserting a chart. For us it's enough if we use the recommended charts command, so let's click on it. The Insert Chart dialog appears. It has 2 tabs, the Recommended Charts and the All Charts. As its name suggests, on the Recommended Charts tab, Excel recommends some chart types to us. For example, there is the clustered bar chart. You see that in case of the clustered bar chart, the market share values would be represented by these bars, by these blue bars. A clustered bar chart is used to compare values across a few categories. Use it when the chart shows duration or when the category text is long. In this case, the categories are the names of the banks here. Each category has a corresponding market share value, and of course, the value determines how long the bar would be in a clustered bar chart. So we could use the clustered bar chart to compare the market share of banks. However, I don't like it. It just doesn't look good for this data. The other category on top is a very long bar. Then we have some very short bars and then some medium bars, let's say. I don't like it that these short bars seem so insignificant compared to this very long bar at the top. Let's check out the second recommended chart, the clustered column chart. A clustered column chart is used to compare values across a few categories. Use it when the order of the categories is not important. Actually, the clustered column chart is quite similar to the bar chart or clustered bar chart. But of course, here we would have columns instead of bars. But I don't think that the clustered column chart fits the data either. The other category would be represented by a ridiculously tall column, at least compared to the other columns. And I think the short columns here are even more insignificant compared to this tall column than the short bars compared to this very long bar. These columns are so short that they barely exist. Let's check, however, the third recommendation. Now, this is the pie chart. A pie chart is used to show proportions of a whole. Use it to show numbers that relate to a larger sum and always equal to 100%. Do not use this chart if it contains many slices, as angles are hard to estimate. It seems that for the data we have here, the pie chart is an excellent solution. The market share values here add up to 100%. And of course, we want to show the proportions of market share. The idea behind a pie chart is, of course, that we have a pie here and we have slices. Now, these slices, of course, are the categories, so the banks. We have altogether 9 categories here, so the 8 banks and the other category. And for 9 categories, the pie chart is a good choice. If we had 30 categories, however, then it would probably not be a good choice because we would just have too many slices. Now you might say that these slices are quite narrow here, so it will be hard to infer which slice belongs to which bank. However, there are ways to deal with that and I will show you how. If I clicked on OK, then this pie chart would be inserted onto this worksheet. However, I want to go to the All Charts tab to show you that Excel actually offers a lot of different types of charts. The most common charts are actually the column chart, the bar chart, the line chart, and the pie chart. And sometimes you might see the combination of a column chart and a line chart. In the crash course, of course, we will stick to the pie chart. You see that actually in Excel, the pie chart has a few different versions. It has, for example, a 3D version. Or the pie could be transformed into a donut. Generally, I don't like 3D charts because they can cause more harm than good. So I think quite often the 3D effect actually makes the chart read worse. But the pie chart is an exception for me. I think a 3D pie chart can look very good, but at the same time it can be very informative as well. So I will choose the 3D pie option. If I hover my mouse over this picture, or so the chart preview, then I'll see approximately what the pie chart will look like, and I like this view, or I like this look, so I will click on OK. Our 3D pie chart has been automatically inserted onto our worksheet. And it has been automatically selected. When your chart is selected, then on the ribbon, 2 additional tabs appear, the Chart Design tab and the Format tab. You can also see these handles or circles on the border of your chart. And there are also 3 buttons next to your chart when your chart is selected. And while the chart is selected, Excel also highlights the underlying data. The bank names or the categories are in purple, so they have this purple border. The market share figures here have a blue border. In terms of a chart, we say that this is the series of this pie chart. Think about the series as the actual numbers or figures that we want to represent. Cell B1 has a red border, because that is the name of the series. The title of the chart is also market share. If I hover over it, you see that the chart title pop-up appears, so that we know that this is the chart title element. But if I hover over my pie, you see that the name of the series is also market share. And in a pop-up, I see that the other category or point in the market share series has a value of 55.75%. If I click outside of this chart, then it will not be selected, so these buttons from the right side disappeared. There is no highlight on the underlying data, and the two additional tabs have disappeared from the ribbon. But if I hover over the chart and click on it, then the chart is selected again. We can resize our chart by using the handles. You can hover over a handle, and when this double arrow appears, then you can press and hold your left mouse button and drag your mouse to make your chart bigger or smaller. When you are hovered over your chart and you see these black arrows pointing into 4 directions, then you can press and hold your left mouse button and you can drag your chart on your worksheet somewhere. It's important that the chart is sort of above your worksheet. I could, for example, put some data into cell C18 if I wanted to, despite the fact that it's blocked by my chart. I will select my chart again, and actually I don't have to use the handles to make my chart bigger. I can go to the Format tab, and in the Size command group I can adjust the height and the width of my chart. We have a lot of options in Excel for formatting our chart or changing its design. Make sure that your chart is selected and then go to the Chart Design tab. There is the Chart Styles command group. First, let's check the Change Colors command. If you want to change the color of the slices in your chart, Excel provides a few options here. However, I think I will just go with the default one. Next to the Change Colors command, you see that there are quite a few predefined styles. Currently, Style 1 is selected. But if you hover over, for example, Style 2, then Excel shows you what the pie chart would look like with that predefined style. Style 2 doesn't look so good, I think. However, we can always choose a style and make modifications to it. I usually take this approach because I think that Excel has some very cool predefined styles that I have to only slightly modify to get a very cool chart. Let's check out some other styles, for example Style 3. Now I think Style 3 looks good actually, and probably this is what I will go with now. But you see that there are really a lot of possibilities. I like actually Style 7 as well because I think that it's quite good on the eyes, so it's easy on the eyes. But actually there are more predefined styles. You just have to click on this downward pointing arrow here, and then you will get 2 more. I like Style 9 as well, but let's stick to Style 3. Once you click on the selected style, of course it will be applied to your chart. A lot of people prefer not to have the grid lines on the worksheet when working with charts. Select the View tab of the ribbon. Make sure that your chart is not selected, so for example let's select cell A14, and now we can deactivate the grid lines. So uncheck the grid lines option in the Show command group, and you see now the grid lines have disappeared. I can still select the cells, but the gray grid lines or these gray borders have disappeared. Now actually they are grid lines, so the borders in Excel are considered these. I added the borders to the data here, and you see that these borders didn't disappear. Borders are something that we add manually onto the worksheet. We use the borders command here, but grid lines are there on the worksheet by default. Now actually I don't mind having grid lines even if I work with a chart, but I agree that maybe it's better to deactivate the grid lines when we have a chart. The plain white background I think looks better than a background with grid lines. Let's select our chart and go to the Format tab. On the left side we have a Current Selection command group. And here we have a drop-down menu. Let's click on this downward pointing arrow. In this drop-down menu, we see the chart elements that are currently part of our pie chart. If we select the chart area, then our whole chart will be selected. And we have the handles, for example, so we can resize our chart, or we have these 3 buttons here, but we will discuss these a bit later. Let me select, however, the chart title now. Now you see that the text has been selected, so this title has been selected, and if I wanted, I could edit it. For example, I can say market share in the USA. I just have to click outside the chart title, and now it has been changed. Actually, I clicked on my pie, and the plot area of the chart has been automatically selected. You see here in the drop-down that it says now plot area. Now the plot of the chart is usually the most important part of the chart. You might have heard the expression that some data is plotted on a chart, or a data series is plotted on a chart. So the chart itself in Excel will be in the so-called plot area. We also have the legend. In this style, the legend is on the right side of the chart. The legend helps explain our chart, so it gives information about it. You see that we have squares of different color for the different categories, and the legend makes it obvious what color belongs to what bank. I think that some colors are pretty similar. For example, Truist Bank and PNC Bank have very similar colors. They are here actually. So actually it's a bit hard to differentiate between these two. But don't worry, we will deal with this issue. Let's check the remaining elements of our pie chart. There is the series market share. If I click on this, then the pie or the slices of the pie are selected. And there is one more element, the data labels for the series. You see that the data labels are these squares that show the market share percentages. Our chart doesn't really look good. For example, we cannot see the data series of the narrower slices, but of course we'll deal with this issue as well. There are actually a lot of options for formatting each chart element. For example, now the data labels are selected. I can click on the Format Selection command here, and on the right side a pane appears called Format Data Labels. I have quite a few options for the data labels and also for the text in the data labels. I want to add the category names to the labels. Now the chart is a bit crowded, but we will deal with that later. But now the data labels are more informative. We not only have the legend to explain our chart, but also the data labels. So not only the legend makes it obvious what color goes to what category, but now the data labels make it obvious that the other category, for example, has 56% of market share. I can also change the position of the labels. I could go with inside end, for example. So now the labels are sort of inside the slices. I can go with outside end. And now actually the pie has become a bit smaller, but the data labels now are outside of it. Still the labels here are a bit crowded, but we will deal with everything later. We have also an option Best Fit. You see that in case of some labels, or actually maybe most labels here, Excel automatically put the labels far from the slices or relatively far from the slices, but still these lines going from the data labels to the slices make it obvious what data label goes to what slice. Now our chart is not that crowded anymore. However, I don't want to use this option. I don't think it looks good, so I will actually go with outside end, I believe. And for now, I can just close the Format Data Labels pane. If I select here the plot area and click on Format Selection, then the Format Plot Area pane appears, so this is where I can format my plot area, but for now we don't need this. Each chart element here has its own pane on the right side, so this is how you can find the customization options for each chart element. Let's now discuss these 3 buttons that we have next to our chart when the chart is selected. Let's start with the middle one with this paintbrush. This is the Chart Styles command. This is something we have already discussed. Basically, you get the options that we saw on the Chart Design tab. So you can choose a predefined style for your chart, and you can change the color scheme of your chart if you want to. Let's check out the button at the bottom. So this is a filter button, of course. And here actually, of course, we can filter our chart. So for example, I can take out Citibank. So I will uncheck Citibank and I will click on Apply. And now actually Citibank has disappeared from the chart, but because I've taken out a category, the color scheme also changed. Or actually not the color scheme changed per se, just the colors of the slices. But of course I want to involve Citibank, so I will check it and click on Apply. Let's check this big plus sign on the top. This is the chart elements command. Here we can activate or deactivate chart elements. For example, we can deactivate the chart title. I will just simply uncheck it. So now my chart doesn't have a title, but there is more space for the data labels and also for the pie itself. Let's reactivate the chart title, however. Now actually I don't see the modified chart title, so the chart title is again the default market share, but I don't care about it, to be honest. What is important is that while this chart title is selected or I hover over it, you see this black arrow or triangle that points to the right. Let's click on it. There are some quick options for changing our chart title. By default it is above our pie chart, but we could choose the centered overlay option. However, it would not be good because then it would be blocked by one of the data labels. However, if you click on more options, then the format chart title pane appears. So if you want to format your chart elements, you can either go to the Format tab, select the element from the drop-down and click on Format Selection, or you can use this command here, the Chart Elements command, and you can pretty much arrive at the same place. But I will close this Format Chart title pane now. Let's check the data labels options. So actually I could deactivate the data labels, but I want to reactivate them. Now again, the modifications have been lost, but this is not a problem now. Let's click on the black arrow next to the data labels. Let's select the outside end option. And let's also click on data callout. Now because I clicked on this data callout, the labels are sort of looking like speech bubbles. But I think they look good, and now it's really obvious what label goes to what slice. Let's check the options for the legend as well. We could change its position, but I think that it's good on the right side actually. Of course, if I deactivate it, then we have more space for the pie and the data labels, but I think a legend is a good addition to this pie chart. Let's select the chart area, and let's go to the Format Chart Area pane. I have accidentally clicked on the Chart Elements command. Let's click on the Effects group, and let's expand the 3D rotation options. I mentioned that I usually don't use 3D charts, but I think that a 3D pie chart can actually look very, very cool. We can rotate our pie chart on the x-axis or on the y-axis. The x rotation is now 0 degrees. Let's increase it a bit. So basically we are just turning our pie now. This could be actually very useful. I could turn my pie in a way that the narrow slices are at the bottom. So this way actually I can see the narrow slices a bit better. But I can also say that, I work for JP Morgan Chase, so I want JP Morgan Chase to be at the bottom. And now that I have JP Morgan Chase at the bottom, I can change the Y rotation. Let's increase it. Now the pie is sort of losing this nice 3D effect. So let's actually decrease the Y rotation. And the more I decrease it, the more prominent the 3D effect becomes. I think I will go with the 30 degrees option. Assuming that I work for JP Morgan Chase, now I have a very good perspective, I think. If I have a presentation with this chart, then here I make it obvious that yes, we are JP Morgan Chase, and this is the slice that we have of the pie of the market share. But I can emphasize it even more. I can click on this slice of the pie. Now actually all the series is selected, so let's click on it again on this slice of the pie. And now only the series or the value for JP Morgan Chase is selected. Press and hold your left mouse button and drag it to the bottom a bit. Now you see that actually what will happen when we release the left mouse button is that this slice of the pie will be taken out of the pie. So let's release the left mouse button. So now I make it very prominent that the focus is on JP Morgan Chase. The focus is on the slice that JP Morgan Chase has. Actually, I could maybe decrease the Y rotation a bit more. No, actually I think 30 is good. This is the problem with designing charts. You can get lost in the small details. So actually I will just close this format chart area pane. And the last thing I want to do is to adjust the data labels. Fortunately, we can move the data labels individually. I think the other data label is in a good position, Bank of America as well. I will change JP Morgan Chase, but first I want to take care of this crowded area on the left. I will click on the data label for TD Bank. Now all the data labels are selected, so I have to click on it again. And now I can hover over the border of this data label. And when these 4 arrows pointing at 4 different directions appears, then I can press and hold my left mouse button and drag the label. Maybe I will drag it a bit to the right. Now comes PNC Bank. Now comes the US Bank. I will drag it here. Now comes Tourist Bank. Let's drag it under PNC. Okay, let's drag it here. And Citibank. Maybe Citibank. Oh, I didn't want to move my chart. Maybe Citibank can go here. No, it doesn't look good. Okay, now I think the area is not crowded and now it's obvious what bank has what percentage of the market share. So the last label I want to move is the JP Morgan Chase label. I will move it here, let's say. Or maybe actually I move it a bit more to the top so it will not obstruct the Bank of America slice. Okay, actually I don't like it, so I will move it back here. Okay, I think it's time I don't touch this chart anymore. I'm sure that I could make it look better, but I think it's good enough for us. So by modifying the chart elements a bit and changing the rotation of this 3D pie chart, we can provide a very specific view of the data. In this view of the data, we made JP Morgan Chase quite prominent, while at the same time we can still see the competitors clearly. We basically see that our immediate competitors are Bank of America and Wells Fargo, but at the same time it's also obvious what market share our smaller competitors have. And of course, this other category is still very, very prominent. As I mentioned, we could spend hours working with charts, but this is a crash course, so we should move on to the next topic. So let's select the next worksheet. Actually, it's the last worksheet. So it's the Pivot Data worksheet, and this is our final topic regarding Excel in the crash course. First, let's talk about the data we have. We have 2 tables on this worksheet. On the left side, we have a bigger one that goes until row 1000, and on the right side, we have a smaller one. Each row in the table on the left side represents a sales transaction. In column A, we see when this transaction took place. In column B, we see the salesperson who completed this sales transaction. In column C, we see how many items the salesperson sold. We are only interested in the numbers, so we don't care if these salespeople sell pens or computers or whatever. In column D, we see in what sales region the sales transaction took place. EMEA is short for Europe, Middle East and Africa. APAC is short for Asia Pacific. And LATAM is short for Latin America or South America. In the smaller table on the right, we have a summary of sold items per region. We see that in the EMEA region, more than 670,000 items were sold. In North America, more than 612,000 items, and so on and so on. Let's check the formulas we have in column G. I will select cell G2. I've used the SUMIF function to get the sum of sold items in the EMEA region. Notice that I'm using absolute cell references here, so when I copied down this formula, then the range of D2 to D1000 and C2 to C1000 did not change. We've already discussed the SUMIF function, but let's quickly recap what is happening here. So I have selected cell G2 and I will click on the insert function command. The range argument is the range of cells we want to be evaluated, and this is basically column D. Because of course we want to sum the sold items per region, so we have to check for regions. The criteria is in cell F2. In cell F2 we have the text EMEA. You can see it on the right side as well. So we want to take the values of all the rows where the region is EMEA in column D. Of course we have the sum range argument, and this is the range of cells from C2 to C1000. So these are the actual cells that we want to sum. When the function is evaluated, because in cell D2 we have the text EMEA, and then cell C2 will be added to our sum. But the same is true, of course, for cell D7, for example, because the region here is also EMEA, and then the value of cell C7 is added to our sum, and so on and so on. This is of course only a recap. We have discussed the SUMIF function earlier in the course. In cell G6 I didn't use the SUMIF function but the sum function. I just summed the values in these cells, so we get to know how many items were sold overall by our salespeople. In this small table here we have a summary of our data. Or I could say that this is a view of our data. Here we have a breakdown of sold items per sales region. But maybe I also want to see a breakdown per month or per salesperson. Or maybe I want to know how many items were sold in January in the EMEA region. We could actually start writing formulas to get all these different views or breakdowns of our data. Of course, we would use the SUMIF function profusely. But what if I told you that there is a simpler way to achieve this? Instead of creating these views or breakdowns ourselves, we will use a pivot table to do the job for us. If you check the definition of the word pivot in a dictionary, you'll see something like a central point around which something rotates. A pivot table is a special type of table that enables us to get different views or breakdowns of our data very quickly. I've mentioned earlier in the course that this table on the left and also on the right, but we are interested in the table of the left now, is at this point merely a range of cells from the point of view of Excel. Let's make a proper inserted table out of this data. I will actually remove the fill or background from the header, so I selected my header and then I will choose no fill here. I've selected cell A1, but make sure that you select any cell in your table or in this range of cells. Go to the Insert tab and click on Table. Earlier in the course we have already worked with inserted tables, so this is also just a recap at this point. The Create Table dialog has appeared. Excel has correctly guessed the range of cells which I want to base my table on. And the My Table Has Headers option is already checked. And this is good because indeed we have headers in the first row. So let's click on OK. And let's go to the Name Manager, so go to the Formulas tab and Name Manager. And you see that now we have a table called Table 1, and this is our table here. So this is the table on the Pivot datasheet. Let's give a more meaningful name to our table, so I will give the name Pivot Data to this table. It is generally a good practice to base your pivot tables on properly inserted tables. A bit later I will show you why it is a good practice. But for now, make sure that any cell is selected in your table, go to the Insert tab and click on Pivot Table. Before I click on it, notice that there is a pop-up, Pivot Table, easily arrange and summarize complex data in a pivot table. So we can use a pivot table to arrange data, so to get different breakdowns of our data or different views of our data. And the pivot table will also summarize our data for us. But without further ado, let's really click on this pivot table command. The Create Pivot Table dialog appeared. First we have to choose the data that we want to analyze. By default, the Selected Table or Range option is selected, and this is perfect for us. And Excel also correctly guessed that we want the pivot table to be based on the pivot data table. We can put our pivot table on a new worksheet or an existing worksheet. I want the pivot table to be on a new worksheet, so the default option is perfect for me. When we choose this option, then Excel will create a new worksheet for us automatically with our pivot table in it. And actually this new worksheet will appear to the left of the selected worksheet. So we have this pivot data sheet here selected, and the new worksheet will appear to the left of it. So basically it will be a new worksheet between the pie chart worksheet and the pivot data worksheet. We have an option of analyzing multiple tables, so we could check this option, add this data to the data model. But I will leave it unchecked because this is actually beyond the scope of the crash course. I click on OK now, so my pivot table will be created. Let me navigate to my last worksheet. So we still have the pivot data worksheet, but we have a new sheet, so Excel created a new sheet for us automatically. The name sheet 1 has been assigned to it, and our pivot table is on this sheet. And just I have told you, the new sheet was created to the left of the selected sheet, so it is between the pie chart sheet and the pivot data sheet. Let's give a more meaningful name to this worksheet, for example, pivot table. And let's check what we have here. Believe it or not, we have a pivot table here, but of course this pivot table is empty at this point. Cell A3 has been selected automatically, and actually this is where our pivot table starts. We have some useful instructions here. To build a report, choose fields from the pivot table field list. The pivot table field list is on the right side of this worksheet. If I select, for example, cell F3, which is currently outside of my empty pivot table, then the field list disappears. But if I select any cell that is currently part of the empty pivot table, then the pivot table fields pane appears again. On the pivot table fields pane, we have a search bar that we will not use. What is important for us is what we have below this search bar. You see that here we have our headers. So in our pivot data sheet, we have the header, salesman, salesperson, sold item, sales region. And on the pivot table sheet, we have our headers here. So basically, these are the pivot table fields, or the fields that we can use for our pivot table. In sort of the middle of this pane, we have the text, drag fields between areas below. We have here like 4 boxes, one for the filters, one for columns, one for rows, and one for values. In order to have a meaningful pivot table, we have to drag our fields or our headers to these 4 areas. We don't have to use all of them for a pivot table, but we have to use at least 2 for a meaningful pivot table. I'll hover over the sales region field, and when it gets this green background, then press and hold your left mouse button and simply drag your sales region field to the rows area. Then release your left mouse button. Now we have the sales region field in the rows area, and actually we have our pivot table here. Finally, it's not empty. I will zoom in so you will see it better. So the pivot table still starts on cell A3. We have the text in cell A3 row labels, so this has been added automatically by Excel. And we also have a filter here. So if I click on the filter, I see that I can filter for the regions. We have the region names here, and basically these are the rows of our pivot table. Because we dragged the sales region field to the rows area, then the regions have become the rows of the table. Notice also that because the sales region field is now part of the pivot table, it is checked now. The other fields are unchecked, so it means that they are not part of this pivot table. We also have the text here in cell A8, grand total, but there is no grand total calculation now, because of course our pivot table is just a bunch of region names at this point. To get a meaningful pivot table, we have to put something or set something into the values area. Let's drag the sold items field into the values area. And now finally we have a meaningful pivot table. We have the same breakdown here as we have on the pivot data sheet here. But we didn't have to use any formulas to achieve this. We just had to use a pivot table and drag 2 fields to the appropriate areas. Because the sold items field contains numbers, Excel basically automatically summed the sold items per region in the pivot table that we created. In the values area, you see that the field was renamed to sum of sold items automatically by Excel, and in cell B3 you see the name of the field. We could change the calculation here, but we don't have to, and actually it's beyond the scope of this crash course as well. And actually in this case we need this calculation, so we need to sum the sold items per region. This is what we wanted to achieve. At this point you might say that, okay, a pivot table is nice, but it's not that much work to make this breakdown, for example, on the pivot datasheet. So we just have to write a formula with the SUMIF function. And of course you are right. But as I've mentioned earlier, a pivot table is something that enables us to get different views or breakdowns of our data very quickly. Let's, for example, drag the salesperson field into the columns area. Our pivot table has been instantaneously updated. The rows are still the sales regions, but now we added columns to our breakdown, and each column represents a salesperson. So now we see how many items each salesperson sold in each sales region. And the pivot table automatically sums the values. Let me scroll to the end or to the left of the pivot table. In the last column we actually have a grand total, where still we have the summary of the sold items per region. Of course we could do this manually as well. But instead of writing a bunch of conditional formulas, we just have to drag and drop the fields to the appropriate areas to get very different breakdowns of our data. So actually the pivot table saves us a lot of trouble and a lot of time. I mentioned that the pivot is some sort of a central point around which something rotates. And basically the idea here is that we can play around with our data, we can rotate our data, we can get different views of our data, and we just have to click a few times actually, and move our mouse a bit. We haven't actually checked the filters area yet, so let's drag the sales month field into the filters area. In cell A1, the name of the field appeared, so sales month, and in cell B1 we have a filter. I can select March here, click on OK, and now I only see a breakdown for March. I can also select multiple months, so I have to check the select multiple items option. And now I can check, for example, January, February and March, so the first quarter of the year, and if I click on OK, then basically I have a breakdown for the first quarter of the year. Of course, the idea of the pivot table is that you can drag these fields wherever you want. Now we are filtering for sales month, but maybe we want to filter for salespeople instead. Let's first remove the sales month. So in order to remove a field from the pivot table, you can just drag it outside of the area. And if I release the sales month field here, then we don't have the filter anymore. But actually you can also click on this downward pointing arrow next to a field and select remove field from the drop down. So now we only have a rows area, so the sales region, and we calculate the sum of sold items per sales region or per row. But now I will drag the salesperson field into the filters area, and now I can very easily filter for salespeople. For example, I can select Katniss Coolidge here. And now I have a breakdown of how many items Katniss sold in each sales region. I will actually remove this field, so the filter field. And let me actually move the sales region field to the columns area, so I can just simply drag and drop it. Now we still see the sum of sold items per region, but this is actually not the breakdown I want to see. I will drag the salesperson field into the rows area. So now the salespeople are the rows basically, and in each column we see how many items they sold in the respective sales region. We could filter for the salespeople in cell A4, and we could filter for the regions in cell B3. But what I will do now is drag the sales month field into the rows area. I drag the sales month field under the salesperson field. Because of that, the sales months are nested inside the salespeople. You see that these collapsible buttons appeared next to the salespeople. It means, of course, that we can collapse these fields or expand them. If I collapse Adam Allen, for example, Then I see how many items he sold in each sales region, but I don't see a monthly breakdown of it. But if I collapse the field, then I see how many items he sold in January in APAC and EMEA, LATAM, and so on and so on. I haven't mentioned this yet, but when you select a cell inside your pivot table, so when your pivot table is selected, not only you see the pivot table fields pane, but also two new tabs appear, the Pivot Table Analyze tab and the Design tab. Let's select the Pivot Table Analyze tab, and let's select a cell with a collapsible button, so for example cell A5. In the Active Field command group, there is the Expand field and the Collapse field commands. I could collapse these fields manually, one by one, but if I click on the Collapse field command, then all the collapsible fields are collapsed in my pivot table. And if I click on the Expand field command, then all the fields are expanded, so I don't have to expand them manually, one by one. You might have noticed something interesting. We only have the first quarter here, so a breakdown of the first quarter. And this is because earlier the sales month field was a filter field. And if you remember, we filtered for the first quarter for January, February, and March earlier. And actually, if you check the sales month field in the Pivot Table Fields pane, then you see that on the right side of it, there is the filter icon. So it means that we are filtering for data or filtering out some data. Let's click on this downward pointing arrow. And let's click on Clear Filter from Sales Month. So now there is no filter on the sales month field anymore. So now we see a breakdown of all the months per salesperson. What if I want to change this breakdown? So what if I want to see a breakdown of months and I want the salespeople to be nested inside the month? Of course, it's very easy to do that. I can just simply take the salesperson field here and drag it under the sales month field. And now I have a breakdown of month. So now I see how many items were sold in each month in each region. And if I collapse a month, then I can see a further breakdown of salespeople. So now we see, for example, how many items Joe Jaster sold in January in the APAC region, EMEA, LATAM, and so on and so on. Now let's actually collapse all the fields here. And let's talk briefly about the design of the pivot table. So click on the Design tab while your pivot table is selected. If you don't like the default style of the pivot table, then you can choose from a variety of pivot table styles here. You could also apply your custom style. If you click on the More button here, then you see that there are really a lot of predefined pivot table styles, but you could even create your own style. The default style, of course, is this one, which is selected, so this light blue style. But if you hover your mouse over the different styles, then you see how your pivot table changes. I could go with maybe a medium style here. For example, this one. But I don't like it that the salespeople are not really separated here. So I want to have some lines at least to separate the salespeople or to separate each row in this breakdown. And actually to do this, I can just click on the Banded Rows option here in the Pivot Table Style Options command group. And now these blue lines appeared in between the salespeople, so I think now we have a much better breakdown. I could actually also check the Banded Columns option, and now we also have vertical lines or borders, let's say. So now these numbers are separated very nicely, and if I click on the collapsible button, then I see that yes, indeed, and now my pivot table is looking really like a proper table. We also have a layout command group where you can change the layout of your pivot table. For example, there is the grand totals command where we can simply remove the grand total calculations from the pivot table. So I will choose the option off for rows and columns. And now we don't have a grand total row in row 17 and a grand total column in column F. But actually I want to get it back. So I will just click on grand totals again. And I will click on for rows and columns. Actually in column F, we have the grand total per row. And in row 17, we have the grand total per column. I've mentioned earlier that it is a good practice to base your pivot tables on properly inserted tables. Let's go back to the pivot datasheet. Let's add a new row to our inserted table. So I will just go to the bottom of it. I will copy row 994 and then I will paste it to row 1001. I will change the number of sold items to 168. Notice that the inserted table has readjusted itself or resized its own range. So now row 1001 is also included in this table, and we know this based on this purplish corner symbol here that we have in cell D1001. This is something that we have discussed earlier as well, but it's always good to have a short recap. Something quite interesting actually happened. Our formulas have been automatically updated. Although I wrote these formulas before this table became a properly inserted table, and although I used absolute cell references, once this table became a properly inserted table and I extended it, so I added a new row to it, Excel automatically adjusted the formula in cell G2. So now it goes from D2 to D1001 and C2 to C1001. The rest of the formulas were not updated, however. So let me actually just drag the formula in cell G2 down. And of course these numbers didn't change because I added a new row with the sales region EMEA. I want to be consistent with my formulas. I'm not necessarily a fan of what Excel did, so it basically adjusted an absolute range by itself. But at the same time, actually, because Excel changed my formula, we see the correct number here. So now we have 671,000 sold items in the EMEA region. Let's see if our pivot table reflects this change. Actually, it does not. And this is because once you create a pivot table, you create a snapshot of your data. Your pivot table is not directly linked to your data. When you create a pivot table, Excel creates a so-called pivot cache. The pivot cache is basically the snapshot of our data that Excel keeps in the memory of our computer. And when we change the layout or the view of our pivot table by drag and dropping the fields to different areas, then Excel uses this pivot cache to very quickly calculate as per our new breakdown. So thanks to the pivot cache, Excel can perform calculations very, very quickly. But at the same time, if your underlying data change, then the pivot table will not reflect that change. Make sure that your pivot table is selected and then go to the Pivot Table Analyze tab. I mean, if your pivot table is not selected, you cannot go to this tab, of course. And here in the middle, we have a data command group. Click on the refresh command. And here we can either use the refresh or the refresh all command to sort of refresh our pivot table and include the new row into it. So let's click on refresh. And probably you have noticed that the pivot table was actually refreshed. So now it shows us the correct number of sold items in the EMEA region. We have only one pivot table now, so it doesn't matter if you use the refresh or the refresh all command. But if you're working with multiple pivot tables and you want to refresh all of them, then you can always use the refresh all command. If we didn't base our pivot table on a properly inserted table, then it would be a bit more work to refresh the pivot table. If this table was not a proper table but a range of cells, then on the Pivot Table Analyze tab, you would need to go to the Change Data Source command, and you would need to reselect your data source or your range of cells. Because we are using a properly inserted table, when we simply refresh the pivot table, the newly added row was automatically included into our pivot table. But if you're not using properly inserted tables and you add more data to your table, then you actually have to change or reselect your data source. Now I don't have to do anything here. I just wanted to show you that the Change Pivot Table Data Source dialog appears, which gives us an opportunity to change our data source, but I will click on Cancel because we don't need to do that now. I would suggest, however, basing your pivot tables on properly inserted tables. So if anything changes in your table, you can just simply refresh your pivot table and you don't have to deal with changing your data source. Pivot tables are actually very complex, and we could discuss them for hours. But at this point, I believe you have strong foundations about pivot table. We have actually reached the end of the discussion of Excel in the crash course, so let's summarize what we learned in this section. In the Excel section of the course, we covered a lot. We talked about data organization, arithmetic operations, functions, cell references, data types, conditional formatting, inserted tables, errors, charts, and of course, pivot tables. But of course, we couldn't cover everything in the crash course, so I'd like to suggest some topics to you for further learning. We haven't talked about data validation. Data validation is making sure that your data is correct. For example, that there are no unnecessary spaces in your data. I suggest checking out the trim function, the len function, and how you can check for equality in Excel. So how you can check, for example, that two cells contain the same values. Text manipulation is also very important. You can read about the mid, find, and concatenate functions to get to know more about text manipulation. We talked about conditional functions, for example, the if and the SUMIF functions, but you should read about testing for multiple conditions. I'd suggest checking out the AND or ifs and SUMIFs functions, for example. We haven't really covered really advanced formulas, for example, the index match-match formula. We haven't talked about the special array formulas, so I'd suggest reading up on them. And while you're at it, you should check the differences between Excel 365 and earlier versions of Excel in regards to handling array formulas. And there are a lot of other topics that we couldn't cover in this crash course, but they are very important. For example, copying and pasting data, finding and replacing values, importing data, merging cells, and printing. You can of course read all about these topics yourself, or you can enroll in my master course and continue learning with me. I hope you forgive me for advertising my paid course briefly. If, by the end of this crash course, you feel that you'd like to become a true professional in working with data, I hope you'll take my 3-in-1 Excel, VBA and SQL master course, which is, at the point of recording this video, is available on udemy.com and tmsonic.com. On both websites, you can get lifetime access to approximately 40 hours of material. The master course will give you amazing skills for working with data, so you won't ever need to spend money on another course. In the description of this video, you will find a link to my course on Udemy and also on tmsonic.com. If you use the Udemy link that is in the description of the video, you will find an amazing discount. You might see a different currency here. On Udemy, I currently see euros. However, what is important that with our link, you can get a huge discount from this course. However, on tmsonic.com, you can save even more money. Tmsonic.com very often offers a special discount for this course, which means that you can get my master course for as low as $9.99. If you haven't done so, please subscribe to our channel and please like this video. This would help us a lot. But now it's time to learn about VBA. VBA stands for Visual Basic for Applications, and it is a programming language, of course. The VBA programming language has a very specific purpose. We can program, or in other words, automate processes in Office applications, for example, in Excel. Despite this specific purpose, VBA is a programming language in its own right. I've designed the crash course in a way that the knowledge that you get here while learning VBA could be transferred to other programming languages as well. So now you will not only learn VBA, but the fundamentals of programming as well. I hope you like it, and maybe you'll start a career in programming, but I have to warn you that programming is hard. I think actually that anyone can learn programming, but it requires a lot of dedication, and of course you have to be motivated by it, so it has to be something interesting for you. Even if you realize that you like programming very much, and you dedicate a lot of time to it, you will probably struggle a bit with some concepts. This is just part of the natural process of programming. Struggling, getting confused is part of the job. It also happens to me, though it doesn't happen to me as often as it did when I just started programming. So don't be too hard on yourself if you don't understand something immediately. You can always rewatch the part of the video that you don't understand. But if you find yourself really struggling with the concept, you can just move on to the next topic. With time, the concepts that you find difficult at first will become clear. What is important is that you don't give up. I have opened a new Excel workbook. I suggest you do the same. In order to start writing VBA code, we have to open the VBE, the Visual Basic Editor. There are two ways to do that. Let's press Alt F11, and now the Visual Basic Editor has opened. Now I have my Excel workbook in one window and the Visual Basic Editor in another window. I will close the Visual Basic Editor for now, because I want to show you the other way of opening the Visual Basic Editor. We have to add a new tab to our ribbon. To do that, go to File, go to Options, select Customize Ribbon. On the right side, we have a field Customize Ribbon, and by default, the Main Tabs option is selected. All we have to do is to check the Developer option here near the bottom. Once it is checked, simply click on OK. Have you noticed that a new tab has appeared? So right before the Help tab, we have a new tab, the Developer tab. Click on it. On the left side, you see the Code command group, and you see the Visual Basic command. As we can see in the pop-up, it opens the Visual Basic Editor, and the shortcut is what I've already shown you, Alt F11. But we can simply click on this command, and now the Visual Basic Editor is available again. You see a top menu in the Visual Basic Editor. What I mean is this File tab, Edit tab, View tab, and so on and so on. Below this top menu, you find some very useful commands. For example, we can go back to view our workbook, and then we can go back to the Visual Basic Editor. But you can, of course, also save your work or run the code that you have written. You see that the pop-up says Run Macro. You might have heard the word macro in regards to VBA, and actually I would like you to think about a macro as simply VBA code. Later in the course we will record a macro, so we will talk a bit more about what is VBA code and what is a macro exactly, but basically they are the same thing. When I opened the Visual Basic Editor, 3 windows were opened by default. The first is the Project Explorer here. The second one is the Properties window here at the bottom. And we also have an immediate window. It might happen that you don't see the immediate window, but it's not a problem. Actually, we can close all these, so I will just close all these 3 windows. Now we see this gray area with which we cannot do anything. But of course it is not a problem. Go to the View tab and click on Project Explorer. So now the Project Explorer is back. And for now, we only need the Project Explorer, so I will not activate the immediate window and the Properties window. In the Project Explorer, you see that we have a VBA project, and in parentheses you see the name of our empty workbook, Book 1. Each workbook is a VBA project as well, so we can write VBA code in each workbook, and we can save that code and we can run that code. The VBA project contains everything we need to start writing VBA code. We have a folder here called Microsoft Excel Objects. And inside this folder, we have a Sheet 1 object or a Worksheet object, and we also have a This Workbook object. Let's double click on Sheet 1. Now we have a window where we can write VBA code that we can run. It might happen that this window is smaller for you, so if you see something like this, of course you can resize it, but I would suggest simply maximizing it. And then on the right side, of course, you can minimize or restore this window. So this is a place where we can write VBA code, but actually in the crash course we will not use this, so I will simply close it. If we double click on this workbook, a similar window appears, so this is again a window where we can write VBA code. In a crash course, however, we will not use this window either, so I will close it. Just because we will not write code here during the crash course, it doesn't mean that it's unnecessary to use the This Workbook object for writing code. It has its purpose, and the sheet objects also have their purpose for writing code, but they are beyond the scope of the crash course. Select the VBA project, press your right mouse button, choose the Insert option, and click on Module. A new folder was created under the VBA project called Modules. At the same time, of course, we have inserted a new code module called Module 1 by default. Module 1 has been opened automatically, but of course I can close it and I can just reopen it. We can of course write VBA code into a code module, and we can insert as many code modules as we want. During the crash course, I will insert new modules whenever we have a new topic or lesson. So by using modules, I think it will be very easy for you to follow me. Soon we'll write our first lines of VBA code, but first I want to change a few things a bit. First of all, I want to rename this module 1 to test module. For this I will need the properties window, so select View and click on Properties window. I will make it a bit smaller. Module 1 is selected now, so we actually see the properties of module 1, and a code module has only one property, a name property. You can think about a property as data belonging to a code module in this case. I will rename the module to test module. And I will press enter. So now the module has been renamed. I wanted to show you how you can rename a module. It's quite useful. I will start typing into the window of the module. So this is where I can actually start typing VBA code, but first I will not type VBA code, but I will show you how small the letters are, or how small the font size is by default. So I will type here, these letters are very small. I don't think it's comfortable you to watch the video while I'm using such small fonts. So let's make them bigger, and this is something that you also want to do. Select Tools, Options, and go to Editor Format. The default font of the Visual Basic Editor is Courier, but I will choose Verdana. Once you clicked on this downward pointing arrow and you see this list of fonts here, start typing Verdana. I don't think it matters which one I choose, but actually I will choose this one. And I will also change the size of the font, so I will choose the biggest one, the 24. So I will click on OK. And I think these fonts are quite big now, so it won't be a problem for you to read the code that I'm writing. I will press enter now. And a warning message, or actually an error message, appears, which says compile error, expected end of statement. You see that what I've typed is in red, which means that it is not valid VBA code. The Visual Basic Editor recognizes that it is not valid VBA code, so there's a problem with it. As soon as I pressed enter, the Visual Basic Editor gave me this warning message. Of course, now I didn't want to write valid VBA code, but actually I find it quite annoying when the Visual Basic Editor keeps showing these warning message boxes whenever it doesn't like something that I'm typing. I will click on OK, and I will go back to Tools, Options, and on the Editor tab, we have an option Auto Syntax Check. I will uncheck this option and click on OK. We will still receive error messages when there is a problem with our code, but not while we are typing our code. When we run our code and there is a problem, then we will get to know what the problem is with the code, so we will see these error messages popping up. But the Visual Basic Editor will not annoy us with totally unnecessary message boxes. I will delete what I've written down. And now it's finally time to write our first lines of valid VBA code that we will run. To write valid VBA code, of course you have to know the syntax of VBA. The syntax of a programming language is the set of rules you have to follow while writing your code. We'll write a subroutine now. A subroutine is a piece of code or unit of code that we can run. Type the word sub, press space. The word sub tells VBA that we are defining a subroutine, and now we have to give a name to our subroutine. To do that, we can use the letters of the English alphabet. I will type our first subroutine. Notice that the name our first subroutine is a compound word. So this word is made up of different other words. So we have three words here, our, first, and subroutine. Notice that I capitalized the first letters of these separate words. This is called the Pascal naming convention. This is the naming convention that I will use for our subroutines. You don't have to do what I'm doing, but I just wanted to explain to you what I'm doing. Now move your cursor after the word, our first subroutine or the name of the subroutine, and press enter. Some interesting things happened actually. The first letter of the word sub was capitalized. If you remember, I just typed sub without any capitalization. But now the S has been capitalized and the word sub is in blue. And it is in blue because it has a special meaning to the Visual Basic Editor. It tells the editor that we are defining or declaring a subroutine here. The name of the subroutine is unchanged, so the Visual Basic Editor didn't do anything to it, but it added parentheses after it. When we were learning about Excel, we learned about arguments of a function, and actually subroutines can also take arguments, and these arguments would come inside the parentheses. But this subroutine will not have any arguments, so we will not put anything inside these parentheses. Once I pressed enter after typing this, not only the parentheses were added automatically by the Visual Basic Editor, but also the words here and sub. And they are in blue, so they have special meaning for the Visual Basic Editor. Of course, we know now that a sub refers to a subroutine, and I think the word and is quite obvious. So the and sub keywords mean that the subroutine ends here, ends on this line of code. I told you that a subroutine is a unit of code that we can execute or we can run. What we have between the first line and the last line of the subroutine is of course the code that will be executed. And so far we don't have anything here. I will press enter a few times, so just I have a bit more space between the sub and the end sub. And I will actually press tab. Of course, what I did is I indented my code a bit. I like to indent the code that I'm writing inside the subroutine. I think it's a good practice because it makes your code read more easily. In VBA, there is a function readily available to us for showing message boxes. Type MSG box. Then press space. And what you see here in this pop-up are the arguments of the message box function. You see that there is a prompt argument and it is in bold. This is an argument that is compulsory for the message box function. It is the only compulsory argument of the message box function actually. You see that the rest of the arguments are inside square brackets, like buttons, title, help file, and so on and so on. And the brackets mean that they are not compulsory arguments, so we don't have to provide them. But we have to provide a prompt for the message box. You might have actually noticed that the Visual Basic Editor automatically capitalized the M and the B, despite the fact that I didn't capitalize anything here. And of course you also saw that the words and sub, for example, were automatically added by the editor. The Visual Basic Editor is not actually a simple text editor. While we are writing VBA code to the editor, it starts processing it. I will talk about this a bit later. I just wanted you to know that if you see behavior like this, that letters are capitalized automatically, for example, then it is a natural behavior from the Visual Basic Editor. I have to press space, and now I will provide a prompt argument. The prompt is the text that the message box will show, or the message that the message box will show. The prompt has to be a text. And while learning about VBA, or actually most other programming languages, we use the term string instead of text. A string is a series of characters, basically. Actually, the message box function would make sense of a number as well, so I don't have to provide a string here. But I do want to provide a string here, and in this case I have to use double quotes. I will type a double quote now, and then I will type this is our first line of VBA code. And I will type a double quote again. What I have inside the double quotes is the string itself, so this will be shown in the message box. The double quotes will not be shown. The double quotes merely tell VBA that this should be regarded as a string. This is of course part of the VBA syntax. Make sure that your cursor is inside our first subroutine. And let's run our code. We can either click on the run command, or we can press F5. Let's click on the run command. Once we run the code, we see our Excel workbook, and we actually see the message box. With the string, this is our first line of VBA code. If I click on OK on it, then I'm back to the Visual Basic Editor, because the code has run successfully. So this has been our first line of real VBA code. Of course, the first line and the last line are also valid VBA code, but this is actually the line of code where we instruct Excel to do something for us. And of course, now this is something minor, so we just show a message box. But still, this is a very important step. You told Excel to show you a message box, and it did. So far we know how to declare a subroutine, how to use a message box function, and how to run our code. I think it's time that we save our code. To save our VBA code or the VBA project, so the code that is part of this workbook, we can simply click on Save. Don't forget that for now we have an empty workbook. Let's try to save it in XLSX format. Some sort of a warning message appears. The following features cannot be saved in macro-free workbooks VB project. What happened actually is that the default extension in Excel, so the XLSX extension, cannot save VBA code, so it is a type of macro-free workbook. VB project stands for our VBA project or the VBA code that we have written. To save a file with these features, click No. So if you want to save your VBA code, click No, and then choose a macro-enabled file type in the file type list. It basically means that we have to save our file with a different extension, an extension that designates a file type, which can save macros or VBA code. To continue saving as a macro-free workbook, click Yes. So if you don't want to save the VBA code, you can click on Yes, but of course you want to save the VBA code, so let's click on No. And actually let me rename the workbook first to VBA Test. And from the Save as Type field, I have to choose Excel Macro-Enabled Workbook. So the file extension will be XLSM instead of XLSX. Whenever you see an Excel workbook with the XLSM extension, it means that it is a macro-enabled workbook, so there is probably VBA code in it. Let's click on Save. Our workbook has successfully saved, so now the name is VBA_test instead of book 1, but I will actually close the Visual Basic Editor and I will also close my workbook. I will navigate to my Documents folder, this is where I saved the workbook. And of course I will open it to confirm that the code is still there even after I close the workbook and reopen it. Notice that we get a security warning once we open a macro-enabled workbook or a VBA code-enabled workbook. The macros have been disabled, so the VBA code is disabled, we cannot run it. We can however click on Enable Content and then we can run the VBA code. The default behavior of Excel is that it disables the macros of the macro-enabled workbook. And actually it has a good reason to do so. We can write VBA code that automatically runs once a workbook is opened. And with VBA actually we can create new files or delete files. So although VBA is designed for automating Office applications or working with Office applications, a malicious user could potentially write VBA code that is harmful. For this reason, Excel automatically disables all the VBA code. But of course, when you know that the VBA code is not harmful, you can enable it. Obviously, all the files that I provide for you during this crash course are harmless. So I hope you trust me and you will enable my VBA code. This security warning actually might come in a different style, so to say, it might be actually a pop-up, I think. But what is important is that you ultimately enable the code, the VBA code. Let's go to the Visual Basic Editor. And indeed, we have the test module with the code our first subroutine, and I can run it again successfully. Perfect, I click on OK, and I can go back to my workbook actually. So now you know how to save your VBA code so that you can run it again later. As I mentioned, by default, Excel disables the macros and you see this security warning that you have seen earlier. But of course you can change this setting. You can go to File, Options, choose Trust Center, click on Trust Center Settings, and on the left side choose the macro settings if it's not chosen for you by default. And here you see the macro settings. And the default behavior is disable VBA macros with notification. Of course, we saw this notification, this security warning. You can disable all VBA macros without notification, so all VBA code without notification. And of course, maybe later, when you want to make sure that no VBA code is running, you can use this option, but for the crash course, don't use this option, of course. There is also a third option for disabling VBA code except if it's digitally signed, but we are not interested in that. But there is a fourth option, enable VBA macros, not recommended, potentially dangerous code can run. I usually go with the default actually, but if you have to work with a lot of workbooks that have VBA code, then in the future you might want to enable all the VBA code that you trust. But I think actually that the default is perfect, even though it can be a bit annoying to see this security warning popping up all the time. It is something that might protect you in the future from harmful VBA code. So I will not change anything here. I will click on cancel. And actually I don't want to do any more work in this workbook, so I will just close it. Now, because this is the only workbook I'm working with, so this is the only VBA project, so to say, once I close this workbook, the Visual Basic Editor will also be closed automatically. So let me close the workbook, and you see that the Visual Basic Editor has been closed as well. I have opened the VBA section start.xlsm file. This is of course a file that you can download. The link to it will be in the description. It might happen that you have to download a zip file, but in that zip file you should be able to find the VBA section start.xlsm workbook. Notice that this is an XLSM workbook, so it can contain VBA code. I didn't get the security warning after opening this file because this is not the first time I've opened this file, but probably you get the security warning. So make sure that you enable the content or you enable the VBA code. There are 3 worksheets in this workbook, the names, the profit and the analysis worksheet, but this is not important for us now. What is important that this will be the workbook into which I write all the VBA code of the crash course, or at least the VBA code of the VBA section of the course. Let's open the Visual Basic Editor. Don't forget that you can go to the Developer tab and click on the Visual Basic command, or you can use the shortcut Alt F11. We have our VBA project here, and you see that each worksheet we have in the workbook has its separate worksheet object, so to say, where we could write VBA code. But we don't need this actually. What we of course need is to insert a new module. Let me rename this module to crash _01_integers. Let's of course open the module so we can start writing our VBA code. An integer is a type of number, but shortly I will talk more about it. Let's implement a subroutine that adds 2 numbers together and shows the result in a message box. When I say implement a subroutine, I mean write a subroutine or declare a subroutine, whatever, but usually we say that we implement subroutines when we are programming. Let the name be add numbers. So I will press enter. And of course the Visual Basic Editor already added the and sub keywords for me. I need some more space, so I will press enter a few times. I will press tab. And I will type a double quote, and I will type declaring variables. Notice that this text will become green once I leave this line of code, so I will simply press the down arrow. When you start a line of code with a single quote, then that line of code becomes a comment. By default, the Visual Basic Editor shows comments in the color green. Comments are only for us VBA programmers. We can comment our code, so we can, for example, describe what a part of our code is doing. This can help other VBA developers or programmers understand our code better and quicker. When we execute or run our VBA code, this line of code will not do anything. So the user will not see anything of this line of code. It's only for our information. Let's type the following: dim space number 1 as space, And now a list of options appeared. Of course, I will talk about everything shortly, so don't worry if you don't understand what is going on. We could select integer from this list, but we can also start typing integer. And now you see that integer is highlighted in blue, so I can just press tab. And the Visual Basic Editor automatically typed the rest of the word integer for me, and it capitalized the I. I will just click outside of this line of code now. And now you see that the word dim is in blue and it has been capitalized, and as integer are also in blue, and as has also been capitalized. So these three words have special meaning for the Visual Basic Editor. The dim keyword is short for dimension, and we use it for declaring variables. After the dim statement, we have to name our variable, so the name of this variable will be number1. Of course, you probably ask, what is a variable? And of course, it is a very good question. In the subroutine that we are implementing now, we want to add two numbers together. The first number will be stored in the variable called number1. When we run our code and the execution hits this line, then the Visual Basic Editor will create a variable called number1. A variable is something into which we can save data. We will of course save a number into this variable. What exactly happens actually when we hit this line of code is that a very small part of our computer memory will be used by VBA to store the value of the variable number1. When we declare an integer variable, and I will tell you later what an integer is, so when we declare an integer variable, then that variable will be assigned a default value, and this default value is 0. So when this line of code runs, then we know that we are creating or declaring a new variable, number1, and by default its value will be 0. This 0 will be saved into our computer's memory. And later in the code we can access this 0, so we can access this address of our computer memory by referring to the number1 variable. This all might be confusing to you, but part of programming is understanding what is happening inside your computer when you are writing your code. So very simply put, we will store a number in the number1 variable, and later in the code we can just type number1 and we will have access to this number. And now let's talk about what an integer is. An integer is a type of data. An integer is a relatively small round number. For example, 100, 1000, or even 5000. In the Excel section of the course, we discussed cell formatting. And we discussed that the cells in our worksheet can contain different types of data. Let me go back to the worksheet actually. Let's go to the Home tab. And inside the number command group, we have this list of data types actually. In Excel terms, we were talking about cell formats, so the cell can have a number format. And of course, this meant that the cell contains a number. But we also discussed the short date and the text formats as well, and I think the scientific notation we also discussed. So just like in Excel, you might want to work with different types of data in VBA. If you want to sum numbers or add numbers, then of course you want to use some kind of number. And an integer is a type of number. So it's a round number, a relatively small round number, which is perfect for our purposes now. The as keyword declares what type of data the number1 variable will hold. So here we declare that we want to use a variable called number1 in our code, and the as integer part declares that this variable will hold an integer. Let's copy this line of code and let's paste it right here. And of course, let's rename our second variable to number2. So now we declared two variables. So now we told the Visual Basic Editor that we want to use two variables in our code, number1 and number2, and both these variables will contain integers, so numbers. By the way, when I'm naming my variables, I use the camel case notation. You can use the letters of the English alphabet and also numbers to name your variables. Let me delete this one and Let me just type the word 1. So now this is also a compound word. We have a word number and another word 1 here. When I name my variables, I use the camel case notation, as I've mentioned. So the first letter or the first word is lowercase, but every other first letter of every other word is uppercase. But I will just delete this one and I replace it with the number 1, the actual number 1. It's actually not necessary to declare variables in your VBA code, but I think it is a good practice. I don't know if I've already mentioned this, but of course we use the dim keyword to tell the Visual Basic Editor that we are going to declare a variable. So now that we have two variables declared, we have two variables that both have the default value 0. But of course we want to work with different numbers. So we have to assign values to our variables. So let me put the comment here below. Assigning values to the variables. Let's assign the number 100 to the number 1 variable and 200 to the number 2 variable. This is how we assign values to variables in VBA. On the left side we have the variable, then we use the equal sign, which is the assignment operator, and on the right side we of course provide the value that we want to assign to the variable. So if we run our code now, and if we reached these two lines of code, then the memory location designated by the number 1 variable would hold the value 100 and not 0, and the memory location designated by the number 2 variable would hold the value 200 or the number 200. And of course when we run our code, this is what exactly will happen. Now we of course have to add these two numbers and show the result in a message box. So let me type number 1 plus number 2. Actually, when I left this line of code, then the Visual Basic Editor removed the plus sign. The plus sign is the operator for addition. But actually the Visual Basic Editor cannot really make sense of this. We have two variables where we store integers, we add them together, but we don't do anything else with them. When we are doing something with our variables, for example adding them together, then we have to do something with the result. It cannot just hang somewhere in our code. We could declare a third variable to store the result, but it is unnecessary now. We can simply use the message box function. As the prompt argument, I will provide the expression number 1 plus number 2. Notice that the prompt argument is bold here, so this expression is the prompt argument now. The message box function will be able to make sense of this, so we will get the result of adding these two numbers, and then the message box will show the result. I will click outside of this line of code, and now the M and the B of the message box function have been capitalized. Make sure that your cursor is somewhere in the add number subroutine, and let's run our code. Our code has run successfully. We see the message box with the result of adding 100 and 200 together, so I will click on OK, and we are back to the Visual Basic Editor. I think it's time for me to tell you what an integer actually is. I will switch to my Chrome browser. I have already navigated to the data type summary page of the Visual Basic documentation. Programming languages have documentations. And of course, these documentations describe how a programming language works. When you begin to learn programming, documentation is very confusing, I think. At least I needed some experience before I could make sense of a documentation of a programming language. But still, documentation is very important. After you become confident with your programming skills, the documentation will be your primary source for a programming language. And sites like Stack Overflow or Quora or other forums will be just your secondary source. In case you don't know, Stack Overflow and Quora are websites where a lot of people ask questions about programming languages, and so on, and they usually get answers to their questions. Of course, you will find this link in the description, and I think it's a good idea to familiarize yourself with documentation. When we are programming, of course, we are working with data. And as I've already mentioned, there are different types of data. You can perform calculations on numbers, but you cannot perform calculations on strings, so on text. Whenever you use data while writing VBA code, or in Excel for that matter, your computer must allocate memory to your data. And different types of data require different amount of memory. Let's scroll down a bit. We find the integer data type, and this is the point where I realize that actually this is the wrong documentation. I need the Visual Basic for Applications documentation, so I will navigate to that, and I will close this one. So this will be the link that I will provide in the description. So we are on the data type summary page of the VBA programming language. So you see that this is the Office VBA reference, so the documentation for the VBA programming language. A data type is the characteristic of a variable that determines what kind of data it can hold. So basically this we have already discussed. The variables that we have in our code here are holding integers. So let's now check what integers are. So let's scroll down a bit. And now we see here integer. An integer takes 2 bytes of memory. And actually in terms of modern computers, it's extremely little. What is more important for us is that an integer can hold numbers from the range of minus 32,768 to 32,767. So this is the biggest number the integer can hold, and this is the smallest number an integer can hold. And of course an integer has to be a round number. So if we wanted to add 50,000 and 50,000 together, then we could not use integers because integers can hold a maximum of around 32,000. So we need to actually use a different data type if we want to work with numbers that exceed this value or that are lower than this value. But in our subroutine, we of course add 100 and 200 together, so it's not a problem to use the integer data type. We will use different data types in the course as well, so we will get back to the documentation later. But there are still a couple of things that I want to discuss it with you before we move on and we continue coding. I think it's quite obvious now that the Visual Basic Editor is not a simple text editor. It actually changes our code. It capitalizes letters, changes the color of a word, and it also gave us options for choosing a data type. While we are writing VBA code, the Visual Basic Editor is actually constantly working in the background. Once we write a line of code and we leave that line of code, then the Visual Basic Editor processes that line. And this is absolutely the intended behavior. But you might wonder why it does that. Currently, I'm working on a laptop with a Windows 10 operating system. It might happen that you have the same setup, but you might not have the same setup. Probably you don't have the same laptop as I do. You can have a different operating system. Maybe you are working on an iMac. But no matter the hardware that we use, and no matter the operating system that we use, when we write our VBA code, we want our VBA code to do the same exact thing regardless of the hardware and the software. So if you use a Mac, for example, then you want to see the same result as I see. You want a message box to pop up, and you want to see the result of summing these two numbers. We are of course using VBA code to achieve this. The Visual Basic Editor makes sense of our VBA code, but our computer, our machine, cannot make sense of VBA code. It makes sense of machine code, so to say. So the VBA code has to be translated for our machine. You might also have heard the word compiling. While we are writing our code, the Visual Basic Editor is actually compiling our code. It is translating our code for our machine. There should be actually several steps for our VBA code to be translated into machine code, but the VBE editor is doing the first step for us. Actually, the VBE editor and our computer is doing the job for us. When we are writing VBA code, we just have to know how to write VBA code. How our code is getting translated for our machine is not our concern. I don't think it's necessary to get into more detail about this. I just wanted to make sure that you have some concept of why the Visual Basic Editor is messing with our code. It is messing with our code because it is actually helping us. So far we have used the message box function to confirm that our code is doing what we intend it to do. But after a while, it becomes quite annoying to see all these message boxes when you run your code. And actually, there is a better way to do this. I will just comment this line of code out. And on the next line of code, I will type debug dot. And you see that actually the Visual Basic Editor helps me. So it tells me that I can either type assert or print after debug dot. And what I will need is the print method. And after a space, I can just add an expression number 1 plus number 2. You see that now both debug and print are in blue and they have been capitalized. So the Visual Basic Editor is helping us and it's compiling our code. Debug is a special object in VBA that we can reach from anywhere in our code. Later in the course I will talk more about what an object is in programming, but for now it's enough for you to know that objects have their own functions. The debug object, for example, has a function called print, but if we are talking about functions that belong to an object, we usually say method instead of function. This could be a bit confusing, but welcome to the world of programming. There is a lot of stuff that is confusing here. What matters is that on this line of code, I access this special debug object, and I type a dot or a period to access its print method. What we say is that we use the dot notation to access the methods of an object. The print method, of course, takes an argument, and basically this argument is what should be written to our screen. Because, of course, the print method will print out or write something to our screen. Go to View and click on Immediate Window. This is actually where the print method of the debug object writes the result of this expression. So if you don't open the immediate window, then you will not see the result of printing this expression. Let's run the code. And indeed, 300 has been written to the immediate window, so the print method of the debug object is doing its job. I think it's a much better practice to use the print method to print out the results of our code than using the simple message box function and deal with the annoying message boxes. Actually, at this point, I will save my work and we can move on to the next topic. Let's add another code module. So select the module folder, right-click and insert a new module. Actually, let me remove this module. I just want to show you how to remove a module. So select it, press the right mouse button and click on Remove and the module name. VBA will ask you if you want to export the module before removing it. So actually you can export your VBA code or a code module and you can import it to another VBA project, but I don't want to do that because this is an empty module, of course. So I will click on No, and now the module has been deleted. Okay, so let's add another code module again, but this time we will not delete it. And I will rename it to crash 02 strings. We're going to implement a subroutine that concatenates two strings. Concatenate means to join together, to merge. Let's type sub concatenate strings and let's press enter. We have to declare two variables, of course. So I will put the comment declaring variables. And the first variable will be called myString1, and it should be a string, so I will declare it as a string. Once you see the string data type selected here, you can actually also double click here. And I will declare another variable, of course, and it will be called a myString2. I mentioned that a string is basically text, so it is a series of characters, but when we are talking about VBA or programming in general, we usually don't say text, but we usually say string. Let's check actually the VBA documentation about the string data type. So I will just scroll down a bit. A string is of variable length, so of course you can have a string with 10 characters or with 1000 characters, for example. It takes 10 bytes of memory, which is not that much actually, still. But of course it takes extra memory depending on the length of the string. Of course 10 characters don't take as much memory as 1000 characters, for example. And here you see the range of the string variable, so how big it can be actually. Now you see 0 to approximately 2 billion, which simply means that you can have insanely long strings in VBA. Now, of course, string is a fancy word for text. And what you can do with strings, for example, is to concatenate them, so join them together. Let's assign values to our variables. My string 1 will store the value Abraham, and my string 2 will store the value Lincoln. So we have assigned Abraham to my string 1 and the Lincoln to my string 2. Don't forget to use the double quotes. This is how VBA knows that you are assigning strings, so that you are declaring strings here. What I've been doing so far actually is assigning hard-coded values to our variables. It doesn't matter how many times I run this code, the string Abraham will always be assigned to the myString1 variable. Because I have hard-coded this string here, so I'm not taking this value from a database, for example, or from an Excel worksheet. It's not a problem to hard-code values, especially when we are talking about educational content. But as we progress with learning and as you progress on your career with programming, you should use hard coding as little as possible. Okay, but it doesn't matter now that we are hard coding these values, so let's print out the value of my string 1 and the value of my string 2. So I will use debug.print here, and first, of course, it will be my string 1. So on the first line I will print out my string 1, and on the second line I will print out my string 2. When you use the print method, you print a new line. So in the immediate window we should see the name Abraham and the name Lincoln on two separate lines. Actually, I will clear the immediate window. Let's run the code. So indeed, Abraham has been printed out on the first line and Lincoln has been printed out on the second line. Don't worry about this space here. If I clear the immediate window and there is no space and I run the code, then there should be no space there. Yes, I just left a space there. Okay, so for now we confirmed that we saved the values Abraham and Lincoln into these two variables. Now let's have a third debug.print line and let's concatenate these two names. In VBA, the concatenation operator is the ampersand, so this symbol. So I will just copy my string 2 here. And let's run the code again. So still first we are printing out Abraham, then we are printing out Lincoln, and then we are printing out Abraham Lincoln, however, without a space. Let's, however, add the space so it will read more easily. So what we have to do is not only concatenate these two variables, but concatenate a space in between them. So you see that after the myString1 variable, I use the concatenation operator, and then I simply type a space inside double quotes, and then I concatenate the myString2 variable. So if I run the code now, actually I will clear the immediate window and run the code now. And you see that now we have a space between the names Abraham and Lincoln. I repeat again that the double quotes are only for telling VBA that this is a string value, that this is a series of characters. But the double quotes themselves don't become a part of the string. So notice there are no double quotes in the immediate window. Now we have discussed the string data type, and you also know how to concatenate or join your strings. So we can actually move on to the next topic. Let's add a new code module, and I will name it crash03 longs. Actually, I will just copy the code from the crash01 integers module and paste it into the new module that we have inserted. I will change the name of the subroutine to add longs. And actually, I will also get rid of this commented outline. And let me clear the immediate window as well. A long is another data type. We can store round numbers in a long data type, but much bigger numbers than we can store in an integer. Let's try to assign the value 50,000 to the number one variable, and don't forget that at this point it should store an integer. So we declare this variable to be an integer variable. Let's run the code. A message appears and it says that we have a runtime error, and this is a type of overflow error. A runtime error is an error that happens when your code is already running. We ran our code, and when it hit this line of code, so when I wanted to assign 50,000 to the number one variable, then a runtime error occurred. This is because an integer cannot store a value that is so big. So an integer cannot store a value like 33,000, let alone 50,000. So this line of code basically broke the whole process while the process already started running. And this is not good. You want to avoid runtime errors. Actually, you want to avoid all types of errors, but especially runtime errors. I can click on debug here, and then the line of code will be highlighted. I mean the line of code where the problem occurred, that broke the whole process. I can actually click on reset, and the highlight disappears. Maybe I didn't mention it, but actually, if you want to assign a negative number to a variable, you just have to use the minus sign. Let me assign minus 10,000 to the number one variable and run the code. You see that the result is correct. However, if I want to assign minus 50,000, then we should get a runtime error again, the overflow error, and indeed. So I will just click on end, and I will change the types of these variables to long. Let's check the documentation about the long data type. So here is the long data type. So this is a long integer, so it is a round number as well. Notice that it takes twice as much space as an integer in our memory, of course, or in the computer's memory, but it can hold much bigger values. So it can hold a number that is bigger than 2 billion or that is smaller than minus 2 billion. 4 bytes is actually also very little space, but I just wanted you to get a sense of how much a byte really matters. So if you have 2 additional bytes, you can work with much bigger numbers. So with the long data type, you can work with much bigger numbers than with the integer data type. Let's get back to the Visual Basic Editor, and let's actually run the code now. I will clear the immediate window first. So you see that it was not a problem to assign the value minus 50,000 to the number one variable, because now it is a long variable and not an integer. You might be wondering why I even talked about the integer variable if it can store only such small numbers. I could have started with the long variable, so we could just skip the integers. But the reason for that is that I want to instill in you that it does matter what type of data you use, so what type of variable you use. Although it doesn't really matter if a piece of data takes 2 bytes in your computer's memory or 4 bytes in your computer's memory, as a programmer you should be as efficient as possible. If it's an integer is enough, then use an integer. However, if you have to use big numbers, then use a long. It's a good practice to be as specific about your data as possible. So far we've used integers and longs, which both represent round numbers. But what if you need to work with decimal places? So what if you have to work with non-round numbers or decimals? For this we can use another data type, fortunately. Let me add a new module. I will rename it to crash04 doubles. And I will just copy the code from the longs module and paste it to the doubles module, and of course I will change the name of the subroutine to add doubles. You might have noticed that we have a data type in VBA that is called double. And with doubles we can use decimal places. Let's check the documentation. So the double is here. A floating point also refers to a decimal number, so a number with the decimal places. A double takes 8 bytes, so twice as much of memory as a long. But a variable with a type of double can hold numbers that are extremely small or extremely huge. A double has a separate range for negative numbers and for positive numbers or values. And you see that these values or the limits are provided in scientific notation. So if you need decimal places Or even if you use round numbers, but the ln is not big enough or not small enough for you, then you can use a double. Let's just do that. So let's go back to the Visual Basic Editor. And instead of declaring these two variables as longs, let's declare them as doubles. And let's add, I don't know, 4000.5 and 2000.3. I will clear the immediate window and let's run the code. And indeed, the calculation is correct. Of course, we can have more decimal places here, and the calculation will still be correct. So here is our result. So far, we've discussed the string data type and 3 different data types for working with numbers. So at this point in the crash course, I think you have all the foundational knowledge for data types in VBA. So let's move on to the next topic. I will insert a new module, and I will rename it to Crash 05 Array Intro. Let's implement a subroutine called Array Intro. I don't know if I've already mentioned this, but while I'm doing work in the VBA section of the course, I constantly save my work. In the description, you will not only be able to download the VBA section start.xlsm file, but there will be another file named VBA section end.xlsm. The end.xlsm file will be the file into which I save all my work. So if you have any problems following along, you can always download the end.xlsm file, the VBA section end.xlsm file, and check the code in that file. Of course, when you download the VBA section start.xlsm file, it will be empty. Previously, we've discussed data types like integer strings, longs, and doubles. Previously, one variable contained only one value. But it would be nice if we had a data structure that could hold multiple values. You might have guessed, but for example, an array is such a data structure. As its name suggests, a data structure is a structure in which data can be organized in a specific way. You might have heard about arrays. You can think about arrays as a collection of values. We store the values in an array under indexes. Let's first declare an array. I will type dim employees, then parentheses after employees, and inside the parentheses I will put a 4. And I will also declare that this array will hold strings. We know that the employees variable is an array because of the parentheses after it. Inside the parentheses, we declare that the highest index of this array will be 4. And with the asString keywords, we also declare that this array will hold strings. You might think that in the employees array, we will be able to hold 4 different strings. But actually this is not the case. We can hold 5 different strings in the employees array, because by default in VBA, arrays are indexed from 0. When we declare an array like this, so when we put a number inside the parentheses, then we declare a static array, but we'll talk about this later. The next step, of course, is to add values to the employees array, so to add strings to the employees array. I will simply type employees, then 0 inside parentheses, and I will assign the name Sarah to the employees array at the 0th index. I will copy this line 4 more times. I will change the names here. And of course, I will also change the indexes. I've assigned the string Paul to the first index of the employees array. The string Emily is assigned to the second index of the employees array, and so on and so on. So at this point in our code, we have an employees array where we store 5 different strings. Don't forget that arrays by default in VBA are indexed from 0, That's why we have an array where the highest index is 4, however, we have 5 different strings in our array. If I didn't use an array here, then I would need 5 different variables to save all these names. So of course the advantage of using an array is that I have to declare only one array into which I can save several values. The next step is of course to retrieve values from the employees array. Let's print out all these names to the immediate window. What I have to do is quite simple. I will type debug.print and then I will just copy this part of the code, so debug.print employees 0. This is how we retrieve a value from an array. We simply specify the index of the array, so the value at the 0th index will be printed out on this line of code. I mean by this line of code. So if I run the code now, Sarah should be printed out to the immediate window. Let's actually confirm this. Indeed, Sarah has been printed out to the immediate window. Let me just copy this line of code. And of course I will just adjust the indexes here. I will clear the immediate window and I will run our subroutine again. So you see all 5 names have been successfully printed out to the immediate window by these 5 lines of code. Imagine that you have an Excel worksheet with 100 cells in column A with some kind of values. And you need to use VBA code to store those values somewhere. Instead of creating 100 variables, of course you can only create one array to store the values. This has been of course only the introduction to the array, but it's important that you understand why it is good to have data structures, for example the array. It is important that we have data structures where we can save values and easily retrieve those values. Let's move on to the next topic, but we will still be talking about arrays actually. I will insert a new code module and I will rename it to crash 06 array indexes. And I will simply copy and paste the array intro subroutine into this newly inserted module. And of course, let me rename this subroutine from array intro to array indexes. I've mentioned that by default in VBA, arrays are indexed from 0. When we declare a static array like this, so when inside the parentheses after the variable name we put a number, then it means that we declare the highest index of the array, but the lowest index of the array will be 0 by default. In VBA, however, you can change the indexing of an array. I can delete this 4 here and instead type 1 to 5. You see that the Visual Basic Editor capitalized the T of the word to, because of course it is a keyword, it is in blue actually. I'm actually still declaring a static array, and when you declare a static array it means that you cannot change the array. More specifically, it means that when you declare an array like this, so 1 to 5, it means that the first index of the array will be 1, and the last index of the array will be 5. So we can store 5 different pieces of data in this array, but later on we will not be able to add more data or increase the indexes of the array. So this is the concept of the static array. There are dynamic arrays that allow us to increase the indexing of the array. But we'll discuss this a bit later. Notice that of course here I declared that the indexing of the array should go from 1 to 5. However, I didn't change any of the other lines. So on this line of code I want to assign the string Sarah to the employees array at the index 0. This should not be possible because now the lowest index of the array should be 1. So let's check what happens if I run the code. I get a runtime error. More specifically, I get the subscript out of range error. Typically, we receive this error when we want to access an index of an array that doesn't exist. And of course, in the employees array, we don't have an index 0. Our indexes go from 1 to 5. So let me click on end. And let me just change this 0 to 5 and this 0 to 5 as well. I will actually clear the immediate window as well. And I will run the code. Everything seems to be fine. And notice that in case of the array, it doesn't matter the order in which you assign values to the array. I started with assigning a value to the array at index 5, so at the highest index, and the code did not break. There is another topic that I want to discuss now, and that is the variant data type. Instead of as string, I will declare this array to be a variant. Don't forget that once we declare a variable, and this is of course an array now, when we run the code and we hit this line of code, then space for our array will be created in our computer. As I mentioned, it's not necessary to declare variables in VBA, but I think it is a very good practice to start your subroutines by declaring the variables that you will use in your subroutine. It gives your code a good structure, and later if you have to go back to a subroutine and change it, you will immediately see what variables your subroutine is using. But as I've mentioned, now I want to discuss the variant data type. If you declare something as a variant, then it can hold anything or any type of data. In this array, we are storing strings, but we are not explicit about it because we are saying that this array, this employees array, is a variant, so it can store anything. Longs, integers, strings, anything. Let's check the VBA documentation. We've already seen this page, this data type summary page for VBA. Let's scroll down to the variant data type. If a variant stores numbers, then it takes 16 bytes of memory. And the range of the numbers that a variant can store is the same range as of the double. But notice actually that a double only takes 8 bytes of memory. However, a variant takes 16 bytes of memory, so twice as much as the double data type. Let's check the code that we have written so far. For example, in the first module, we could declare these variables as variants instead of integers. However, an integer only takes 2 bytes of memory, while a variant takes 16 bytes, so 8 times as much as an integer. And the truth is that it's not a problem for a modern computer to use 16 bytes. And of course, during the crash course, it really doesn't matter if we are using integers or variant variables. But the best practice is to be as specific about your data as possible. Your code will be more efficient, so it will use less memory. And at the same time, it will be more obvious what your code is doing. So if I read only this line of code, then I don't know what type of values will be stored in the employees array. And it only becomes obvious when I see what values are assigned to this array. However, if instead of a variant, I declare this employees array to hold strings, then it's obvious right at the declaration that the employees array will hold string values. Also notice that if a variant holds a string, then it takes 22 bytes or 24 bytes by default. Plus, of course, it needs additional space for the characters. Notice that a string variable takes only 10 bytes by default. So the variant, in this case, takes more than twice as much memory. But what is important here is that whenever you see the variant in VBA code, it is a wildcard for any type of data. I've talked about what a static array is. Now I think it's time to discuss what a dynamic array is. Let's insert a new code module, and let me call it crash 07 dynamic arrays. First I will copy the code of the array indexes module, and I will of course rename this subroutine to dynamic arrays. First, let me declare a static employees array, and let's say that the highest index should be 3. And this employees array will hold string values, so let me just change the variant to string. Let's, however, imagine that I change my mind. Let me just copy this line of code here. And then I say that this employees array should be able to hold 5 values, and it should be indexed from 1 to 5. To do this, I will use the redim keyword, and of course it's short for redimensioning, or probably redimension. I will of course change this 3 to 1 to 5. With the redim keyword, we can change the indexing of an array. So on this line of code, we declare an array that goes from index 0 to index 3. So altogether it can hold 4 different strings. But on the next line of code, I change my mind, and of course it is a very bad practice to write code like this, but this is only for educational purposes. But what is important that I change my mind and I say that this employees array should be able to hold 5 strings instead of 4 strings, and it should be indexed from 1 to 5 instead of 0 to 3. I'm saving actually values into the employees array from the index 1 to the index 5. So maybe everything should be fine when I run the code? I don't think so. I will clear the immediate window first, but let's see what the problem will be. Now this time we don't receive a runtime error, but a compile error. Specifically the compile error array already dimensioned. Earlier I mentioned that when you declare an array like this, so when you put a single number inside parentheses, or even if it is not a single number, but for example the expression 1 to 5, then you are declaring a static array. So when you declare an array and you are specific about the indexing of that array, then it is a static array and the indexing of that array cannot change. So we cannot redimension the employees array because we were explicit about the indexing of the array. It is very important that the type of error we receive now is a compile error. Earlier we've received runtime errors. And I believe I mentioned that a runtime error occurs when the code is already running and the line of code breaks the process. Compile errors are a bit better, because a compile error means that our code has actually not run. The Visual Basic Editor can catch compile errors before the code is executed. Earlier I think I mentioned that compiling is the process of transforming our VBA code so that our computer can understand our VBA code and run it. And code compiling is done by the Visual Basic Editor. So here what is important is that you know that there are 2 types of error, the runtime error and the compile error. In case of a runtime error, your code is running, and at one specific point it breaks. However, in case of a compile error, your code has not yet run, but the Visual Basic Editor tells you that there is a problem with your code. And of course now the problem is that we declared a static array and we cannot redimension or redeclare a static array. So I will click on OK. We are now actually in break mode or debug mode. But if I click on reset, then this yellow highlight disappears and we are in the normal mode, so to say, so we are not in break mode anymore. But it doesn't really matter. What matters is that we correct this problem. In order to correct this problem, I simply have to delete this 3 from inside the parentheses while declaring the employees array. When you declare an array like this, so with parentheses only and no number inside the parentheses, then you are declaring a dynamic array because you're not explicit about the indexing of the array. At this point, the Visual Basic Editor will not know how many values you want to store in the employees array. However, on the next line of code, we redimension the array, so we change the indexing of the array, and we explicitly say that we want this array to store 5 different strings, and the indexing should be from 1 to 5. Let's run the code. I will make the immediate window a bit bigger, but you see that all the 5 names have been printed out successfully. Now let's say that later I realize that I want to store a 6th value in the array. Let's say that I want to store my own name, so after I print out the 5 names, I want to store my name Mark at the index 6. And of course I also want to print my name out. I will clear the immediate window and run the code now, and of course our code will break. And now this time it is a runtime error because I want to access an index of an array that doesn't exist, so there is no index 6 of the employees array. Notice, however, that the 5 names have been printed out to the immediate window. So because this is a runtime error, our code ran successfully until this line of code where I wanted to assign my name to the index 6. So our code broke while executing, and this is kind of a big problem. I will click on End. And actually what I have to do is to redimension the employees array once again. So before I try to store my name in this array, I will change the indexing of this array from 1 to 5 to 1 to 6. So of course, again, I redimensioned the array. And now when I assign my name on this line of code to the index 6, then there should be no problem, and my name should be printed out below these 5 names. I will clear the immediate window, and I will press F5 to run the code again. And actually everything seems to be fine, so the 5 names have been printed out, and then my name has been printed out as well. But actually not everything is fine. Let me try to print out the name at index 1, so to print out the name Paul before I print out my own name. Let me clear the immediate window. So what we want to see now is that after I add my name, the name Paul will be printed out to the immediate window, and my name Mark will also be printed out to the immediate window. Let's run the code, and I will make the immediate window bigger, of course. Now there is a problem now, so the 5 names, or the 5 original names here, have been printed out to the immediate window, and my name has also been printed out to the immediate window, but Paul should have been printed out to the immediate window right before my name was printed out. What happened? This line of code was skipped? Actually, it wasn't. You see that a new empty line was added to the immediate window, so this line of code ran. But actually, after I redimensioned the employees array, all the values have been cleared from it or deleted from it. And at this point of the code, it only has one value, Mark, at index 6. So all these other values have been cleared because I redimensioned my employees array on this line of code. However, there is a solution for this. There is a so-called preserve keyword in VBA. If I not only redimension but also preserve my array, then the values will not be cleared from the array even if I redimension it. I will clear the immediate window and I will press F5 again to run the code. And this time I see the result that I wanted to see, so the 5 original names have been printed out, and then the name Paul was printed out again, and then my name was printed out. I mentioned earlier that in the VBA section of the course, you will not only learn the VBA programming language, but the fundamentals of programming as well. This is why we are discussing data types and also arrays in great detail. An array is a basic data structure, and in most programming language you will find a data structure that is like the array. So it is important that you understand the concept of the array. Don't worry, because by the end of the VBA section we will have fully automated a process in Excel. But until then we will go step by step and we'll learn the fundamentals of programming and of course the fundamentals of writing VBA code. But now it's time to move on to our next topic. Let's add a new module, so let's insert a new module. I will rename it to Crash 08 for loop. And I will implement a new subroutine called for loop. And I will actually copy some part of the dynamic arrays subroutine. So let's say I will copy this part of the code and I will paste it here, of course. And actually I don't need a dynamic array here, so I can have a static array. And instead of index 5 here, I will just have an index 0. At this point, if I try to run the code, everything should be fine, so nothing will be printed to the immediate window, but nothing breaks, and it's good. Previously, if I wanted to print out the 5 names of the employees array, then I had to add 5 lines of code. But of course, this can be done in a better way. And for this, we will use a technique called looping. Now, of course, we will familiarize ourselves with the for loop of VBA. Looping is also called iteration. Looping or iteration means going over a set of values or a collection of values, so basically going over the values of an array or going over the indexes of an array. Iteration or looping is of course not exclusive to VBA, it is a fundamental programming concept. First, I will declare some additional variables. For example, the variable I as a lon, this will be actually our looping variable. And although I already know that I could use an integer here, I like to declare my looping variable as a long, Because actually most of the times I don't know how big my array is, so what the highest index of my array is. And it could happen that an integer would not be enough. For example, if my array has an index of 50,000, then I could not use an integer. I'm sorry if I'm too theoretical now. Shortly you will see what this loop-in variable I is used for. I will also declare another variable called firstIndex, and this will also be alone. And let's declare another variable called lastIndex, and of course it will also be a lone variable. I actually don't need more variables. After I assigned the strings to the employees array, I want to loop over my array. Of course, now I know that the first index of my array is 0, but let's assume that we don't know what the first index of an array is. Let's assume that our subroutine here, so the code that we write here, has to deal with an array whose first index we don't know. Earlier we've seen that in VBA we can change the indexing of the array, so the first index actually can be anything, 0, 1, 100, whatever. Now probably it will be 0 or 1, but we cannot be sure, so we have to deal with this in our code. And of course what we do is we say first index equals L-bound employees. L-bound stands for lower bound, and it is a function that we reach from anywhere in our VBA code, like the message box function. However, the L-bound function takes an argument, so we have to pass an argument to the L-bound function, and this argument is an array. The L-bound function will return the lowest index or the first index of an array. Functions actually are like subroutines, but functions normally return a value. And of course the L-bound function will return the first or the lowest index of the employees array. Earlier, when we used the message box function, we didn't use parentheses to provide an argument to the function. However, here we are using a parenthesis, so in case of the L-bound function, we use a parenthesis and we pass the argument inside the parentheses. The reason for this is because the L-bound function actually returns a value, and we have to save this value somewhere, so we save this value into the first index variable. And when we assign something to a variable that is returned by a function, then we cannot omit the parentheses. So if I try to omit the parentheses here, the Visual Basic Editor immediately highlights the line of code in red, which means that this is not valid VBA code, so I actually have to use the parentheses in this case. The lowest index of our array, of course, is 0, so the L-bound function will return 0, so the value 0 will be saved into the first index variable. Now, of course, we need to get the last index or the final index or the highest index of the array, and for this we can use the ubound function. And of course, it also takes an argument, which is the array whose last index or upper bound, because ubound stands for upper bound, we want to get. So the L-bound function returns the lowest index and the ubound function returns the highest index of an array. So the value 0 will be returned and saved into the first index variable, and the value 4 will be returned by the ubound function, and we save this value into the last index variable. If the ubound function returned 50,000, for example, it wouldn't be a problem because the last index variable is a long variable. However, if we declare this variable to be an integer, then we would not be able to save the value 50,000 into it. This is why I prefer to declare my variables here as longs. Even though I know that the first index is 0 and the last index is 4, but I want to write code here that could theoretically deal with an array that has a very, very big index or high index, like 50,000. So now at this point, we know the first index, so we save the first index into a variable and the last index of the employees array into another variable. The only thing left is the iteration itself, so going over the values of the employees array. So we have to write our loop now. I will type for I equals first index to last index. I will also type in next. And actually I will add a new line here, and I will type debug.print employees, and in parentheses I will type an I. So this is the correct syntax for a for loop in VBA. There are other types of loops in VBA, but we are learning about the for loop now. We have to start our for loop with the for keyword. You see that it's a keyword because it is in blue. Next, we have to declare what looping variable we will use. Our looping variable will be the variable I that we declared here to be alone. I actually is short for index, and many times you will see that people use the variable I as a looping variable. This is just something that people usually do when writing VBA code or code in general. We have to assign an initial value to the looping variable I, so we assign the value of the first index to the looping variable, and of course the first index is 0, so at this point of our code 0 is assigned to the looping variable I. Then we use the to keyword and we declare or specify the last value for the looping variable, or the maximum value for the looping variable, and the maximum value is the same as the last index. Now we know that the last index is 4. So basically here we specify that our loop will go from the value 0 to the value 4. On the next line of code we use the print method of the debug object. Of course we want to print out the name of the employee to the immediate window. Instead of hardcoding an index here like we did here, we are using the looping variable, the variable I. When our loop starts, then the value of variable I is 0, so we will print out the name at the 0th index, so of course Sarah. After Sarah is printed out, this line of code, so this next keyword is hit. And what the next keyword does is restart our loop. But it not only restarts our loop, but it will increase the looping variable. So after we hit the next keyword, then we come back to the loop or inside of our loop, but this time the value of the looping variable I will be increased by 1, so we will print out the name at index 1, so we print out the name Paul. And again we will hit the next keyword, so the looping variable will be increased by 1, so we'll print out Emily at index 2, and so on and so on. At one point the looping variable will be 4 and we will print out the name Joe. We will hit the next statement again, or the next keyword, and the looping variable I will be increased by 1, so it will be 5. Its value will be 5. But because we specified at the very beginning that we will only loop until 4, so the maximum value of our loop or the looping variable will be 4, no more names will be printed out, we will exit the loop, and we will of course end the subroutine. Let me make the immediate window a bit bigger, and let's confirm that what I've said is actually correct, so let's press F5 to run our code. And indeed our code has run successfully. Instead of having 5 debug.print lines, we have only one debug.print line inside the for loop, and still the 5 names are printed out to the immediate window. Let's say that I change our array here, so I will declare it as a static array still, but the maximum index or the highest index will be 5, and I will add my own name at the 5th index. Let me clear the immediate window and I will run the code again. And you see that the code is still running successfully without a problem. Although I changed the indexing of the employees array and I added my name to it, this part of the code is fully dynamic, so it runs without a problem, even if the array has become a bit bigger. The first index is still 0, so the L-bound still returns the value 0, but the U-bound function returns this time the value 5. So now our loop goes from 0 to 5. And once the looping variable becomes 6, we simply exit our loop, so VBA exits, and the code continues executing, but of course we don't have anything else after our for loop, so our subroutine simply ends. As I mentioned, looping or iteration is fundamental to programming or computer science. So at this point, We know about the different data types. We know about the array, which is a data structure, and it is of course a way for organizing our data. But now we also know how we can iterate over an array dynamically. How we can use a for loop to access all the values of our array. We are actually making great progress here. Just think about it. If we want to automate Excel processes with VBA code, we need to be able to iterate over data. For example, to iterate over the cells of an Excel worksheet, like column A here. And of course I'm foreshadowing a bit because we will indeed iterate over these values later. I just wanted to give you an example for why looping is so essential. While discussing iteration or looping, I must talk about the infinite loop. Let's insert a new module. And let's name this module Crash 09 Infinite Loop. I will simply copy and paste the for loop submodule, but of course I will change the name of this subroutine to infinite loop. I will clear the immediate window and I will make it a bit smaller. And actually I will add one more line of code here under the debug.print statement. So it will be I equals I minus 1. An infinite loop is something that you should avoid at all cost. The infinite loop means that the loop never ends. At one point, of course, your loop will end. At one point, your program will just crash. For example, because your computer is out of memory, or if you're working with files, it might happen that there will be no more space on your hard drive. The infinite loop is very problematic because once you run your code and it hits an infinite loop, no error message is thrown because an infinite loop is not an error, but it is a serious mistake on behalf of the programmer. But your code runs without a problem, so your machine can execute the code, but of course the loop will just never end. Although you should avoid this at all cost, I think it is absolutely necessary that I show you how to deal with an infinite loop in VBA in case you encounter one. Let's get back to our loop. So we know that we have to specify the first looping index or the initial value of the looping index, and of course it will be 0. And we also have to specify a maximum looping index, and it will be 5 in this case. So normally this loop would run 6 times, so the initial value of the variable I would be 0, and then Sarah is printed out. And on the 6th iteration, the value of the variable I is 5, and the name Mark is printed out to the immediate window, and then our loop exits. Because the variable I will be 6, and it is greater than the maximum value that we specified here. When you deal with any type of loop, you need to have an exit condition. Our exit condition here is that the loop should only go to the last index, or the value of the last index variable, which is of course 5. Once the variable I exceeds the value 5, then the exit condition is met and the loop does not run again, so we exit the loop. However, I added here an extra line of code where I assign the value I minus 1 to the looping variable I. At the first iteration of the loop, the value of the variable I is 0. And the name Sarah will be printed out to the immediate window because Sarah is at index 0. At this point, I minus 1 will be minus 1. So it will be 0 minus 1. So the value minus 1 will be assigned to the looping variable I right before we hit the next statement. The next statement will increase the looping variable by 1, so minus 1 plus 1 equals 0. So again, Sarah will be printed out to the immediate window. And yet again, the looping variable will be assigned the value minus 1, and the next statement will increase this minus 1 to 0, so again we will print out the name Sarah. And the value of the variable I will always be 0, so we will never hit the exit condition. Let's run the code so you will see an infinite loop in action. You see that the name Sarah is continuously printed out to the immediate window. I will press Escape now. By pressing Escape, I stopped the execution of the VBA code. However, I failed to do that because I waited for too long and the process is now unresponsive. What we can do now is to go to the Task Manager. So I'm using a PC with Windows 10, so I will have to go to the Task Manager. You can press Ctrl-Alt-Delete, the shortcut Ctrl-Alt-Delete to go to the Task Manager, or you can simply search for the Task Manager here. Let's open the Task Manager once we found it. You see that Microsoft Excel is not responding. So what we have to do now is to press the right mouse button and to end the task. So basically we will just close Excel. I have to reopen my file and I have to go back to the Visual Basic Editor. Of course, before you run the infinite loop subroutine, make sure that you save all your work. But of course, keep in mind that there is a VBA section end.xlsm file, so there is a link to that file. So even if you lose some work that we are doing here, you can always recover it from the VBA section end.xlsm file that you can download. So I've shown you how you can kill a process, so how you can basically kill the whole Excel process. And unfortunately, in case of infinite loops, probably this is what you will have to do, because you will probably realize that you are in an infinite loop too late. However, I will run this subroutine now again, and after like 2 seconds I will press Escape. Actually, I changed the code a bit and I made a mistake, so this should be I equals I minus 1. So now this is a proper infinite loop. So okay, now I will run the infinite loop subroutine again, and after like 2 seconds I will press Escape. The code execution has been interrupted, which basically means that I pressed Escape, so I stopped the VBA code manually. I will click on End, and what you should notice is how many times in these 2 seconds the name Sarah has been printed out. A lot of times, really a lot of times. You see that we are in an infinite loop and the name Sarah is always printed out, because the looping variable I will always be 0 when we hit this line of code. So if you notice quickly enough that there is a problem with your VBA code, you can always press Escape to stop it. But if it is too late, you simply have to kill Excel, the Excel process. Of course, this infinite loop is harmless. This is for only educational purposes. But unfortunately, there are infinite loops that can do like real damage. And I think this is something that I must tell you about when teaching programming. Let's, however, move on to the next topic. Let's insert a new module. And let's call it Crash 10 Single Cell Ranges. I will implement a subroutine called Single Cell Ranges. And I think at this point it's time to discuss the range object, and it's time to actually get data from the Excel workbook through VBA code. So far we have written VBA code, but we always hard-coded the data. For example, this 100 and this 200, they don't come from an Excel workbook, but we just hard-coded these values, and we did this with all the other values, so far we have not taken anything from our Excel workbook here. But this will actually change, because this time we will take the value mark from cell A1 of the names worksheet. So we will use VBA to save the value of this cell. Before we proceed, make sure that only one Excel workbook is open for you. So make sure that only the VBA section start.xlsm workbook is open, and make sure that the names worksheet is your selected worksheet. Otherwise, the code that we'll write now will not work as intended for you. I will go back to the Visual Basic Editor, and I will declare a range variable called RNG. Now actually this range variable will be what we call an object variable that will hold a reference to a range object. So simply type dim RNG as a range. Earlier we've used non-object variables, like the number 1 variable here or the number 2 variable here. We stored integer values in these two variables, and these integers are simple numbers, they are simple values. But an object variable is something different, is something more complicated. The RNG object variable here will hold a reference to a range object. Now a range object, of course, is a range of cells, a range of Excel cells. For now, we will only work with a single cell range, and of course a single cell range is a range that represents or refers to a single cell on an Excel worksheet. Now of course this range variable has to refer to a range, so we have to assign a range to it. But because this is an object variable, we have to use the set keyword. However, I will not use the set keyword first. I want to break the code. On the right hand of the assignment, so after the equal sign, type range, and inside parentheses type the string A1. Range is not a VBA function. Range in this context is a property. But the range property here is sort of working like a function. We pass the argument A1, so the string A1, to the range property, and basically what happens is that the range property returns cell A1 of the active worksheet, so the selected worksheet that we have here. This is why I said to make sure that you have only one workbook open, so this VBA section start.xlsm workbook open, and make sure that this names worksheet is selected. Let's run the code. We receive a runtime error, object variable or with block variable not set. I've mentioned that the range is an object. It's not a simple value like an integer or long. It is an object. Because it is an object, this RNG variable is an object variable, and when we want to assign something to an object variable, we have to use the set keyword. I will click on end here, and I will type set before RNG, and you see that it is in blue and the S has been capitalized. If I try to run the code now, nothing really happens, but the code is not breaking, which is good. Actually, I will clear the immediate window as well. Basically, at this line of the code, the RNG variable holds a reference to cell A1 on the names worksheet, on this active or selected worksheet. Because this is a crash course, I cannot go into objects in great detail, unfortunately. But still, I have to talk about them a bit. You might have heard about object-oriented programming. Object-oriented programming is a way of programming. It is a way of organizing your code. In object-oriented programming, you think about everything as an object. By the way, object-oriented programming is usually abbreviated to OOP, and maybe it's better if I start using the abbreviation OOP. Let's go to our worksheet, so the names worksheet. In the Excel section of the course, we've discussed that the worksheet has a lot of cells. In terms of OOP, we can say that we have the range object to represent a single cell of a worksheet. A range actually can refer to a range of cells, so it can refer to more cells of a worksheet, but let's just say that a range is a single cell now. So a worksheet has a lot of cells. On this worksheet, for example, we have some cells with some data in them, but a lot of cells are blank or empty, so there is nothing in them. However, from the Excel section of the course, we know that we can, for example, format cells. We can give different backgrounds to cells, different fonts, different font sizes, and so on and so on. The idea here is that we have the concept of a cell or a range, and we should be able to do the same things to each of the ranges or cells that we have in our worksheet. If I want, I should be able to put the text mark into all of the cells or ranges here. If I want, I should be able to make the background of all of the cells here yellow, for example. So we should have a prototype of a cell, a place where we define in code what a cell should be able to do. For example, a cell or a range should be able to hold a value, for example, the text mark. Let's go back to the editor, the Visual Basic editor now. and let's print out the value of cell A1. I will simply type debug.print rng.value. Earlier I mentioned that we have the special debug object in VBA, and it has the print method, and we can access its print method with the dot notation. So we have to type a dot before the method name print. Notice that we do the same thing here with the RNG object, so with this range object. Don't forget that at this point it is a single cell range, so it represents cell A1. And this range or cell has a value, and this value is a text mark actually. And in order to access that value, we have to use the dot notation on this object. And what we access is actually the value property of the object. But at this point, you can think about the value property as a function that returns the value of the cell. So what's inside the cell? Let's run the code. And indeed, the text or the string mark has been returned, but this time we are taking it from our Excel workbook. Let me actually change this to mark222, and if I run the code now, then mark222 will be printed to the immediate window, and indeed mark222 has been printed to the immediate window. Let me actually change it back to mark, and let's go back to the editor. So at this point we know how to get data from our Excel workbook through VBA code. Unfortunately in the crash course, as I mentioned, I cannot get into objects and OOP in detail. But what is important now is that you know how to set a range object, so how to work with an object variable, so a variable that holds a reference to an object, and how to access the value of this single cell range, so range A1. Later in the course we will discuss how VBA knows that we want to get cell A1 of the names worksheet. But for now what you should know is that you can access the range property of a worksheet. And of course you have to specify the range of the worksheet. So we are now specifying cell A1. So this RNG object variable will hold a reference to cell A1. I will comment out this line of code, and actually I will copy it. I want to show you that instead of the range property, we can also use the cells property. And actually it takes two arguments, a row index and a column index. So I will put 1, 1 here. So this line of code basically does the same thing as this line of code. But instead of the range property of a worksheet, we use the cells property. And when we use the cells property, we have to define a row index and a column index. Now the row index, of course, is obvious, so row 1. And of course, column index 1 refers to the first column of the worksheet, so column A. So basically we are referring to cell A1 here as well, but we are referring to it in a different way as in the previous line of code. But if I run the code again, then the value of cell A1 is printed out to the immediate window. If I change the row index here, from 1 to 2, then the value of cell A2 will be printed out to the immediate window, and indeed Livia has been printed out to the immediate window, so the value of cell A2. Now if I change the column index from 1 to 2, then the value of cell B2 will be printed out to the immediate window, and indeed the value of cell B2 is Ulrich. I will actually change this back to cell A1, so row index 1 and column index 1, and let me show you another way of referring to cell A1 actually. We can still use the range property, but instead of the string, we can actually use the cells property again. So we have to say 1 and 1 here. So instead of the string A1, here basically we refer to cell A1 with the cells property. But if I run this code, it will not work. We got a runtime error, method range of object global failed, and actually it is quite cryptic, but I wanted you to know what this is. I will click on end. So if we are using the range property to refer to a cell, but we don't pass a string to the range property, but we are using the cells property as an argument, then even if it is only a single cell range, so even if we want to refer only to a single cell, we have to provide a second argument, the end of the cell. So actually I have to copy this. So now I'm using the range property, and don't forget that in this context the range property works like a function, so it returns something. It will return a cell to us. Or sorry, more like a range of cells, but we are returning a single cell range now. The first argument is cell A1, so the cell at row index 1 and column index 1, and the second argument is also cell A1, so the cell at row index 1 and column index 1. I will clear the immediate window, and if I run the code again, then mark is printed out again. So now we have a variable that holds reference to range object, and we know 3 different ways of referring to a single cell range. Probably it's a bit confusing that I'm talking about properties and I'm saying that properties are behaving like functions in this sense. And I can imagine that it's quite confusing that we are using the range property here and then the cells property twice. But when you really start working with VBA, you might see these 3 different ways of referring to a range, and I wanted to make sure that you know what this means. But the takeaway here is that if you want a variable to refer to a cell, then you have to declare it as a range, and you can use the range property or the cells property to set a reference to a range in your code, or to set a reference to a cell in your workbook. And once you successfully set the reference to a range or a cell, then you can take its value using the dot notation and the value property. So now you know how to take a value from a workbook, so how to refer to a cell using VBA code and how to access the value of that cell. And as I mentioned later, we will talk about how VBA knows that we want to get the value of cell A1 from the names worksheet. But now let's go back to the Visual Basic Editor and let's actually check multi-cell ranges. So let's see how we can refer to a range of cells by using the same RNG variable. Let's insert a new module and let's call it Crash 11 multi-cell ranges. And first I will just copy the single cell ranges subroutine, and of course I will rename it to multi-cell ranges. Now let me actually comment out this line of code and uncomment this first line of code, or the line of code with the first set keyword. So I'm using the range property to get a reference to a range, range of cells. But this time I want the range of cells to be A1 to A3, so I don't want a single cell range of course, but I want to get this range of cells. I can type a colon after A1 and A3. So now my range object variable will refer to the range of cells A1 to A3. Let me run the code now. We get a runtime error, type mismatch error. I will click on debug so we will see what line of code throws the error. So the error occurs when we want to get the value of the range object, so the range of cells that the range object refers to. And the problem is that this range object doesn't have a single value. So this range object is made up of 3 cells and each cell has its separate value. So this is the problem now. I will click on Reset Project. So there is no yellow highlight anymore. So basically what we need to do now is to loop through this range of cells and print out the 3 values or the 3 strings that we see here. First I will declare a new variable called cell, so dim cell as a variant. This cell variable will be actually my looping variable. And actually it will refer to a single cell range when I'm looping. But when I'm looping through a range of cells and I use a loop variable like the cell looping variable, then I usually declare it as a variant type. Don't forget that a variant can be anything. So this variable will be able to refer to a range object as well. We talked about the for loop, and actually we will use the for loop here, but we will not need an I looping variable, so the looping variable will be this cell variable. And actually we will use a for each loop. Let's type for each cell in RNG, and then let's type the next statement. You see that each is a keyword, so it is in blue, and also in is a keyword. Let me actually also type debug.print cell.value. We know that the RNG object variable refers to the range of cells A1 to A3. And we also know actually that it will be on the names worksheet, so it refers to cells A1 to A3 on the names worksheet in this case. When we use for each, then we don't need to have a loop-in variable like I, so we don't need to have a counter, so to say. Because with for each we specify that we want to loop through each of the items in the RNG object. Now, of course, in the RNG object, each item will be a single cell range. So first, at the first iteration, the single cell range will, of course, refer to cell A1, and actually this cell loop-in variable will be cell A1 at the first iteration. So at the first iteration, this cell.value basically means the value of cell A1. And on the next iteration, the cell variable will refer to cell A2, so we will get the value of cell A2, which should be Livia, I believe, yes. And at the third iteration, the cell variable will refer to cell A3, so we will get Frank, the value of cell A3. Once there are no more items, so once we looped over all the items that the range object refers to, the range variable refers to, we exit the loop. When we use the for each loop, we don't have to specify an exit condition. We just have to specify what we want to loop over, and of course this is a range of cells now. And we also have to specify, or we also have to have a loop-in variable, so that at each iteration we can refer to a different cell of this range variable. Let me clear the immediate window and let me run the code actually. Now indeed it is working, so we are using the for each loop now, and Mark, Liv and Frank have been printed out, so the values of cells A1 to A3. So now it's very important that you know about the for each loop and you know how you can use it to loop over a range of cells. Let me actually delete this line of code. And let me comment out this first line of code, first set line of code, so to say, and let me uncomment the second line of code where we set the RNG object variable. Here we are using the range property again to get a range of cells, and the beginning of the range will be cell A1. However, I will change this 1 to 3, so the end of the range will be cell A3. I will clear the immediate window. And if I run the code again, then we get the same result. So if we run this line of code, instead of this line of code, still the RNG object variable will refer to the range of cells from A1 to A3. We are making great progress here. We've made the first steps of getting data from an actual Excel workbook or worksheet through VBA code. As I mentioned earlier, later we will discuss why this line of code, for example, refers to cells A1 to A3 on the names worksheet and not of the profit worksheet, for example. But for now, what is important is only the VBA section start.xlsm workbook is open for you, and the selected worksheet in this workbook should be the names worksheet, and then your code should run the same way as it runs for me. So as I've said, we are making great progress, but of course we are not the end of the road, so let's continue with the next topic. So far we have iterated over the range of cells A1 to A3 on the names worksheet. At the very beginning of the course we were discussing one-dimensional and two-dimensional data. We can consider the range from A1 to A3 to be one-dimensional, because we are using only one column, but we are using several rows. Once we also include the range from B1 to B3, so once the range is A1 to B3, then we have two-dimensional data. And usually, of course, when we work with Excel, we will have two-dimensional data, so a table-like structure. We could actually use a for each loop to iterate over this range as well, so this two-dimensional range. But with the for each loop, we don't really have a control of how the data will be looped over. We cannot decide if we want to loop over rows, so cell A1, then B1, then cell A2 and B2, and then cell A3 and B3. Or we want to loop over by columns, so first cell A1, then cell A2, then cell A3, and when we are finished with this column, then we go to the next column, and then we loop over the cells B1, B2, and B3. When we work with VBA, of course, usually we have to process two-dimensional data, so it is essential that we have control over how the data is processed. Later we will talk about how to loop over this range of cells in two different ways, so by rows or by columns. But for now, we'll discuss two-dimensional arrays. So far, we've discussed only one-dimensional arrays. For example, if we go to the Array Indexes module, we specified that the employees array should be indexed from 1 to 5, but because we have only one index, then sort of we can think about the array as a one-dimensional array. However, we can have a two-dimensional array, so an array with two indexes. And once we know how to make a two-dimensional array, we will know how to process this, let's say, small table in a two-dimensional array. Let's insert a new module, and let's rename it to Crash 12 two-dimensional array. Let's implement a subroutine with the name two-dimensional arrays or two-dimensional array. I will declare a two-dimensional array called names, so I have to type dim names. And I know actually that I want to process or save this range of cells in my two-dimensional array. So let's say that the first dimension of my array will represent the rows or row indexes. So I know that I will need 3 rows or 3 indexes. And the second dimension of my array will represent columns or column indexes. So I will need altogether 2 indexes for the columns. What I can do is specify that the first index will go from 1 to 3. So the first index of my array, the first dimension, is the row dimension, sort of. I can put a comma here, and I can actually specify the second dimension of my array, which will go from 1 to 2. These will be the indexes for my columns, so index 1 is column A, of course, and index 2 will refer to column B. Although we will save strings into this array, many times you will see that people declare arrays as variants, and actually it doesn't really matter now if we have an array declared as a string or declared as holding strings or variants, so I will just declare this array as an array of variants. In this introduction of two-dimensional arrays, I will actually not get the values, so these names from the worksheet, but I will simply hard-code them. Later we will create a two-dimensional array from this range of cells exactly, so we will not hard-code the values, but for now let me just hard-code the values. In order to store a value in a two-dimensional array, we just have to specify the indexes under which we want to store the value. Let's say that we will go row by row sort of, so first I will save my first name and then my last name, and then Livia, and then Ulrich, and then Frank, and then Smith. So first I have to save the name Mark, and in order to do that I will say names 1, 1 equals Mark. If I run the code will not break, so it seems that everything is fine. And you know what, let me just print out my name. So I will actually print out the value stored in the names array at indexes 1 and 1. So let me run the code, and indeed my name has been printed out, so my first name has been printed out, so everything seems to be working fine. When we are working with two-dimensional arrays in VBA, you can think about a two-dimensional array as an array that has a row index and a column index. So we save the string Mark into row index 1 and column index 1, and of course column index 1 refers to column A basically. But we are working with an array, so we are not using the column letters but the column indexes. I said that I want to save the values row by row basically. Of course I'm just imitating it, so I'm not really saving the values from the worksheet. But I will put my last name here. And of course I will change the column index. So the value lengyel has been saved to the names array at row index 1 and column index 2. Basically we could say that these two indexes refer to cell B1. Column B has the index 2, and of course row 1 has the index 1. Of course this is only a two-dimensional array, so it doesn't have to do anything with rows and columns. But a bit later we will process this range of cells in a two-dimensional array. And I think that when we write VBA code and when we process a range like this in a two-dimensional array, then the best way is to think about these two indexes as the row index and the column index. Let me actually concatenate my name. So we will print out my full name. I will concatenate a space, of course, in between my first name and my last name. But here I will copy this part of the code. And if I press F5 now, then you see that my full name has been printed out to the immediate window. So we successfully stored values in this two-dimensional array, and we also successfully retrieved these values. We specified that the column index will go from 1 to 2. So in the names array, we have column index 1 and row index 1, column index 2 and row index 1, but we cannot have column index 3 and row index 1. So let's imagine that at this point we jump to the second row, so we want to save the values Livia and Ulrich in our names array. I suggest you pause the video and you try to do this yourself, so do it below this debug.print line of code. Of course I will also do it, so you don't have to pause the video, you can just watch me do it, but I suggest you practice a bit. However, of course, I will continue. So we have the names array. And this time we want to go to row 2, so row index 2 and column index 1. And we want to save the name Livia here. The name Livia is in cell A2, so column index 1 and row index 2, as you can see here. So this is how we can imitate saving a value into cell A2. Of course we want to save the name Ulrich, or the surname Ulrich as well. And we will of course change the column index to 2. So now in the names array at row index 2 and column index 2, so at cell B2 let's say, we save the name Ulrich. Let's print out the name Livia Ulrich as well, so I will just copy this line and paste it here. And of course I just have to change the row indexes, or the first indexes of this array. So if I run the code now, I will of course delete my name, and now I will run the code. Then we see that my name has been printed out, and of course Livia Ulrich has been printed out on this second line. Now let's move on to the third row, so we will want to save these values into our array. And of course I suggest that you do it on your own. So I suggest you pause the video, but if you don't want to do that, then of course I will just continue and I will do the work for you. So this time of course we want to save the name Frank at row index or first index 3 and column index or second index 1. Now, technically we have this two-dimensional array and we have the first index of the array and the second index of the array, or the first dimension of the array or the second dimension of the array. But I think maybe it's better if I refer to row indexes and column indexes. I think it's less confusing than referring to first and second indexes. And I hope you agree with me. Notice actually that the row index of the names array goes to index 3, so it's not a problem if I specify index 3 here as a row index. The column index will be 1, so basically we are referring to cell A3 now, and we want to save the string Frank here, because Frank is in cell A3. In cell B3, so at row index 3, but column index 2, we have the surname Smith. So let's save Smith here, and let's print out the name of Frank Smith as well. So I will copy this line of code, and of course I will just adjust the row indexes here. I will clear the immediate window, and I will run the code again. And now we are working with a two-dimensional array, and what is printed out to the immediate window is basically the same thing that we see on our worksheet. So we see my name first, then Livia Ulrich, then Frank Smith, and this is exactly what we see in the immediate window. So this has been the introduction to two-dimensional arrays. I have hard-coded all the strings that we saved into this names array. So basically I just imitated saving the values from the worksheet into the names array. But shortly we will actually save this range of cells into a two-dimensional array dynamically, so we will actually save these range of cells. So we will process them as an array. And of course, in order to do that, we will insert a new module. Let's call this module Crash13 Nested Loops. And let's implement a subroutine here, looping two-dimensional array. So we will loop over a two-dimensional array now, and of course you will see what a nested loop is. But basically a nested loop is a loop inside a loop. So when we have two or more loops nested into each other. First, let's declare the variables that we will use. We will have an array called employees, and after the name of this variable I will just put parentheses, but I will not put anything inside the parentheses. So basically I'm declaring a dynamic array now, so I don't specify the indexes, and actually this array will hold a variant types. I will need, of course, the I variable, so the looping variable, and I will declare it as a lon. I can tell you that we will have two for loops nested into each other. So we will actually need another looping variable, and I will call this other looping variable j, and of course I will declare it to be a lon. I've told you earlier that I basically stands for index, but if you need other looping variables in a subroutine, then usually your second looping variable is called j, or at least this is what people usually do. And j actually doesn't really stand for anything, but it is the letter that comes after I in the English alphabet. I will declare four more long variables. I will have a first row index, so first row IDX will refer to first row index. I will also have a last row index. And I will also have a first column index. Now I will call it first call IDX, so it will refer to first column index. And of course I will also have a last column index. So last call IDX, last column index. Shortly, of course, you will see why we have these variables declared. What I want to do is actually saving this range of cells into the employees array. So I want to make this employees array a two-dimensional array, but I want to do this dynamically or automatically. So I don't want to hard code the values as we did previously. And it's very fortunate that I don't have to do that. I can do this in one line of code. So I can process this range of cells as a two-dimensional array by using only a single line of code. Very important that only the VBA section start.xlsm workbook should be open for you, and the names worksheet should be selected. Otherwise, your code will not run as my code. Later in the course, I will tell you why it is important that you have only this workbook open and you select this worksheet. The range of cells that we want to process in a two-dimensional array goes from cell A1 to cell B3. So let's go back to the editor, and let me just simply assign this range to my employees array. So actually simply accessing the range property of the worksheet and assigning it to an array will process the range of cells A1 to B3 automatically as a two-dimensional array. I mentioned that the range property of the worksheet, and of course I'm talking about the names worksheet now, but later in the course I will get into more detail what I mean by this. What is important now that once this line of code is hit, then our employees array will be basically the same as our names array here in the previous module. So let me actually just copy this line of code from the previous module, and I will paste it here. Of course, I will have to change names to employees, but I will copy this line of code twice, and I will adjust the row indexes. I will clear the immediate window, and I will run the code now. And indeed, what we see is that this line of code creates a two-dimensional array automatically, so this employees array will be a two-dimensional array. And at row index 1 and column index 1, we see the name Mark, and then at row index 1, column index 2, my surname, at row index 2, column index 1, Livia, at row index 2 and column index 2, the name Ulrich, and at row index 3, column index 1, Frank, and at row index 3, column index 2, Smith. So I didn't have to manually specify my indexes. Assigning a range object to an array basically created a two-dimensional array automatically. And you see that when VBA does this automatically, then the first index of the employees array basically refers to the row indexes, or basically are the row indexes, and the second index of the employees array are basically representing the column indexes. So we have two columns, columns A and B, but we have three rows. So we go to cell A3 and B3. We have two columns, of course, so column A and B, and column index 1 refers to column A, column index 2 refers to column B. But we have three rows or three row indexes because, of course, we go until cell B3, so until the third row. So in the employees array, the indexing is the same as in the names array in the previous module. So first we have the row indexes going from 1 to 3, and then the column indexes going from 1 to 2. Previously, when we worked with one-dimensional arrays, VBA by default indexed the array from 0. However, when you assign a range object to an array, then the indexing, in case of both indexes, start from 1. I will comment out these three lines of code because actually we don't need them. We just need to confirm that indeed the correct values or the correct range of cells was saved into the employees array dynamically. Before we will loop over this array, this two-dimensional array, we need to know the first row index. Now we know that it will be 1. And we also need to know the last row index, and we know that it will be 3. And we also know that the first column index will be 1, and the last column index will be 2. But of course we want to get these values dynamically. So for the first row index, we will of course use the L-bound function. So this is a function that we've used before. And we know that when we use the L-bound function, we have to of course pass an array to the function. So we will get to know the lower bound or the first index of the employees array. But now the employees array is a two-dimensional array, not a one-dimensional array. So we have to specify that we are interested in the row index or the first index of the employees array. So the lowest first index of the employees array. Now in this case, we have to provide another argument or pass another argument to the L-bound function. The first argument is of course the array whose lower bound we want to get. But because this is a two-dimensional array, we have to also specify which dimension we are interested in. And basically when I put 1 here, then I say that I'm interested in the lower bound of the row index. And it will actually be 1. Of course, for the last row index, I will have to use the ubound or upper bound function. So I will save the result into the last row index variable, and I will use the ubound function here. So the value 3 will be returned into this last row index variable because we are using the ubound function. And we specify that we want to get the upper bound of the employees array, and we want to get the upper bound of the row index. So basically the last row, and we know that the last row will be 3. Let's actually confirm that the correct values are returned. So I will just put debug.print here, and we will print out the first row index, and then we will also print out the last row index. I will clear the immediate window and I will run the code. And indeed, the first row index is 1 and the last row index of the employees array is 3, and this is what is printed out to the immediate window. I will actually delete these two lines, we will not need them. Using the L-bound and the U-bound functions, try to assign the correct values to the first column index and to the last column index variables. You can stop the video, but of course I will continue working, so basically I will copy and paste this line of code. And of course now I'm interested in the first column index. Now we know that the first column index will be 1, so column A, but this function, the L-bound function, will return this value automatically to us. However, this time I have to specify that I'm interested in the lowest column index, so at the second dimension. And let me just copy this line of code and paste it here, and then I will save the last column index. I will also use the U-bound function, as I did in the case of the last row index. So basically the value 2 will be returned, because that is the highest index of the employees array at the second dimension. Now actually we have everything that we need for looping, but let me actually just confirm that the first call index and the last call index variables are correct, or their values are correct. So let's print out these values. So I want to see 1 and 2 printed out. And indeed 1 and 2 have been printed out, so the lowest column index will be 1 and the highest column index will be 2. Okay, so far so good. I can delete these two lines of code. And now actually we have everything to loop over this two-dimensional array. First, let's loop over by rows, so let's loop over the first dimension. So what we will have to do basically is to loop over the data by rows. Of course we will loop over our array, so not this range of cells or not these cells. But of course this range of cells is a perfect visual representation of our two-dimensional array now. So what we want to do is to loop over this range by rows. So first Mark will be printed out, then my surname, then Livia, then Ulrich, then Frank, then Smith. We will use a nested loop, so two loops will be nested into each other. And because we want to loop over rows, the outer loop will use the row indexes and the inner loop will use the column indexes. So let's see what I mean. So let's continue coding. So let's type for I, so the first looping variable or the outer looping variable. So we have to initialize this looping variable, and we, of course, will initialize it to be the first row index. And we want to loop until the last row index, of course, and we know that the last row index will be 3. I press enter and I will put next here, but after next I will put a comment, and this comment will be just the letter I. So here I'm sort of signaling that this next statement increases the looping variable I. So this next statement belongs to this line of code, so to this loop. So now we have our outer loop, but we need to have our inner loop. So let's press enter and let's have another loop. And the looping variable for our inner loop will be j, of course, and the initial value of j will be the first column index, which will be 1, and we will loop until the last column index, which will be 2. And of course we need another next statement, and I will put the letter j in a comment after the next statement, so we know that this next statement refers to this for loop, or they are together. This is a loop that we have, and this is of course our inner loop. But this next statement refers to the outer loop, or is part of the outer loop that we have. Of course what we want to do is to simply loop over the array, and now we have our inner loop nested inside the outer loop. And actually I only need one more line of code to print out all the values of the array. Of course it will be a debug.print line. And I have to access the value of the employees array at row index I and column index j. Let's run the code to confirm that it runs as we intend it to run. And actually everything seems to be fine. I will make the immediate window a bit bigger. So indeed we are looping over by rows. So my first name comes and then my last name, as we can see here in the worksheet, and then Livia comes and Ulrich, and then we go to the next row and Frank and Smith are printed out. Now each first name and last name is in its own line, because of course the print method prints a new line to the immediate window, and we are not concatenating the names. But this is not a problem. We see that we are looping over by rows. Nested loops are not the best in regards to performance actually, but sometimes you just cannot avoid nested loops. And you will see a lot of nested loops in other people's code, and a nested loop is also a basic concept of programming or computer science. So it's important that you understand what is happening here. So let's go over this nested loop structure step by step. We will not go over all the steps, but we will go over enough steps so that you see what is happening here. So when we hit this line of code, then the looping variable I is initialized to be 1, and we will loop until this variable I is 3. So once this variable I would be 4, we stop looping. Of course, we have the second looping variable, the variable j, and of course this variable represents the column indexes, so we are looping from the first column index, so column A, to the last column index, column B. And once this variable j is increased and it exceeds 2, then we exit this loop, so we will not loop again. When this line of code is hit for the first time inside our loop, then the value of I is 1, so it's the same as the first row index, and the value of j is of course 1, so the first column index. This is why mark is printed out, so the value at cell A1 basically. Then we hit the next statement here, and then the looping variable j is increased by 1, so this loop runs again. We are not hitting this line of code, so we are not increasing the looping variable I, only the looping variable j is increased, and this loop runs again. So this time I is still 1, so we are still getting the first row sort of, or we are still specifying the row index to be 1 here. But j has been increased, so we are getting the value from the second column. So basically it's column B and it's row 1, so we are getting my name here, so my surname here. So my surname is printed out, and then we hit again this next statement, so then the variable j is again increased, but this time its value will be 3, which exceeds the last call index, so the last column index is 2, and now the variable j is 3, so this loop doesn't run anymore. So this is the time when we hit this next statement. So once we are done with this loop, then we hit this next statement, and the looping variable I is increased by 1. Now the looping variable changed, and actually we get back to our inner loop once again. So after we hit this next statement, we get back to the beginning, so we get back to the outer loop, and of course the inner loop restarts. The value of the looping variable j will be 1 again, and this time when we hit this line, we are getting the value from row index 2, so I is now 2, and column index 1, so basically the value from cell A2, which should be Livia. Again we hit this next statement, and the variable j is increased, so this time we hit this line of code again, and we will get the value from row index 2 and column index 2, so from cell B2, so the value from cell B2, which is Ulrich. And once again we hit the next statement, and the looping variable j is increased by 1, but this time it exceeds the exit condition, so the last column index is 2, but now j is 3. So we once again exit the inner loop, and we once again increase the variable I. So we once again hit this next statement, and once again we are back to the beginning, back to the outer loop. But this time the value of the looping variable I is 3. But the looping variable j will be 1 once again, so the initial value will be set to 1 once again, and when we hit this line of code, then we will retrieve the value from the employees array at row index 3 and column index 1, so basically the value of cell A3, which is Frank. Once again we hit this line of code. So once again, we increase the looping variable j, and it will be 2. So when we hit this line of code, then we will get the value at row index 3 and column index 2. So cell B3, which should be Smith, the value Smith. Once again, we increase the looping variable j, but this time it exceeds the last column index because it will have the value 3. So we quit this inner loop, and once again, we increase the looping variable I, but it will be 4 this time, and it will exceed the exit condition because the last row index is 3, and now the looping variable I is 4. And this is actually the time when we exit the loop fully. The inner loop will not run anymore, and the outer loop will not run anymore either, because the exit condition for the looping variable I has been met. Actually, I have explained the whole loop here, so the whole nested loop. I intended only to explain maybe the first 2 iterations, but it's not a problem. I hope that you got some value out of it, because it is really, really important that you become familiar with the nested loops. They can be really, really confusing at first, but I hope that a detailed explanation helps you. We are not finished with this subroutine, however, because so far we have looped over our employees array by rows. However, I want to loop over columns as well. So I will put the comment here, looping over columns. And I suggest you copy the loop that we have and try to change this loop yourself so that we are looping over columns. So basically the values will be printed out as Mark, Livia, Frank, and then the surnames or last names. We have printed them out row by row, so Mark and Lengyel and Livia and Ulrich and Frank and Smith, as you can see it in the immediate window still. So Mark, Lengyel, Livia, Ulrich, Frank and Smith. Actually, I messed up my immediate window bit, so I will just clear the values. So basically, what we want to do now is to loop over columns. So Mark, Livia, Frank, and Lengyel, Ulrich, and Smith will be printed out under each other. So try to do this on your own, and you should pause the video because, of course, I will show you how to do it now. Fortunately, I don't have to change a lot of things here to be able to loop over columns instead of rows. This time our outer loop should loop by columns or column indexes, so the variable I will be initialized to the first column index, and it will stop after the last column index is reached. And of course our inner loop, so the looping variable j, will be initialized to the first row index, and it will loop until the last row index. Between the 2 loops I will put a debug.println, and I will print out some dashes. So in the immediate window, these 2 loops, or what the 2 loops will print out, will be separated by some dashes. Let's try to run the subroutine. Unfortunately, I get a subscript out of range error. Do you remember what this error means? It means that we are trying to access an index of an array, for example, that does not exist. And I actually made a mistake here. Let me clear the immediate window. I should have swapped these 2 looping variables. So this time our code should run successfully, and actually it does. So first you see we are looping by rows like before, but after the dashes we are looping by columns, so the first names are printed out first, so column A basically, and then the last names are printed out, so column B. I will clear the first half of the immediate window, so we will still see what was printed out by this nested loop. So let's sort of walk over this loop as well. So now in the outer loop we have the column indexes defined, so we are looping over columns in the outer loop, and then we are looping over rows in the inner loop. So when we start looping, then the I variable will represent the first column index, which will be 1, and then variable j will be initialized to the first row index, which is 1 of course, and it will go, so this variable j will go until the last row index, which is 3. So this time the variable j represents the rows, and this is why our subroutine broke when I first ran it, because I forgot to swap these indexes, and the variable j was still referring to the column indexes. However, we see now that the variable j should represent the row indexes. So when we hit this line of code for the first time, then both j, so the row index, and I, the column index, are 1. So we print out my name, Mark, from cell A1, so to say. Then the next statement is reached and the variable j is increased by 1. So we print out the value at row index 2 and column index 1. So don't forget that we didn't hit this next statement, so the column index is still 1 here. So we are printing out the contents of cell A2, which is of course Livia. And then again we hit this next statement, and then the row index will be 3. It will be actually the last row index, so the exit condition is reached, but still it is not exceeded. So the value of the employees array at row index 3 and column index 1 is printed out, so the name Frank, which is basically cell A3. And then again the next statement is reached, and the variable j is increased by 1, so it will be 4, and this time we exceed the exit condition, so the last row index is 3, and now variable j is 4, so this time we quit the inner loop, and this is the time when we hit this next statement that increases the variable I, so the column index will be 2. We are still not exceeding the exit condition, so of course we hit the inner loop again, and this time we will loop over the values of column B, so column index 2. Of course the row index, so variable j, is initialized to 1 again, so when we hit this print line, then the row index is 1, however the column index is 2, so we print out the contents of cell B1, so my last name. And then the row index is increased, so we hit this line of code again, and then we print out the contents of cell B2, so the family name Ulrich. And of course, the column index now is still 2, but the row index is also 2, so it was increased. And when we hit the next statement again, then the row index will be 3, so we will print out the value stored in the employees array under row index 3 and column index 2, so the family name Smith from cell B3. And then variable j, so the column index is again increased, but this time it exceeds the exit condition, so it will be 4 and the last row index is 3. So we again hit this next statement and we increase variable I, but variable I this time will be 3. And don't forget that the variable I represents the column indexes and the last column index is 2, so this exit condition is met as well. So we exceeded the last column index. So the outer loop exits and no looping will be done anymore in this subroutine. Of course, in the crash course we are progressing gradually, but I think that this subroutine, so what we are doing here, is really complicated. We are processing a range of cells as a two-dimensional array. We are getting the lower and upper bounds, so the first and last indexes of this two-dimensional array. And we are looping over this two-dimensional array in two ways. So we are looping over by rows or looping over by the first index or first dimension, and then we loop over by columns, so the second dimension or the second index. We've been discussing arrays and looping for a while, so I think that the next topic will be a bit different. But don't worry, these have not been the last loops that we have written in the crash course. Let's insert a new module, and let's call it Crash 14 Conditional Logic. Let's implement a subroutine called Conditional Logic. Let's declare two integer variables called number1 and number2. Let's assign the value 100 to the number1 variable And let's assign the value maybe 99 to the number 2 variable. During the Excel section of the course, we discussed conditional logic already. We familiarized ourselves with functions like the if function and the SUMIF function. The concept is the same in VBA, so the concept of conditional logic is the same as we saw in Excel. We use conditional logic in programming to test for conditions and to make different decisions based on the result of our test. A condition can be either true or false. And of course, if a condition is true, then we want to do one thing, but if a condition is false, then we want to do another thing. This is of course the first time that we see conditional logic in VBA, so we will take it easy. In order to use conditional logic, we will need the if keyword. After the if keyword, we have to test for a condition, and the condition we will test for is if the variable number 1 exceeds the variable number 2, so it's greater than the variable number 2. After our condition, we have to use the then keyword, and I will press enter. And to finish our test, so to finish this block of code, we have to use the and if keywords. You see that the words if, then, and are all keywords in VBA. When we use the if keyword, so when we are applying conditional logic in VBA or in programming actually in general, we say that we have written an if block of code, or we can also say that we have an if branch here. Let me type a new line, and of course it will be debug.println, and I will just print out variable number 1 is bigger than number 2. Let me clear the immediate window and let's actually run the code. And indeed the string variable number 1 is bigger than number 2 has been printed out to the immediate window because the variable number 1 holds the value 100 while the variable number 2 holds the value 99. So what happens here is that with the if keyword we signal that we will test for a condition. Then we have to specify the condition we are testing for, and of course we are testing if the variable number 1 is bigger than the variable number 2. The greater than sign here, of course, is a conditional operator now. And actually the conditional operators in VBA are the same as in Excel. So after we specify the condition, then we use the then keyword. So basically the condition that we are testing for is in between the if and the then keywords. And if the condition evaluates to true, then the code in this if block is executed. However, if the condition is not true, so if the condition is false, then this line of code, so the if block, the code inside the if block is simply skipped. Let me clear the immediate window and let me assign the value 200 to the variable number 2. It doesn't matter how many times I run my code, nothing is printed out to the immediate window because this condition is false, so this line of code is skipped. Let me change the value of the number 2 variable from 200 to 100. If I run the code now, still nothing is printed out because still this condition is false, so the variable number 1 is not bigger than the variable number 2 because they are equal. However, if I change the operator here, so if I say greater than or equals, and now I run my code, then this line of code is hit and the string is written to the immediate window because now this condition is true because the variable number 1 is the same as the variable number 2, so they are equal. And actually I will just delete the greater than sign and clear the immediate window, and now I will run the code again. And this condition again evaluated to true, so the string has been printed to the immediate window. Notice that I'm using the equal sign like I use it here, but this time the equal sign does not represent assignment. This time with the equal sign we check for equality between these two variables. If you use the if keyword, then the equal sign will have a special meaning as part of your condition. So this will be the operator checking for equality and not the operator with which we can assign values to variables. There is also the less than or equal operator. I will clear the immediate window, and if I run the code now, this condition evaluates to true because the two variables are equal. But if I check if the variable number 1 is less than the variable number 2, then nothing happens, so this condition evaluates to false now. Let me change this operator, so the less than operator to the greater than operator. And let me change the value of the variable number 2, so let it be 200. Now if I run the code, of course, this condition evaluates to false because now the variable number 2 exceeds the variable number 1, or at least the value stored by the variable number 2 exceeds the value stored by the variable number 1. What we have here is a very simplistic if branch, let's say, but it can become more complicated. We also have the else if keyword in VBA. But the idea is basically the same. After the else if keyword, we can check for another condition. So we will check if the variable number 2 is greater than the variable number 1. After specifying a condition, we have to use the then keyword. And actually, if this condition evaluates to true, I want to print out the text that number 2 is bigger than number 1. Let's run the code. And it seems that this line of code has been skipped. And of course, it was skipped because this condition evaluates to false. However, this other print line has been hit or executed by the Visual Basic Editor because this condition evaluates to true. What happens when our code runs is that first, of course, this condition is checked. Now this condition evaluates to true, so this line of code is skipped. However, we don't jump to the end if line, so we don't quit this if block of code because we have an else if statement or else if block. And it has another condition, and because this condition, the first condition, evaluated to false, then we hit this line of code, and now we test for this condition. And because this condition evaluates to true, this other print line is not skipped, but we see this string in the immediate window after we run the code. Let me change the value of the variable number 1. So now this condition will evaluate to true. So let's run the code now. So in this case, because the first condition evaluates to true, this line of code is executed and this condition is not even checked, so we skip the rest of the code here and we quit the if block. We only check this other condition or this other test if the first one evaluates to false. Let me change the value of the number 1 variable again, so let it be 200, and now neither condition evaluates to true, so they will be both false. So if I run the code, it doesn't matter how many times I run it, neither lines are executed. This condition evaluates to false, and then the second condition evaluates to false, and there are no more conditions to check, so we end the if block and then the subroutine ends. However, in VBA, we have another keyword that we can use, the else keyword. And after the else keyword, we don't specify any conditions and we don't use the then keyword, but I will copy and paste this line here. And the string will be, they are equal. Let me run the code now. And now the string they are equal has been printed out to the immediate window. So now the variables are equal, so the first condition evaluates to false, so this line of code is skipped. However, the second condition also evaluates to false, so this line of code is also skipped. In case all the conditions evaluate to false and we have an else branch, then the else branch will run, so the code inside this else branch will be executed. But we only hit this line of code if all the conditions that we specified above it evaluate to false. So if I change the value of the number 1 variable, and it will be 300, and if I run the code again, then this condition evaluates to true and only this line is printed. and this condition is not checked and we don't hit the else branch because the first condition has been evaluated to true. Now, this has been conditional logic in VBA in a nutshell. It could be more complicated, but this is a crash course, so we will not dig deeper into conditional logic. But conditional logic is also a basic concept of computer science. Let's just quickly recap what we have done so far in the VBA section of the course. We have talked about data types, we talked about the array data structure, and we also familiarized ourselves with the two-dimensional array. Then we learned about loops, and of course, loops or iterations, also a basic computer science concept. We have also discussed the range object, but we will discuss objects in a bit more detail later. And we challenged ourselves with nested loops as well, and now at this time we know what conditional logic is. So slowly but surely we are getting all the building blocks that we need in order to automate Excel processes using VBA code. Let's move on and let's combine looping and conditional logic. So let's add a new module and let's rename it to Crash 15 Exit Loop. Let's implement a subroutine called exit loop. We will combine looping with conditional logic to exit a loop early. If you exit a loop early, then you loop only until it is necessary. So it is considered a good practice and it's good performance-wise as well. Let's declare some variables first. I will declare the variable I as a long. Of course, this will be our looping variable. But I will declare another long variable called first row IDX or first row index. And actually I will declare a third long variable and it will be called last row index or IDX. And I will declare one more variable called name and it will be a string variable. Make sure that only the VBA section star.xlsm workbook is open. Select the profit worksheet. On this worksheet we have some salespeople from cell A2 to cell A18. Let's say that we want to write a loop that finds Jessica Stone, and once it finds Jessica Stone it will not continue looping, so we will exit the loop. What we will do is to print out each name until we find Jessica Stone, and once Jessica Stone is found then we will print out her name, but we will stop looping. So the rest of the names below Jessica Stone will not be printed out. We will actually not use an array now, so we will actually loop over these cells or this range of cells on the profit worksheet, so make sure that the profit worksheet is selected for you. Let's go back to the editor and let's hard code some values. Now the first row index will be 2, the last row index will be 18, and the name will be Jessica Stone. We will start looping at row 2 because the first name Abby Wood is in row 2, and we will stop looping at row 18 because the last name Tobias Ferguson is in row 18, so this is why I hard-coded these two values here. Later in the course we will actually get dynamically the index of the last row, but for now I will just hard-code it. So basically we will loop over the rows or the cells A2 to A18. And once Jessica Stone is found, so once the value or the contents of the cell will equal to Jessica Stone, then we will stop looping. So let's implement our loop. Of course this will be a for loop, and we will initialize the variable I, so the looping variable, to be the first row index, and we want to loop until the last row, of course. We need a next statement as well, so our loop is ready, but it's not doing anything so far. First, let's just print out the value or the content of each cell, And what we will do is use the cells property. Now this is a property that we used earlier, and the cells property belongs to the worksheet object, but we will talk about this a bit later. What matters is that we have to specify a row index and a column index. So, basically the same idea as with the two-dimensional array. And the single range of cell based on the row index and the column index will be returned by the cells property. Now we will loop over only one column, so column A, so the column index will always be 1. However, the row index will always change. So basically the row index will be represented by the looping variable I, and the column index will always be 1. With the dot notation, we have to call dot value to get back the value or the contents of the cell that we are currently looping. Let me clear the immediate window and let's run the code. I will make the immediate window bigger. So first, the contents of cell A2 is printed out, and the last one that is printed out is the contents of cell A18. Now we are not exiting the loop early, so I just wanted to confirm that the loop is running as intended, or the code is running as intended. So what happens basically is that because in the cells property we specify a row index and a column index, then a cell, or actually a range object representing a cell, will be returned by this highlighted part of the code. At the first iteration, we will return the cell at row index 2 and 1 and column index 1. So it will be, of course, cell A2. And of course, at the next iteration, the variable I is increased. So we will return the cell that is at row index 3 and column index 1, so cell A3, and so on up until cell A18, because of course 18 is the exit condition. So once the variable I is increased to 19, then we exit the loop and nothing else is printed out, of course. Once the cell or the single cell range object is returned by this highlighted part of the code, of course we access its contents or its value, and this is why you see the names printed out into the immediate window. So basically this is the way for accessing the value of a cell, but this you have seen earlier when we were discussing single cell ranges here, for example. But this time we use the cells property inside the loop, so we are using the looping variable I to specify the row index for the cells property. Let me actually clear the immediate window, and let's actually leave this line here. So after this line we have to specify the condition. So basically we want to check if the value of the cell that is currently returned is equal to the name Jessica Stone, and of course we are storing this name in the variable called name. Of course I will need the endif to close my if block. If we found Jessica Stone, so if this condition evaluates to true, then we want to print a new line, so debug.print, and let's say we found, then a space, and we concatenate the name variable here. So basically once we hit Jessica Stone, so once we hit cell A10 here, then this condition evaluates to true, and this additional line of code will be printed out. Let's run the code. So indeed, after Jessica Stone is printed out, then the text "we found Jessica Stone" is also printed out. However, we are still not exiting the loop, so all the other names are printed out as well. At the iteration when we are checking cell A10, then this condition evaluates to true and this line of code is executed, but in the case of all the other iterations, this condition evaluates to false, so this line of code is not executed. The only thing we have to do is to add a new line under this print line, and we will use the exit for keywords. Now, both the exit word is a keyword, and of course the for word is also a keyword. But basically with the exit for keywords or statement, we tell VBA that we want to exit this for loop early. So once we print out this line that we found Jessica Stone, then we hit the exit for line, and we basically just jump out of the loop, so the looping variable I will not be increased again, and we will not get back to these lines of code. Let's clear the immediate window, and let's actually confirm that the code runs as we intended to run. And it seems that it's working. So of course Abby Wood is printed out and Catherine Jones and so on and so on. But once Jessica Stone is printed out, then this condition evaluates to true, and then we print out the line we found Jessica Stone, and we hit the exit for line, so we exit the loop early and we don't print out any names anymore. I would like to remind you again that the code only runs as intended if you have only this workbook open, so the VBA section start.xlsm workbook, and you select the profit worksheet on this workbook or in this workbook. I mentioned earlier that exiting a loop early is good for performance as well. On this worksheet, we are checking only 18 names, and 18 names is really very few for a computer, so it's not really hard for a computer to run a loop 18 times. Actually, we are running it 17 times, sorry, because we are starting from row index 2, so we are basically running the loop 17 times. And once we are at row index 10 or iteration 9, then we exit the loop early, so these cells will not be iterated over. It doesn't really matter actually if we are looping 9 times or 17 times. However, if there were 1 million names here and Jessica Stone was in cell A10, let's say, then it would be a big difference for performance. Even if you have a good computer, 1 million iterations are considerably slower than 9 iterations. Programming or writing code is not only about getting the job done, but getting the job done efficiently. And of course, if you are still learning programming, so if these are the first lines of code that you're writing, then your first objective should be is to write code that does the job. And probably you don't even know the difference between code that does the job and code that does the job efficiently. But still, I want to instill this idea in you at this very early stage of your career, that you should always consider being efficient. If you write some code that does the job, then I suggest at the beginning or early stages of your career, you should constantly go back to the code that you have written and try to make it better. This will help you tremendously to become better at programming or writing code. Okay, so actually what we have done here is quite good. So we iterated over a range of cells without using an array. You might ask why actually we learned about arrays then. But don't forget that this is just one-dimensional data, so we are using only one column, and actually we used a two-dimensional array, so we converted a range to a two-dimensional array previously at this range of cells actually. And we iterated over the range by row and then by column. So it was actually quite useful that we used an array. However, it is not strictly necessary to use an array to loop over a range of cells, even if it is two-dimensional. But it is actually essential that you understand what a data structure is, and an array is a data structure, so an array is a way of organizing data. And of course, it's also very important that you understand how you can save data into an array under indexes and how you can retrieve data from an array under indexes. In the VBA section of the course, I not only want you to know how to automate Excel processes in VBA, but I also want you to have a good foundational knowledge in programming. And understanding a basic data structure like the array is really so essential for programming that it just cannot be skipped. However, I think I've talked enough for now, so actually we should move on to the next topic. So let's get back to the Visual Basic Editor. Let's insert a new module, and let's call it Crash 16 Worksheet Object. I will copy and paste the exit loop subroutine that we have written, but of course I will rename it to Worksheet Object Subroutine. so worksheet object sub. We've talked about the exit for keywords. Now I want to show you another keyword, the exit sub keyword, or pair of keywords, sort of. With the exit sub keywords, we can exit a subroutine early. I will make my immediate window a bit bigger. If I run this code now, nothing is printed out to the immediate window, because as soon as this line of code is hit, so as soon as the exit sub line is hit, then the subroutine ends. So this part of the subroutine never runs. So nothing is printed out to the immediate window. Make sure that only the VBA section start.xlsm workbook is open for you, and make sure that the profit worksheet is selected. Before we exit the subroutine early, let's print out the value or the contents of cell A2, for example. Of course, I have to access the value property of this range object. If I press 5 now and run the code, then Abbey Wood has been printed out to the immediate window, so exactly the contents of cell A2. I will press F5 to run the subroutine. Abbey Wood has been printed out to the immediate window, so the contents of cell A2 on the profit worksheet. Select, however, the names worksheet now, and let's run our subroutine again. I will, of course, clear the immediate window, and I will press F5 again. And this time Livia has been printed out, so this time the contents of cell A2 has been printed out on the names worksheet. Notice that we didn't change anything in the code, so we are accessing the range property and we are passing A2 as an argument, so we get back cell A2, basically the range of cell A2 here, and we access its value or the contents of the cell. But depending on what worksheet is selected, our code produces different results. If the names worksheet is selected, then we are taking cell A2 from the names worksheet. If the profit worksheet is selected, then we are taking the contents of cell A2 on the profits worksheet, or profit worksheet, sorry. Earlier, I've mentioned that range is a property here actually that returns a cell or a range. And I've also mentioned that the range property is a property of the worksheet object. When we type this in our code, then actually Visual Basic Editor implies an active sheet object for us, so a worksheet object for us. Let me type active sheet here and a dot. Notice that as soon as I left the line of code, so this line of code, the A and the S have been capitalized by the Visual Basic Editor. Active sheet returns a worksheet object to us, and actually it returns the selected worksheet object, so the currently selected worksheet object. Let me run the code now, so I will clear the immediate window. Abbey Wood is printed out to the immediate window because the active sheet is now the profit worksheet. But if I select the names worksheet and run the code again, then Livia is printed out because now the active sheet is the names worksheet. We know that the range property returns a range of cells. It can be, however, a single cell range, like now. But now we know that the range property belongs to a worksheet object. And now let's talk about what a worksheet object is. In an Excel workbook, we have at least one worksheet, but here we have 3 worksheets. These worksheets have different names and there is different data on them. But we can do the same things with each worksheet. We can rename them, we can add data to them or delete data from them. And of course, we can also use formulas on worksheets. So we could use any formula on any worksheet. You can think about the worksheet object as the code behind a worksheet, an Excel worksheet. Earlier, I think I've mentioned that there is of course a range object as well. So each cell can be taken as a range object. And we can also do the same things with ranges or cells. So we can give background colors to them. We can put formulas in them, we can put data in them, and so on and so on. And you can think about the range object as the code that defines what a range is. When we add new worksheets to a workbook, then the same code runs, so the same blueprint of a worksheet is created, so the same worksheet object is created. Of course, these worksheet objects are a bit different, so they cannot share the same name, for example, in the same workbook. But the idea behind objects in programming is that you can do the same things with 2 objects of the same kind. So you can do the same things to two worksheet objects, and you can do the same things with two range objects. Objects have properties and methods. We've discussed that in VBA we have the special debug object that we can reach from anywhere, and it has a print method that prints out some text or a string to the immediate window. A method is very similar to a subroutine or a function. But a method belongs to the object, so only the debug object has this print method. A worksheet object or a range object doesn't have a print method. Objects also have properties. A worksheet object has a range property, and you can think about properties as data belonging to an object. For example, a worksheet also has a name property, so the name of the worksheet is basically some data that belongs to a specific worksheet. But a property can also behave like a function, so it can return something. For example, the range property returns a range. I think I mentioned that the ActiveSheet object is a special object. Basically, it refers to the worksheet that is selected, so the worksheet that you see when you click on the Excel application. I have only one workbook open, but it might happen that you have multiple workbooks open. So actually VBA has to somehow refer to a workbook as well. When we type this line of code, then the Visual Basic Editor implies the active workbook object. So I have typed active workbook, and actually the active workbook object refers to the active or the selected workbook. I'm working with only one workbook now, and I suggest you do the same. But if you had more workbooks open, then the workbook that is in the front would be your active workbook. So we have the workbook in the front, and then the worksheet that is selected in that workbook, and then we are calling or getting the range of cell A2 of that selected worksheet. And ultimately, we want to get the contents or the value of cell A2 on this selected worksheet. There is actually one more object that the Visual Basic Editor implies, and this is the application object, which is also a special object. The application object refers to the Excel application that is running currently. So if I clear the immediate window and I run the code again, then still Livia is printed to the immediate window, but this time my code is longer. But if I select a different sheet, so if I select the profit sheet, then Abbey Wood should be printed out to the immediate window if I run the code again. And indeed Abbey Wood is printed out because now the profit worksheet has been selected. Of course, if I have another line of code here and I just say range A2.value, then we will see that both these lines produce the same result. So now Abbey Wood has been printed out twice, but if I select another worksheet, so the names worksheet, then Livia will be printed out twice. But on the first line of code, we are much more specific about the range or the cell A2, whose value or contents we want to be returned. We specify that there is an Excel application running, there must be an active workbook or a workbook in the front, and there is a worksheet selected in that workbook, and we want to get the contents of cell A2 on this worksheet. This other line of code does the same thing, but everything else is implied, so we do not see this fully qualified path before the range, before calling range. Of course, when we automate Excel processes, we probably have to work with several worksheets. It can be convenient sometimes to use this ActiveSheet object, but if we are working with several worksheets, we should be more specific about the worksheets that our code is working with. I will comment out these 3 lines of code because we will not need them. And at the top, I will actually declare a worksheet object. It will be called WS, and this will refer to a worksheet object. So not a workbook object, but a worksheet object. When we familiarized ourselves with the range object, we saw that when we have object variables, like this worksheet variable here, then we have to use the set keyword when we are setting the objects or when we are setting the object references. So let's set a worksheet here. Let's say set WS equals, I will copy part of this line of code, so application.activeworkbook.worksheets, And you see that the Visual Basic Editor is actually helping me, so I can just select Worksheets. And I can actually refer to a worksheet by its name. So I will pass the name of the worksheet as a string, as an argument to the worksheet collection, or the worksheets collection, sorry. Actually, worksheets is a property like range, but it returns a so-called worksheet collection. But here actually we are very specific about wanting the worksheet with the name profit. So with this line of code, we refer with the WS variable to the worksheet object that is called profit. So basically this WS variable will refer to this worksheet, so this profit worksheet. Let me just copy this line of code and paste it here. If I delete application.activeWorkbook from here, then actually I would have the same result, so the WS object variable would still refer to the worksheet with the name profit in this workbook. But in the previous line of code we are more specific about where the worksheet object is that we want to refer to. So it's in the Excel application, the active workbook of this Excel application. So based on this line of code we know that the active workbook should have a worksheet called profit. Let's actually print out the name of the worksheet, but let's use the WS variable here. So debug.print ws.name. So worksheet has a name property, and of course it is the name of the worksheet. The Visual Basic Editor didn't capitalize this name property, and this is because actually I have a name variable, which is a string variable. So let's say that the Visual Basic Editor is a bit confused now. But even though this name property is not capitalized, it will figure out that I want the name of the worksheet printed out to the immediate window. So we should see the name of the worksheet profit printed out to the immediate window. But actually I will exit the subroutine early after the name of the worksheet has been printed out. So the rest of the code from here will not run. Okay, let me run the code. And indeed we were able to create a valid reference to the worksheet named profit. I will comment out this line of code, and actually I will move these two lines. I just want to show you that this line of code can also create a valid reference to the same worksheet object. And indeed now the WS variable holds a reference to our worksheet named profit. I can delete these two lines of code now, and actually I will comment out this line of code, but I will uncomment this line. And let's actually run the code. Don't forget that I simply copied the exit loop subroutine. So the subroutine will print out the names of the salespeople, but once Jessica Stone has been found, then it will print out that we found Jessica Stone, and we will exit the loop early. Okay, it seems that the code is running as expected so far. Inside of our loop, we make two calls to the sales property, and the sales property also belongs to a worksheet. So a worksheet object has a range property and a cells property, and they both return a range object, or a cell or a range of cells. Instead of simply writing cells and then a row index and a column index, I will specify the worksheet, so ws.cells, and here as well ws.cells. So now in my code I'm very specific about the worksheet. The ws variable holds a reference to the worksheet named profit. And here on these two lines of code, I'm very specific about what worksheet I'm working with currently in my VBA code. Let's run the code. And the code runs as intended, so we find Jessica Stone and everything is fine. If I check my workbook, then still the profit worksheet is selected. Now let me select the names worksheet. I will clear the immediate window, and even though the names worksheet is selected, the code should run the same way as it has run a moment ago. So indeed, it doesn't matter now that the active sheet or the selected sheet is the names worksheet, because in my VBA code I'm specific about working with the worksheet called profit. You know what? Let's comment out this line of code, and let me delete the ws dot parts of these two lines. So now the selected worksheet is the names worksheet, and if I run the code now, then Livia and Frank are printed out, and then I believe 15 blank lines. This is why I had to scroll up a bit in the immediate window. Don't forget that we are starting from cell A2, so from row index 2, and Livia is in cell A2 and Frank is in cell A3, but then until row index 18 we have only blank cells. Because I'm not explicit about what worksheet I'm working with, depending on what worksheet is selected, the code produces different results. If I select the profit worksheet and I run the code again, then the code runs as intended and we find Jessica Stone, because the Visual Basic Editor here implies the active sheet and the active sheet is now the profit worksheet. But if I uncomment this line of code and I re-add the ws.parts here, then it doesn't matter what worksheet is selected, the code will always run the same way. So let me select the names worksheet and let me run the code again. We found Jessica Stone again, and if I select the profit worksheet, then the code will run the same way. So it's extremely important that you are specific about the worksheets that you are working with. If you work on a single worksheet, then the active sheet object can be a good solution. But when you have to automate a process that uses several worksheets, and this is the usual thing that happens, then you must use worksheet variables in your code and you must set these worksheet variables correctly. So you must make sure that these variables refer to the correct worksheet. And instead of simply calling the cells property or the range property, at least qualify the worksheet. So be explicit about what worksheet you are working with. Of course, it might happen that you have to work with several workbooks. And of course, we can have workbook variables as well, so we can refer to different workbooks as well in our code. But that is beyond the scope of this crash course. We are actually approaching very quickly our goal in this crash course, so to automate a whole process in VBA. But we still have to talk about something new before we do that. We have to talk about functions. Let's add a new module and let's call it Crash 17 Functions Intro. Let me actually just copy the worksheet object subroutine and I will rename the subroutine, of course, to Functions Intro. In the Excel section, of course, we talked a lot about functions, for example, sum, SUMIF, if, VLOOKUP, and so on and so on. In terms of VBA, functions are very similar to subroutines. So we can use functions to do something. So a function is a unit of code that we can run and it does something. But a very important distinction between subroutines and functions is that functions can return values. Typically, we use functions if we want something to be returned. So far, we've used only subroutines, and of course, we got things done in subroutines, but nothing was returned by our subroutines. And this is all and well because subroutines cannot return anything. When we are working with VBA, so when we are automating Excel processes, then we have to write at least one function for ourselves. And this function should return a row index or a row number. In our subroutine here, we are hard-coding row indexes. So we are hard-coding the first row index and the last row index. And of course, we use these two variables or these two row indexes to loop over some rows in our worksheet. Specifically, of course, we are looping over the cells from A2 to A18 on the profit worksheet. Normally in Excel, we work with tables or ranges that look like tables, for example, this range of cells here. Normally in the first row, we have the headers, so we have the name for the columns. And from the second row onwards, we have our actual data. When we automate Excel processes, we should know the index of the first row, so the row where our data starts. What we cannot know, however, is the last relevant row, so the row index where our data ends. For example, here the data ends in a row 18. And we have to write a custom function for ourselves to get to know where the data ends. Let's go back to the editor. Let's scroll to the bottom. Now after the and sub keywords, let's type function GetLastRow dummy, and let's press enter. We have written our first function, and of course it's not doing anything, but you see that the F in the function word has been capitalized and it is in blue, so it is a keyword in VBA, it has special meaning, and of course the and function keywords also have a special meaning. If we want to implement a function, we have to use the function keyword first, then we have to add a name to the function, and after the function name we have parentheses just like in subroutines, and if the function takes arguments, then we should have the arguments here. But our function will not have any arguments, so the parentheses will stay empty. Of course, the end function keywords signal that this is the end of our function. I call this function GetLastRow dummy, so a dummy function, because it will not really do real work, so to say. But what we will do is to return the hard-coded value 18. And in order to return a value in a function, you have to use the function's name and you have to assign a value to it. So GetLastRow dummy equals 18 will return the number 18. Instead of hard-coding the row index here in our subroutine, let's call the GetLastRow dummy function instead. This function doesn't take any arguments, so we don't have to use parentheses here. Let me actually just clear the immediate window and run the code again. It seems that our code is running again perfectly, so this GetLastRow dummy call actually returned the value 18, and the value 18 has been saved into the last row index variable. So we are not hard coding the value 18 here, but a function returns it for us. And notice actually that we have now a code module and there is a subroutine in the code module, and under this subroutine there is a function. And actually notice that with the horizontal line, the Visual Basic Editor sort of separates our subroutine from our function. So in the same module, a subroutine can successfully call a function. And actually by default in VBA, subroutines and functions can call each other, even if they are in different modules, and we will see an example for this later in the course. Now we are calling a function from the same module. Our next task will be to actually create a GetLastRow function that will not return the hard-coded value 18, but that will actually return the relevant row index every time. Let's confirm, however, that 18 has been returned, so we know that Jessica Stone is in row 10, but we see that Tobias Ferguson is in row 18. Now actually I can just print out the last row index variable, so let me actually just do that. So debug.print last row index, and if I run the code now, and if I scroll to the top of the immediate window, we see that 18 has been printed out. So indeed, the value of the last row index is 18. So this GetLastRow dummy function indeed returned the value 18. But let me actually change the name from Jessica Stone to Tobias Ferguson. I will clear the immediate window and run the code. And now actually we see that all the names have been iterated over, even Tobias Ferguson, who is in the 18th row, and we also printed out that we found Tobias Ferguson, and actually we exit the for loop now early. However, this is the last iteration, so this exit for call doesn't help us a lot now, but this is not a problem. We cannot know where Tobias Ferguson is. Sometimes we have to loop over all the values, even if we have an exit for statement. Let me actually just delete this line of code. I don't like it that this 18 is printed out. So as I've mentioned now, the next step is to change this function, or to have a new function more like, that returns the correct row index. So in this case, of course, the correct row index is 18, but if we iterated over this range of cells, then the correct row index would be 3, of course. For the sake of simplicity, we will always get the last relevant row based on column A. So let's go back to the Visual Basic Editor and let's insert a new module. And let's rename this module to Crash 18 GetLastRow. Let's implement a function and let's call it GetLastRow. I will declare a lone variable, so it will be called row count. And let's assign the count of all the rows in the active sheet to this variable. I will type application.activeWorkbook .activeSheet .rows .count. Let's print out the value of the row count variable. Let's run this function. Now indeed the correct result has been returned. It doesn't actually matter what the active sheet is now, the result should always be this, so 1,048,576. Of course, if we go to the bottom of a worksheet, we can confirm that the last row index is 1,048,576 indeed. But of course I owe you an explanation. In this GetLastRow function we will actually use the ActiveSheet object for the sake of simplicity. Now actually it's enough if I type ActiveSheet.rows.count, I don't have to type application.activeWorkbook. But in the crash course I prefer to fully qualify the sheet. So I'm accessing the Excel application that is running, then I'm accessing the active workbook in it, or the active workbook object, or the selected workbook, and the selected sheet or the active sheet of this workbook. We have seen this part of the code so far already, so we know that this part of the code basically returns a worksheet object to us, the active worksheet. A worksheet object also has a rows property that basically returns all the rows. Technically the rows property returns a range object, but basically it returns all the rows. This is what we have to know. And then once all the rows of the worksheet or active sheet is returned, we can access the count property, which will basically tell us the number of rows that are on the worksheet. So it should return basically a row number or a row index, the last row index or the last row number. Now of course we have to return something, so the GetLastRow function is supposed to return the last relevant row number or index. So let's return then something. So GetLastRow equals application.activeworkbook.activesheet.cells, and we will use the row count variable here as the row index, and the column index will be 1. And I will type end XLUP .row. Again, I'm fully qualifying the active sheet here. It would be enough to type ActiveSheet.cells and so on and so on. But here again, we are explicit about accessing the Excel application, the active workbook of this application, and then the active sheet of this active workbook. Of course, this function could be much better, but for the sake of simplicity, I'm using the active sheet object. So this part of the code, of course, returns the active sheet object for us. And here we are calling its cells property. Basically, this part of the code returns the last cell in column A. So the row index is 1, it's a hard-coded one, so we will always work with column A in this GetLastRow function. Now actually in most Excel versions, the row count, so this row count variable here will be 1,048,576. However, in some very old versions of Excel, this number could be significantly lower. What matters is, however, that we are getting the last row index here dynamically. So we are not hard-coding any number. But let's get back to this part of the code. So basically, this part of the code here, so basically this line of the code here returns cell A 1,048,576. And then we are calling end, the end property, and in parentheses we are specifying XLUP, And basically this XLUP is a so-called enum, but what you have to know that it represents a number for the Visual Basic Editor. Instead of trying to explain what this part of the code does, I will simply show you. So don't forget that this part of the code so far returns cell A1,048,576. This AND XLUP call is equivalent to pressing Ctrl-Shift-Up arrow. So basically we have selected a huge range of cells here, and this range of cells ends with the last cell, so cell A1,048,576. But by calling the AND XLUP, we get to know the beginning of this range. And here on the names worksheet, the beginning of this range is cell A3, of course. But if I do the same on the profit worksheet, so I select cell A1,048,576 and then I press Ctrl-Shift-Up arrow, then the beginning of the range, so the last cell with value from the top, will be cell A18. So the beginning of the range will be cell A18. Then we access the row property or call the row property, and the row property will basically just return the row index or the row number of the beginning of this range. So in this case it will return 18. So in a very simplistic way, this is how we can get the last relevant row based on column A. So this is the function that will get the job done for us. I will go back to the functions intro module and I will just simply copy the functions intro subroutine and I will paste it under the GetLastRow function, but of course I will rename this subroutine to using GetLastRow. I will actually delete these lines of code, so the comments. And what I will do is, instead of calling the GetLastRow dummy function, I will simply call the GetLastRow function to get the last row index, or the last relevant row index. Let's run this subroutine. And it seems that the subroutine is working still, so all the salespeople are printed out to the immediate window, and Tobias Ferguson is in cell A18, so the loop here hits cell A18, and then we print out that we found Tobias Ferguson. So this time we are using the GetLastRow function to dynamically get the last relevant row based on column A. Now of course we are getting the last relevant row based on the active sheet. So if not the profit sheet was selected for me, then the last relevant row would be not 18, but it would be, for example, 3 if I selected the names worksheet. So let me actually run the code again. I will clear the immediate window first. So basically what happens here is that the first row index is still hard-coded because we start the loop from cell A2. But the GetLastRow function returned 3 now because the active sheet now is the names worksheet, so 3 has been returned. However, in our loop we are specific about working with the profit worksheet. So first Abby Wood is printed out, then Catherine Jones. However, the loop doesn't continue because the last row index now is 3 and not 18. Of course, we could make the GetLastRow function better, and it could return the last row based on the worksheet name, for example. But this simplistic function is good for us for the crash course. Let me run the code again, but this time let me select the profit worksheet. So I run the code again, and now the code works as intended. So now all the names are printed out. So now the GetLastRow function indeed returned 18. So the last relevant row of the profit worksheet, and of course this time the profit worksheet is the active sheet. This is why the code is running well. Shortly we'll actually reach the end of the VBA section, so we will very shortly automate a process in VBA. But one very important thing that I want to let you know is that by default, when you implement a function in VBA, then you can use that function in your Excel workbook as well. Let me select cell E1, for example, and let me type equals and GetLastRow. Notice that Excel suggests 2 functions. One is the GetLastRow function, the other one is the GetLastRow dummy function. So these are the functions that we have written ourselves in VBA. So by default, when we implement the function in VBA, we can use that function in our Excel workbook as well. So let's actually use the GetLastRow function. I, of course, have to close the parentheses here. I will press enter. And actually 18 has been returned, so we get the GetLastRow based on column A. And because actually I'm using the GetLastRow function on the profit worksheet, the active sheet will be considered this profit worksheet. However, if I select the names worksheet and if I use the GetLastRow function here, then 3 should be returned by this function, and indeed 3 has been returned. Of course, it doesn't make sense to use the GetLastRow function here, so I will delete it, and I will also delete it from the profit worksheet. But I wanted to show you that you can actually come up with your own custom functions in VBA that later you can use in Excel. Quite cool, isn't it? But now let's move on. So let's go to the Visual Basic Editor and let's insert a new module. And let's rename it to Crash 19 Automation VBA. I will copy some code into this module that I have already written. You don't have to type this code yourself. You will find this code in the VBA section and.xlsm workbook that you can download. The link to this workbook is, of course, in the description. I'm not sure, maybe you will have to download a zip file, but in that zip file you should be able to find the VBA section and.xlsm workbook as well. So let me just paste this code. Of course, the end.xlsm workbook is this start.xlsm workbook, so when I'm finished with the course, then I will just simply rename this workbook. So if you download the end.xlsm workbook, then in the Crash 19 Automation VBA module, you will find the code that I have pasted here. This code actually is a single subroutine, but the reason I don't type it is that it would take a lot of time. And I thought that I would just save some time for the crash course and I would just paste this code here. But don't worry, because we will go over this whole subroutine so you will understand each line of code. Now first, actually, let's talk about what we want to automate. For this we have to go back to our Excel workbook. You're familiar with this profit worksheet, so here we have this table, and in column A we have the names of a bunch of salespeople. In column B, we see how much profit each salesperson made in US dollars. And in column C, we see in what region the salespeople are active. EMEA stands for Europe, Middle East and Africa, NORAM stands for North America, and APAC stands for Asia Pacific. So, for example, Abby Wood made a profit of $2,200 US dollars in the EMEA region. And Peter Floyd, for example, made a profit of $500 in the APAC region. We have another worksheet in this workbook, the analysis worksheet, and this is actually where we will do most of our automation. The first thing we'll do is to copy this table from the profit worksheet onto the analysis worksheet. Then in column E, we have a name of 5 salespeople. And we will try to find how much profit they made based on the table that we will copy here. For example, Paul Road made a profit of $7,000. So in cell F4, the profit value should be 7,000. And for Tobias Ferguson, of course, this value should be 6,900. But as I've mentioned, we will copy the table here, and we will check for the profits in this copied table. And the sort of third step in our automation will be summing the profits by regions. So in cell I2, we will see how much profit was made in the APAC region altogether by all the salespeople, and in cell I3, for example, we will see how much region was made by all the salespeople in the EMEA region. We could actually use the VLOOKUP function here for column F, and we could use the SUMIF function here for column I. And actually in our VBA code, we could use these functions, but I decided that we'll take a different approach. The code that I have written will do the job like the VLOOKUP function or the SUMIF function, but instead of simply calling a function, we imitate what the functions do, what these two functions do. Basically, we'll be using loops and conditional logic. And basically the reason I chose to go down this path with you is that it is the harder path. If you watch the Excel section of the course, then you're familiar already with the VLOOKUP function, the SUMIF functions, so you wouldn't really learn anything new. But by not using these functions, but using our own way to find the profit figures and to sum the profits by region, you will get some knowledge or practice that actually you can transfer to other programming languages as well, for example. Because looping and conditional logic is part of most programming languages actually. Let's actually check if the code runs. But before we do that, I want to talk about how to run your VBA code. So far we have run all the VBA code from the Visual Basic Editor, and this is fine. But now we are automating an actual process. So if someone wants to use this process, so if someone wants to run this code who doesn't know VBA, will not be able to run the code because that person will not be able to find the Visual Basic Editor. What I will do is to add this subroutine, this automation VBA subroutine, to the Quick Access toolbar here. So let's customize the Quick Access toolbar. Click on this downward pointing arrow and More Commands. Now I want to customize the Quick Access toolbar for only this document, so for only the VBA section start.xlsm workbook. And on the right side, instead of popular commands, I will select macros. Basically, if you select macros, then you will see all the VBA code that we have written so far. Actually, you see all the subroutines that we have written. For example, the automation VBA subroutine that I just actually pasted into the module, but we will get back to it, don't worry. So I will select this automation VBA subroutine and click on the Add button, so it will be added to the Quick Access toolbar of this workbook that I'm working with. I will also click on Modify here, and I will select a nice icon for this subroutine. And let's just select this friendly smiley face here. Now actually we could also change the display name of the subroutine. So we would not change the name of the subroutine if we changed the display name. But in the Quick Access toolbar, then friendlier display name would be shown. So let's actually change this to run code. I will click on OK and OK again. And now in the Quick Access toolbar, this smiley face appeared, and if I hover my mouse over it, then you see that we have a tooltip, Run Code, so this display name. But the actual name of the subroutine did not change, of course, so still the automation VBA subroutine is here in this Crash 19 module, and if I click on this smiley face, then this automation VBA subroutine runs. So actually I will click on the smiley face, and the message box appears, the profit sheet must be selected, the process has been aborted. Now this is actually good. I will click on OK. I have implemented this subroutine in a way that it has to start on the profit worksheet. You see here actually that there is the line with the message box that says that the profit sheet must be selected, and if the profit sheet is not selected, then we are exiting the subroutine early. And actually the reason the profit sheet should be selected is because of the GetLastRow function, because here actually we are using the GetLastRow function that we have written already. And if you remember, in the GetLastRow function, we are simplifying things and we are using the active sheet object. So basically, in this automation VBA subroutine, it is absolutely necessary that the profit worksheet is the active sheet when we start running the code. So let me select the profit worksheet, and now I will click on the smiley face. And let's check what happened on the analysis worksheet. The data has been copied. The profit figures were found, so for example 1,000 for Catherine Jones, 1,800 for Jessica Stone, so everything seems to be fine. And also the sum of the profit per region was calculated automatically by our automation VBA subroutine, and I just had to click on this emoji or smiley face. Actually, after we go over the code, maybe we will add a new line to the code, maybe we will use the message box function to show that the process has successfully run, because if you noticed, after I clicked on a smiley face, we didn't get any feedback, and maybe we should get some feedback after the process has successfully run. It's very important that once you run VBA code, you cannot undo it. If you watch the Excel section of the course, then you know that you can undo Excel commands, but actually you cannot undo VBA code. So once VBA code runs and it changes something, then it will be changed for good. You can of course manually delete it. So I could manually delete all this data here and here, whatever. But you should know that once the code runs, then it runs, it makes the changes, and you cannot just simply undo it. So you have to make sure that the code you run will not cause any damage. And actually it's always a good idea to have a safety copy of a workbook. So even if you run some VBA code and it does something unintended or it does some damage, then you still have a safety copy of a workbook to fall back on. But let's now go back to the Visual Basic Editor and let's finally discuss this automation VBA subroutine. So how we arrive at this result. I've declared two worksheet object variables, so the profit WS and the analysis WS variables. As the name suggests, this variable will refer to the profit worksheet and the analysis WS variable will refer to the analysis worksheet, so I will refer to these two worksheets. I have here two loop-in variables, I and j, and I have these additional lon variables here. In this last row variable, I will save the last relevant row, I mean row number or row index, and of course it will be 18 because we have data in cell A18 here. We will actually work with a two-dimensional array, and these variables will store the first and last indexes of this two-dimensional array. This is something that we have already done, actually. I have two string variables here. They will store the worksheet names, the relevant worksheet names. And finally, we have an array here, the range to copy array. We will use these four long variables to get the first and last indexes of this array. Now, of course, it will be a two-dimensional array, so it will have a row index and a column index. Hence the name in first row index, last row index, first column index, and last column index. So first we assign the worksheet names to these two variables here. So we have a profit worksheet and an analysis worksheet. Then we set our worksheet variables. Now don't forget that these are object variables, so we have to use the set keyword in front of them. And what we do is we get the active workbook. Of course, for me only one workbook is open, so the active workbook will always be this VBA section start.xlsm workbook. And then I access the worksheets property of the workbook. And then I specify that I want to refer to the worksheet named profit by the profit WS variable. And then I also specify that this analysis WS variable should refer to the worksheet whose name is analysis. So now I have two variables that refer to the two worksheets that I'm working with. I save the last relevant row index into the last row variable. And we've already seen that because of the GetLastRow function, the name of the active sheet must be profit, so we have to select the profit worksheet before we run the code. Otherwise, the code would not run as intended. And we saw that the message box appeared when the analysis sheet was selected before running the code. However, I might have forgotten to tell you about this operator. So here, of course, we have conditional logic, so we have this if block, and this operator checks for non-equality, so of course this is the condition that we are checking here in this if block. And basically we are saying if the name of the active worksheet is not profit, so this checks for non-equality, then we should show the message box and we should exit the subroutine early. So if the name of the active sheet is not profit, then this condition evaluates to true and these two lines of code run. However, if the name of the active sheet is profit, then this condition evaluates to false and then we continue with the code execution. Okay, so at this line of code we have the last relevant row index and of course it will be 18. And now we will continue, and actually here we have our two-dimensional array This is also not new, so we saw how to do this. Basically, we are specifying that we want to create a two-dimensional array based on a range that is on the profit worksheet. And here we actually concatenate a string. So of course, the first step of our automation is to copy all this data from the profit sheet onto the analysis sheet. So basically, we create a two-dimensional array from this range of cells from A1 to C18. But we are actually not hard-coding this string, so we are not hard-coding A1 to C18 here, but we only hard-code A1 to C, and then we concatenate the last row variable, which will be 18, of course. So actually, if we added a new row here, our automation would still run successfully. Let's actually confirm this. I think I will later delete this newly added row. So instead of Tobias Ferguson, let's have a Tobias Thomas with, I don't know, maybe 1000 profit for NORAM. So if I run the code, then on the analysis worksheet, I should see 21,800 for NORAM. I should see Tobias Thomas here. And actually nothing should change here, so a new row should be added here and the NORAM profit value should be increased by 1000. So let's actually select the profit worksheet and let's run the code. Let's go back. And indeed, Tobias Thomas has been added here and the profit of the NORAM region was increased by 1000. So because we are getting the last relevant row dynamically, we are creating this two-dimensional array dynamically as well. Now we are using the L-bound and the U-bound functions to get the relevant indexes, so first and last indexes of this arrange to copy array. This is something that we have done earlier, so basically here we are getting the lower bound of the row index and then the upper bound of the row index. Now of course the lower bound of the row index will be 1. Because the data starts in row 1, but the upper bound this time actually will be 19 because I have added a new row, but actually I will just delete this new row. And actually I will just use a format painter to change the format. And let me just actually delete Tobias from here as well. You know what, I will delete everything basically, so everything that the automation did. So let's actually run the process again. Okay, we are back to the default. So the first dimension or the first row index will be 1 because our data starts in row 1, of course, but the last row index will be 18 because the data ends in row 18. And then, of course, we have the second dimension or the column index. So we get the first column index and the last column index, and our data goes from column A to column C. So the first column index will be 1 because it's column A, and the last column index will be, of course, 3 because the data ends in column C. So we can start looping, and this is also something that we have done already. So we have a nested loop here, and we are looping over this data by rows. So first the first row, then the second row, third row, and so on and so on. But what we do is we copy the data. So for example, at the first iteration, I will be 1 and J will be 1 as well. So we will get cell A1 of the analysis worksheet. And we assign a value to this cell A1. And of course, we assign the value based on the two-dimensional array. So basically, in the first iteration, we assign the value or the string name to cell A1 of the analysis worksheet. And of course, in the last iteration, we assign values to cells A18, B18, and C18 of the analysis worksheet. So this is the part of the code where we just use a simple nested loop to copy the data from the profit worksheet onto the analysis worksheet. So once the code is here, so hits this comment, data copied, then the data is readily available. So this data is readily available on the analysis worksheet. So step 1 of the process has been successfully completed. Now comes step 2, finding the appropriate profit figures for these 5 salespeople. So let's go back to the editor. Now here I declare some more variables, and actually I didn't want to declare so many variables at the top. Usually you declare all your variables at the top, but actually you don't have to declare them all at the top. So I thought that the variables that are necessary for the second step will be declared here after the data has been successfully copied, so after the first step has been successfully completed. Now actually I just have a bunch of long variables, and I'm just saving column indexes in these variables. And I also hardcode actually the last relevant row here based on column E. So basically the column index of column A is 1, the column index of column B is 2, the column index of column E is 5, the column index of column F is 6, and the last relevant row based on column E is 6. So let's look at the worksheet. So in the second part of this automation process, we want to find the appropriate profit values of the salespeople based on the 2 columns A and B. So if we find Catherine Jones, for example, then we will copy the appropriate profit figure from column B to column F. So the relevant columns here are A, B, and E and F. And Tobias Ferguson, so the last salespeople for whom a profit figure we want to find, is in row 6. So this is why the last relevant row based on column E is row 6. So actually if I added a new salesperson here, then our code would not find a profit for that salesperson, because our code only checks the salespeople from cells E2 to E6, because I have hard-coded this value here. So basically again we have a nested loop, and here in this loop we check for equality between columns E and A. So basically we want to find the salesperson's name. Notice that our outer loop goes from 2 to 6, so to the last row based on column E. So basically we are starting with Catherine Jones, and then we start looping, and once Catherine Jones is found, then we will check if the contents of cell E2 are the same as the contents of cell A3, and because this condition evaluates to true, then we save the corresponding profit figure into column F. So of course we are assigning the appropriate profit figure based on column B. So basically this 1000 here from column B is assigned to cell F2. Now once Catherine Jones is found, for example, so once this condition evaluates to true, then we exit the loop early and we get back to the outer loop, so then we will start searching for Jessica Stone. And of course, once Jessica Stone is found, then we exit the loop early again and we will search for Paul Road, and so on and so on. So this is what this loop does, and I added the comment profit search ended, so the second part of the automation process is finished at this line of the code. Now comes the last part of the automation process. So we have to find the overall profit made per region. So of course we have to work with columns B and C, so the profit figures are in column B, the regions are in column C, or the corresponding regions are in column C, and we have to put the overall profit per region in column I. So in this part of the code, I declared some new variables, so the column index for column I, it will be 9, and if you quickly calculate, then column I is the 9th column, so there is A, B, C, D, E, F, and G, H, I, so the column index of column I is 9. I have declared a few strings, so basically these are the regions, APAC, EMEA, and NORAM. So we have the APAC string variable, the EMEA string variable, and the NORAM string variable. And we also have 3 new variables, long variables, APAC sum, EMEA sum, and NORAM sum. When we declare long variables, by default they will be assigned the value 0. And this is perfect for us, so we don't have to assign an initial value to these variables, because the initial 0 is perfect for us. Of course, these are the variables where we will save the overall profit per region. What we are doing, of course, is we are looping over the columns or the cells, And notice that I hard-coded the column indexes. So in the third column, in column C, we have the regions. And in column B, so at column index 2, we have the profit figures or the corresponding profit figures. And here inside the loop, we have conditional logic. So we have this if block. We actually have this if branch, an else if branch, and another else if branch, and then the if block ends. So we are looping here from 2 to 18, so until the last relevant row. Of course, we are going to 18 now. At the first iteration, of course, I will be 2. So basically, here we check if the value, at the first iteration, we check here if cell C2, so row index 2 and column index 3, contains the string APAC. Now actually I forgot to add dot value here. The code runs without adding dot value here, but actually I think it's better if we do that. So again, in the first iteration we check cell C2, and cell C2 has the string EMEA, so it is not APAC. So this condition evaluates to false, and because it evaluated to false, we hit this else if branch, so we test for this second condition. And this time, actually this condition evaluates to true, because indeed cell C2 contains the string EMEA. And now we will take the corresponding profit value from cell B2, and we will add this number or figure to the EMEA sum variable. So notice that we have the EMEA sum variable on the left side, and then we assign EMEA sum plus the profit figure of cell B2 to this variable. At the first iteration, this variable is 0, so basically the right-hand side reads 0 plus 2200. But when we reach Daniel Kin, then this 2300 has to be added to this 2200. So when we hit this line of code again, then the right-hand side will read 2200 plus 2300, if I'm not mistaken. Yes, I'm not mistaken. So always the right-hand side is evaluated when we are doing an assignment. So this EMEA sum variable will always be increased by the corresponding profit figure. Notice as well that when we are checking for a condition, then the equal sign is the operator for checking for equality. But once the equal sign is not part of a condition, then the equal sign is the assignment operator. In column C, actually, we don't have any blank cells, and we only have these 3 regions. So the region names correspond to these 3 variables. So actually at each iteration, either the APAC sum, the EMEA sum, or the NORAM sum variable will be increased by the corresponding profit figure from from column B, sorry. So once the loop runs, then we will have the correct profit figures stored in these 3 variables. And of course, what we have to do is to save these 3 correct figures into the cells I2, I3, and I4. So basically here, so I2, I3, and I4. So actually we are finished with this automation, so we have gone over the code, but I said that it would be good if we got some feedback about the successful run of the process. So I will, at the very end, I will just put a message box call, the process has run successfully. So let me actually just clear all this data from the analysis worksheet. Let's run our code. Now it's good that it's not running, so the profit sheet must be selected. So let's then select the profit sheet and run the code again. And indeed we get the message box that the process has run successfully, and we got our data back. So we have finally automated the whole process with VBA code. So we have reached the goal of the crash course, but actually I suggest that you take a good look at this code, so at this automation VBA subroutine. This has not been an easy task. I designed this course that step by step we can reach this automation. So of course we talked about data types first, we also talked about worksheet objects, two-dimensional arrays, and then of course we were talking about loops and nested loops and so on and so on. But I know that once we put all these things together, it can feel quite overwhelming and challenging. But this is perfectly normal while you're learning VBA or actually any other programming language. As I mentioned earlier, I use loops here, nested loops and the array structure and conditional logic, so that you can transfer what you've learned here to other areas as well. But it basically, even if you don't transfer it, it gives you a very good foundational knowledge of writing code. Because it is really essential that you get comfortable with conditional logic and looping. So don't worry if not everything is clear for you. I suggest you come back to this part of the course later, and I suggest you try to go over this code step by step in your head. So for example, to go over the nested loops in your head step by step. Getting comfortable with this code can really help you to develop your programming skills. So we have achieved the goal of the VBA section of the course, but I still owe you one explanation. I've said earlier that macro is basically VBA code, and this is true, but before we conclude the VBA section of the course, I want to explain the difference between a VBA code and a macro. So let's actually get back to the worksheet and let's talk about what a macro is. Select the developer tab of your workbook. I've mentioned earlier that a macro is just VBA code. But personally, I prefer to refer to VBA code to the code that I've written myself, and I use the term macro for VBA code that was automatically created. A very cool feature about Excel is that if you choose to, you can get everything automatically translated into VBA code that you do in Excel. So I prefer to say that the code that we've written so far is VBA code because we have written each line of code ourselves. But what we will do now is to create a macro. More precisely, we're going to record a macro. Inside the code command group of the developer tab, there is a command record macro. Each of the commands you perform, there is the description of the command, each of the commands you perform will be saved into the macro so that you can play them back again. This essentially means that once you activate this record macro command, then everything you do in Excel will be recorded, so basically automatically translated into VBA code. The idea is, of course, that many people do the same things over and over while working with Excel. So recording a macro or creating VBA code automatically to automate these boring processes sounds really good. So they can just perform a process only one time, record it as a macro or VBA code, and then they just have to run the VBA code and then they don't have to work another day in their lives. It's a nice idea, but of course it doesn't work this way. For certain tasks, it might be enough to record VBA code or record a macro. But most of the times you have to write VBA code yourself, or actually you have to at least change the recorded macro yourself. If you don't know how to translate something into VBA code that you are doing in Excel, then I think it's a good idea to record a macro and check the VBA code that was created automatically for you. But as you will see shortly, macros, so automatically created VBA code, is not the best. Of course, now we'll record a macro and then we will check out the code that was created automatically for us. But first, actually, I want to delete everything from the analysis sheet that we don't need. So basically, I will record a macro that will recreate this automation VBA subroutine. So I will delete the profit figures from column F and also the profit figures from column I. We have to start on a profit worksheet, so I will come back to the profit worksheet. And let me actually just select cell F2. So the first step I will do is to select cell A1 on this worksheet, and you will see this translated into VBA code. To record a macro, of course, just have to click on the record macro command, and then the record macro dialog appears. We have to give a name to the macro. Now let's give the name automation macro. And actually a subroutine will be created for us with this name automation macro. There's a drop-down list here, store macro in, and let's select this workbook. So we want to store the macro in the VBA section start.xlsm workbook. We could give a description to the macro, but we don't need that, so let me just click on OK. You see that the icon for the record macro command changed, and now it says stop recording. Basically, it means that we have started recording our macro or our VBA code. It is not recorded that I'm hovering over these commands. But I will select cell A1 now, and this is actually now has been translated to VBA code. I will press Ctrl-Shift right arrow, so I select my header. Now I will select Ctrl-Shift down arrow, and I will press Ctrl-C to copy this table. I will select the analysis sheet. Now cell A1 is automatically selected, but let me select cell A1 on the analysis sheet still, so I will click into the cell, and I will press my right mouse button, and I will copy values only. I will select cell F2, and I will insert a VLOOKUP function here to find the profit figures. So I will double click on VLOOKUP. The lookup value will be cell E2, so Catherine Jones. The table array will be cell A1 to B18, and the column index number will be 2, so we want to get the profit figure back, the figure from the second column from this table array. And actually for the range lookup argument, let's provide a 0, so we want to get an exact match. I will click on OK. I will simply copy down this formula, so I will double click here at the bottom corner of cell F2. And now I will use the SUMIF function to sum the profits per region. So I will select cell I2, click on the insert function command, select SUMIF. I want the regions to be evaluated. Actually, it should go from C2 to C18, okay. The criteria will be, of course, cell H2, and the sum range will be the range from B2 to B18. I will click on OK, and I will copy down this formula as well. Let me select cell A1, and actually I will click on stop recording. You might have noticed, but actually I made a mistake in both formulas. I'm not using absolute ranges here or absolute cell references, so the range is adjusted. And though the VLOOKUP function still finds all the profit figures, here because of the adjusted ranges, the profit figures are not good. I think APEC is good, but I'm sure that NORM is not good, and I think EMEA is not good either. Yeah, actually EMEA is not good either because we start from cell C3, so the profit figure of Abbey Wood is lost. So actually I should have used absolute references here, but I will not re-record this macro because of this mistake. I hope you'll forgive me, but actually I don't have much time now, so I don't want to restart this process. What is important that we know that there is a mistake in both formulas, and of course we want to take a look at the recorded VBA code, so that is important for us. By the way, if you are not familiar with the VLOOKUP function, the SUMIF function, and you didn't check the Excel section of the course, then I suggest you do it because we talked about these two functions in detail. But let's now go to the Visual Basic Editor and let's check what was recorded. A module has been automatically inserted with the name Module 1. And there is a subroutine in this Module 1 called Automation Macro. Now this is the name that we gave to this macro or to this subroutine. And then there are a few lines here, so a few lines that are actually comments, and one comment says Automation Macro, so the name of the subroutine, and then macro. This is just something that the Visual Basic Editor does, so whenever you record a macro, you can expect these lines to be seen. Range A1 is selected, and we talked about that the active sheet object or the active sheet is implied here. So actually the range A1 will be selected on the worksheet that is currently selected when you rerun this macro, when you run this macro. We will later rerun this macro ourselves. We started on the profit worksheet, so cell A1 here was selected. The next line of code basically selects the header. You see this AND property and the Excel to right enum, so the direction is to the right. So basically this line of code did this, so it's the same as pressing Ctrl-Shift and the right arrow. And then the next line of code, of course, goes to the down direction. So basically this line of code does this. So pressing Ctrl-Shift down arrow. Then we are copying the selection. Notice that in the first 3 lines of code, the select method of the range object was called. So cell A1 was selected, then the header was selected, then our whole table was selected. And actually macros use the select method, but it's completely unnecessary to use the select method in VBA code. So I suggest you avoid it. Anyway, our whole table is selected now. So our whole table is selected now here. So basically this table or range of cells is the selection object and we copy it. So we call copy on it. Then the analysis worksheet is selected. Now range A1 or cell A1 is selected again. However, we have selected the analysis worksheet. So now the active sheet is the analysis worksheet here. So cell A1 of the analysis worksheet is selected now. And of course, there was nothing in cell A1, so these cells were all blank, and these cells were all blank, and these cells were also blank. Now the paste special method is called, and basically the values are pasted into cell A1. Of course, I should say that the values are pasted starting from cell A1. So this line of code, and actually this is a single line of code, pastes all the values here. You see that there is an underscore at the end of the first line here, and the underscore has a special meaning for the Visual Basic Editor. Basically, it says that this line of code continues on the next line of code, so these 2 lines of code are essentially one single line of code. The words, sort of, that you see before the colons, so paste, operation, and transpose, are arguments of the paste special method. And with this special colon and equal sign syntax, the Visual Basic Editor assigns values to these arguments. They are called actually named arguments. We haven't talked about them, but believe me that they are simply arguments. And the Excel paste values enum, which is basically just a number, tells the Visual Basic Editor that only the values should be pasted. So the formatting of the cell should not be pasted. Then we select cell F2. So of course we are on the analysis worksheet, that is the active sheet, and now we selected cell F2. Now the cut copy mode property of the application object is set 3 times to false. I'm not sure actually why it is set 3 times to false, but basically all of these 3 lines of code just clears the clipboard. So we pasted some data and then the clipboard is cleared. So cell F2 has been selected, and now cell F2 is basically the active cell object. So this active cell object now refers to cell F2, or the single cell range of F2. The active cell object has a formula R1C1 property, and we assign our formula with the VLOOKUP function to it as a string. The macro recorder uses the so-called R1C1 notation, and this is the way it assigns a formula to a cell in Excel. There are better ways to do this, but this is what the macro recorder does. The lookup value argument is of course cell F1. Now this R1C1 notation is sort of a relative notation, so you always have to consider what range or cell is currently selected, because the R1C1 notation will show you everything relative to this selected cell. So now F2, range F2 or cell F2 is selected, and the lookup value argument for the VLOOKUP function was cell E2, of course, so Catherine Jones. So what happens here, this is actually the lookup value argument, so this is cell E2 in this context. So what happens here is that after the R, after the row, because R stands for row, there is no number and there are no square brackets, which means that we are still in the same row. And it's true because in this context this refers to cell E2 and cell F2 is selected, so they are in the same row. After the C, which stands for column, there are square brackets and the number -1. Which means that now cell F2 is selected, but we have to go 1 column to the left, so we have to go 1 column index lower. And of course, this refers to cell E2 in this context, so we have cell F2 selected. And of course, in cell E2, column E is 1 column index lower than column F. So relative to cell F2, this notation means cell E2. And then we have the table array here, so basically this is the beginning of the range and end of the range. And I believe in this context, R-1 and C-5 should refer to cell A2. And Oh, A1, sorry, so it refers to cell A1. And then the other notation here after the colon, R16 and C-4 refers to cell B18 then. Yes, it refers to cell B18. So still don't forget that cell F2 is selected, so relative to cell F2, -1 row index and -5 column index is cell A1, and relative to cell F2, +16 column index, so there is no minus here, so +16 actually row index, sorry, not column index, so +16 row index and -4 column index will be cell B18. And then this 2 is the column index number argument, so we want to get the value from column B, and the 0 is forcing an exact match. So when this code is executed, so this line is executed, then we have the VLOOKUP formula here in cell F2. Then the autofill method is called on the selection object. Now the selection is still cell F2, and basically this line of code just copies down the formula. So we will have the VLOOKUP formula here from cells F2 to F6. Then this range of F2 to F6 is selected. Then I selected cell I2. And now again 3 times the clipboard is cleared. I don't know actually why. But here in the active cell, so in cell I2, then the SUMIF function has been applied. And the formula R1C1 notation is used. So we are here now in cell I2, and this is the formula that is applied to the cell. So the macro recorder actually doesn't record things like when I click on the insert function command and when I delete some things, or when I select a range multiple times while passing an argument to the SUMIF function. But basically what is recorded is when I press enter and the SUMIF formula is applied to the cell. Now of course again this R1C1 notation is used. So first I believe the criteria argument is passed. So in this context, this notation should refer to cells C2 to C18, and actually they do. So yes, they refer to cell C2 to C18. Then we have the sum in criteria itself, which should be cell H2. So it is just -1 column, but we stay in the same row. So in this context, in the context of this formula, this notation means cell H2. And this is the sum range, which should be cells B2 to B18, I guess. Yes, it should be. Yes, exactly. So you see that this R1C1 notation is not that good for humans. I think only the macro recorder uses this. And you see that depending on what cell is selected, the notation can be interpreted differently or has to be interpreted differently. So when cell F2 is selected, then RC-1 means cell E2. However, when cell I2 is selected, then RC-1, so the same notation, means something different, so it means cell H2. The SUMIF function is also auto-filled to the range of I2 to I4. Then I2 to I4 is selected, and then cell A1 is selected. I think this is the last step or last thing that I did before I stopped recording a macro. So actually this automation macro does the same stuff that we do here in this Crash 19 module. And actually this module has more code. So actually in this sense, the recorded macro is more advantageous because there is less code here. But the problem is that it is less dynamic. And it is very hard to read the code, so it can be quite challenging to read the R1C1 notation. And of course, a lot of things are hard-coded here. So, you know, when we select a range, when we select a worksheet, these things are all hard-coded here. So if you want the exact same steps to be repeated all the time, then a recorded macro can be a good choice. But if your data can change, then you have to at least come here and change something, so change the recorded code. Let me actually rename this module, and this will be our last module in the VBA section of the course. So let me rename this to Crash 20 Automation Macro. The last thing we will do is to rerun this macro, but we will not do it from the Visual Basic Editor, but we will go back to the workbook. And actually, let me just delete everything. This is, I believe, what we should have for the beginning. And of course, we still have the data on the profit worksheet. I actually have to select the profit worksheet otherwise the result will not be good. On the Developer tab, there is a macros command, click on it, and actually all these subroutines should be here, so all the subroutines that we have written and all the subroutines that we have recorded as well. Now let's select Automation macro, and you can simply click on Run to run this recorded macro. And very quickly it ran. So we have the same result as before, and yeah, unfortunately I didn't use relative absolute cell references here. So the formulas are not the best, and actually they don't produce the good result, but this is not really a problem for us now. Our goal was to learn about VBA, and we could do that even with not the best formulas. So actually we have reached the end of the VBA section, so let's summarize what we have learned in this section of the crash course. We've covered a lot in the VBA section of the course. We talked about data types, the array data structure, one-dimensional and two-dimensional arrays. We've familiarized ourselves with iteration or looping and also conditional logic. And we also discussed errors, we discussed runtime errors, and we talked about what compiling is. We've implemented subroutines and functions ourselves. We've talked about how we can run VBA code and how we can record macros. And we also covered the range object and the worksheet object. But in this crash course we couldn't cover everything. So here are some suggestions for further learning. There are data types that we didn't cover, for example the Boolean, the date and a decimal data type. There are additional data structures that you should read about, for example the collection and the dictionary. We have only covered the for loop, however there are other looping structures, for example the do and the while loop in VBA. We didn't talk about how to handle errors and how to debug your code, and those are extremely important concepts. You should also read about constants and module-level variables and workbook events and worksheet events. Make sure to read about the workbook object as well. And you should also check out class modules and what object-oriented programming is. Of course, you can always enroll into my master course to continue learning about VBA. In the master course, everything is covered that is covered in the crash course, but of course in more detail, and every topic is covered that I suggest for further learning. In the master course, I talk about objects a lot. Actually, the students in the master course create custom objects and work on a very complex object-based automation task. You can buy the master course on either Udemy or Tmsonic. If you want to buy the master course on udemy.com, then make sure that you use the link that we provide in the description of this video, so you will get an amazing discount. However, if you want to save even more money, then you should check out tmsonic.com, because you will find that very often Tmsonic offers a huge discount on the 3-in-1 Excel, VBA and SQL master course. When Tmsonic offers a discount, then you can get the master course for $9.99 only. If you haven't done so, please subscribe to our channel and like this video. It would help us a lot. But now it's finally time to learn about SQL. Welcome to the SQL section of the course. Before we start writing SQL code, we have to clarify some terminology and install some software. So let's start with clarifying the terminology. First, let's check the dictionary definition of the word database. A database is a structured set of data held in a computer, especially one that is accessible in various ways. And sure, it's true. So a database is basically data held in a computer. And usually we want to have a way to interact with that data. So having some data somewhere in a computer and not using it, it's basically useless. One way to access the data or interact with the data is using the SQL language. But before discussing SQL, let's check the definition for a relational database on Wikipedia. We will work with a relational database in this crash course. A relational database is a digital database based on the relational model of data. This basically means that in a relational database, we have tables. We store data in tables, and these tables have rows and, of course, columns. So actually, a database table is quite similar to an Excel worksheet. A system used to maintain relational databases is a relational database management system. Our RDBMS will be MariaDB, and we will shortly install it on our computer. Many relational database systems have an option of using the SQL structured query language for querying and maintaining the database. And of course, we will also use SQL to query our database, so basically to get data from our database or manipulate the data in our database in some way. Actually, now we are on w3schools.com, and don't worry because I think that in the description you will find both these links. So, SQL is a standard language for accessing and manipulating databases. Now, SQL has become standardized. However, there are different versions of SQL. I think the SQL code that we will write will be like 99% standard. But keep in mind that we will use MariaDB, so the MariaDB Relational Database Management System, and you can be sure that 100% of the SQL code that we will write is compatible with MariaDB. SQL is of course a proper programming language like VBA. So in order to write valid SQL code, you have to know the syntax of the SQL language, and this is what you will learn now. So SQL is quite a specific language. It has specifically been created for interacting with the databases. Although it is quite a specific language, you see that we can do a lot of things with SQL. And in the crash course, we will discuss some of these. In the course, actually, mostly, we will use the Visual Basic Editor to run SQL queries. So we will have our SQL code inside our VBA code. So sort of we are coming full circle. In the Excel section, of course, you learned about how to use Excel for manipulating data or working with data. In the VBA section course, we learned how we can automate Excel processes. And we also learned about the fundamentals of programming. And now in the SQL section of the course, you'll learn about the SQL programming language and the fundamentals of databases. So you will know how to get data from an actual database. And once you get this data through VBA code into your Excel workbook, then you can work with that data with Excel or with VBA. Whenever someone sends you an Excel workbook, most probably the data comes from a database. On the job market, it's very valuable to know the basics of databases and to be able to write valid SQL code. And what we have to do now is to install MariaDB. Navigate to apachefriends.org. We are going to install XAMPP, which is a software package containing MariaDB. XAMPP is the most popular PHP development environment. PHP is a programming language for creating websites, but don't worry, we will not use PHP at all in this crash course. It is just part of the XAMPP software package. Perl is also a programming language that is part of the XAMPP software package, but we will not use Perl either. However, we will need, of course, MariaDB, and we will actually also use Apache. Apache makes it possible for your computer to act as a server. Basically, we need Apache in order to start the MariaDB service. XAMPP is available for Windows, Linux, and also for the Mac. I'm using a Windows 10 machine, so of course I will download the Windows installer. So my download has started. Once the download is finished, then I will click on the installer, of course. Probably this message box also appears for you that it seems that you have an antivirus running, and in some cases this may slow down or interfere with the installation. But you can simply click on yes, I have never had problems with installing XAMPP. You might see a warning message like this one, so there is an activated user account control, but this should not be a problem for the XAMPP installation either, so just simply click on OK. Finally, we have arrived at the XAMPP setup wizard, so let's click on next. And here actually you can select the components of XAMPP. At least this is true for the Windows installer. I believe that for the Mac installer you cannot even select the components, so the job is done for you. Basically make sure that Apache and MySQL are selected. Actually you cannot deselect Apache, so make sure that MySQL is selected, and MySQL is the same as MariaDB in this context. And also make sure that the PHP MyAdmin is selected. PHP MyAdmin is basically an administrative dashboard, and we will use it to create our database. So the bare minimum is Apache, MySQL, and PHP MyAdmin. You will not be able to deselect PHP, but this is not a problem. I think that the whole installation takes about 800 megabytes, and actually I will not deselect anything, I will just install everything with XAMPP. The default folder is the XAMPP folder on my C drive, and this is perfect for me, so I will click on next. And the default language is English, and I'm perfectly fine with English. Uncheck this learn more about Bitnami for XAMPP. We don't need to learn more about Bitnami now, so let's click on next. And after I click on next, XAMPP will be installed on my computer. You have to be patient because it might take a bit of time for XAMPP to get installed on your computer. But of course in the video I will fast forward this part. So click on Next to install XAMPP. XAMPP has been successfully installed on my computer. The option, do you want to start the control panel now, is automatically checked, and this is fine. I want to start the control panel, so I will simply click on Finish. So this is the XAMPP control panel, and this is where we can start services. So this is where we can start MariaDB. Now actually MariaDB here is called MySQL, and I think it's a bit confusing that on the XAMPP control panel we have MySQL. However, on ApacheFriends.org we have MariaDB. But believe me that MySQL here basically means MariaDB. You can think about MariaDB as a version of MySQL. Click on Start next to MySQL. If the text here gets a green background, then it means that the MySQL or MariaDB service has been successfully started. And the Start button has also become the Stop button actually. Click on Admin. In your browser, you are automatically navigated to localhost/phpMyAdmin. However, the site cannot be reached so far. Localhost refers to your own computer, because we want our own computer to act as a server. So we want our own computer to run a database service basically. Go back to the XAMPP control panel and start the Apache service. Once it is green and the Start button has become the Stop button, then it means that Apache is running successfully. So it's not enough to start MySQL or MariaDB, you also have to start the Apache service. I will refresh this page now, and we are now in phpMyAdmin. Don't worry about PHP, as I said it's another programming language, but we will not use it. phpMyAdmin is basically just a nice administrative dashboard for our databases. We actually have started our own local database server, so now our own computers are acting as database servers. So we can create databases and they are managed by our own computers. On the right side here you see database server, and there is an IP address for the database server. Now this IP address is basically the same as localhost, so it designates your own computer. And the database server type we have is MariaDB. You also see the version of MariaDB, but this is not important for us. On the left side you see some databases that were created by default for us. We will not use any of these databases. We will of course create our own database to work with. What I want to do, however, is to protect phpMyAdmin with a password. So to protect our database server with a password. A user called root has automatically been created, and actually now we are this root user. Let's add a password for the root user. Click on User Accounts and click on Edit Privileges, where the username is root and the host name is a localhost. Near the top, click on Change Password. I will provide a very weak password, so 1234 1234. phpMyAdmin tells me that it is an extremely weak password and you should never use such a weak password when you are doing actual work. But I think for this crash course, this very weak password will be enough for me. I will of course retype 1234 1234. Then I will click on Go. The message at the top appeared. The password for root at localhost was changed successfully, so now our database server is protected by a password. But we are not done yet. I will close this tab, so I will close phpMyAdmin, and I will go back to my control panel. And again, I will click on Admin, so I can access phpMyAdmin or my database server. However, we get an error. The messages cannot connect, invalid settings. But what is important is basically this access denied for the root user. Go to the XAMPP folder on your computer. So I installed XAMPP on my C drive to the XAMPP folder. You should have a phpMyAdmin folder here. And here you should have a file config.inc.php. Use any text editor to open this file, for example Notepad. So I will just press my right mouse button and I will open this file with Notepad. I will maximize the window. Find the line CFG servers I auth type and change config to cookie. Don't change the user, but change the password. So find the line CFG servers I password and put the password here that you set in phpMyAdmin. Mine was 1234 1234. So I will save this file and I will close it. And now if I refresh the page, so if I refresh localhost/phpMyAdmin, Then I see this welcome to PHP My Admin page, and then I prompt it for my username and password. So let's provide them. Root, and mine is 1234, 1234. And now we are again in PHP My Admin, so now our database server is protected, but we ourselves know how to access it. Let's go back to the XAMPP control panel. I know we haven't done any work yet, but soon we will do some work in PHP My Admin. Regardless, I want to show you that if you don't want to use PHP My Admin anymore, then you can stop the MySQL service and also the Apache service. And if I now refresh this site, then the database server is not running anymore. But of course, if you want to do more work, you can just restart both these processes. And if I refresh the page now I have PHP My Admin again. Let's create a database. In order to create a database in PHP My Admin, you just have to click on New here. And all we have to do is specify a name for the database. I will call this database Business. And I will click on Create. So now we have created our very first database called Business. However, we are not storing any data in our database, so let's create a table for this business database. I will call the table Sales. And actually, it's perfect if the table has 4 columns, but later we could actually change this, of course, but 4 columns is perfect for us now, so let's click on Go. Here we have to specify the columns for our table. And of course, the actual data will be saved into this table. So in the crash course, we will use only this sales table inside the business database. When we are talking about databases, actually columns are also referred to as fields, and the rows of a table are also referred to as records. So now what we have to do is to specify the type of the columns or fields that we will have in this sales table. The name of the first field will be ID. It is pretty standard that every database table has a field called ID. An ID is of course a simple number, but each of the records or rows have to have their own unique ID. At least this is the best practice. After the name of the column, we have to specify the type of the column, so the data type that will be stored in this column. Int is short for integer, and varchar is string, and text is also a type of string. But as you can see, there are quite a few data types in SQL. For the ID, we will actually use the big int, so the big integer. A pop-up appears and you see that the big integer has a huge range. So we could save so many records in this table that it's like, unbelievable. I don't even know how to pronounce this number or these numbers. Remember that in VBA, an integer couldn't even hold the number 33,000. But the SQL integer can actually hold a number that is in the billions. And actually it would be enough for us, but the best practice is to go with the big integer data type for the ID field or column. The only thing we have to do for the ID column is to check the AI option, which is short for auto increment. Once I checked the auto increment option, a primary key, a so-called primary key, has been added for the ID column. We cannot really dig very deep into SQL because this is just a crash course, but basically this primary key or primary index ensures that each record or row in our sales table will have a unique ID. So no 2 records will share the same ID, so there can be no 2 rows where the IDs are both 100. And it is very important that we don't let anyone insert any row record into a table that would duplicate an ID in our table. The name of the second column should be name, and this will be a varchar column. So varchar stands for string, and usually we use the varchar data type in SQL if we want to store relatively short strings. I use varchar if the string is not longer than a few hundred characters. For the varchar data type, we have to specify a length, so a maximum length, and I will specify 199. Actually, it's 191, sorry, not 99. But this is something that I've been doing historically, and actually we will just store names here, so 191 characters or this limit will be more than enough for us. The name of the next field or column will be profit, and the integer data type is perfect for us. The last column will be called region, and it will be a varchar column with a limit of 191. Basically, we'll recreate the same table ultimately that we saw in the VBA section of the course. And I think we also saw it in the Excel section of the course. But this time the table will come with an ID. Now actually we don't have to set anything else or change anything else, so we can just click on Save here. And now our table has been created. So on the left side you see that we have the database called Business, and this business database has a so-called sales table. And actually here we see the structure of the table. So it has an ID, and basically this key next to the ID shows us that there cannot be duplicate IDs in this table. And we have a name column, a profit column, and a region column. In the name column, we will store names of salespeople. In the profit column, we will store how much profit they made. And in the region column, we will specify in which sales region they are active. Our table is so far empty, so let's insert some actual data into it. Click on Insert here at the top. Actually, at the top, we can insert a new record or row. You see that the column names are here, so ID, name, profit, and region. We don't have to specify an ID because it will be incremented automatically, so SQL will be able to assign the ID automatically. But let's actually provide a name here, like Joe Paulson. Let's say he made $300 profit, so let's say that this profit column is in dollars, so shows the profit in dollars. And he is active in the EMEA sales region. Now, EMEA stands for Europe, Middle East, and Africa. I've mentioned this earlier in the course. Simply click on Go. You should see the message, one row inserted. And actually, this is the SQL query that was executed to insert this record into the sales table. But we will discuss insert queries a bit later. If I click on the sales table now, then here, in the middle, sort of, you see that now we have a record or row in this table with the ID of 1, so this was automatically assigned, and the name is Joe Paulson, and Joe made $300 profit in the EMEA region. Let's insert another salesperson. The name should be Sarah Smith, for example. And Sarah made $600 profit in the APAC region. APAC stands for Asia Pacific. Let's click on Go again. And this record has also been inserted, and the ID of the row was automatically assigned, so the ID is 2, and if I click on this sales table, then you see that now we have 2 records or rows in this table. It's time to write our first valid SQL query, I believe. A query is just a piece of SQL code that does something, so for example retrieves some data from a database. Shortly, as I mentioned before, we'll write SQL queries inside VBA, so we will have VBA code mixed with SQL code, so to say. But let's just use phpMyAdmin to write our first valid SQL query, because in order to use VBA for executing SQL queries, we'll have to do some more work, so we will have to install a driver. But I think now you're eager to see a valid SQL query. So let's just click on SQL here at the top. And let's just say select star from sales. And actually we don't need to use these backticks. Select is an SQL statement or keyword. I prefer to use the term keyword actually. So select has a special meaning for the SQL language. It of course tells SQL that we want to select or retrieve some data. By the way, you don't have to make your keywords uppercase, but it is a good practice to do so. Whenever I write some SQL code, I always make sure that the keywords are all in uppercase, so we see immediately what is the structure of my query, or what is the structure of my SQL code. Now the star also has a special meaning actually. It basically says select all, so it basically stands for all the fields or columns. And actually we will not specify which records or rows to retrieve. So in this context, you can understand this select star as select everything. From is again a keyword, and after the from keyword, we have to specify from which table we are selecting all the records. Notice that we are inside the business database, so this query will run against the business database. So we better make sure that there is a sales table, so a table called sales in the business database, if we want this query to run. So this is perfectly valid SQL, and it says select all the records and rows from the sales table. Let's click on Go on the right hand side. And actually we see this green message, which basically says that 2 records or rows were retrieved, and the query took very little time. And you see the results here. So both rows that we inserted into this table were retrieved, of course. Let's click again on SQL. And actually what I want to show you is that I will actually delete this and the backticks as well. And I will add a semicolon. Here we don't have to add a semicolon to make this a valid SQL statement. But actually I usually add a semicolon at the end of my SQL statements. The semicolon is sort of a separator in SQL. So it separates the SQL queries or statements. And because of this semicolon, I see that this is my SQL query. Of course, even without the semicolon, it would be obvious that this is my SQL query. But later when you work with SQL, I think you will find it beneficial to use the semicolon. If I run this query again against the business database, then again these two rows from the sales table are returned. Actually, I want to delete both these rows. So I will go to SQL again, and I will simply say delete from sales. And I don't need the backticks, but I will add the semicolon. With this query, actually, I will delete all the records of the sales table. And the reason I want to do this is that I want to insert new records, and I don't need these two original records. So if you want to delete all the rows from a table, then this is the syntax, delete keyword, and then the from keyword, and then you have to specify from what table you want all the records to be deleted. But later in the course, we will talk about these delete queries as well. Let's click on Go. Now actually, we have a pop-up, do you really want to execute delete from sales? So basically, we will delete all the records, and in this case, when we want to execute such a dangerous query, then PHPMyAdmin actually shows us this warning, but I'm sure that I want to delete all the records, so I will click on OK. And now if I click on the sales table, then there is nothing in it. You know that I provide files for this crash course, for example, the sql.txt file. You will find a link in the description to download this file. Maybe it will be part of a zipped package. But what is important is that you open this sql.txt file and you copy everything from it. After you copied everything, click on SQL while you are in the business database and paste everything here. Basically, we will insert the records that we want to work with into the sales table. And we insert 17 records into the sales table. These are the so-called insert queries. So this is the way for inserting data into a table, but later we will talk about the insert query in more detail as well. For now, simply click on Go. If I click on my sales table now, then you see that the records have been successfully inserted. However, Abbey Wood, the first record, starts with the ID 3 because actually we had two rows previously in this table. So actually SQL automatically assigned the ID with 3 to Abbey Wood, and actually I don't like this. So actually I will just quickly change the IDs here, so they should go from 1 to 17. I actually forgot about this auto increment, so this is my bad, sorry. But you just have to double click into the ID fields and you have to change them manually. So now the IDs go from 1 to 17, so now the table is perfect for us. Let's execute another SQL query. Of course, let's select everything from the sales table again, just to confirm that there will be 17 records selected. So the query is, of course, select star from sales. I will click on Go. And indeed, 17 records have been returned and everything seems to be fine. So now we have our table ready and we will work with this table in the remaining part of this SQL section. So what we have to do now is to make sure that we can run SQL code from VBA. In order to be able to use VBA to interact with MariaDB, we have to install a so-called ODBC driver. I've already opened the relevant website for us, and of course you will find the link in the description. We're going to install version 8 of the ODBC driver. My operating system is Microsoft Windows, and I have a 64-bit operating system, so I will choose that. And I will start downloading the MSI installer. You are navigated to a page like this, and actually you don't have to either sign up or log in. You can just click on this link, no thanks, just start my download. And your download should start. Once your download is finished, then click on the downloaded file. And you should see this dialog, welcome to the setup wizard for MySQL connector ODBC 8.0. click on Next, read the license agreement and then accept it, and click on Next. A typical install is perfect for us, so click on Next, and click on Install. Actually, this MySQL connector / ODBC driver installs very quickly, so when you see the wizard completed dialog, you can simply click on Finish. But we are not done, we have to configure some things. Either search for Administrative Tools, so Windows Administrative Tools, and choose the ODBC data source 32-bit or 64-bit. I have a 64-bit operating system, and if you have Windows 10 as well, then you also have a 64-bit operating system. And actually I also have a 64-bit Excel installed, or Office installed. In case you have a 32-bit operating system, or your Office is a 32-bit version, then you will probably need to click on the 32-bit version of the ODBC data sources. Otherwise, you should go with the 64-bit version. You can actually search directly for these ODBC data sources, so you can just search for ODBC here. And you have the 32-bit version here or the 64-bit version, but you can reach this from the administrative tools as well, so I will click on the 64-bit version. Click on the System DSN tab and click on Add. In the list, you should be able to see MySQL ODBC 8.0 Unicode driver. Select it and click on Finish. Now we have to configure a data source. So basically we have to establish a connection to MariaDB / phpMyAdmin. My data source name will be phpMyAdmin. Into the TCP/IP server field, type 127.0.0.1. This is the IP address of your computer. We saw this in phpMyAdmin as well, so 127.0.0.1. Don't change the port. For the user, put root here. And for the password, I will provide 1234, so this is the password that I set for the root user. And now in this database drop-down field, if you click on this downward point arrow, you should see the databases that we see in phpMyAdmin. Select the business database, so the sales table is in the business database, and click on Test. You should see this dialog or message box, test result, connection successful, click on OK, and click on OK again. Actually, now we have everything to run SQL queries from our VBA code. Click on OK, of course, and open the SQL section.xlsm workbook. Either in the description you will find a link to this file, or this file will be part of a zipped package that you can download, and of course the link to this zipped package will be in the description as well. Unlike in case of the excellent VBA sections of the crash course, there is only one file for the SQL section of the course. So there is one workbook more like for the SQL section. For the previous sections we had a start file and an end file, but now we only have the SQL section.xlsm workbook, because actually I have written all the code for you, so I can save a lot of time. But don't worry, because we will go over the code line by line. In case you have missed the VBA section of the course, I suggest you take a look. But in any case, I want to tell you that XLSM stands for Macro Enabled Workbook, so in this workbook I have written code and we can access that code. On the quick access toolbar, you should see these three icons, so this like manager icon. And actually, with this manager icon, we can very conveniently execute the manager subroutine. There is this warning icon, and it is for executing the delete all records subroutine. And there is, of course, this tick icon in a circle, so it's a tick in a circle. And this is for executing the automation VBA SQL subroutine. We will of course discuss all these subroutines, but I just wanted to show you that we have three subroutines added to the quick access toolbar by default. In this workbook we have three worksheets: SQL data, profit and analysis. We will need the profit and analysis worksheets for our VBA automation, because actually we will extend our VBA automation that we worked on in the VBA section of the course. We will actually get the relevant data from our database for this automated process, but this we will discuss at the end of the SQL section, I believe. So let's go back to the SQL data worksheet. This is actually where we will retrieve our data from our database. So we will use this worksheet to get the data. Let's go to the Visual Basic Editor. You should have the Developer tab here and click on Visual Basic here. I have added 4 modules in this workbook. The first one is called Code, and it contains the Manager subroutine. And I have written all the SQL queries that we will execute in this section of the course here. But of course, everything now is commented out. We will get back to this subroutine shortly, but let's check this Crash 19 Automation VBA SQL module. So this is the extension of our automated VBA process that we worked on in the VBA section of the course. In the VBA section of the course, I gave a very similar name to this automated VBA process. So this is why you see here Crash 19 Automation VBA SQL, so that you can sort of connect the two modules. But we'll come back to this module much later. Now let's check the Delete Records module. There is a very simple subroutine here, and with this simple subroutine, we can just delete all the records or all the data that we retrieved from the database. Now, of course, we are not actually deleting data from the database, we are just deleting the retrieved data from our worksheet. And we also have a helpers module. We have written this GetLastRow function in the VBA section of the course. And we also have the GetDataFromDB subroutine. Now this is new. This is the subroutine that will actually retrieve data from the database for us. We will get back to it later, don't worry. And we also have another subroutine called Execute Query. We will use this subroutine, for example, for inserting some data to the database, but we will get back to this later as well. For now, let's click on the Code module. And actually, at this top menu, click on Tools and click on References. Actually, VBA can use for a lot of things. Of course, most often we use it to automate Office applications, for example, Excel. But in certain cases, like now, we want to extend VBA a bit. So we want to be able to establish a connection to the database and to run SQL queries against the database. And in order to do that, we have to add a reference to the Microsoft ActiveX Data Objects library. The current version here is 6.1, but the version doesn't really matter. What matters is that there is a tick next to this Microsoft ActiveX Data Objects library here. The ones above it should be ticked by default. But if you don't see the Microsoft ActiveX Data Objects library here, then you have to scroll down a bit and you will find it somewhere. But actually, if you're using this workbook that I've provided for you, then the tick or the check mark should be there next to the Microsoft ActiveX Data Objects library. Now actually, a reference is basically just some more code that extends the capabilities of VBA. We will use the ActiveX Data Objects, of course, to establish a connection to the database and run queries against it. Let's close this window. And first, let's just confirm that everything is fine and you can actually retrieve data from our database. After that, I think I will walk you over the code. So for example, the GetDataFromDB subroutine. We are in the subroutine called Manager Sub, and two variables have been declared, the connection string variable and the SQL query variable. They are both string variables. The connection string will be a very long string, and we will need it to establish a connection to our database. The SQL query variable will actually store our SQL query, so this is the variable that we will use for assigning our SQL query. The connection string is quite long, so you see that I assign all this to the connection string. And notice that these are basically chunks of strings, so there are more pieces of strings here. But each line of code ends with an ampersand and an underscore. With an ampersand, we can concatenate strings, and this is something that I mentioned in the VBA section of the course. And with the underscore, we can tell the Visual Basic Editor that this line of code is continued on the next line of code. So all these 5 lines of code are actually one big line of code for the Visual Basic Editor. Now actually, I've written the connection string for you. So the only thing you have to do is maybe make some minor adjustments. If you have done exactly what I did, then you don't actually need to change anything here. Now in this connection string, we have to specify a driver. And inside these curly braces, you should specify your ODBC driver. So this MySQL ODBC driver, basically you have to put the string that you see here in the administrative tools, in the ODBC Data Source Administrator. So click on System DSN. Now this is what we configured. And this is the name of your driver. So make sure that this name is exactly here inside these curly braces. The server should be 127.0.0.1, so your local computer. The database should be the business database that we have created. The user should be root, and the password is 12341234 for me. Now, if you created a different password in phpMyAdmin, then of course use that password here. So the two things you might have to adjust is the password and the driver if you use a different version than mine. Otherwise, let's just uncomment these two lines of code. So we will assign the SQL query select all from sales to the SQL query variable. And then we will use the GetDataFromDB subroutine to run this query against the database and to save the data to our worksheet. You see that we have to pass the connection string here and the SQL query to the GetDataFromDB subroutine. But of course, shortly I will talk about this subroutine in more detail, but now I just want to confirm that you can actually get all the data to your worksheet. Notice actually that the SQL query is a string. So of course, SQL query is a string variable. So we have to enclose our SQL query in double quotes when we use VBA to run our SQL queries. But we already know that select star from sales basically means that we are retrieving all the data from our sales database. So let's go back to our workbook, select the SQL data worksheet, and click on this manager icon, so we will run the manager subroutine. And this is exactly what you should see here. All the data from the sales table has been retrieved. In the first row, you should see the field names, and in the rest of the rows, of course, you should see the actual data. If this is what you see, then everything is configured perfectly for you, so we can really start learning about SQL. Of course, always make sure that Apache and the MySQL/MariaDB service are running when you are executing queries. I will stop now both, and I will run the manager subroutine again. The data you see here was not refreshed. I just didn't delete the data, so the data is still in the worksheet. However, you see that an error message has been thrown. We get a runtime error, which says that it can't connect to MySQL server on a local host, basically. Let's click on End. I will actually run the delete all records subroutine. So now all the records have been deleted, and I will rerun the manager sub. So you see that no data will appear here. We received the same error message, so can't connect to MySQL server on the local host. I will click on End, so no data has been retrieved. Because of course, VBA cannot run any queries against the database because the database server is not running. But once I restart the MariaDB service and Apache, then I should be able to get the data very quickly. Indeed, the data is here again, and it was blazing fast. I think at this point we have to talk about the VBA code a bit. We've already talked about the manager subroutine, so we have this connection string variable here. And this is quite a long string, and of course it has all the necessary information that is necessary for establishing a connection to our database server. As we've discussed, we specify the ODBC driver here, the address of the server, which is our local machine. We specify the database that we want to run queries against. And by the way, when I say running a query against a database, it's just some specific terminology that basically means just to execute an SQL query. Now in the connection string, we also specify the user and the password for the user. So this information we need to establish the connection to our local database. We also discussed that in the SQL query variable, we write the actual valid SQL code. And because we are inside the Visual Basic Editor, the query has to be a string. So this is why there are the double quotes. But actually, if you just copy-paste the SQL queries that are in between the double quotes, then you can run them in phpMyAdmin without a problem. I've been logged out, so I have to log back in. So if I copy this query, for example, and if I paste it into phpMyAdmin, I have to actually select the business database. And if I paste it here and run the query, then you see that the query has run successfully in phpMyAdmin. So make sure that you don't copy the double quotes, in case you want to check your queries and run them in phpMyAdmin. We will check now the GetDataFromDB subroutine. We see that it takes two arguments, the connection string and the SQL query itself. This subroutine is in the helpers module. We have implemented the GetLastRow function in the VBA section of the course, so we will not discuss that. And this is the GetDataFromDB subroutine, the subroutine that we will discuss now. So you see that it takes two parameters, connection string and SQL query. And actually these two arguments or parameters, so in this context argument and parameter is the same, but I think I should stick to argument. So it doesn't matter what you call these two arguments. Now they have the same name as in the code module. So in this manager subroutine, we have a connection string variable and SQL query variable, and the names of these variables are the same as the arguments in the GetDataFromDB subroutine, but they don't have to do anything with each other. These arguments have the same value as the two variables that we pass to the subroutine here, but actually we could name the arguments something totally different. But I think it's good that they have the same name, so it's sort of a bit more intuitive for us. So the GetDataFromDB subroutine gets the connection string, so all the information that is needed for establishing a connection to our local database, and it also gets the SQL query that we want to run against the database. First, we declare a connection object variable, which actually will be a connection object. We need this connection object to be able to establish a connection to our database. I don't think we have used the new keyword in the VBA section. Basically, this line of code means that we declare a connection variable, an object variable, that will refer to a newly created or instantiated ADODB.connection object. When we create a new object, we usually say that we instantiate a new object, but it basically means that we create a new object. So this variable will refer to a new object here, a new connection object, that we can use to establish a connection to our database server. We also declare a record set object variable, which refers to a newly instantiated record set object. We will use this record set object to actually run the query against the database. The reason we have this ADODB.connection object and ADODB.record set object available in our VBA code is because we set the reference to the Microsoft ActiveX Data Objects library. But we have already talked about this. So basically this is why we needed the reference to that library, so we will have the connection object and the record set object. We also have a record array variable, so obviously this is going to be an array. This array is declared to be a variant, and actually it doesn't matter that we don't use parentheses after the variable name. This will still be an array. Actually it will be a two-dimensional array, but you will see this later. And then we have a bunch of long variables. Mostly we will use them for looping. So on the next line of code, we call the open method of the connection object, and we pass the connection string variable to it. If everything goes well, then the connection is established to our database server on this line of code. We saw what happened when the connection could not be established, so we received an error, but if we don't receive an error, then the connection is established, and then we can call the open method of the record set object. We pass then the SQL query, so the SQL query that is here, this argument, so we pass this argument to the open method of the record set object, and we also pass the connection object itself. Now basically if everything goes well, then the retrieved data will be available in this record set object. Then we access the fields and the count properties of the record set object, and what is returned here is assigned to the field count variable. The field count of course shows us how many fields we retrieved. In the query that we have run so far from VBA, we retrieved all these 4 fields, so the field count should be 4 at this point. Then we have a simple loop, and basically what we do here is to create the header. So this line of code that I have highlighted basically adds the header to the worksheet. Notice actually that we are accessing the fields by indexes, so by an index I mean. And the iColumn variable is initialized to 1, but we always subtract 1 from the iColumn variable because the fields are indexed from 0. But what is important is that in this part of the code, so on the right hand side, we get the field names and we assign it to the cells specified in the left hand side. And then what happens is that we call getRows on the record set object, and we assign the result to the record array, so that this is the point when the record array variable will be a two-dimensional array. When we work with two-dimensional arrays in the VBA section of the course, then the first index was the row index and the second index was the column index. Now here it's vice versa actually. So the first index or first dimension of this array will be the column index and the second dimension will be the row index. And actually they are indexed from 0, but that is not a problem. Here we have a nested loop, and basically this is the loop that adds the data to the worksheet, so the loop that adds all these rows to the worksheet. In the outer loop, we use the column index, so basically we are adding the data column by column, so first the IDs, and then the names, and then the profit figures, and then the region figures, or the region data, sorry. So we have this two-dimensional loop, and inside the loop we have only one line of code, and in this line of code we assign to the appropriate cell the value extracted from the record array, so from this two-dimensional array that actually contains the retrieved data. And notice that, as the variable name suggests, the first dimension is for the column index and the second dimension is for the row index in this record array. In the last line of this subroutine, we are auto-fitting the columns, so basically the width of the columns are adjusted to accommodate the data that is in these columns, so to say. I will make column C wider, then I will hover my mouse over the border of column C and D and double-click. So this is what the auto-fit does. So this is what this line of code does actually. I just put this line of code here so that the data looks a bit better. Let's also discuss the delete all records subroutine. This should also be in the helpers module, I believe. No, there is a delete record module. So we have a subroutine here, delete all records. Basically we are getting the index or number of the last row based on column A. So in this case, of course, it will be 18. So this is the last row. 17 is the ID, but the row in the worksheet is actually 18. So 18 is returned in this case. And then we hard code the last column, and the last column index will be 4, so column D. In the SQL section of the course, we'll exclusively use this table, and this table has 4 fields. So we can make sure that this delete all records subroutine will delete all the records, even if we take all the data from the table like now. For working with other tables, this subroutine should be adjusted, but for the crash course it is perfect for us. There is a nested loop here. In the outer loop we are looping over the rows and then the columns, and basically with the clear method we are deleting everything from each cell. So basically we are deleting the data row by row, and we are clearing all the cells. Okay, I think that at this point we have discussed all the subroutines that we needed to discuss. A bit later actually we will discuss the execute query subroutine, and at the end of the section we will also discuss this crash 19 module. But for now let's get to the code, or the code module, sorry. So this is the query that we have run, and of course with this query we can retrieve data. If an SQL query starts with select, then it means that we are going to retrieve data. We discussed that the star has a special meaning in SQL. It means that we want to retrieve all the fields. And after the star, we have the from keyword. And after the from keyword, we have to specify from which table we want all the fields to be returned. Because nothing else comes after the table name, if you have a query like this, then it means that all the rows or all the records will be retrieved. This is a very typical query, which basically reads, select all the fields and all the rows from the sales table. We will execute a lot more select queries in this section of the course, but I will actually comment out these 2 lines of code, and I will uncomment these 2 lines of code. And what we'll do now actually is inserting a new record into a sales table. And then actually we will run another query to select all the data from the sales table. So you see that first actually we will execute an insert query, and then we will execute a select query, and this will work without a problem. Let's first delete all the records we have, and let's go back to the editor. Retrieving data is of course one of the most basic operations, so this select query is one of the most basic things that we can do. But of course, inserting data into a database or a table is of course another basic operation that we have to be able to do. In order to insert data into a table, we of course have to start a query with the insert keyword. And then comes the into keyword. And after the into keyword, we have to specify the table name. Of course, the data will be inserted into the table that we specify here. So this part of the query so far reads, insert data into the sales table. After specifying the sales table, inside parentheses, I specified the columns into which I want data to be inserted. I want to insert data to the name column, to the profit column, and the region column. Notice that I didn't specify the ID column, and of course this is because the ID column is an auto-increment column. I don't have to specify a value for the ID. The ID will be automatically assigned to my newly inserted record. After specifying the fields into which I want data to insert, I have to use the values keyword. And after the values keyword, I have another parenthesis where I specify the actual data that I want to be inserted. So I want the name Daniel Kin to be inserted into the name field. The profit figure should be 2,300. And Daniel represents the EMEA region, so I provided EMEA here. Notice that I provide the data in the same order as I specified the fields. So the first piece of provided data will be inserted into the name field, and the 2,300 figure to the profit field, and the EMEA string will be inserted into the region field. Notice also that I enclose the strings inside single quotes now. The name field and the region field are varchar columns, which basically means that they are string columns. The profit field or column is an integer field, so this is why I don't enclose the number inside the single quotes. But if the field is a varchar field, then I should enclose the values with single quotes. So the first half of the query basically reads, insert some data into these columns of the sales table. And the second part of the query reads, this is the data that I actually want to insert into these columns. And of course, when we use the insert keyword, a new record or row will be inserted. So we are not overwriting our current data. The execute query subroutine is called, and we pass the connection string and the SQL query variable to the subroutine. Shortly we will discuss what this subroutine does. But of course it should run the query against the database, so once this subroutine runs successfully, then we should have a new row in the sales table, and it should be Daniel King's row. So after the new row is inserted, then we run the query that we are very familiar with now, so they select all from sales query, and we simply call the GetDataFromDB subroutine like we did here, so that we'll have all the data in our worksheet. So let's actually run this query. Let's go back to the worksheet and let's run the manager subroutine. Everything seems to be fine. Now notice that we have a new row for Daniel Kin here. However, the ID for Daniel Kin is 20 and it's not 18, so Tobias is 17 and Daniel is 20. And actually it's not a problem. If you remember, first we manually inserted 2 rows into the sales table, and then we deleted those 2 rows. And then we inserted these 17 rows or records into the database, but we manually had to adjust the IDs. But because of the auto increment and because we deleted 2 records earlier from the table, the new row Daniel Kin got the ID 20 and not 18. So let's just go to phpMyAdmin. I will actually refresh this page. So now I should see, actually I shouldn't have refreshed it. I can just simply select the sales table. And I see that Daniel Kin is here, and I will just manually adjust Daniel Kin here. What I meant is, of course, I adjusted the ID of Daniel Kin, and actually this is what you usually don't want to do. So it's not really a good idea to come to phpMyAdmin and start messing with the data. But of course, you are just taking a course, and I think it's important that you see that this can also be done. So now the IDs in the table are going from 1 to 18, and this is perfect. Let's actually rerun the manager subroutine. And of course I made a mistake, because by rerunning the manager subroutine, now a new row was inserted, so another row for Daniel Kin has been inserted, and I didn't want to do that. So let's get back to phpMyAdmin actually, and let's simply delete this new row with the ID 21. Let me delete all the records from here as well, so clear the worksheet. And I will actually comment out the insert query. So now only this select query will run when I run the manager subroutine. So perfect, there is 1 row for Daniel Kin, and our rows go from 1 to 18. Perfect. Let's actually discuss the execute query subroutine. This should be in the helpers module, yes. So it takes 2 arguments, the connection string and the SQL query, same as the GetDataFromDB subroutine. We also instantiate the 2 objects that we need to establish a connection to the database, so the connection object And there is also a record set object. And of course, we use the record set object to run a query against the database. And basically what we do here is we establish the connection to the database, and then we run our SQL query against the database. But we are not retrieving any data. So when we use here the execute query subroutine on this line of code, we are running this insert query so the data is inserted into the sales table. But actually we need the GetDataFromDB subroutine to retrieve the data or to sort of copy the data into our worksheet. If we run a query like the insert query, so if the query is not retrieving anything but sort of modifying our table, then we will use the execute query subroutine. But when we want to retrieve data, then we will use the GetDataFromDB subroutine. Let me comment out these lines of code, and I will uncomment this line of code here. So now we will learn about the where clause or the where keyword. Let me also comment out this line of code, so where we call the GetDataFromDB subroutine. So basically we will execute this SQL, this select query now. We are familiar with this part of the query, so select all from sales. However, after the table name, we use the where keyword, and actually this part of the query can be regarded as a where clause, a so-called where clause. When we use the where keyword or a where clause, we are basically using conditional logic. After the where keyword, we specify the condition, so we specify the field, and now of course the field is ID. And after the ID, we can say that we are using a conditional or comparison operator. This is here the equal sign, and then we specify the number 18. Basically this query reads, select all the fields from the sales table where the ID is 18. So we will still retrieve all the fields, so all these 4 fields. This is why we are using the star here. But in the where clause, we specify that only the row record should be retrieved whose ID is 18. So only Daniel Kin will be returned. Let me delete all the records, and let's run the manager sub. And indeed, only Daniel Kin has been retrieved. So now only one record has been retrieved, but all the fields of this record have been retrieved. I think it's quite obvious why the where keyword or the where clause is very important. A lot of times you don't want all the data to be retrieved from a table. Tables in a database can have millions or even billion rows. And in a lot of situations, you need only one row or a couple of rows. For this, we can of course use the where clause. Let's run now another select query. This time we will retrieve all the records whose ID is less than 18. So basically everything should be returned except for Daniel Kin. I don't have to delete all the records, these will be overwritten, so let's run the subroutine, the manager sub. And indeed, all the records have been retrieved except for Daniel Kin because his ID is not less than 18. So we can use the less than operator in the where clause as well. The next query we run will say, select all the fields from the salespeople where the ID is less than or equal to 10. So basically we will select all the records here from ID 1 to 10. Let me delete now all the records, because actually we will retrieve fewer records. So let's run the manager sub. And indeed, the records or rows have been retrieved whose ID is less than or equal to 10. So the first 10 rows basically. Let's check the other the next select query. Now we will retrieve the records from the sales table where the ID is greater than 10. So let me delete all the records and run the manager sub. And indeed now the records have been retrieved whose IDs is greater than 10. Let's check the next query we have. This time we will retrieve all the records whose ID is greater than or equal to 10. So this time actually if I simply run the manager sub, without deleting all the records, I should have one more row. So in the second row, I should actually have the record with the ID of 10. And in the 10th row, I should have Daniel Kin with the ID of 18. And indeed, this is what happened. Let's check the next select query. This time, the condition for retrieving records is not based on the ID column, but on the region column. And don't forget that the region column is a varchar column. So here, for the condition, we have to use quotes, single quotes. Basically now we will retrieve all the records where the region is EMEA. Let's actually delete all the records first and let's run the subroutine. And indeed, you see that all the records have been retrieved with the EMEA region. However, the region is not EMEA, then we don't have the record here. The ID column is very useful to make sure that each record will have its own ID, so that there is something unique about each record. But when we retrieve data, we usually don't retrieve data based on IDs. I think this query is much more meaningful than the previous queries that we ran, so the query is based on the ID column, because this could really be considered a real scenario. You want to see the sales figures from the EMEA region only, so you run this query against the database. Let's delete all the records, however, and let's check our last query here. So now we will retrieve the record where the name is equal to Daniel Kim. So basically we will retrieve only the last row of our table. And no, I was mistaken actually, because it seems that we have another Daniel Kim in our table, and actually it surprises me because I wanted all the names to be unique, but actually it doesn't really matter. It's actually good that we see an example where based on the name, 2 records are returned. So everything is fine, I was just a bit surprised. Okay, I can actually comment out these lines of code and we can start talking about updating records. But before we do that, I want to emphasize that the where clause or the where keyword is extremely important in SQL. Most of your select queries will have a where clause. This is why I wanted to show you a couple of examples for specifying different conditions for returning records. It's very important that you know the syntax for a select query that has a where clause. We have discussed so far 2 basic operations, so retrieving data or selecting data and inserting data into a table. Now it's time to update data in the table, so update data that is already in the table. If we want to update a record, then we have to use the update keyword. Let me comment out these 2 lines of code. So this is the SQL query. This is the SQL query that we will run against the database. So we will call the execute query subroutine, and then we will select all the data from the sales table again. So first we use the update query, which will tell SQL that we want to update a record or records. Then we have to specify the table in which we want to update records. And then we have to use the set keyword. And after the set keyword, we have to provide the new values. Name equals Paul Rogan. We of course change the name from Daniel Kim to Paul Rogan. We will update the record with the ID of 18. You can see it in the where clause at the end of the query. So this is why I told you that the name Daniel Kim will be changed to Paul Rogan. But after this name equals Paul Rogan part of the query, we put a comma, and we also specify that the profit figure should be updated to 1,800. And then the query ends with a where clause. This where clause is extremely important because of course it specifies that we will only update the record with the ID of 18. So no other records will be updated, only the record with the ID of 18. Notice that after the where keyword, when we use the equal sign, then it checks for equality, so if the ID is equal to 18. However, after the set keyword, we use the equal sign for assignment, for assigning new values to these fields. So first we will update the record with the ID of 18, and then we will retrieve all the records from the table. So let's go to the worksheet. Let's delete all the records and let's run the manager sub. Now indeed we don't see Daniel Kim, so the record with the ID of 18 now belongs to Paul Rogan, and the profit is 1,800, not 2,300 as previously, but the region has not been touched, so the region is still EMEA. Okay, so this has been the update query, but actually I forgot to mention something when we were discussing the where clause, so let me just comment out these 4 lines of code, and let me uncomment this line of code. And let's say that we want to select the record where the ID is 100, and we know that we don't have a record with the ID of 100, so let me go back to the worksheet. I will delete the records, and I will run the manager sub. I made a mistake, so the query was actually not running because I commented out only this line of code, this SQL query, so I specified the query, but I didn't comment out this line of code that actually runs this query against the database, so sorry about that. Let me run the manager sub again. Now we get a runtime error. Either BOF or EOF is true, or the current record has been deleted. Requested operation requires a current record. This error message seems to be quite cryptic, but basically it means that no record could be retrieved. If you're running SQL queries against the database from the Visual Basic Editor, but nothing could be retrieved by a select query, then you get this error message. I mean, if no record is retrieved, then it shouldn't be an error, but it's important for you to know that in this context it is considered to be an error, and basically this message means that nothing could be retrieved, and of course we don't have a record with the ID of 100. However, notice that our code actually, so the GetDataFromDB subroutine actually added the header to our worksheet. So if you see the header added and you get the error message, then it means that nothing could be retrieved. The table itself could be retrieved, so the headers could be retrieved, the fields could be retrieved, but no records could be retrieved based on the query that you wanted to execute. I will change this to 18 actually. And let me just duplicate the last M in from, and let me run the manager sub again. Now we get a different runtime error, and this time, of course, the SQL query is not valid, so from is not a valid syntax. And basically we get the message, you have an error in your SQL syntax. Check the manual that corresponds to your MariaDB server version for the right syntax to use near from sales where ID equals 18 at line 1. So this is a bit long, so the error message is a bit long, but basically it tells us what's wrong. There is a SQL syntax error. Unfortunately, it's not very specific, so it doesn't say that from is not a valid keyword. It just shows you, the error message shows you approximately where the problem can be, but you have to figure it out yourself. Let me click on end, and let me actually, of course, correct the query. So this time if I run the query, then yeah, Paul Rogan should be retrieved, and there are no problems. Let me actually delete everything now. And now that I have shown you all these error messages, let's move on to the next topic. So I will comment out these lines. And let's actually check how we can delete a record. Let's uncomment these 4 lines of code. So far we know how to select or retrieve records, insert new records, and update existing records. And the 4th basic operation is, of course, the deletion of records. This is our example SQL query for deleting a record. We start the query with the delete from keyword. Then we specify the table name from which we want a record or records to be deleted. And then it's very important that we have a where clause, because in this where clause we specify that we want the record with the ID of 18 to be deleted only. So the other records will not be touched. We execute this SQL query with the execute query subroutine. And then, as usual, we will select all the data from the sales table. So let's go to the worksheet and let's run this code. So let's run the manager subroutine. It seems that everything is fine. So all the data has been retrieved, but there is no record with the ID of 18. And if I go to phpMyAdmin and select my sales database, then you see that the last record has the ID of 17, so it's Tobias Ferguson, so Paul Rogan, I believe, has been deleted. There is not much else to discuss about the delete query. What is extremely important, of course, to use a where clause to make sure that only those records will be deleted that we really want to delete, and we will not touch any other records. I will comment out these 4 lines of code. And actually I've just noticed that I have the immediate window open and I don't need the immediate window, so I will close it. So now I have actually more space, which is good. So now you know the 4 basic operations that we can do with data. So we can retrieve data, we can insert new data, we can update existing data, and we can delete data. Let's talk a bit more about retrieving data, and I will uncomment these 2 lines of code now. Until now in our select queries we used the star, so this special symbol for SQL, which basically means to select all the fields or columns. But many times you don't need to select all the fields or columns. For example, you don't really need the IDs of records most of the time. So in this select query, instead of the star, I have specified the 3 fields whose data I want to be retrieved, so the name field, the profit field, and the region field. And of course, we have to separate these fields, and we separate the field names with commas. But actually, as long as you don't forget about the commas, then I think you will not have a problem writing queries like this. Let's actually simply run the query. I will delete all the records now, and let's call the manager sub. So this time we don't have an ID column, but we specified that we only wanted the name, the profit, and the region columns. And actually all the records have been retrieved, so everything seems to be fine. Let's check the second example. So I will uncomment this line of code. So we are still selecting the name, profit, and the region fields from the sales table, of course. But at the end of the query now we have a where clause, where we specify that we only want records to be retrieved whose region is APAC, So let's go back to the worksheet, let's delete all the records, and let's run the manager sub. And this time only the 3 records with the APAC region have been retrieved. So if you don't need all the fields to be retrieved, then instead of the star symbol, you have to simply specify the fields from which you want data to be returned. There is not much else to discuss about this, so let me comment out these lines of code, and let me uncomment these 2, because now we will discuss the as keyword. In the query we've run a few moments ago, we specified the columns from which we wanted data to be retrieved. And in our worksheet, the actual column names have been retrieved. However, we can use the as keyword to give an alias to these column names or field names. The SQL query I have here is very similar to the previous one. So it's very similar to this one actually. But here, after specifying that I want data from the name field to be returned, I use the as keyword and I give an alias to the name field, so the alias will be salesperson. I don't give an alias to the profit field, however, again I give an alias to the region field, so the alias should be sales region. Let's run the query. I will delete all the records and run the manager sub. So this time the same records have been retrieved. However, now in the header I see salesperson instead of name, and I see sales region instead of region. In a table in a database, you might realize that not all the field names are obvious. Or there can be situations when it's obvious for you, so the field names are obvious for you, but it's not obvious for the people for whom you are creating a worksheet, for example. So in this case, the as keyword can be very useful. With the as keyword, you can be more precise about the headers or the column names. This is actually all I wanted to say about the as keyword. And now we will start talking about functions in SQL. We will run this query, so I will uncomment these 2 lines of code, and we will start with the SUM function. Just like in Excel, we have functions in SQL as well. And basically they have the same purpose as in Excel, so we use functions in SQL to manipulate our data, for example, to perform calculations on our data. Let's check the SUM function first. Actually, the SUM function in SQL does the same thing as the SUM function in Excel. It sums some numbers or figures. So our SQL query now reads select sum profit from sales, which basically means that we want to retrieve the sum of the profit column of the sales table. So after the select keyword, we specify the function that we want to use, and then inside parentheses, we specify the field whose values or figures we want to be summed. Let's run the query. I will actually delete everything first, and now I will run the query. So the sum of the profit has been retrieved. Basically, all the profit figures were summed. And actually the header that we have now is the function call. So the sum function, and inside parentheses the profit column. And of course we know what it means to sum the profit column, but if you want to create workbooks for other people, for your colleagues, they might need a more specific header. So let's check the second query we have here. So we will run this second query, and we will select the sum of the profit from the sales table, but this time we have a where clause. So we specify that we want to sum the profit figures only for those records where the region is APAC. So basically we will get the sum of the profit that was generated in the APAC region after we run this query. Actually, I wanted to talk about the S keyword. This is why I mentioned that this header name is not the best, but shortly we will get to that. But first, let's run this query. So I will just simply rerun the query. So this time the figure is lower because we only got the sum of the APAC region. So the EMEA and the NORAM region, I believe, have been excluded from this sum operation. And now let's check the third query, and now I can talk about the S keyword. So the result of this third query should be the same as the result of the second query. But you see that after calling the sum function on the profit column, I use the S keyword and I specify that the header or the column name should be aliased as APAC_profit. By the way, when you alias a column name, make sure that there are no spaces. Previously I used a camel case, and I told you what camel case is in the VBA section of the course. But this time I'm using the so-called snake case. Everything is in lowercase, and instead of spaces, I use underscores. This is basically the snake case. Okay, knowing what the snake case is not that important actually. What is important is that we run this query now, and you will see that instead of sum profit, the header will be APAC profit, but the figure should be the same, so 9,300. Let me rerun the query. And indeed, the header is now APAC profit and the figure is the same. So now we are quite specific about what profit figure we show. In the Excel section of the course, we of course use this sum function. So we know that actually we can do this summing operation in Excel as well, so using an Excel function. And you know, it might be beneficial if you retrieve all the data and then you perform all the calculations on that data in Excel. But at the same time, if you have to perform a lot of calculations on your data, then it might be a good idea to let SQL do the job for you. So if you need a profit figure like this, then you can just write a query that does this for you, and you don't have to do additional work in Excel later. But it's really up to you how you work. Depending on the situation, you might want SQL or Excel to do the calculations. Okay, I think we've discussed the sum function in enough detail. So let's discuss the AVG function, which is basically the same as the average function in Excel. So let me uncomment these two lines of code now. The AVG function calculates an average. Using the query here, we'll return the average of the profit. So of course the syntax is very similar to the syntax that we used earlier. After the select keyword, we specify that we want to use the average or AVG function, and the field based on which we want this average be calculated will be the profit field. And of course this profit field is in the sales table, so we retrieve this sort of average calculation from the sales table. So let's go to the worksheet, and let me just delete these records and let's rerun the subroutine. So the header reads AVG profit, and now the average profit has been calculated and it has been retrieved. In the Excel section of the course, I believe I talked about what an average calculation is, in case you're not familiar with it. I think for most people it's obvious, but if it's not obvious for you, you can always check the Excel section of the crash course, where I explain what calculating an average means. But let's move on to the next query we have here. So I will comment this one out and uncomment this one. We still want to retrieve an average figure from the sales table. However, we have a where clause here, so we want to get the average figure based on the EMEA region. So after running this query, we will get to know the average profit generated in the EMEA region only. So let me just run the query. The header is still AVG profit, however you see that the average profit in the EMEA region is different than the average profit made in all regions. Let's check the next query. This is the last query about the AVG function. So basically this third query is the same as this second one, however I'm aliasing the name AVG profit. So this time when I run the query, the header will be more obvious, so it will be obvious that we are talking about EMEA profit. I could have actually added underscore average to this, so I could have aliased it as EMEA profit average, but I hope you'll forgive me for that. Let me just run the query. So the figure is still the same, but now we have a more specific header. There is not much else to discuss about the AVG function. So let's move on to the count function. By using the count function, we can very quickly get to know how many records we have in a table. In the sales table we don't have so-called null values. So if we go to phpMyAdmin, actually I was again logged out, so I have to provide the password again. So if you look at phpMyAdmin in the sales table, you see that we have some data for all the fields in all the records. It might happen that a field has a special null value, but it is beyond the scope of the crash course. However, if you want to know how many records there are in a table, then you can use the count function. The only thing you have to be careful about is that you choose a field where there are no null values, and typically the ID field is a field where you don't have any null values, so every record should have its own ID. So in this query we are using the count function, and basically we count the IDs, and because each record has its own ID, we will very quickly get to know how many records we have in the sales table altogether. So let's actually go to the worksheet, let's delete the records and run the manager sub. The header is count ID, but what is important for us is that the number 17 has been retrieved. And indeed, we have 17 records or rows in the sales table. Imagine that you work for a multinational company, for example, an international bank that has millions or tens of millions of customers. If your boss simply wants to know how many customers the company has, you can just write a query like this, and your boss will be amazed at how quickly you provided the result. Of course, you could retrieve all the customer data and then use Excel to check how many records you have or rows you have. But firstly, it will be much slower. And secondly, you have to consider that an Excel worksheet has 1,048,576 rows only. So you cannot really retrieve all the data if you work for a company that has millions or tens of millions of customers. But if your current task is simply letting your boss know how many customers the company has, then you don't have to consider the limitations of a worksheet. You can just simply run a count query or a select query with the count function, and you will get to know how many customers the company has in no time. I think it was the last function that I wanted to talk about. So now actually we reached the last topic here, the limit keyword, so I will uncomment these two lines of code. We can use the limit keyword in MariaDB to return a specific number of records. Imagine, for example, that you start a new job and you have to familiarize yourself with the database and its tables. Maybe some of the tables have millions and millions of rows, and of course the more rows a table has, the more time it takes to retrieve the data. But if you just want to familiarize yourself with the tables, you just need a few examples. For example, it might be enough to retrieve 5 records from each table, so you will see the structure of those tables. At least you will get to know the big picture of your database. So here we have this query, select all from sales, so we will retrieve all the fields from the sales table. But instead of a where clause, we use the limit keyword. And after the limit keyword, we specify how many records we want to be retrieved. Basically, in this SQL query, we specify that we want the first 5 records to be retrieved from the sales table, and we want all the fields to be returned. So let's go to the worksheet, let's delete this, and let's run the manager sub. Indeed, we returned all the fields, but we retrieved only the first 5 records because we used the limit keywords and we specified that we want only 5 records to be returned, so the first 5 records. If I was not familiar with this table, then with this very short and elegant query, I can very quickly get an overview of the structure of this table. So I see that here basically we have profit figures based on regions, and we also have the salespeople in this table. And I just had to write a very simple query, and of course it was blazing fast to retrieve 5 records. To get this general overview of this table, 5 records are enough. But imagine that there is like 1,000,000 records in this table, but it's totally unnecessary to retrieve all the records if I just want to know what fields are in the table and I just want to check what values we have behind those fields. Let me delete all the records from here. Now actually we reached the end of the manager sub, so we reached the end of all these examples. But there is one more thing that I will talk about, and it will be the automation using SQL. But before I talk about it, I want to say a few words about SQL in general. So I think in a crash course you got a nice fundamental knowledge about SQL queries. But of course there is more to SQL queries than what you have learned here. The queries we have are quite simple actually, so we didn't really get into complex queries. But I think it's very important that you know the 4 basic operations, so selecting or retrieving data, inserting data, updating data, yes, it's here, and deleting data. And we also talked about a bunch of different stuff like the as keyword, limit keyword, and so on and so on, and we also checked some basic functions. So actually we've covered quite a lot, but this is only the tip of the iceberg. But now without further ado, let's check the Crash 19 Automation VBA SQL module. As I mentioned before, this is basically the same automated process that we worked on in the VBA section of the course. This is why I chose this name for this code module, so that it's very similar to the module that we had in the other file, the file that we used for the VBA section of the course. In case you haven't watched the VBA section of the course, I suggest you do it because there I explain this whole automation process, and then you can come back and then check the SQL version of this automation process. But basically what we have here is a profit worksheet and an analysis worksheet, and this analysis worksheet looks the same as the worksheet that we had in the VBA section file. However, on the profit worksheet we don't have any data, but in the VBA file we had all the data already here, and we just simply copied the data from the profit worksheet onto the analysis worksheet. Now actually the only difference is that we don't have any data here, so we will use SQL to retrieve the data from our local database, and then we will copy that retrieved data to the analysis worksheet, and the rest of the automation process will be the same. So the profit figures for these salespeople will be searched for here, and we will also sum the profit per region here. In order to execute this subroutine we have to be on the profit worksheet. And this is something I also explained in the VBA section of the course. What I want to talk about quickly is, of course, the difference between this subroutine and the subroutine that we use in the VBA section. So here we have this part of the code, so we have the connection string, and then we run this SQL query. So basically we will have the result of this SQL query on our profit worksheet. And let's check the query. Actually we simply select the name, the profit, and the region columns of the sales table, and actually we alias all 3 columns, so the name column will be still the name column but with a capital N, the profit column will be named profit USD, and the region column will be a region column with a capital R. So this is really the only additional code that I added to this subroutine. The rest of the code is the same as before. We just copy this retrieved data onto the analysis worksheet, and then we do the rest of the automation. So let's go to the profit worksheet and let's run the subroutine. It is in the quick access toolbar, so we have this check mark here. And if I click on it, I will run the automation VBA SQL subroutine, so I will click on it. And actually it ran extremely quickly, and we have the message box confirming that the process has run successfully. We see that the data has been retrieved onto the profit column, and if I check the analysis column, I see that the data was successfully copied here. The profit figures for these salespeople were found, and we successfully calculated the sums per region. So what we've achieved in this crash course is actually huge. We have automated a small process, but we automated it with VBA and SQL. So now actually we get data from an actual database, and we work with this retrieved data using VBA. I hope you agree with me when I say that we've done a great job in the crash course. Let's actually summarize what we learned in the SQL section of the course. I will actually delete all the data from here and also from column F, these cells and these cells from column I. because of course I will make this file available to you, and I don't want the data to be here when you download the file. Actually, I will have to delete all the records from here. And yes, I think the file is ready for upload. In the SQL section of the course, we covered all the basics of SQL. So now I think you have a good foundational knowledge about SQL. We worked with data types like the big integer, and the varchar. Now you know how to create a database in PHP-MyAdmin, and you also know how to create a table in PHP-MyAdmin. We have run select, insert, update, and delete queries. We talked about the sum, average, and count functions. We've used where clauses profusely, and you should also know how to use the limit keyword. But of course, there is always more to cover, and because this is a crash course, we cannot cover everything. So here are some suggestions for further learning. There are other data types in SQL, and you should check what these are. You should also take a look at the create table and alter table and drop table statements. For creating a table using SQL, or changing a table using SQL, or deleting a table using SQL code. Joins is a very important topic. I suggest you read up on the inner join and the left join for sure. And you should also allocate some time to check what the unique constraint is. It's also very important to familiarize yourself with the AND and OR conditional operators. And you should also check how you can group results. And of course, you should check some additional functions, for example, the min and the max function. But most importantly, you should check what subqueries are. In the SQL section of the course, we didn't really reach the level where we write very complex queries. So we didn't discuss subqueries, but if you want to work with data, it's essential that you know what subqueries are. In the master course, of course, we discuss what subqueries are. So we discuss all the topics that I suggest for further learning. And by the end of the master course, you have written quite complex queries. You can enroll into the master course on udemy.com or on tmsonic.com. If you want to continue learning with me on Udemy, then make sure that you use the link that you can find in the description of this video to claim this amazing discount. But if you want to save even more money, then you should check out tmsonic.com, where you will be able to buy this course for $9.99 only. Of course, this huge discount is not always active on tmsonic.com, but it is actually activated quite often. If you haven't done so already, please subscribe to our channel and like this video, because it would help us a lot. You've reached the end of the crash course, so it is time to say goodbye. But before I bid you farewell, I would like to congratulate you on a job well done. Although this has been only a crash course, I've made sure that it is quite a challenging course. So you should really be proud of yourself for completing it. I hope you've enjoyed the course and you'll continue learning with me. Please share this video on Twitter and on Facebook so that other people can benefit from this crash course as well. But now it's really time to say goodbye. So goodbye, have a great day, and I hope we'll see each other again soon.